Welcome back, aliens. My name is Navin Reddy, and in this video we're going to talk about core Java. In this particular course, which is a lengthy video, you're going to learn everything from the basics of core Java to the end of core Java. Now, this is not the first time I'm uploading the video on Java. If you can see from last few years, you will find multiple Java playlists and multiple Java full-fledged video. But we all know, right, the quality of videos are going up every day, plus the number of features getting added to a language is going up. And that's the reason I'm going to re-record the entire course. Now, this is a full-fledged course, and that's why it's so lengthy, but you cannot finish the entire course in one day. Even if it says 12 hours or 13 hours, it will take time. Now, let's talk about Java. Now, why Java is so famous? Now, if you see the programming index, the top 5 programming language, you will always find Java there. Maybe at the first position or at the 4th position, you will find Java. Why Java is so famous is because Java has multiple features which helps it to be used in the enterprise market. I mean, not just enterprise market, it can be used for mobile development, web development, and of course, enterprise application. And most of the big companies, if you go there, they are using Java as their preferred language. Now, in Java, we have a technology called JVM. And it's not just Java, we have multiple languages running on JVM. So even if you are working on some other language, let's say Kotlin, Scala, Groovy, ultimately you're working on Java technology. And that's why if you learn core Java, it is much easier for you to jump to different languages. And I've also observed, irrespective of which interview you're going for, it can be for development or testing, and that doesn't matter which language you're working on there, maybe Python, C#, C++, they might ask you Java questions because most of the interview questions are based on Java, because they feel that if you know Java, that means you know other languages as well, or you can learn other languages easily. As for my experience, or did I forget to introduce myself? My name is Navin Reddy. I'm a corporate trainer, software developer, and currently focusing more on blockchain, but Java is my first love. So I'm working on Java from last 12 years. I've made multiple courses on Java on YouTube and different platforms. And yeah, I can teach Java any day, any time. Yeah, sometimes I have to watch my own videos to revise the concept. But the thing is, I love Java. And with this experience, I'm making the entire course. I was talking about my experience, right? In fact, I have learned multiple languages. In this all 12 years, maybe I have worked on 12 different languages. You can name it, maybe C++, C, Python, Java, JavaScript, Go language. So I love most of the languages. Some languages I learned just for the projects. But then when I was learning those languages, I was feeling, hey, it's so easy. It's because I have learned Java. Yes, people say Java is difficult. Yes, to start with, it is difficult. Maybe if you want to learn Java as your first language, it's kind of difficult, because if you're coming from other language, let's say Python or JavaScript, and if you want to print one statement, you can actually see that in one line. That's not the case with Java, right? You have to write 5 lines of code. But yes, once you make a big application, the number of lines will remain almost same. Okay, so Java is difficult, yes, just to start with. But the thing is, Java is one of the most readable language. What I mean by that is, if you are looking at someone else's code, you can read the Java code line by line. That's not true with other languages, okay? So Java is great in that terms. Java is maintainable, and maybe that's why most of the industries are preferring to use Java. Now, Java has multiple features. We'll talk about those features later, but just to name them, we got Vora, which is write once, run anywhere. It supports multi-threads. It has a collection API concept. You can handle the exceptions, and we are going to learn everything in this particular course. Now, just to go for the history of Java, Java was made in 1995 by Sun Microsystem, and it was led by the team of James Gosling. Later on, Oracle bought Sun, so now the trademark of Java belongs to Oracle. Yes, in between, Oracle did some messed up things with Java, but yeah, they are back on track. And the beauty is, Java is getting updated every 6 months. Not the major updates, but they are working hard to make Java as the most powerful language. So I hope you are excited for the entire course. We are going to start from the basic, as I mentioned, and you will learn a lot of different stuff. But as I mentioned, it's not about completing the entire course in one day. You can use a timeline to jump between these sections. And also with this, we also have a code there. So in the description, you will find the link, GitHub link, where you can access all the codes. And maybe it will be helpful for you to write this code. So let's start the journey. I know you are excited to write your first Java code, but the thing is, to write the Java code, you need a place to write the code, right? So basically, you need an editor. Of course, Notepad works, right? We all love Notepad. Apart from Notepad, we have multiple softwares using which you can write your Java code. Maybe you can use WordPad, or you can use Notepad++, you can use Edit+. When it comes to programming, there are multiple editor options available. Specifically for Java, one of the most famous IDE. Now, IDE stands for Integrated Development Environment. So basically, we have editors where you can only type the code, or you can use a IDE where you can type the code, where you can run the code, where you can compile the code, where you can debug the code, and you can do everything in an IDE. Now, which is good. Now, for beginners, using editor makes sense, but then if you are working on a real project, you can use a IDE. Now, it is dependent upon you which IDE you want to use. In this course, we are going to use VS Code. Now, there are multiple options available. We have Eclipse, IntelliJ IDEA, we have NetBeans. In fact, I have worked on a lot on NetBeans. At the start of my career, I have worked on Eclipse as well for some few years, and then I have worked on IntelliJ IDEA for 1 or 2 projects. My personal favorite is IntelliJ IDEA. The only thing is the ultimate version, which is awesome, is a paid version. The community version is good, but it has some limited features. Now, why we are using VS Code is because it's a very lightweight editor or an IDE. So you can do everything in VS Code, and it's also lightweight. Okay. Apart from that, you also need a compiler, right? So of course, when you write a code, of course, you have to compile your code so that your machine can understand that. And in terms of Java, we have to download JDK, which stands for Java Development Kit. Now, how do you get these two softwares? It's very simple. Just go to your browser and search for JDK download. And also you can search for VS Code. So these are two softwares we are going to use. Let's start with JDK first. In JDK, we have 2 versions. We have a proprietary JDK of Oracle, and we have an open source version. In fact, there are multiple implementations for open source. You can choose any of them. We have Corretto, we have different implementation. You can just explore them. But I'm going to use Oracle JDK here. Yes, at one point, Oracle made Java paid, but now it's free again. So we can use Oracle JDK here. And you can just click on the Java downloads, and you can see it will give you multiple options. The thing is, at the point of this recording, Java 19 already launched. Java 20 is going to release soon. And with every new version, in fact, Java is following this 6 months updates now. So every 6 months, you will get new updates, right? So with every new update, you will get some features, but the basic language will remain same. So irrespective if you are watching this when we have Java 25, don't worry. Java is backward compatible, and the basic language features will be same. Of course, there will be minor tweaks in the new updates, new features, but overall it will be same. In case if there is something new happening which is changing the basic concept, we are going to re-record that video in the series. Okay, now which version to choose here? Should we go for Java 19 or Java 17? The thing is, with every 6 months you get new features, right? But not every version is LTS. LTS stands for long-term support. So there are some versions which get long-term support. Now Java 17 is one of them. So instead of downloading Java 19, we are going to go for Java 17 because it's LTS. So if I click on Java 17 here, and you can depend upon which OS you're using. I'm using Windows here. For the core Java, we are going to use Mac OS, but then the setup will change, but the underlying software will remain same. The code will remain same, right? So irrespective of which OS you're working will not make any difference for the course. But for this video, I'm using Windows here. And if you're using Linux, you can choose Linux distribution or Linux package here. If you're using Mac OS, you can download based on, is it a Mac Apple chip or it is a Intel chip. And you can go for Windows as well if you're using Windows. And for this machine, I'm using Windows. So you can click on this download here, and it will take some time for the downloading. This setup is actually very simple. You just have to change one thing, which I will show you in some time. And it's straightforward in Mac. In Windows, you have to set the path. Okay, we'll see how to do that. Next is VS Code, and you can just click on this download here. Now, first of all, VS Code is a very popular IDE. Now, if you're coming from some other languages, you might have already used VS Code. So it's quite easy. Okay, now depending upon which OS you're using, you can download one. I'm using Windows here. I will click on download, and yeah, it's starting soon. And you can see it is downloading here. Now let's start with the JDK first. When you click on JDK, it will take some time. The thing is, in my machine, I already have these two softwares. So the first screen might look different for both of us. You can see for me it says reinstall. I will say yes. So here you can see it says next. In fact, for you as well, you have to just click on next, next, next. Everything is smooth. And depending upon your machine speed, it will change. The speed might change. Okay. That's JDK install. But how do we verify if you have JDK? Okay, we'll do that in some time. But let's do the setup for VS Code. Again, straightforward setup. Say I accept. You don't have a choice here. You can say next, next. Nothing to specify. Just by default it will be there, so just keep it and install. So by the time it is happening, what I will do is I will open my command prompt. And how do you check if you have Java installed? So go just type Java -- version, and it will give you the Java version. If it is coming, that means Java or JDK is installed. In fact, you have to check one more thing, which is Java C version for the compiler, and you can see it is giving me the version here. But in case if you get error that the Java C command not found, even if you have installed it, that means the path is not set. How do you verify the path here? It's very simple actually. You can just go to search and search for environment variables, or if you type environment, it will give you the first one. Just click on that. And here if you can see, we have an option of environment variables. Just click on this environment variables. And you can see we have user variables path here. You have to make sure that you have a path variable. Or you can edit it in system variables. If you want this to be applied throughout the system, different users, then you can use system variables, or you can use a user variable here. I will go for system variable. Make sure that you have path. In case if you don't have a path, click on new and set the variable name as path and set the value. Now what is the value here? Now the value is your bin folder. So what you can do is you can go to your C drive, go to program files, search for Java here. You can see we have Java, and open this JDK. Click on bin. Now this is a path because inside this bin you have Java C. So copy this and you can paste it here in the environment variables value. Now since I already have path variable, I will not create new. If you don't have a path variable, click on OK. But I will not do that because I already have a path variable. Just double click it. It will show all the path variables. For my machine, I already have it here. If you don't have it, find the empty place or click on new, paste, and you're done. And click on OK. For me, it's already there, so I will just remove this and click on OK. OK. Now, once you do this setup, you have to make sure that you restart your CMD. And now try for Java C version, and it works. Okay. So that's how you install JDK and make it work. Now let's open VS Code. Now, once your VS Code is installed, you can see it's done for me. I will say launch. So that's how VS Code looks like. Now this is a place where you have most of the settings. In fact, I have already used VS Code in my machine with different extensions, and that's why you can see them here. But for you, you will not be having this extension. You will be having only first 4. Now, how do we check if everything is working? Just click on terminal here, new terminal, and try to do Java C here as well, and it works. So your JDK and VS Code is all set. Now you can start the code. Now, once we have our setup done, it's time to write our first code. That's right. So finally, we are going to run our first Java code here. Now for that, we have to open our editor. So of course, in the last video, we have discussed that we are going to use VS Code. So let's open VS Code here. So I will say code. Okay, so our VS Code is all set to write our first code. You can see it will give you a welcome screen when you do it, and then it will ask you the preference. Do you want a light color, dark high contrast, or light high contrast? I would say go for dark because it's good for development. It will not strain your eyes at least. So let's close this, get started, and this is how your VS Code will look like. Okay, simple stuff, right? Now what we'll do is, first of all, where you will get your folder. So you will see your folders on the left hand side. So this is where you will get your project, all the files which you want to work with. So you'll be having that here. Now, of course, in the upcoming tutorials, we'll be using a different IDE, and I want you to get used to different IDEs when you work with. So on the left hand side, we can see we have an Explorer here. And then if you want to search something, we have it here. If you want to add some extensions, which we are going to do later, we'll add certain extensions to work with. At this point, we don't need any extensions, so just keep it blank. I mean, no need to install anything here. In my machine, I already have something on some other accounts, but on this account, I don't think so. Anyway, and then if you want to run and debug, you will find the option here. Now, why do we run? Of course, we know why to run, right? But why do we debug the application? Yeah, we'll see that later. At this point, let's open our files of Explorer here. And this is where I want to create my first project. Now, how do we create a project? Now, project will be a very broad term at this point. What we are going to do is we will create some files. And of course, when you merge these files and libraries, you create a project. At this point, we are not working with any external libraries. At this point, we are just going for a simple files. Okay, hello world, right? So for that, what we'll do is we'll click on open folder because all these files will be part of one particular folder. So we'll click on open folder and it will give you certain options where you want to save this. So I will save this on my desktop itself. Okay, in fact, on my desktop, I want to create one more folder. So I will say open folder again. Inside desktop, I want to create a folder here. We'll say I will have a short name. We'll say course, create, and open. So you can see we got our course folder here. What I will do is I will zoom inside my VS Code so that you can see everything properly. And again, the recommendation would be to watch this on a bigger screen so that you can actually understand each and every line, because on mobile sometime you will be seeing a font size and a small font. Okay, I don't want to see this page every time I open my VS Code, so I will just uncheck this and click on close here. And let's create our first file, and this is where you are going to write our first code, right? So we have already seen how do we install JDK, how do we check the version on the terminal. Can you do that in this? So VS Code itself has a terminal here, so you don't have to open the external terminal. Of course, if you're using Windows, you will be having an option of command prompt. But let's click on terminal here, and you can see we have an option of terminal. Click on this one. Okay, this is where you can enter your commands, whatever commands you have. The same command will write here. So we'll say Java version, and you can see I have Java 17 in this machine, and Java 18 is already released, but then Java 17 is the LTS version. So when you say LTS, it means long-term support, right? So we'll use that. And we'll also check if my Java C is working. You can see Java C is also there. Now Java C basically stands for Java compiler, as we discussed before. So we need both. We need Java to run the application. We need Java C to compile the code, right? Okay, cool. So we got the terminal as well. I will just minimize this a bit. Okay, so now let's create our first file. So what we are going to do is we'll click on this particular file here and we'll name this as hello.java. Now there is something you have to remember. Whenever you create a Java project, you have to make sure that you give an extension, or Java files basically, you have to give an extension with .java. Now different languages have different extension. When you talk about C, we say .c. When you say C++ language, we say .cpp. When you say JavaScript, we use .js. In the same way, in Java, we say .java. Simple stuff, right? So you got our file here. Now VS Code will give you some suggestions. We'll ask you to install some extensions for Java, and we'll click on recommendation. Okay, it is asking us extension pack for Java, which will help us. It will give you some options and extra stuff. Again, this is just an advantage which you get from VS Code. Again, not required if you don't want to install this extension. I think I should go for it. We also have IntelliCode for AI assistance, but yeah, we'll stick to this extension. Again, in your machine, you don't have to install this. There's no compulsion. You can still write your Java code, but maybe it will give you some suggestions and stuff in between. Let's see. Let's close this and let's write our code. So extension will be installing behind the scene. You don't have to worry about it. So basically, how do we write our Java code? It's very simple actually. First of all, the question is, what do you want to do in this code? Do you want to create a game, or do you want to build a rocket which will go to Mars? I will not be doing those extra stuff. What I will do now is I will create a very simple file which will print hello world. I know. That's how you start a programming language, right? It's irrespective of which language you're learning, the first thing you do is you print hello world. So here I want to print hello world. Now how do we do that? See, if you are coming from other languages, let's say Python, right? So what you do is, if you want to print hello world in Python, you can write only one line. And maybe Java is not that famous for simplicity at the start. Of course, when you build a bigger project, Java is much more structured compared to the languages, but then to start with, it's not that easy, so just bear with me. Okay, so what we are going to do now is, if you want to just experiment with Java, if you want to play some, if you want to test some code or stuff, we have an option which was introduced in Java 9. So basically you can write your code in one line and you can get the output. Example, so even before we jump to hello world, let me show you something. So we have a concept of JShell in Java. So it was introduced in Java 9, as I mentioned. So you can open your terminal, and here let me just increase the size a bit. So what I will do is I will click on JShell, or I will type JShell, and it will give you a JShell prompt. Okay, now J in this case is Java, so it should make sense now. Okay, so what you can do in JShell is if you want to experiment something, example, why do we write code? Why do we build applications? So to solve problems, right? Now it can be a very simple problem as well. Example, if you want to add two numbers, it's very simple. You can say 2 plus 3, and if I say enter, you can say we got 5, right? So we got the answer, which is 5. What if you want to do a subtraction? You can do that. So 9 minus 6, and you can see we got 3. So this is working. But what if you want to print something? So in this case, what you can do is, whenever in Java, if you want to do something, we use something called methods. At this point, you don't have to remember methods and what the definition is. Just remember that there is a concept called methods using which you can do something. The only thing you have to remember is if you want to do something, you need methods. In the same way, if you want to do something here, I want to print something, right? So we have to use a method called print. It is an inbuilt method in Java, so you don't have to worry about it, just use it, it will work. So whenever you call methods, you have to pass the values. So I want to say, hey, print, but then it will say, okay, I will print, but what you want me to print? So you can mention that in this bracket. So in this round brackets, you can mention, I want to print hello world. Now, if you want to just print a number, let's start with that first. So let me just print a number, which is 6. And in Java, there's one more thing. You have to put a semicolon at the end. It should work in this, but then remember this. At the end, put a semicolon. That's how you mention, hey, something is getting ended. So we got a semicolon there. And now what you can do is, let's try to run this code. Now, errors, right? Errors are very important in your life, in your programming life, basically. You see, you got the error. It says, cannot find a symbol called print. It's not working. Okay, cool, no problem. So let me just clear the screen. Clear command is not working. Ignore that. It will say. So let me open JShell once again, and because I just want to keep it on top. So what I will do now is, if I want to print something and I want to print a value 6 at the end, I want a semicolon as well. Now, Java says if you want to call print, print belongs to something, right? So when I say it is available inside Java, so the statement you have to always mention is system.out.println. See, there will be a point where we'll talk about what is system, what is out. At this point, it's very difficult to understand. So just bear with me. This is a statement which you have to use if you want to print something on the console. Okay, so if I want to print something here, just say system.out.print and whatever value you want to pass. Say enter, you can see we got 6. But what if you want to print hello world? I don't want to print 6. So if you want to repeat the same statement, of course you can type or you can click on the up arrow. It will give you the option. Now here, if you want to print hello world, you have to put that in double quotes. So whenever you want to do something with text, see, numbers are easy to use. You can simply say 6. But if you want to work with a text, you have to put that in double quotes, the way I've done it here. So in this double quotes, you have to mention hello world. Right? That's how you start a programming journey, right? I will say enter and you can see we got hello world. What if I want to print something else? Which is very simple. You can say double quotes, Naveen Reddy, Telusko, and if I say enter, you can see we got the text. So whatever you want to print, just put that in double quotes and it should work. And you can see we are getting the output as well. So cool. So we are able to do this with the help of JShell. But will it work in this? If I try to copy this, in fact, why to copy when we can type it? So let's type system.out.println, and here we'll say hello world, and let's give a semicolon at the end. It was working on JShell, but when you work with Java files, because this is how you build a project, right? JShell is not to build projects. It's just for the experiment. If you are learning a language, it is good. But if you want to make it work, you can do. If you want to build a big application, say .java file and write your code there. So let's compile this code. Now, how do we compile? Okay, so there are 2 steps you have to follow. First, when you write a code, you have to compile the code and then you can run the code. So to compile the code, you can say Java C in the terminal, and let me just increase the font a bit. So you have to say Java C and then you have to mention the file name. So first you have to make sure that you are in a correct folder, which is course. So you can see that this is the folder we have, and then you have to mention Java C and then the file name. The file name in this case is hello.java. Click on enter. Oh, we got an error. Okay, so it says something is missing, something else was expected and you are giving this is not working. So this is not how you write applications or code in Java file. We have to do something else. But at this point, we have understood, right? How do you work with JShell? So you can, if you want to do something with JShell, just write a code, it will work. If you want to add 2 numbers, it will work. You can't do that here. We have to do something extra. So let's solve this problem. So we are not able to run this code, right? This is not working. We want to get hello world on the screen. It was working with JShell because JShell says you just pass a statement, I will work. But then when you build an application, when you run the application, how exactly it works behind the scene, Once we understand that, we can write this code. So in your machine, you will be having something called JVM. Now, by default, when you say Java is platform independent, is because of JVM, because in your machine, you will be having JVM. Irrespective of which OS you use, it can be Windows, Linux-based OS, or Mac, or whatever famous OS we have, it will have JVM installed. And of course, if you have JVM, you can run Java application. And if you don't have JVM, you can't run Java application. Okay, so we got JVM here, right? Now what JVM says, hey, I will work. But then there's one question. When you say JVM will work, but JVM works on which environment? So underlying, we have your OS. So this is your OS, and then your OS is working on a hardware, right? So you'll be having a hardware. It can be a laptop, it can be a desktop, it can be a phone, doesn't matter. You have a hardware. On top of that, we have an OS. On top of that, we have something called JVM. Now JVM says, okay, my job is to execute a Java code. Okay, so whatever Java code you create, JVM will execute that. But then JVM will not accept the code directly. See, what happens is Java goes in multiple steps in Java application. When you as a programmer, so let's say you are a programmer here, and when you write a code, you will not directly write a code which will run on JVM, okay? And we don't even do that, right? We don't even write a code which directly works on the hardware. And we don't even write a code which works directly on OS. Java says if you want to make it work, you have to run your code on JVM, but then JVM will not understand what you're talking about. And one more thing we have talked about, right? Java is platform independent. So what does platform independence means? It simply means that you can run your application on any machine. Okay, so when you write a Java code, it will run on any machine irrespective of the hardware or the OS. But the only thing it requires is that machine need to have JVM. So irrespective of which platform I'm talking about, if it has JVM, your application becomes platform independent. But JVM itself is platform dependent. Okay, so example, you can't run JVM on iOS. So we can't say Java is platform independent when JVM itself is dependent. So yes, your application is independent, JVM is not. So JVM need to be built for a particular OS. And let's say if it is Windows, in my machine it is Mac, but let's say if it is Windows, we have JVM available on Windows. So your JVM says, hey, I will run your code, but you have to submit me not the Java code, but something called a bytecode. So you have to convert your code into an unreadable format for a normal human being, and this is called a bytecode. Because JVM only understands bytecode. But can you write bytecode? Of course not. You only understand English type of languages, right? So whatever we have written the code, we have written system.out.print. It's English-like language, right? So what you create is a Java code. So this is your Java file or Java code. And then you have to convert this Java code. So this is Java code which is more of readable. This is not something which you can read. So basically you have to convert this into a Java code or bytecode. So for that we have something in between here which is called a compiler. Now since this is a Java compiler, we can call it as Java C, which is Java compiler. Okay, so basically you will write this code. So this code will be getting compiled into a bytecode, and that bytecode goes on the JVM it will run. Okay, makes sense, right? So that means when you write something, it will go into bytecode, and then bytecode will run on JVM. Now the only thing is, see, your project can be a big project, right? Here I'm writing only one file. It can be 10 lines of code. It can be 10 files. It can be 100 files. It can be 1,000 files. Out of all these files, there will be only one file with JVM will execute. Okay, JVM will start with the first file, and then of course that file will depend upon other files and it will execute. So JVM says, you need to tell me what that file is. Okay, so even if you have 1,000 files which you want to run in your project, you have to give the first file. So in this case, what you will do is you will specify, hey, that's my first file. So when you run the code, you will specify the first file, and also that file need to have something called a main method. Okay, so as I mentioned before, right, we have print. In the same way we have main. So your file, the first file, need to have a main method. So when I say first file, it is not like you have to follow a sequence, create this file, then that file. Out of all the files in your project, the execution will start from the first file, which you specify. Okay, and that file need to have main. Not just main, it is looking for a specific signature. Okay, so when I say signature, it means the entire method signature, the method name, what are the values you're passing and all those stuff. And of course, all this term you will get used to in some of these sessions, don't worry. So first you have to make sure that you provide a main, and main has a particular signature. Again, what each word means, that we'll see later. So the signature is this. It is public static void main. So you have to remember, always pass this method. I know there are 4 words, but then this is the thing you have to remember. And main will accept some arguments, some parameters. So you have to pass string A. Now again, we'll discuss this, what this string is, what is public, static, void. We'll discuss that in some time. But main is looking for this signature. So your code will not work without this signature. Okay, so remember this. So that makes sense. So what are the steps you have to follow? So the first step is, as a programmer, you will be creating a Java file. Okay. Now once your Java file is ready, you will put that into compiler. Then compiler will compile it. Then that code becomes a byte file. A byte code basically. Then you will take this byte code, you will run that on JVM. Now once your JVM says, okay, I'm running the code, JVM will look for this particular syntax. It should be there in your code. And then you will get the output, right? Simple stuff. Okay, now there's a space in between here. If you can see, this is a space. I have left that space intentionally because we'll add certain things there. So at this point, just remember, there's a space here. There's a box remaining here. We'll add that box in some time. Now, once we have understood all those things, it's time to expand this code. Now, if you remember, we have to write everything in a main, right? So this section should be a part of, remember what JVM will ask you for? JVM will ask you for main. So we have to put that into main. So what is the syntax for main? It's very simple. It is public static void main. We have seen that. Of course, these words will define that words in the upcoming session. And once you understand all these terms, you are Java programmer, right? And in this, we'll say string A, and that's it. This is the syntax you have to follow. Now, there's one more thing. In Java, now Java is object-oriented. Now, what is object-oriented means, we'll discuss that later. But in simple terms, object-oriented means everything should be an object. And to create object, we need a class. Okay, again, we'll discuss all those things in the upcoming session, but a class is missing here. In fact, if you compile this code, this is what your Java say will tell you. Java say says, hey, where is your class? Your class is missing. Okay, let's do that. So let's put that a class here, and we'll give a class name. At this point, we'll keep the class name and file name same, and we'll say open bracket and close, and we'll give an indentation. So basically we have to follow this thing. Always give a tab. So every time you open a curly bracket, give a tab. It looks good. Okay, there's no compulsion. It looks good, and we love to build stuff which also runs and looks good. Okay, so this looks good, right? Ignore this X and these suggestions. These are the extra suggestions coming from your VS Code, but ignore that part. In fact, is it because happening of this extension? Let me just remove this. So let's not use that extension because it will give you suggestion. It's good for development, but not for teaching purpose, right? It adds extra text there. Okay, cool. So this is how you write your code. Okay, we got a class, a file name, and then public static void main. In bracket, you have to mention the parameters. Again, we'll discuss that later. And the only thing, important statement here is system.out.print hello world. Okay, now let's see if this works. Let's clear the screen and compile. You can see there is no error. But the moment I compiled, if you can see on the left hand side, we got this extra file. We got hello.class. Now this is your bytecode. Remember, we have talked about a bytecode here. This is a file which got created automatically. So when you create a Java file, when you send it for the compilation, it will create the bytecode. And the extension for the bytecode is .class file. The extension for Java code is .java file. And now it is compiled, done, right? Now it's time to run your code. So remember when I mentioned to run, you have to use JVM, and for that you have to use a command which is Java, and you have to mention the class name, not a file name this time, just a class name. The class name is hello and say enter. You can see we got hello world. So yeah, that's how it works. So simple stuff. That's why we can able to complete our code, and we are able to run this code. Now, if you have done till now, give a round of applause or a pat on your back because you deserve it. Okay, so this makes sense, right? So there's a gap here, right? So let's remove this gap. So what we have here, so basically, when you run your code, basically think about you're cooking something in a kitchen, right? So where do we cook? Of course, in a kitchen, right? Why not in a hall or in a bedroom? It's because in the kitchen, to cook something, you need extra things, right? Example, if you make a biryani, I don't know if you know the recipe, even I don't know the recipe, but if you make a biryani, you have to add extra ingredients, right? Now those things are kept in the shelf. So in the kitchen, you will not just have that resources which are there in the platform, but also you will be having extra stuff. Now the same way, if you want to run your Java application, you need extra libraries, and you also need a runtime. Now runtime is something where you can run things, right? Now you can run something in a JVM, so that is part of run. But then what if you need some extra libraries? You need an environment as well. So Java provides you one more thing. So we have one more layer here, which is above your OS, which is called JRE. So when you want to run something, you use JRE to run it. Now JRE stands for Java Runtime Environment. And what is your JVM? JVM stands for Java Virtual Machine. Okay, so basically we have two things. We have a JVM and we have a JRE. Now JVM is a part of JRE. Now what else you will be having inside your JVM? You will be having some libraries. So JVM with libraries is a part of JRE. So whenever you run something, it runs inside the JRE, and JVM is actually responsible to run it. Okay, and by default, when you want to run your application on any platform, it need to have JRE, which will have JVM. Now, not every machine will have Java C. Java C is only for development purpose, right? So we can imagine this in this section. So basically, we have an outer box, which is your JDK, which is used by developers, inside which you will be having something called JRE, and in this you will be having JVM. So as a developer, you will be installing JDK. JDK will have JRE. JRE will have JVM. But to run something on any other machine, let's say if you have made the application, you want to run this on your friend's machine will only have JRE and JVM. JDK is not required. And that's why we say Java is Vora, which is write once and run anywhere. Right? So you just have to write on your machine, you can run it on any other machine, provided you have JRE and JVM installed. So that's how your Java works behind the scene. I hope it makes sense now. Okay, so we were able to run this code and we understood something what is happening behind the scene, right? So basically we know now that as a programmer, as a Java developer, you write our Java code, which will be having .java extension, and that gets compiled by Java C. And then when you compile the code, what you get in output is a bytecode, which will be having .class file. And then you can run the .class file in your JVM. And basically, it's a part of JRE, which will have JVM as well as libraries, lot of classes. And then everything is a part of a JRE. That JRE you will be installing on OS, right? So basically you need to have a hardware. Of course, you need a machine to run, right? That machine will be having an OS, and then OS will be having a JRE, which will have JVM. But as a developer, you will need one more tool, which is JDK. Now, when you install a new JDK, you get the updated JRE and JVM with it. Okay, so the version of JDK which we are using is JDK 17, which is LTS, which is long-term support. And in every new version, you get some minor extra features, right? So even if you are watching this after 10 years or 8 years or 5 years, you will be having new version of Java. Of course, next 5 years, you will get 10 new versions, and every new version will have minor updates. But the base thing remains same, right? So whatever you are learning is actually from Java 1 itself. The system.out.println is same in Java 1. So don't worry about the new updates. The core concept will remain same. Okay, cool. Now, once you have this thing, what next we can do? Now think about this world. Of course, first of all, why we build software? We build software so that we can solve a problem. Now, what problem we are trying to solve? So basically, we are trying to solve the real world problems with the help of virtual world. Example, you wanted to buy something, so you got Amazon, which delivers everything at home. So you got Amazon as an online service. You wanted to book a cab, you got Uber. So for every problem, we have a solution in the virtual world, right? So banking, everything is happening online. Now, when you say you are replacing the real world with a virtual world solution, so basically we need to work with one thing. The most important thing now is actually data. So basically we want to work with data. So how will you work with data? So basically you need data as well as processing on it. So whenever we build a project or when you build an application, what we are doing is we are doing the processing on data. Now this data can be coming from user or something. So maybe you will accept the data from the user and then you will do some work with it. Maybe you want to store this data. Now, where exactly do we store data? So we store data in something called database. So we have a database here in which you'll be storing your data. So whatever data you're getting from the user or from after processing. So let's say we got a user here, user sends us data, we will apply a processing on that. So we will do some work in between. And then at the end, we might store data in database. Now this database is actually a permanent storage or a persistent storage, which you say. Now when you say it is permanent, that doesn't mean you can't change it. Of course you can replace the values as well, but then the data stays there. Okay, so if you just store it, and even if you shut down your machine, the data will be stored. Example, when you copy movies or games on your laptop, it stays there, right? It will get deleted when you say delete, but the data stays there. So this makes sense, right? But when I say you will receive data from the user and then you will be doing some processing on that, where you will store the data for temporary purpose. Of course, database is there for permanent storage, but during processing, you have to store your data somewhere, and that somewhere is variable. So this is where you store your data. Now, what is variable? So imagine variable as a box, and in this box, you will store your data. Now, what data you want to store? Your data can be numeric, it can be text, it can be image, whatever you want to store. So you can store that data in this variable. Now, I'm not talking specific to Java. In general, when you say you want to store data, you will store that in a box, and that box will have a type to it. It can be of type numbers, it can be of types text or image or video. So here we are trying to store data, right? So let's say I want to store a number which is 5. So this box will have a number 5, and it will also have a name to it. Maybe I can give a name, let's say a number. Doesn't matter what name you give. Of course, there are some restrictions on names, but num works. You can use any name which you like. Maybe you can create one more box here, and you want to store the number itself, but let's say a decimal value, something like 6.5. You can do that. Okay, and maybe you can have a different value to it, different name to it. Maybe you can say marks or grades. Maybe you want to have one more box where you want to store your name. So I can do that. I can store my name as Naveen, and it will have a variable name. So maybe I can say this is user. So user is Naveen. So basically what you do is you create a box, and inside the box you'll be having values. Now this box are actually called variables. So we can name this box as a variable. Okay, and so what we got till now, we got that a box will be called a variable, and you'll be having a name to it, you'll be having a value. So name and value will be there. Apart from that, Java is actually called strongly typed language. Now what it means is whatever variable you want to create. So if you want to store the data, of course Java says, hey, we'll accept the data, but tell me also what kind of box you want. A different type of data will require different box. Okay, that makes sense. So I will say, hey Java, I want to store a number. So I want to create a box for me which will accept numbers. So we can say, okay, this makes sense. Number will go there. We can also treat this as a number, but this is a text, right? So in Java, we call them as a string, right? So text will be having a string. So this box type is string. What about this box? Of course, we say this is a number, this is also a number, but in number as well, we have a category inside it. So one of the category I will mention is this. We can, if you want to store numbers, we can store that in something called int. Now int means integer. Okay, so we can store data in the integer format, but we cannot store 6.5 in int because 6.5 is a real number. So int will accept numbers, but why it is called int? Why not natural numbers or whole numbers? Is because maybe you want to store negative values as well. So remember your maths concept. So we have negative numbers to positive values. So everything will be considered as int. So we can store -5, +5, that's your choice. Okay, so this makes sense. So what I will do now is, if I go back to the code, of course we want to print hello world, but we have done that. Now I want to store values so that I can do some processing on it. Now what kind of processing I want to do? Maybe I want to add two numbers, maybe 2 + 2 or 5 + 6, simple stuff, right? But before that, we'll see how do we store data. Even if you don't store data, you can just go inside this system.out.print, whatever operation you want to perform. You want to say 3 + 5, that will work. So you can just go back here and say compile and run. So remember this thing, every time you make a change, just make sure that you compile it first. So the first step is compilation and then running. And you can see we got the output, which is 8. Just ignore this percentage symbol as of now. Actually, there's one more thing I wanted to mention. Whenever you print something, let's say I want to print this number here as well. I want to perform different operations. So you can write multiple statements for different operation you want to perform. So you can say 8 + 7. So we are doing addition here and then addition here. Let's clear the screen. Okay, I have to first compile. Okay, that's what. Compile, run, and you can see we got the value. Now the only thing you can see is the result are bit that together, right? We want to give a space of maybe I can print 15 on new line. So what you can do is, instead of using print, you can actually use something called println. Now println means print new line. So it will print and it will go on new line. So we can do that here as well. So just say ln at the end, println, which is print new line. And now compile, run, and you can see we got the value. We got 5 and 15. So from now, we'll not be using print, we'll be using println. Okay, so again, println means it will print, it will go on new line. So we got println. Now what else we can do here? So I don't want to perform the operation here. Remove that. I want to store that value first. So how do we store? Of course, we need box, right? So I can say num1. As I mentioned, I can use any variable name. So let's say num1, or to start with, let's say num, just to keep it simple. And then we can give a value to it. Let's say value is 3. So remember, we have to mention the variable name, and then we have to mention the value for it. And at the end, of course, you can put a semicolon. So we can say we got num equal to 3 and we got a semicolon. So in Java, after every statement, you have to give a semicolon. You might be thinking, hey, why don't we have a semicolon here? It's because that is a block. So we don't put a semicolon out at the end of a block. The reason is it signifies that's the end. Here, if we don't mention semicolon, how do we define that that's the end? So it's good to put semicolon at the end. And anyway, Java will give you error if you don't do that. The next thing we have to do here is we have to also mention the type. What type of num is this? So we can say int. Now we have to say first you have to specify the type and then you mention the variable name. Maybe if you have learned some other languages where you put the type afterwards, in Java we first put the value or put the type and then we put the name, then we assign the value. Now this equal to here is called assignment operator because you are assigning a value. So what it will do is it will take the value from the right hand side, it will assign the value to the left hand side. Okay, remember this. Equal to will take the value from the right hand side, it will assign the value to the left hand side. Okay, so we got a variable which is of type int. Okay, so this is num, which is a variable, and then we can print it now. Let's only print the value, that's it, nothing much. I will just save. Now once you click on save, you have to compile the code and run the code, and you can see we got 3. Okay, cool. So now can I create more variables? We can actually. So let me just rename the variable from num to num1, and here as well I will print num1. Okay, and then I will create one more variable which is num2 is equal to. So every time you want to create a variable, just mention the type, which is int, of whatever type of variable you're creating. At this point we are working with numbers, so we'll say int num2 equal to, we can assign the value which is 5. So we got 3 and 5. Here, what you can do is you can actually perform the operation here itself. So you can say num1 plus num2, that works. So instead of adding values, we can also add the variables. Okay, so now what we're doing is we are saying num1 plus num2, and the addition will be getting printed. Let's try. So I can just go back here and say compile, run, and you can see we got 8. You know what? Instead of adding it inside this, it's not a good practice. What you can do is we can create another variable called result. And that's right, variables are free to use. Of course, behind the scene it is consuming a lot of memory, but it's working, right? It's free as of now, but later on we'll focus on how can you make your code more efficient so that it will use less space, right? At this point it works, so we can say num1 plus, so whatever operation you want to perform, you can do that here. And instead of printing and doing addition here, we can simply print result. So what you're doing now is you're adding the value, and then you are storing that in a result, and then you're printing it. It should work. Let's try. Compile, run, and you can see we got 8. So this is working. So that's how you can create variables. So remember this thing, every time you want to create a variable, you first need a name for it. At this point is num1. You have to also mention the type of it. At this point this is int, and you have to assign the value for it. In the upcoming videos, we'll talk about how can you create a variable which will be having a name with a different type and different value. So now we know what variables are and how do we create them. So basically in the last video we have talked about how to create a variable with the help of the data type and the value as well. Now what are the other options we have? So we have worked with int, right? Do we have other options? So basically we have multiple data types to store your data. So let's talk about the first thing, which is data type. In fact, there are two categories of data type which we can normally work with. One is called primitive, and the other one we'll keep it question mark. Okay, at this point we are not discussing about the second one. The first one is primitive. So basically in Java we have a lot of inbuilt data types available which you can use, and they are primitive. Now primitive simply means it is simple, basic to use, to work with. So whatever data you normally have, normally we work with numbers, we work with point values, we work with characters, we work with true or false. Now for that we have this category. So we can divide primitive into 4 categories here. The first one is of type integers. The second one we have is floating point value basically, so we can say float. And the third one is characters. And the fourth one is your boolean. Of course, when you divide this, we have more categories to it, but in general we have 4. We have integer, float, character, and boolean. Now when you say you want to store a range, a negative range to positive range, numbers, normal numbers or natural numbers you can say. In fact, we can call them as integer itself because we are starting with negative value. So that goes into integer. Whenever you have point values, that goes into float value. Whenever you go with characters like A, B, or any regional characters you have all across the world, that goes into character. And then when it comes to true and false, we go with boolean. Now inside integer itself, we have multiple subtypes to it. We have a concept of byte, we have short, we have int, and we have long. For float, we have another option which is of double, and then of course we have float. And then char is characters are characters. So in characters we can have different type of characters. In boolean, the only values we can have is true and false. Okay. So example, if I go back to my code and if I want to create a different variable, this time let's say float. So I can just come back here. I can remove this section, and here I can say this: we are creating a float value. Now, how do we get a float value? So we can simply say float, and then we can have a value. Let's say 7, or name to it, right? So name we can have is marks. Of course, we don't put in marks, but let's go with marks. And then we can go with a value. Now floating point values will be having a dot, right? So we can say 6.5, something like this. So float marks equal to 6.5. That makes sense, right? Okay, cool. In the same way, we have also mentioned we have subtypes to integer. We can have a byte format. But why do we need all these extra formats? For that, let's understand some basic concept. Now basically when we talk about integers itself, so if we talk about integer, we have some sections to it. So integer will have different part. So integer will have different sizes. Example, if you want to store a normal number, so in general we always go with int, and int has its own value. Okay, so when you talk about int, the size of int is 4 bytes. So we can say 32 bits, and then it has a range to it. And you can find the range on the screen. We also have a format which is, let's say if you want to store a bigger value, a very big value. So in this case, I mean, of course, if a value goes beyond that range, we have to go for a long format. Now long supports 8 bytes. Now, of course, when you have more bytes, it will occupy more values, and it will have a range. So of course, you can find the range on the screen. Now, what if you want to store a smaller number? So of course, int provides you that range, but then what if you want to save memory? You don't want to go for int range. In that case, we can have a short value. Now short is only 2 bytes. So if you want to have a limited range, you can find the range on the screen. And then we have the next range, which is of byte. Now byte is only 1 byte. Okay, so 8 bits. And whatever you want to store, you can store in that. Of course, it has its own range. Now, how do we calculate this range? So we do with the help of, it goes from negative values, right? So it is minus 2 raised to 8 to plus 2 raised to 8 minus 1. Okay, so which is 2 raised to 8 is what? It is, oh, we're starting with negative value, right? So it is 2 raised to 7 and 2 raised to 7. And the range, so how do we calculate 2 raised to 7 is 128. So it starts from minus 128 to plus 127. So 128 minus 1, 127. That's how you can calculate the range for all the other numbers. And you can, of course, you have seen that on the screen. So this is how we can use integer. So which one to use? So if you want to get a variable which will have a value, let's say 5 or 6 or maximum 127, you can go for byte. Now how do we get that variable? It's very simple. You use a type which is byte. You specify a variable name, let's say num, and you assign a value which is 8 or any other value which you want. Of course, that should be in a range, and that's how you can store it. Now what if you want to have a float value? Now float actually gives you 2 different values or 2 different types. Now it depends upon which programming language you have worked with before. Example, if you have ever worked with C, by default we have a value which is float. So by default we have float there. Now float only takes 4 bytes and it has its own values you can store. And then we also have an option of double, which takes 8 bytes. Now what do you think, which will be the default value? Think about it. Will it be float or double by default in Java? So default is actually double, not float. Okay. Now why double is because, see, float are good when you have limited values, when you have limited precision, because after your point value, example, if you have a value which is 126.5678 or whatever values you have, so float will have a limited precision set here. But on the other hand, double will have a longer one, right? So double can have more values. So whenever you perform scientific calculations or any kind of calculation, if you wanted to make it fast and it would support maximum precision, you can use double there, right? And by default, Java supports double. So if you want to create a variable which is with double, so you can simply say double, and you can create a variable named num is equal to, you can assign a value which is 5.6 or whatever value you want to assign. But how about float? Now, if you try that with float, it may not work. Example, if you say float, and if you say a variable name which is num and equal to, so when you try to assign 5.6, it will give you error. It's because by default, the moment you say point values, it will be considered as double. And if you want to say, hey, I don't want to work with double, I want to work with float. So explicitly, you have to mention, hey, okay, this is actually double value. So this is actually a float value, so you can put a f there, right? So 5.6f, that's how you define it's a float value. For double, you don't have to mention that. Now, how about character? So when you work with character, and in other languages, character will have a less bits, but in Java, it goes for 2 bytes. So in other languages like C, you have only 1 byte. It's because it normally occupies the integer range. It normally occupies the character range, ASCII values. But then in Java, we thought, hey, can we just have all the characters in the world, not just English, all the languages? So Java actually follows something called Unicode, not ASCII by default. It will support Unicode, and it has 2 bytes, which is 16 bits. So it has a bigger range, right? So this is a range it normally works with. So of course, you can work with any type of values you have, and any type of characters basically you have. And if you want to define a character variable, it's very simple. You say char, and then you specify the variable name, let's say character, or C equal to whatever character you want to assign. Let's say I want to assign a character which is K. Now in this case, if you want to work with a character, can we use double quotes? Now double quotes is for string, right? For character, we have to use single quote, and you have to put your character into single quote. And remember, it will only accept a single character. And next we have of type Boolean. So if you want to work with Boolean, now Boolean will only accept true or false. Okay, there's no subtypes here, only true or false. Now one thing you have to remember, now in other languages, it may represent it with the help of 1 and 0. In Java, we don't do that. So in Java, it doesn't work with 0 and 1, it is true and false. So it's not like true is 1 and false is 0. It's only true and false. It is normally used for conditions. If you want to check for a condition, based on that, you will do something. That's why we can use true and false. I mean, think about computers. When you say computer can think, it's because of this true or false. Okay. And how do we define a Boolean variable? So it's very simple. You use a keyword called bool, and then you mention a variable name, let's say b is equal to, you either assign true or false. Okay, you don't have to put a single quote or double quote because they are itself keywords. So these are the options we have. Now, if you want to see this in a code, it's very simple. You can just go back here and say, okay, byte is done. Let's create some variables with different type. So int we have already seen, so we'll say num1. This is how you assign integer value. But if you want to go with a byte, so you can say byte b, or we'll say by equal to, now can I assign a value which is 129? You can see it will give you, if I do that, and if I go back to my compiler, compile, you can see it will give you error. It says possible lossy conversion from int to byte. So this is int, which is 129. It will, if you try to save that in a byte, it will not work. But what if you say 127? That's the last value you can store. Compile. Okay, there is a problem with result. Let me just remove this section. And compile, no issue. Okay, so this is how you save byte value. What if you want to store short? So you can say short sh equal to, and you can assign value which is, let's say 558. Any number doesn't matter. And then what if you want to work with long? So long L is equal to. Now when you work with long, remember this thing. After every number for long, you have to put a L at the end to specify that's a long number. The thing we have done with float, we have to put F in the same way long needs L. And what if you can do here with float? So you can say float F is equal to 5.8. Okay, let's try with 5.8 and let's see what happens if you try to compile this. Compile. Okay, you can see it is giving you error. It says again possible lossy conversion from double to float, because by default 5.8 is double. If you want to mention, hey, that's not double, that's float, you can put a F at the end. That should work. You can work with double as well. Double D is equal to 5.8, same value, but this time it is double. And then what else we can work with? We can work with character as well. So we can say char C is equal to, in single quote you can mention a character K. Then we can go for Boolean, which is Boolean in this case, and you can say B is equal to true. Simple stuff, right? Let's try to compile this. Of course, we are not printing anything, so don't expect anything on the console. Compile, or there's an error. It says cannot find symbol bool. Okay, my bad, it is Boolean. The only problem is when you work with multiple languages at the same time, you get confused somewhere. So that's Boolean, not bool. So in the notes as well, I need to change it. So I will say this is Boolean. Cool. And now let's compile this once again. Compile. Okay, there's no problem. And let's run this. Of course, it will run, but then you will not see any output, right? No output because we're not printing anything. So yeah, that's about this. We have different type of data types we can work with, and all these are inbuilt. Apart from this, we also have some more data types which we'll see later. They're not type of primitive, but this is primitive data types, and this is working. Okay, awesome. So now we know what variables are, what data types are, what a size or range of each data type here, and you don't have to by heart them. You will get used to it. The more practice you do with these variables, you will get used to when to use what. But what if I remove that single quote there? Let's try compile, and you can see we got an error. We can't even put double quotes there. It will give you error as well. And you can see you can't even put double quote. So you have to put single quote because that's what character represents. And the character can be numbered as well. So you can put a character here, which is 8, which is a character itself, right? Digits are also character, no error. Okay, so when you talk about data types and then values, what kind of values we can have? So example, if you talk about this 9 or this 8, these things are actually called literals, because they are literally the values, right? So what we can do is we can play with some literals here. Let's work with integers first, and we'll come back to this. So we are basically working with literals now. Okay. Now what kind of literals we can have? For example, we can have direct values. We have 9 here. And we can have any big value provided that goes into the range. So whatever range we have, if it's a part of the range, it will work. So we have all these are decimal values, right? So it will have a base 10. What if you want to work with base 2? Something like a binary format. Can we do this? Let's try. So I will say 0B101. So basically, if you want to put a binary number like 101, which is 5, so you can put B and then you can put a 0. Let me just try if this works. I will say system.out.println, and then let me print num1. Let's see if this works. Put a semicolon at the end. Compile. There's no issue. So let's run this code and let's see what's the output. And you can see we got 5. So yeah, that's the binary format works. What if you want to work with hexadecimal numbers? In this case, you can use X here, and let's put a number 7E. So E also supported, right? So let me just try, compile, run, and you can see we got 126. I don't even know if that's the correct answer, but you can verify. There's one more thing which we introduced later in Java, which is what if you have, let's say, this number? And trust me, I always get confused with number of zeros in any amount. Even if I mention a password or a PIN or account number, and whenever you have multiple zeros, I always get confused. So how do you count the number of zeros here? Of course, you can do it one by one. But in Java, we got this feature where you can put an underscore between numbers. If you want to differentiate them, it was easy to count, right? So you can see we are getting zeros and then we got underscore. Even this works. Let's try it out. Compile, run, and you can see we got the output. Of course, in the output, it will give you a normal number. But as a programmer, it helps you for the number of zeros you are entering there. So these are basically literals, right? Let's try with float this time. So let's say this float and we are saying num1, and then I want to assign a very different value. Can I assign, no, let's go with double just so that I can avoid that F at the end. And here I want to assign, let's say 56. So basically when you try to assign an integer value to float, it will work, or double, it will work because integer will get converted into double automatically when you save it, okay? Okay, that makes sense. Can I have different value? Let's say I want to store a very big number. So I can actually use epsilon e in between. I can say 10, 12 e raised to 10. And let's see if that works. Compile, run. And you can see we got the value as well here. And it will adjust automatically based on its own implementation. So it is assigning 1, 0 here. So there's basically 12 into 10 raised to 10, or 12 into 10 into 10 raised to 10. And then it will adjust its according to its own way. And we have already discussed about the Boolean. It is only true and false. There is no 1 and 0 there. Don't try to assign 1. It will give you error. Let's try. Compile. Okay, you can see we got the error. It says int cannot be converted to Boolean. Remove this. Okay, how about character? Let's try. So when I say character, let's just see, and I want to assign a character here, which is in single quote, let's say A. Now, when you try to print the character, this will work. Compile and run, you can see we got A. Now basically character can be also treated as integer. That's right, we can actually perform operations. So I can say C is equal to C plus 1. So what I'm doing is I'm incrementing C. I'm enhancing the value of it. If it is a normal value, it's a 5, it will become 6. Okay, what if you want to do an increment? Of course, we'll discuss this later, what increment means, but you can say plus plus to increment the value. And if you try that with character, compile, you can see that it is getting compiled. And if I try to run this code, we got A, because we are printing it there. My bad, I would just have to put that here. So first we have to increment the value, then we can print it. So C++ simply means we are changing the value. Okay, this is not a language I'm talking about, the operation on a C variable. And you can see we got B. So when you increment the value of A, it becomes C. It becomes B. Cool. So basically all these things are called literals. In fact, there's a concept of string literals as well, where example, when you talked about hello world, that's a string, that's string literal. In this video, we'll talk about type conversion and type casting. So in the previous video, we have talked about variables, how to create a variable. And then one thing is for sure, in fact, two things. Every variable needs a name, so we have talked about it. And every variable needs a type as well. So if you want to get a variable for numbers, you will say int, float, double, or long. In fact, we have subtypes as well for int. And then if you want to store a character, we can use char. If you want to store a boolean value, we have boolean option. And then we also have a string, which we'll talk about that later. At this point, we have a lot of different types. Now there's one confusion. What if you want to change the type of a variable? Can we really do that? So unfortunately we can't. We can't change the type of a variable, but then can you assign a value to the type? Example, let's say we have a variable which is of type byte. So I'm using a byte variable which is B, and it will have a value. Now of course we have talked about a range of byte as well. You can have maximum 127 plus 127. This is the max value you can accommodate here. But can you assign an integer value? That's a question. So what if you have a variable of type int A and the value of A is 256? Now what will happen if you try to assign this A value, which is 256, into B? Something like this. What if I say B is equal to A? So what I'm doing now is I'm assigning a value of integer to byte. Now unfortunately, this will not work. But what will work? The reverse will work. What if you have a variable which is A and then you're trying to assign a value which is B? This will work. So what happens is the type of A is integer, right? It has a bigger range and byte has a small range. So your compiler says, hey, you're trying to assign an integer value to byte, and at this point you might lose some data. So basically we are trying to convert it and it is narrowing it, right? So we are narrowing the size of it. On the other hand, if we talk about this operation, here we are widening it, because the range of byte is small and integer is a bigger one. So of course you can put a small items in a bigger box, but if you put a bigger item in a small box, it will not work, right? Okay, cool. So that makes sense, right? But then what if you really want to do it? You want to convert an integer value into byte. See, at this point, if the value of A is not 256, what if the value of A is, let's say, 12? Now, the value of A is 12, which can be accommodated in B as well. So at this point, even your compiler will say, hey, I don't know what your value of A is, but I will not allow you to store the value of A in B because A is integer and B is byte. So in this case, you can say, hey compiler, give me 1 second here. What you can do is you can say B is equal to, you can convert A. You can do a conversion by saying, you can give a bracket and you can mention the type, or in which type you want to convert. You can say byte and you can mention the variable name A. So what you're doing is you're converting integer value into the byte format. Okay. Now this concept is called casting. So basically this is actually a conversion, but explicitly you're doing it. So whenever you do explicit conversion, it is called casting. So when I say explicit, there should be implicit as well, right? And that is correct. We have some conversions which are implicit. Example, if you talk about this particular operation here, this is an implicit conversion. Basically, you're trying to store a byte value into an integer variable. So it becomes an integer when you assign it, right? So this is a conversion, okay? So when you do it explicitly, that is casting. When it is happening, if it is happening automatically, that is conversion. Now this makes sense, right? Now, is it means you can do it with anything? Not exactly. There are certain types. Example, you can't store a character value into a Boolean value. Okay, because Boolean only supports true and false and character supports all the characters. So you can't do those conversions. But if anything in the range of integer, float, double actually works. Example, we have talked about integer and byte. If it is long as well, that completely works. Now, what if you have a scenario where you want to store maybe of type a float value. Now let's say you have an integer variable here which is int, let's say x is equal to, and you're trying to assign a float value. Now float value is, let's say, 5.6. Of course I can create a float variable, I can assign this value to that, or maybe this is double because we don't have f. So let's say this is double, and then you're trying to assign that to an integer. Now what will happen is, in this case, even this will not work. So what you have to do is you have to convert it. So what I will do now is, let me just create a float variable here. So I will say float f is equal to 5.6, and remember you have to put f at the end. Now if you try to put f, it will not work. So what you have to do is you have to explicitly convert this value into integer. So what you're doing is you're assigning a float value to an integer, so you're converting it. Now what you will lose here, so at this point you will lose your point values. So whatever value you have in after that point, you will lose it. Example, the value of it is 5.6. So here when you convert that, it becomes 5. So in the x, the value you will be getting is only 5. Cool. So it makes sense, right? So for float, it will cut the value. But coming back to byte now, what will happen when you talk about byte here? What do you think? We don't have point values. So if you have a bigger number, example, let's say this is not 1, this is not 12. Let's say we have a bigger number here. And the bigger number is, let's say, 257. Now what will happen when you assign 257? Because the range ends at 127, you can't go beyond that, right? So in this case, it will use a concept of modulus, okay, or modulo operator. So what modulo will do is it will divide this number. So whenever you try to assign an integer value to byte, which we are doing here. So when you're trying to assign a integer value to a byte, it will convert that into modulo, which is, it will divide the number a, which is 257, and it will find the percentage, okay, so 257 percentage, which is a modulo symbol, and it will divide it with a range, okay, which is 256, because the complete range of byte is 256, right, from -128 to +127. And then the remainder you will get here is 1. Cool. So the answer here, when you try to do it with the 257, it will be 1. I will show you that in the code. So coming back to the code, let's try all this operation which we talked about. So what we'll do is we'll start with an integer value. We can say, or maybe we can start with byte. So we can say byte b is equal to, and maximum you can have is 127. Let's take that value, and let's try to print it here. So we can say system.out.println, and here let's print the value of b. So when you save that, and when you go back here, when you try to run this, so we say java c and hello.java, compilation done. Let's run this code. I can say java space, I have to run with the class file, which is hello, and you can see we got 127. Now what will happen if you try to do that with 257? It will not work. First of all, it will say error. You can see we got the error. It says incompatible types because it is integer type, now 257. Okay, so we can say 127 here. Now next what I'm going to do is I want to create an integer variable here, which is int n is equal to, and I can assign a value, maybe let's say a, because we have used that. So we'll say a, and then the value we are going to assign is of b. So can you assign a byte value to integer, because this is where you're doing converting. And if you try to print the value of a, let's try that. In fact, there's one more thing which came recently in Java. So basically, we always do 2 steps, right? First, you compile the code, and then you run the code, right? So you compile that with the help of Java C, and when you compile it, you say hello.java, and when you run it, you simply say Java and hello. You have to do 2 steps, right? So when you're into learning phase, why to do 2 steps? We can actually do in single step. Again, not recommended for a big project, or not even for a small project. Don't even try that in your company. For learning purpose, we are doing it. So basically, we got a shortcut. We can say Java space hello.java directly. Maybe it is getting influenced by other languages where you simply mention the command and a file name. No need to mention compile and run separate step. Let's try this, and you can see it works. So you can see we got 127. It is perfectly working. And just to show you that things are happening behind the scene, the value is getting changed. You can see we got 125. So from now, whenever you have single file, we'll use this. But remember, this is just a shortcut. Ultimately, behind the scene, we need to do this. Okay, I mean, when you build a project, first you have to compile the code, then run the code. This is a shortcut. And one more thing, this will work only in the recent version of Java, I guess from Java 14. If you have an older version of Java, this might not work. So if it's not working in your machine, that means you have an older version, upgrade your JDK version. Okay, cool. So now what I will do here is we can assign the value, right? But what if you have an integer value, let's say int k, and now you are trying to assign or maybe let's get a byte value. Byte k is equal to a, and let's comment this section. Instead of saying b, I want to assign a value which is 257. Now, even if you have a smaller value, let's say 12, even this will not work, because ultimately the value, the type of a is integer, right? You can't assign an integer to a byte format. And if you run this code, you can say it will give you error. It will say incompatible types. So we got one way, which is you can just cast it with byte. So we are doing a typecasting here. So when you run this code now, it will work. You can say we got 12. Now we got 12 because it is in a range of byte. What happens when you have a bigger value, which is 257? Now this is out of range, right? So you can come back here, run, and you can see we got 1. As I mentioned before, it will perform a modulus operation, which is actually finding the remainder. So it will divide this number by the byte range, which is 256. And it will find the remainder, which is 1. I hope this makes sense, right? So we were able to do the byte conversion, int conversion. This is working. Let's try with float now. So let's say we have a float value, which is f, and the value of float is 5.6, f at the end. Because whenever you get a float variable, you have to put f at the end. And then we can create a integer value. We can say int, let's say this time we'll go for t, doesn't matter what variable name you use. And then if you try to put f there, and if you try to print the value of t, let's see what happens. You can see we got error. Again, the same thing, it says there might be loss of the value from this conversion, but then I want to do it. I want to convert that. So we can put a casting again, and we can say float here. And if you try to run this code, sorry, you're trying to convert that into integer, right? What's wrong with me? And let's try now. And you can see we got 5. So we lost that 0.6 there. Now this concept of casting is actually very important when you start working on the oops concept, object, and the further concept. This casting will be required there as well. At this point, we are doing casting on primitive values, but later on we'll also work with objects. Okay, now we have talked about casting. So what is conversion? So conversion is automatic casting, or we can say conversion is automatic conversion, and casting is explicit conversion. So when you specify something, it is explicit. Cool. Now there's one more concept, which is type promotion. So what do you mean by type promotion? So let's say we have a byte value, and the value of a byte, let's say b, or maybe let's say a, and the value is 10 here. Okay, and then we got a byte which is b is equal to 20. And then when you perform the operation, maybe this should be 120, right? Let's say this is 30. Now when you perform an operation on this, let's say a into b. Now whenever you do a into b, it is what, 300, right? So when you say 300 here, it is going out of byte. Now can you save that into integer? Can I say int result is equal to a into b? Now what is happening here? You're performing an operation on byte. So when you say byte multiplied by byte, it should be byte, right? But the problem is this value will go out of range. So Java says, hey, we will promote you. So this value will be promoted into an integer value. Okay, and you can store that into integer. So this is called type promotions. Let's run this, and you can see we got an error because we are printing t here. Let's print result and run, and you can see we got 300. So I hope it makes sense what is type conversion and casting. In this video, let's talk about operators. That's right, you can perform operations on different values. In fact, we have done that before, but let's expand the examples and more operators. So basically, we can add two numbers, we can subtract two numbers, we can divide two numbers, we can multiply two numbers, and also we can perform an operation so that you will get a remainder of an operation. Okay, so when you divide a number, and if you only want a remainder, we can do that as well. So let me show you those things with code here. So what I will do now is, first of all, let's create two variables, and of course we can name any variable name, but let's go with integer num1, and the value it will have, let's say 7. And then let's have one more variable here, which is, let's say 5, num2 is 5, and then I can perform some operation, and I can save that operation in a result. So let's say if you want to add two numbers, we can do that. We can save the output in result, and then to perform the operation, we can use a plus operator. That's right, we can actually use a plus operator to add two numbers. And then once you have done that, we can simply come back here. We can say system.out.println, and here we can print the result, and just to see if it is working. And as we discussed before, this is not a good way of running a code. You have to first compile the code, then run. But we got a shortcut. I can simply use Java space file name with .java, say enter, and we got 12. So when you say 7 plus 5, we got 12. Cool. Now what I will do is, so we can add two numbers. What about subtraction? Let's try that. So I will say minus symbol and run. You can see we got 2, so it is working. So you can add two numbers, we can subtract two numbers. How about multiplication? We can do that. So we can say star num1 into num2. Come back here, run, you can see we got 35. So 7 into 5 is 35. That is working. How about division? Let's try that. So the moment I say division, we have to use a slash. Okay, so we don't have a division. In fact, that's how we do it, right? We say underscore or something with a slash. So yeah, we got slash, let's try, and you can see we got 1. That's right. 1 is a quotient here, right? So when you divide 7 by 5, you get two things. 1 is a quotient, which is 1. And then you will also get a remainder. Now, in this case, when you use slash, you will only get a quotient, not a remainder. So how will you get a remainder? In that case, you have to use a modulus operator. So we can use, when you say percentage symbol like this, it is a modulus operator. What it will give you is only a remainder. Okay. So if I run this code, you can see we got 2. 2 is a remainder here, right? Now we can use any complex numbers as well, whatever number you want to perform with. And I would suggest you to try certain examples so that you will get used to these operations. Now all this operation actually makes sense, right? These are very simple stuff to understand. Can we use some other operators as well? Let's try. What I will do now is let me just remove this result for time being, or maybe I can just comment this part. I also don't need this num2. Let me only focus on the first variable, which is num1. Now let's say I want to add this num1 by 2. Okay, so basically the value of num1 is 7. I want to increment the value by 2. So what we can do is we can say num1 is equal to. So basically we have to use num1, which is num1 in this case, and we'll add a value to it, which is 2. And then whatever new value you will generate after this will be assigned to num1. Okay, that looks cool, right? Let's try this. I will say num1. Print num1 and let's run this code. You can see we got 9. So this is working. So 7 became 9. So it is working, right? Now, when you know that you are adding the number by itself, okay, what you can do is you can just use a shortcut. Now, what that shortcut says is, let me just comment this section here and let's write it fresh here. So we'll say num1. See, you want to increment the value of num1 by 2, right? You want to add itself by 2. So you can say, I want to add myself. But how much value? So I have to say equal to 2. So what we are saying is we want to increment num1 by 2. Even this should work. Let's try. Oh, we got an error because I forgot the semicolon. And let me just clear this, run. And you can see we got 9. So this is working. Cool. Now it's not just for addition. We can do that for any other operation. Maybe you want to subtract a number by 2. So we can say subtract equal to 2. So it will reduce the value by 2. You can see we got 5. We can multiply with some other number. Maybe I want to multiply the same number with another number and assign it. So we got 56, 7 into 8 to 56. We can divide as well. And so you can use slash and all the operators which you have. Awesome. So this is shorthand. Now going back to the addition operator, and then let's say if you want to add it by 2, we can simply mention the value 2, right? We can also add it by 1. So in this case, if you say add it by 1, the value of num1 is 7, and then you are adding it by 1, you can see we got 8. Now, in fact, there's a shortcut for this as well. What you can do is instead of using num plus equal to 1, you can also say num1 plus plus. Even this is possible. Let's remove the space in between. So even this is possible. You can say num1 plus plus, which is incrementing. So what we are doing here is something called increment. And if you run this code, you can see we got 8. So this operation, let me just make it 1. So all these operations are similar. Okay, so why I'm saying similar, why not same? We'll discuss that in some time, but this is similar. And maybe we have done that before as well when we talked about characters. You know, we remember C++, we've done that. So yeah, we are incrementing it as well. Now, not just incrementing, we can do decrement as well. So instead of saying num plus plus, we can also say num minus minus. So what we are doing now is decrement. So when you say plus plus, that is increment. Let me comment this part. And here I will say num minus minus. Now, why do you have to comment this part? I want to run this. So we can say num minus minus. Let's run this code. See if this works. And you can see we got 6. So that's how you can perform this addition, subtraction, multiplication, division, and increment, decrement. In fact, we have also talked about modulus, which is for finding the remainder. Okay. Now that was about increment, decrement, right? We have talked about that. Now, instead of using plus plus, we can actually use something called, let me just write it in comment. So instead of saying num1 plus plus, we can also say plus plus num1. Just to simplify this example, instead of saying num1 everywhere, let's say num, so that maybe you will get confused by that one extra symbol there, which is 1. Just ignore all this operation. Just focus on this part, which is num and num. Also remove this. Also remove this. Let's see if this is working. Okay, this is working. So basically, we can also say, instead of saying num plus plus, we can also say plus plus num. Now, what's the difference between these two? Even this also works. Let me just try that and show you. You can see we got 8. We are incrementing the value. Even this will give you 8. But what's the difference? What's the difference between writing this afterwards and writing before the variable? So basically, we have a different names to it. So whenever you perform operation after the variable, it is for increment or decrement. So when you do it post, we say it is post increment. And when you do before the variable, it is called pre-increment. Okay, so when we are doing it afterwards, we say post increment. When we say before, it is doing pre-increment. Now you might be thinking, hey, ultimately the value is same, right? So even if you even if you do this or this, both will increment the value. Then why we have two different syntax for it? Why not just simply one? The answer is, it behaves differently when you try to assign a value, when you try to fetch the value. Let me repeat. These two operations will behave differently when you try to fetch the value. Okay, let me tell you what I'm talking about. Let me show you it here. Let's come back here. And let's say I have a different variable, which is int. And then I'm storing that in result. And what I'm storing is num, or maybe I will say plus plus num. Okay. Now think about this, and maybe you can pause the video or whatever you want to do. Just think about what will be the value of result. Okay, I will say result here to print. And maybe you have done your thinking. Let's run this. And you can see we got 8. So what is happening here is the initial value of num is 7, and then you are saying plus plus num. That means you are incrementing it. That incremented value will be assigned to result. Okay. And then you got result, which is 8. Okay. So initially I've also mentioned that this 2 will be incrementing. So we can also say num plus plus. Even this should be doing the same thing, right? Let's try. Oh, there's a twist here. So plus plus num and num plus plus are not same. I mean, it works same if they're individual statement, but when you try to fetch the value from them, when they are performing the operation, they behave differently. So let's understand why it is called pre-increment and why it is called post-increment. So whenever we use assignment operator with this operation, what it will do is, it will check, hey, we have an operation which is num plus plus, but that's a post increment. So first it will fetch the value of num. Let me repeat. It will first fetch the value and then increment. In fact, it looks like one statement, but we have two statements here, right? In fact, we have this statement here, num1 equal to num plus 1. So what it will do is, it will first fetch the value of num, which is 7 in this case, and then it will increment the value of num and it will make it 8. Okay. But then what is assigned to result is 7 itself. And then you are printing that 7 here. Okay. But what will happen when you say, let me just write it here. So we'll say int result is equal to plus plus num. In this case, what will happen is it will first increment and then fetch the value. Okay. So it will first increment itself and then it will fetch the value. And that is what is going into result. I hope this makes sense, right? So this is how your code works when you say plus plus num and num plus plus. In fact, we'll do some more operations with this once we get started, and it will make much more sense later. So in the operators, we have talked about arithmetic operators till this point. So whatever operation we have done, it is for the arithmetic purpose, right? Addition, subtraction, multiplication, division. But what if you want to compare two values? What if you want to have compound conditions? So we are talking about operators, right? So we have talked about arithmetic operators where we can do calculations, we can add two numbers, we can subtract two numbers. In fact, we have also seen how do we increment a value and decrement, right? Now it's time to enhance and go towards something called relational operators. In real world, what we do is we basically have, we compare things, right? So it can be comparing two values, and if you can check with the help of less than, you can check with the help of greater than, you can also compare with two values, right? If they are equal or not. So we use something called equal to there, right? What if you want to negate something? What if you want to find a negative weight? Example, if you have a true value, maybe you want to make it false. So in that case, we also have to move from true to false, right? So basically, we want to implement this with the help of operators in programming language. Now, specific to Java, if you talk about, we have different operators. We can use less than to compare with the help of less than or less than. the first value should be less than second value. If that is true, of course, you will get true value. We can also check for greater than, we can also check for equal to. Now, the only difference is when you talk about equal to, in programming, specifically for Java, equal to means assignment operator. Example, let's say, if you have a value which is 5 and you want to assign that to a particular variable, let's say x, so you say x equal to 5. So this equal to symbol here actually becomes your assignment operator. But what we want here is we want to compare two values, right? So that's why we use double equal to. So in programming, in Java, we use double equal to compare two values. What if you want to check if two values are not equal? In that case, we can say exclamation and equal to. Okay, that's what you say, it is not equal to. So this is comparing for equal and this is comparing for not equal. And this is of course less than, this is greater than. And you can also combine. Example, if you remember in mathematics, we use this symbol which is less than equal to. In the same way, of course, we don't have this key on the keyboard. So we have to use less than, okay. So we have to use less than equal to for this particular combination. We can also say greater than equal to, right? So we can use all this combination which comes up as a part of a relational operator. Now, basically, when you compare these two values, example, let's say if I want to compare if 7 is less than 5, so this will return you a value which is true or false. So it will be either true or false. Of course, we got a static value here, which is 7 and 5. So the output for this will be, of course, false. But if you say 5 is less than 6, yes, that's true. So that's how you define, that's how you compare two values, and that's how you get the output. The point to remember here is the output which you're going to receive is a Boolean value, okay? Now, how do we implement that in a code? So let's go for it. So let's say we have our code here, and in this, what I'm gonna do is I have two values, let's say. Integer, I can say x equal to 6, and then I got y is equal to 5, and now I want to compare these two values. The way you can do that is, of course, when you compare these two values, you will get a Boolean value. So I can say Boolean, I can say result is equal to. Now, how do you store a value and how do you compare? So first of all, storing is easy. You can just assign the value, but how will you compare? In that case, you can say x is less than y, and of course that's available on keyboard, so you can directly use it. And what I want to do is I just want to print the output here. So I can say system.out.println just for printing stuff, and then I can just say result. Now, the moment you say result, it will print the output, and of course you have to compile this code. And the way you can do that is by saying javac demo.java, enter. Okay, there is no issue with the compiling because the syntax looks good. And now I will just run this. I will say java demo, enter, and you can see we got false. Now, why we got false is because the value for x is 6 and the value for y is 5. So the first value is not less than second value, and that's why we got false. But if you say greater than symbol here, it actually makes sense because that's remember, every time you make a change, first you have to compile the code and then you can run the code, and you can see we got true this time. So basically that's how you can compare two values and you can print it. But what if these two values are equal? So let's say we got 6 and 6, and now if we try to run this code, of course compile and run, you can see we got false. Okay, but then they are equal, right? So maybe I want to check if two values, if the first value should be either greater or it should be equal. So we can put that equal to symbol here as already discussed, and now I can just compile and run, and you can see we got true. So this is working. We can also check for less than, even that works because it's equal, right? And anyway, we have equal, so it should work. So we got true. We can also check if two values are not equal. Example, let's say I just want to make sure that x and y are not same. And the way you can do that here is by saying not equal to. So when we say not, it simply means it will, when you say exclamation, it simply means not. So not equal to y. And with this, if I try to compile and run, you can see we got true. So even this is working. But what if you don't want to check for less than and greater than, you want to check if the two values are exactly equal. So in this case, normally in mathematics, we use equal to, but that will not work here. So you have to use double equal to. So you're comparing x with y, and they should be equal. Clear the screen, compile and run, and you can see we got false. The reason we got false is because we have both the different values. So if I make it same now, and if I run this code, compile and run, and you can see we got true. So basically, we have different operators, and this will be used a lot in the upcoming sessions. So it doesn't matter whatever programming you do. See, when you say your computer has a brain, we have to decide based on some values. Of course, I have just checked it with integer. You can try it with float as well. In fact, maybe I can try with double. So I can simply say double here, and I can say this is 8.8, and I can say double, which is, let's say, 6, maybe 9.8, and I can just check if they are less than equal to. And of course, I want you to try different values there, and compile, no issue, run, and you can see we got true. But if you check with the greater than symbol, this should give you false, and we got false. So basically, whenever you have a primitive value, this actually works. Maybe once we start with string, we also try to compare the string values, and let's see how that turns out to be. But this is how you do your relational and relational operator checking with the help of relational operators. We got less than, greater than, equal to symbol, which is double equal to, not equal to, that's one. Yeah, so this makes sense, right? But what if you have two conditions? Example, let's say I got this values, and now I have int a equal to 8 and int b equal to 6. So I want to check if, I want this x to be less than y, and I also want this a to be less than b. I want to check both the operation. And the thing is, when we say I want to check both the things should be true, then only it should print true. How will you do that? How will you combine two different operations or two different checkings? So we are done with the arithmetic operators and relational operators, right? Then we had one question. What if you have two relational operators and which will result in true or false, right? And then you want to combine them. So you want one true or false out of 2 or 3 true or false. So what I'm saying is, let's say I have two variables here, which is x, y, and also we have one more combination, which is a and b. And then I want to check if, I want x to be less than y, and I want a to be greater than b. This might result in true and false, or it might result in true and false. What I want is the output of, I want output of this two combined can be either true or false, but I want the combined output, irrespective if they are true or false individually. So how do I combine this? Now, to combine these two different conditions, we can use a logical operator in between. Example, this logical operator can be and, or, and the second option is or. So it can be and or. Now, what exactly it means? See, if you want that your output to be true, so let's say if you want your output to be true, so you can say, hey, I want both of this to be true, then only I want true. Or you can say, if any of this can be true, I want it to be true. Now, this is very important in terms of computation. So when you say your computer is smart, it's because of a computer can decide based on multiple conditions. So to do that, we use something called a logical operators. So what we do is, again, this concept is coming from mathematics. It's not a programming concept. It is coming from mathematics, where you can use something called AND operator. We can use OR operator, or we can use a NOT operator, which is with exclamation. So the AND operator in programming, we represent that with the help of and the OR operator. So we use ampersand for and we use a pipe for OR. So we can use ampersand, which is and, we can use pipe operator, which is or we can use the exclamation mark for not. Okay, so how do we decide what could be the output of two operations? So let's say the first operation gives you true, the second operation also gives you true. So maybe we can do that with the help of these two conditions. If both are true, then what should be the output? So the output will be true. Again, I'm talking about in terms of AND operation. If one is true, one is false, it is false. If one is false, the first one is false, second is true, again it is false. And if you have both of them as false, again it will give you false. Now when you want such type of output, when if both are true, then only it should be true. Then we can use something called an AND operation here. But what if you have a different set of things in your mind? Let me just divide this, and the second set would be, let's say, if the first one is true and second one is also true, you will get true. If the second one is true, sorry, the first one is true, second one is false, it will give you true. If the first one is false, second is true, it will give you true. And if both are false, it will give you false. If you have a condition or if you have a requirement where if any of them is true, then it should be true. So example, if you can see, if any of one, so of course both are true, that's great. But even if you have one true, that's true. Even if you have one true, that's true. Even if you have one true, that's true, right? But if you have both false, then it will be false. Now, if you compare it with this AND, when you have both true, it will give you true. If any of them is false, you can see that if there's a false, you will get a false here. So this is your AND and OR. So that's how you can combine. We have one more here, which is NOT. Now, NOT basically used to reverse the thing. Example, if you have true, and if you want the output to be false, and if you have false, and if the output you want is true, then you will apply a NOT operation. Now, apart from this, we have one more, which we have not talked about, which is XOR. Again, we'll talk about that in some time. But then we have three basic operations here. We have AND, OR, and NOT. So basically how you combine this, if you want to do that in programming, of course, you can also use AND operator or pipe, or you can use NOT directly. The other option you have is something called a short circuit. So instead of using AND, you can use double AND. Instead of using OR, you can use double OR. And NOT is as it is, we don't have to do NOTs there. Now what's the use of this? So first of all, let's talk about AND. So let's say if you have X is greater than Y, and if you say AND here, and you can say A is less than B. So we have these two conditions here, and I want both them to be true, and that's where you want the output to be true. So example, if you have a Boolean value, which is R here, so you can say R is equal to X is greater than Y, and A is greater than B. If in this case, if both are true, the output is going to be true, right? But what if you use OR here? So if I remove this and if I put up OR here, if any of them is true, it will give you true. As simple as that, okay? Now, why do we call it a short circuit? The reason is, let's talk about OR. In OR, see, the point is, even if you have one true, the output would be true, right? So if the first condition itself is true, it will not even check for the second one. Beauty, right? I mean, you're saving your time. That's why it's called short circuit. You are saving the time. You're taking a shortcut. And you will say, hey, then what happens when you have AND here? So let's say, let me put AND. Now in this case, even if, so let's say first one is true, of course it will check for the second one. But what if the first one is false? If the first one is false, it will not even check for the second one because the output is going to be false, right? So that is why it is called short circuit. Okay, so from this point, we are always going to use short circuits AND and OR instead of using a single ampersand. So it can be, you can say double ampersand for AND, double pipe for OR, and of course NOT will remain NOT. So example, let's say if you already have a Boolean value which is R, so I can say R, and if you want to save that value in S, so whatever value of R you will get, you will save that in S. Example, if R is T, S will be T. But what if you put a ampersand here? But what if you put a exclamation here? So in this case, if this is true, if R is true, it will give you false. It will give you a reverse value. And this is very beneficial when you start working with the project where you have a data, and if you want to do something related to that data. So based on the data, you will change you will do something, you will change the condition, all those stuff. Okay, this thing looks cool here, but how will you implement this in the actual code? That's what we're going to see now. So if you can see, of course I have to go with the same variables. I can say int x is equal to, let's say, 7. And in fact, yeah, let's do it on new line. And I will say int y is equal to 5. So we got these two values. And then apart from this, I want two more variables, let's say a and b. So I will say int a is equal to 5 again, and int b is equal to 9. I'm just getting random numbers here. And what I want to do is, I want to save the data in a Boolean variable. So I will say Boolean result. And let's see what the value you're getting. So first I will declare it here, and I will also print the value for this. Okay, so basically we are trying to print result here, but then I want to perform some operation on this. So I can say if x is greater than y, okay, I'm just checking for one thing. And now you know we have done this multiple times. I will just compile this code and run, and you can see we got true because the value of x, which is 7, is greater than the value of y, which is 5. But then I want to put one more condition here, and I want both them to be true if I want to get the output as true. So what you can do is you can use ampersand, double ampersand here, and you can say A is greater than B. Now if you can see, the first condition is true, okay, this will give you true, but the second one, the second operation here will give you false. Now what do you think is the output? Think about this and let's see. Now the output which I'm expecting here is false. Let's try, and yeah, we got false. It's because the first one is false. So the first one is true, second one is false. So in this case, you both need to be true. Example, if I make this as less than, of course you should not change your condition, you should change your values, but just we are learning, right? So it's fine. Now let's compile this code and run, and you can see we got true. Since both are true, it's true. But what if you use a pipe here? Now pipe simply means OR, right? So even if so let's say both the conditions are true now, and both the operations are true. Run, and you can see we got true. But what if, let me make the first one as false, right? So you can see we have 7 is greater than 5, so this will be false. But the second one is true, right? But still, if you compile this and run, and you can see we got true, right? So this is how you use AND and OR when you have multiple relation. Of course, you can add more. You can also add one more pipe here by saying the value of A should be greater than 1. That's your choice, how many pipes you want to add. Compile and run, and you can see it works. So this is how you use AND and OR. What about NOT operator here? So example, let's say I will only say A is greater than B. Now what do you think what the output is? So if I compile this code and run, and you can see we got false. That makes sense, right? Because the value of A is smaller than value of B. But what happens just before printing result? I'm saying not. So whatever value of result is, we are just doing the opposite of it. If this is true, it will give you false. If it is false, it will give you true. And if I compile and run, you can see we got true. It's because this was false, the earlier one's false, and now when I say exclamation result, it will give you true. So as I mentioned before, it's very important once we go forward towards conditions, if else, for loops. So there's multiple conditions or multiple operations which will result in true or false will be very helpful. In this video, we'll talk about conditional statements. Now, basically what happens, when you say your computer can think, of course, we have a lot of different technologies now. We have AI, ML, right, which can help your computer to think, right? We are saying AI will change the world. But if you go to very basic of AI or any computer, I can say AI is an advancement in terms of computer which can think. But if you can go to the base of it, we have one important thing, which is the flow is depend upon true or false. Example, let's say when you execute a code. So what happens is whenever you execute a code, the flow goes in this way. Let's say there's a flow going on and suddenly there's a point here. So that let's say at this point, so this is a flow of the code. And at this point you decide, okay, if the condition, if based on something, if it is true, I will go this way. If it is false, I will go this way. Or maybe based on some other condition, I will go this way. So what happens, your flow of your execution actually changes based on what you decide at that point. And even if you think about Tesla cars, which is maybe any driverless cars which moves, and based on some conditions, the speed will increase. Based on some condition, the speed will decrease. Based on some condition, the car will take a halt. What if there's an object in front of a car? At that point, the car will stop. Right? So this is a point where it's decide, hey, it's time to increase the speed of a car. So maybe you can say, based on some condition, let's increase the speed of a car, decrease the speed of a car, or stop the car. So based on some condition, you decide the another flow. Now, how will you do that in programming? And that's where we have this option of conditional statements. So what you do is you write statement, 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 and then you decide I will execute this bunch of statement based on some condition. So here we'll be having a condition. If the condition is true, and of course we have talked about Boolean values, we have seen relational operators, logical operators. If you get true, you will execute this particular block here, this block. If it is false, based on something, I will execute this set of lines, right? So should we execute this lines, or this lines will be based on your condition? Now the way you can do that in programming with the help of if else. Now this is similar to most of the languages. If you're coming from any other language, maybe you have seen this. If not, don't worry. I will talk about if else in this particular video. To understand that, let's head towards our code here. And as you can see, we have a demo code, and basically we're using the same file here. I want to basically do something based on a condition. So let's say I have a value of x here, which is 8, okay? A simple value. Maybe I want to print hello or bye based on some condition. So I will simply say system.out.println, and I will print x here. Okay. In fact, I want to print hello. And then I also want to print bye, so I can just reuse the code which I've written here with a proper indentation. Yeah. And then I want to say bye. Now, of course, if you execute this particular code here, if I say demo.java and run, you can see we got hello and bye both. What I want to do is I don't want to execute both the statements. I want to execute hello based on some condition. If that condition is false, I don't want to execute hello. I want to execute the bye statement. So at this point, I want to decide. Now, based on what? So for this example, I want to test based on the value of x. So I can say if the value of x is, let's say, greater than 10. Maybe I'm just taking an example here. If the value of x is greater than 10, in that case, I want to print hello. So, and then if it is false, I want to execute the bye. Okay. So maybe at this point, let me just comment this section. Let's say I just want to print hello only when the value of x is more than 10. Okay. And to start with, let me set the value of x as 18, which is greater than 10. So what I want is at this point, we can dry run this. We can say, okay, the value of x is 18. So if you go for the condition, so if is a condition here, or it's a condition statement, it will check the point here which you mentioned, or with the condition which you mentioned. If it is true, it will execute this statement, or it will not execute this statement. Now, of course, that's true. So if you go back here and compile and run, you can see we got hello. So this is basically the syntax for if. So how with the syntax, we have to use a keyword called if, and then in the bracket, in the round bracket, we have to mention the condition. See, ultimately, if is not concerned what type of operation you're doing here. If is just concerned, is it true or false? So even if you give a true here, if is basically happy. Okay, so if don't want a operation there, if says you give me true or false, I will execute. Example, if I say false here, and if I compile, run, you can see it is not printing hello. Why it is not printing hello is because we are saying false. So when if sees false here, it says, okay, I don't have to execute the block, whatever is written under if. Okay, so there's a space here if you can see. Again, that is optional. Even if you remove that, that perfectly works because Java is not dependent on any indentation. By any chance, if you're coming from Python, in Python we do that. We give a tab to specify that it's a part of the if block. In Java, we don't do that. Okay, I could have simply used a meme from Avengers. You know, it says we don't do that here. Okay, anyway, so you can see we got false and we are printing hello. That perfectly works. Of course, it is not working because we got false. But if you make it true, it will surely execute, compile, run, and you can see we got hello, right? Now, what if I just want to go back to my condition? The value of x should be greater than 10. And for this as well, of course, we want the value to be true and it should print hello, and it's working. But what if the value of x is not 18, it's 8, which is false, right? 8 is not greater than 10. So it will give you false, and that's where you will not see hello. And you can see we don't have hello. Okay, so that's how you can use if. Of course, you can put multiple conditions here. If you remember, we have talked about logical operators. So we can say the value of x should be greater than 10, and I want one more operator. And so I want two conditions basically. And I want x to be less than 20. So I want the value to be in between 11 to 20. I want 20 to be included. So I will say equal to. So the range now, okay, we can also comment something in programming with the help of double slash, which will not be read by the programming or the compiler. So the accepted value for x now is from 11 to 20. Because we are saying greater than 10, which is the value above 10, which is 11, and less than equal to 20, which is including 20. Okay, and now I'm saying and here, and let's make it 18 again. So if you can see, it will surely work, and we got hello, right? So we can basically put multiple conditions. But what if the value of x is 8, or maybe I can say 28, which is not less than 20? So this is true. X is greater than 10. That is true. But x is less than equal to 20. No, that's not true. So this will result in true, and this will result in false. So what do you think the end result would be? So true and false will give you false. Remember, we have talked about that in some table. In fact, that table is called as a truth table. Okay. So now what I want to do is, if it is not printing hello, I want to print by. So I can just remove this. And if I compile this code and if I run this code, you can see we got by. Hello, I mean the hello is not there because the condition is false. But what if I make it 18 now? Of course, that's true. So what I want to do is I just want to print hello. I don't want to print by, because if you run this code and if you see the output, we got hello and by both. We don't want a by in this case. So what you can do is, if you want either this or this, you can use one more thing here, one more keyword which is called else. So normally if else works together. You can also write if alone, or you can say if else. Okay. So there's a compulsion to have if when you want to use else. Okay. Else cannot be alone. Okay, that works. And now if I compile this code and run, you can see we got hello. But what if you make it 28? At this point, it will only go for compile run. You can see we got by. So that's how basically we can use if else. So we have if, we check for the condition, and then we can also write else. In fact, in the next video, let's try to do one more example here. So let's say I have the value of x as, let's say 5, and I have a value which is y, which is 7. Okay, so we got two values, and maybe these two values are coming from the user. So what I want to do is I want to print the maximum of these two. So if x is greater than y, I want to print the value of x. If y is greater than x, I want to print the value of y. So how do we do it? So basically I want to print the value of x and y. So I can say system.out.println, and I want to print the value of x. And let me just reuse the code. I want to print the value of y. But if I just try to print this without checking any condition, it will print both. What I want to print is, I want to print the greatest number from 5 and 7. So in this case, of course, this is a very simple examples, and I'm on purpose taking simple examples is because at this point, it's important for you to understand the concept, not the complex operation, right? So what I can do is I want to execute either this statement or this statement. So whenever you have this condition where you want to execute only one statement or some block of statements, always go for if else. So I can say if, and I can check if x is greater than y, that's what we are checking, right? If this is true, I want to execute this particular statement. Else, I want to execute this statement. That's simple, right? So that's how we can use if else. And if I compile and run, you can see we got 7. But if you change the value, let's say if I make the value of x as 8, of course the output should be 8, and that's what we got. Now one thing to remember here, whenever you have one statement under if or else, you don't need the curly brackets. And you can see we don't have it. But what if you have multiple statements? Example, let's say here, the way we are printing x, let's say I also want to print thank you. Okay, in double quotes, I will say thank you. Now you can see we have two statements inside if. So I want to execute this too when this condition is true. The moment you have more than one statement, you have to make sure that you put the curly brackets. So you open the brackets and you closed it. And this thing will be very, very important whenever you have if, or in future when we work with loops and some advanced concept as well. At that point, if you have multiple statements, you have to put curly brackets. If it is only one statement, you can skip it. Okay. So yeah, that's it from this video. I hope you enjoyed. Yeah, before that, let me just code, and you can see we got the output. So that's it from this video. In the next video, we'll try to expand this logic more, because in this video, we were able to compare two numbers. What if you have three numbers? That will be challenging, right? And if you want to, you can just try with three values without watching the next video, and let's see how you do it. See you in the next video. So we were able to compare two values. Now it's time to compare three values. So let's say we have int x equal to 8, int y equal to 7, and int, let's say z is equal to, let's say 5 or 6, let's say. And I want to print the greatest of these three. Now, what do you think? What could be the solution here? See, one thing we can do is we can compare all the values, but at one point you can compare only two values, right? Example, we can say x is greater than y. We can't simply say x is greater than x, y, and j. Okay, that will be invalid syntax. Let me just show you that. If I try to compile this code, you can see we got the error. So what could be the solution? Of course, we can't do this, but we can do one more thing here. Can we say, when we are saying, let's compare for x. So at one point you can compare if x is greater than y and j both. And we have done that, right? So in one if condition, we can say x is greater than y and x is greater than z, okay? But then don't you think these are two different conditions? And if you want to combine them, and I want both them to be true, in this case, we can use and we have seen this, right? So basically we are doing an and operation here for this condition and this condition. So if this returns true and this returns true, it will execute x. In fact, just to simplify this, I have put the curly brackets in the last video. Let me just remove that, just to keep it simple. And now you can see we got this condition. So if this is true, it will execute x. That means x is greatest. That makes sense, right? But what if, in fact, let me just run this code if this works properly. Clear first and then compile and run. You can see we got 8 because 8 is greatest. But what if the value of z is 9? And if you compile this code now and run, it says 7. Oh, that's weird. That means the code is not complete. See, at this point, if is false, I mean, if by any chance, if this is false, that means we have to go for y and z. We have to compare them. How will you do that? This was simple. How will you compare again? Because in else we don't put a condition, right? But what if we can? So what if we can say else, and again we can put an if. And in this if, we can say y is greater than x, and, oh, not this and, the logical and then y is greater than z. So basically what we're doing is, in the first case, we are checking for x if x is greatest. The second case, we are checking for y if y is greatest. At this point, let me just make y the greatest, which is 17. So of course it should print 17. Run, you can see we got 17. But what if, okay, first of all, let's do a dry run here. So what happens is, it starts from this condition. If the value of x is greater than y, if that is true, it will check for the next one. And as you can see here itself, it is getting false. So the moment you get false here, it will not execute the if block. What it will do is, it will go next. It will say, okay, we got else here. it will execute the else block. But in else is not a simple else, it is else if. One more condition here, which is checking for y. If y is greatest, it will print y. But what if y is not greatest? It is z here. But still, if you compile this code, you will get nothing. You know why? Is because we are not printing z anywhere. So what you can do is, you can do one more else here for z. So if this two are false, of course, you will execute the else block. I can just simply copy this and paste it here. Instead of saying copy paste, I can say code reuse. That makes much more sense. And I can say z. And now if I can compile and run, you can see we got 9. Now this makes sense, right? So if both these conditions are false, it will execute the else block. Okay. And that works. Now you can just change the values in your machine. First of all, copy the code, and whenever you change the values, it will surely work. But there's one more thing. If you can think about this, when you execute this one, and if this gives you false, don't you think the x is small now compared to other two values? So in that case, when you check for y we have to even compare y with x. Anyway, x is smaller, right? So now we just have to compare y with z. We are just saving one operation here. And it's very important. When you save one operation, you are saving time, you are saving resources. So try to be an efficient programmer, not just a programmer. And that's what you do. You check what is required, what is not required, and remove all the unnecessary code. And once we have done this, compile the code and run, you can see we got 9. And you can change the values, it will surely work. So what we have done in this video is we have talked about if, else if, else. And that's how it works. Now once we have talked about conditional statement, in fact in that we have talked about if, and then we have also seen how do we use if else, and then we have worked with if else if. Now for certain use case, we have a shortcut for it, and it is called a ternary operator. Now if you want to use if else on the same line, or if you have a shorter condition and if you can write out that on one line, why not? So what I'm saying is, let's say if you want to check if a given number is even or odd, how do we do it? It's very simple. What you do is you first of all, you take a number. Let's say the number is 4, and if I want to check it, this is even or odd. So using if else, how you do it is we say if, and we check for the condition. If n mod 2 is equal to 0, that means it's an even number, right? So what you do is you come back here, and you don't need curly brackets because I want to write only one statement, and I want to store that in a variable. Now basically we can use a boolean type here, or we can use a string as well. So let's say I'm using a string, okay? And based on this string, or maybe let's keep it simple. So what I will do is I will not print even odd. What I want to do is I want to set the value which is in x, or maybe I will put that in result, and I want to put the result, by default result will be 0. But based on this, if the number is even or odd, I want to set the value for result. If the value is even, I want to set the value for result as 10. If the value is, let's say, odd, I want to set the value for result as 20. Okay, so for even it is 10, for odd it is 20. How do we do it? So in the if condition, you can say result is equal to 10. So if that's an even number, you will say result equal to 10. And if in the else part, you can set result as 20. So what we are doing here is based on some condition, I'm assigning a value. Now this is one way. And of course, at the end, I can print the value of this as well. I can say I want to print result. Nothing fancy, simple stuff. And then I want to compile this and run. So I will say javac demo.java and java demo. And you can see the output is 10. Why the output is 10 is because the 4 here is an even number. What if you make it 5? Now we are making it odd, right? So I can just go back here, compile, run. You can see we got 20. So this is working. Now what you can do is you can convert this code into something called a ternary operator. Now how it works? Let me just comment this section. See, ultimately what we are doing is we are saving the value in result variable. In both the thing, we have the same thing, right? If it is true, then we'll set the value for result. If it is false, for the else part also we'll set the result. So can we do this? Can we say result is equal to? The result can be 10 or it can be 20, right? But how will you do it? How will you check for the condition? So what you can do is you can directly run a condition here. So you can see if n mod 2 is equal to 0. If this is true, then we have to do something, or we'll do something. So we can use something called a ternary operator here. Now how it looks like, so ternary operator looks like this. Let me just write that in comments. So we have to use a question mark and a colon. So what is this question mark and colon? So whatever condition you have, it might return a true or false. So you can put a question mark, you can ask, hey, is it true or false? If it is true, then execute the part which is after the question mark, which is 10. If it is false, you have to execute, or you have to take the value which is after the colon. Okay, I will just give a space here so that it will be much more readable, right? So what we are doing is we are saying for this condition, if this is true, in that case return 10. If this is false, in that case return 20. So you can see out of all these 4 lines of code, we are doing that in one line with the help of ternary operator. Of course, it is not suitable for every if else. It's not like you will say, hey, from now I'm not going to use if else. That's not the case. This is suitable for some examples. Here it makes sense because we have a very short assignment and ultimately you're assigning value to result. So this makes sense. I can just compile and run. You can see we got 20 because the value is odd. But if you make the value as even, let's say 4 again, and if I compile and run, you can see we got 10. So this is how you can basically use a ternary operator. Now if you remember, we have used if else if. You can also do that here. I would request you to try that. Put one more condition here and try it out for multiple use cases. In this video, we'll talk about switch statement. Now to understand switch statement, we have to go for an example. So if you go back to your code, what we have here is, let's say we have an integer value and the value of n is 1. Now the value of n could be from 1 to 7. And might be you have guessed it. So when I say 1 to 7, it might be the number of days. And you're right. So basically what I want here is, if the value of n is 1, I want to print Monday. If the value of n is 2, I want to print Tuesday. So based on the value of n, which can be from 1 to 7, I want to print the day of the week. How do we do it? So of course, you can just simply print the values, right? You can say, hey, I want to print Sunday, and you can just copy paste it, or maybe copy pasting is not the right word. You can say code reuse. So just ignore this X here, it's just a suggestion given by the VS Code. We can say this is Monday, and we can just paste it multiple times. So this is Tuesday, this is Wednesday, Thursday, Friday, and Saturday. You know what? I want to keep Sunday as a last day because that's what we say, right? Weekend. The days should start from Monday. Okay. So I want to print this based on the value of n. At this point, if you just run this, it will print all the values. I don't want to print all the values. I just want to print one day based on the value of n. So of course, you can do one thing. You can just check with the help of if else. You can check if the value of n is 1, you can just print Monday. If the value of n is, let's say, you can say else if here. If the value of n is 2, in that case, I can print Tuesday, right? We can do that. At least let's do between Monday and Tuesday because that's what you are putting into if else. And if you run this code with that changes, you can see it is printing Monday. It is not printing Tuesday because Tuesday is in if else. And you can apply that in all the conditions here, all the statements. You can simply put if else and you can check for n is equal to 3 and then list goes on, right? There is one way. There is another way using which you can do this. In fact, you know what I can do? I can just simply complete this code. And here it should be 3, 4, 5, 6. You know, for 7, it actually makes sense to not even mention the condition because if none of it is matching, of course, it will be Sunday, right? So if there's no office, that's Sunday. Okay. So basically, this is what we can do here. But don't you think there should be a good way or a better way of doing this? So instead of doing if else everywhere and at the end of else, we have a good way, which is called a switch. Now, what switch will do? Example, when we talk about switch, it will switch between the ports, right? Example, in networking concept as well, we use something called switch. So here what you can do is we can use a switch. Now based on a value, it will execute a particular case. And that's why most of the time we say it's a switch case statement. Okay, just follow me. So what I can do is instead of using this if else, I can simply rewrite everything in a switch block, I can say switch, and in this switch you can pass the value, which is n in this case, and then you can write everything in this block. Okay, how do we mention that in this block? I have written capital switch, my bad. What you can do is you can put all this thing inside this block. The only change is, instead of saying if, we don't for the condition, we don't for the check for the condition, we just match, we try to match the case. It can be something like this. We can say case 1 colon. So whatever value you have passed, if this is matching with the case, example, if n is matching with 1, it will execute this statement. Same applies here. In fact, I just want to give a tab to everything else. And then here, I can just say case 2 for this, and let me just complete this thing for all. Okay, and then of course the number has to be changed. So we can say this is 3, this is 4, this is 5, this is 6, and this is 7. Okay, so we are trying to match with all the cases. What I will do is I will start with 7 and let's see what happens. The moment you make it 7, we are basically trying to match the cases. So what happens is when you execute this, it will go to the switch statement, and switch says, okay, I got the value which is 7, and now with this 7, I'll try to match with all the cases here. So it will check if the value which is passed, which is 7, is it matching with 1? No, it will not execute the block. Is it matching with 2? No. Is it matching with 3? No. List goes on, it matches with 7. The moment it matches, it will execute the statement, which is print Sunday, and it will do that. So if you run this code, example, if I compile this and run, you can see we got Sunday. Simple stuff, right? And this one looks much better than the if else, because we are checking for the condition multiple times. Here, we are matching the case, okay? So this looks better, right? And it also works better compared to if else. But there's only one issue here. The issue is, what if the value of n is 2? Now, what do you think the output would be? Think about this. And maybe in your mind, you already have an answer. So what I will do is I will just compile this code and run this code. Oh, that's weird. We were expecting Tuesday, but we got all the values. The reason is, when the moment your switch case matches with a case, example, it will check, is it matching with 1? No, it will not execute this block. Is it matching with 2? Yes. The moment it matches the case, it will execute the block for sure, and it will just try to complete the entire switch statement. It will execute all the cases. It will not try to match again because it's already matched. Oh, that's an issue, right? So what I want is, I can simply ask my switch, hey, once you match with one of the case, just come out of the switch block. And the way you can do that is by using a special keyword called break. Now break is very important because this will be used multiple times for different concept. What we are doing with break here is, it says simply come out of the block. Now once you match with any of the case, just come out. And of course for that you have to put break in all the cases. I will just copy this. I will try to reuse the code here and paste it everywhere. Okay. Now what we are doing is, the moment it matches with the case, it will jump out. Let's try this now. Compile, run. You can see we got Tuesday. It is not printing all the other blocks because the moment you print Tuesday, it will simply jump out because we are saying break. That looks cool, right? Now there's one more important thing. See, for the last case, we are still checking, right? Or maybe we can have one more case. What if the value is 8? It's not even coming in any of the case here. In that case, what you can do is you can do something called default case. If none of the cases are matching, you can do default and you can enter a valid number. I mean, you can print any statement you want. I'm just saying enter the valid number, and you can see the value here is 8. So it should print enter the valid number, and that's what you got, enter the valid number. So this is how basically you can use this switch statement. Now with the recent versions of Java, you can actually avoid using break. There's a different syntax we can use, but again, that we'll see in a separate video of advanced Java concept where new concept has been introduced in new versions, right? But at this point, this perfectly works. And in most of the companies, they are still into Java 8. So let's stick with the syntax. So try it out with different examples and you will be good to go. One of the most important thing about programming is you can do certain things repeatedly. Of course, we have talked about different things now. In normal software development, basically you work with data, and that's why we have variables. So basically you can store your values. In normal application, you decide based on some values. And that's why we have seen if else, we have seen ternary operator, we have talked about switch statement. But then there are certain use cases where you might want to repeat the same thing multiple times. In fact, there are a lot of memes available which says, in our school time when teacher used to say, write this 100 times. What if you can just do that with the help of software? Write the same sentence multiple times. Not manually, but automatically. It should reiterate. It should iterate itself. And the way you can do that in programming is with the help of loops. Let me give an example here. So let's say I have a code here and I want to print something. Let's say I want to print here hi. And I want to print this hi multiple times. Not once, but multiple times. Example, if I run this code now, it will only print hi once. If I want to print that multiple times, I can just copy this and I can just paste it multiple times here, let's say 4 times. And if I type it 4 times, of course, it will print the output in 4 times. We don't want 4 times. What we want is, we want to write this once and it should call itself multiple times. The way you can do that is by removing this part and by doing something. Maybe I can just say, I can just write in comments, I can say, repeat this statement 4 times. Maybe something like that. Of course, this will not work because comments are normally ignored by the compiler. But how do you do that? How do you mention Java, hey, I want to run this multiple times? And that's where the concept of loops comes into picture. So we have a concept like loops, which will reiterate the same thing. And there are multiple loops available in Java. With different languages, we have the same thing, or we can say similar thing. So we have something called a while loop. We have do while loop, and then we have a for loop. Now, mostly we use a for loop, but then we'll start with while and do while, and they have their own use cases. It's not like just because we have a for loop, we'll not be using while and do while. They have their own use cases. Now, just to give you a hint, maybe you want to repeat certain things multiple times, but then what will be the condition? Maybe you want to print that 100 times. That means there is a finite number. 5 times, 10 times, 8 times, 15 times, 20 times, 25 times, 100 times. Or maybe you want to do something based on some condition. Example, do something till I press the enter button. Do something till the system is alive. Okay, something like this. So maybe you want to do something finite times, or maybe you want to do something based on some condition. And for that, we have different types of loops available. So what is loop? Basically, if you want to do the same thing multiple times, you use loop. And there are multiple loops available: while loop, do while loop, and for loop. And there are multiple versions of for loop available, but we'll see the simpler version, which we call normal for loop. And yeah, that's what we have. We'll explore all these loops. We have talked about the need for loops, right? And so we have decided that if you want to repeat something, loops can be a good thing. And we also talked about there are different types of loops, right? We have while loop, do while loop, for loop. In this video, let's try to understand the first loop, which is while loop. So we'll go for the same statement here. If you can see, we are printing hi. And again, as I mentioned before, ignore this X. This is a suggestion given by your VS Code. This is what we are typing, just hi. And what I want to do is I want to print this hi multiple times. So what we can do is we can say, hey, Java, I want to print this multiple times. Java will say, okay, the first thing you do is you put this in a block. Of course, it's not compulsory when you have one statement, but just to understand, just to get started, we are putting that in a block now. And then, of course, we have to follow indentation as well, and we are doing that. Now, what we can do is we can say, hey, Java, I want to run this 5 times. So Java will say, okay, if you want to repeat, you have to use a keyword called while. Now, in English as well, we normally use while to say repeat something, or while it is true, do that. So here we can say while it is what? In this bracket, you have to mention, is it true or false? Now, basically, that's how while works. So if you say true, it will just keep printing this hi because we are saying true. It says, okay, while I'm true, I will keep printing it. So that's why if you just run this code by mentioning the while, you can see we are getting hi. It just keep printing, okay? It's not stopping. If you can see, if I try to scroll down, it is continuously happening. And maybe it will fill my RAM and it will crash. Okay, I don't think so. But let me stop this execution. Otherwise, there will be an issue. So what we can do is, I don't want to continue this for a long time. I want to do that for a particular condition. Maybe I want to say, I want a counter which will start from 1 and it will stop at 5. Oh, when I say counter, it means I need a variable where I can store the value. So what we can do is here, I can just come up and I can say int I is equal to, let's say 1. Now, most of the time when you use loops, you will be using a variable name I. It's not compulsory, we can use any variable name, but it makes sense, right? Because normally when you go inside the while you are executing something, you are changing the values of the I, you basically increment it, right? So it makes sense to call it as an iterator, which will iterate. So I, iterator, makes sense. And that's why most of the time you will say I, j, but as I mentioned, you can use any variable of your choice. So we are using I here, which is I is equal to 1. And then what we can do is every time you run this loop, after printing hi, you can just increment the value of I. Oh, but then how do we increment? And we have seen that, right? We have a concept of I++. So I++ will simply increment the value of I. Okay, that makes sense. And oh, how do I check for the condition? See, it makes sense now because I is 1 and every time you run this loop, the I value will increase, right? So if you run this while for let's say 5 times, it will increment the value of I. Let me show you. What I will do is I will print hi as well as I will print, maybe you can print both the things on the same line. You just have to give a space after hi and I can give a plus symbol. So when you want to concatenate two different things, hi and a number, we can use a plus operator. Yeah, plus works in that way. It works for addition as well as it works to concatenate two things. And here I'm writing I. Now let's see what's the output is. Again, I have not changed the condition, so it will print infinite times. But I just want to see what happens. If I compile this code and run, you can see the value of I is incrementing continuously. And you can see it's so fast. It depends upon your machine speed as well. And let me know when you try on your machine how fast it is. So what I want to do is I want to stop this somewhere. So we have to apply a condition. How do I stop it? So we have to say if I is less than equal to 4. So what it will do is it will check for the condition. Remember, we have talked about this in relational operators. It will continuously check for the condition. So how it runs is initially it will set the value of I as 1. And then in the while loop, it will check if the value of I, which is 1, is less than 4. Yes, it will continue. It will go inside the loop. It will print hi. It will also print the number, which is 1. And then it will increment the value of I. What next? It will go back to while loop and again it will check for the condition because that's a while, right? It will continuously happening. It will again check for the condition where it says, okay, I value now it's 2. So 2 is less than 4, yes, and it will continue. At the end, when the I value becomes 4, it will check 4 is less than or equal to 4, yes. It will print hi and 4 as well. So we got 4 iterations and then it will increment the value of I, which is, it will make it 5. It will go back here and it will check, is 5 less than or equal to 4? False. And that's where it will jump out of the loop. So remember this thing, the moment your while gets a false here, it will not execute this block. Cool, right? Now, after saying all those things, let's try to compile and run. And you can see we got hi 1, hi 2, hi 3, and hi 4. That's how while loop works. Now with this, I have a question for everyone here. And the question is, what if at the end, I'm just saying s out and I'm saying by, and with this by, I'm printing the value of I. What do you think? What will be the output of I? Okay, try to guess it. I'm just running this code to show you the output. Compile, run. You can see we got all the values here. But with by, you got 5. You know why? It's because we got false here when the value of I is 5. And that's why you got the value here. Now, since I is declared outside the loop, the value will be maintained. Okay, now one more thing here. I want to run this in a debug mode. Let me show you how it works in a debug mode. So what I can do is I can go to run and I can say start debugging. Okay, so there are some options. Okay, for debugging, you have to basically, you have to set the checkpoints. What I will do is I will just set the checkpoint here. So basically, debug is an awesome feature in programming where you can set the checkpoint. This is where you want to iterate one by one. So normally when you run the code, it will directly give all the output, right? What if you want to see the steps? So it makes sense. Let me just clear this. And again, I will go into run and get into the debug mode. Okay, so you can see we are in debug mode now. And here on the left hand side, we got variables. We got local a and I. We have two variables. You know why we got a is because of this a variable here. But at this point, we want to ignore that. We want to focus only on I variable. And the value of I at this point is 1. You can see that I is 1. But now, if I say step into, you can see we got system.out.println. It will print the hi and I, the value of I, which is 1. Okay, I want to go step into. Now it will increment the value of I. You can see we got the output as well. We got hi 1. And then when I say step over, it will go for the next step. And you can see before executing it, the value of I is 1. But once I execute that statement, the value of I now becomes 2. Can you see that? It went back to while loop. And this will keep happening for I value 2, I value 3, I value 4 as well. The moment your value of I becomes 5 here, you can see the value of I is 5 now. It is checking and it falls. It will jump out of the loop and it will print by with the value 5. So that's how your while loop works. In fact, what you can also do is we can run a nested loop here. Now, how a nested loop looks like. Let's say I want to print I1 and then I want to do something else. Maybe I want to print hello 3 times after every hi. So let's say I'm printing hi here and then I want to print hello as well. And I don't want to print the value of I anymore. Or maybe let's print the value of I. Let's see what happens. If you keep the value of I here and then incrementing it here as well, that makes sense. But now what I want to do is I want to, after printing this hi, I want to print hello 3 times. Now in that case, I can simply say hello and I can write the same statement multiple times, right? That's how the loop works, right? So I will say hello, hello, and you can see we got hello 3 times. But don't you think we are doing the same thing multiple times? So it makes sense to put that in a loop. So I can simply say while, oh, but what should be the condition? Can I say I is less than equal to 3? No, right? Because see, I want this hello 3 times for every hi. So hi we are getting 4 times. And for every hi, I want hello 3 times. So the same variable will not work. In that case, what you have to do is, you need to work with a different variable. And I will create one more variable here which is called j, and the value of j initially will be 1. And then every time you execute this while loop where it prints hi, it will jump inside here. It will set the value of j as 1. It will set the value, it will check for the condition where j should be less than equal to 3. And then every time you do that, let me open the curly brackets. And we can put this hello statement in here. So we don't have to put this thing now. I can just simply say hello. And of course, I want to print j++ as well. And remember this thing, we are saying j++ in the inner while loop. And then we are saying the I++ in the outer loop. Okay. If you want to understand this with an analogy, just go with an example of days in a week. So we have multiple days in a week, right? So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Sunday I've already mentioned. You know, we basically want Sunday twice a week. But anyway, so if we talk about these days, every day we have 24 hours, right? So if you say this is 1 p.m. on Monday, again, the Monday gets over, the clock will start at 0, right? Then 0, 1, 2, 3, 4, 5, 6, and then it continues, right? As the day changes, the clock repeats. In the same way, once your I is incrementing, it's like a days, Monday, Tuesday, the inner loop, you can imagine that's as a number of hours. It will keep incrementing. But after 3, it will go back to 1 because it will complete the inner loop. It will go back to outer loop. And again, the value of j will become 1. Let me show you how it works. Let me just compile this code, compile and run. You can see we got hi. Oh, we are still printing 1 here. You know what I will do? I will also print j so that you can see the value of j as incrementing it. And let me give a space here as well. Let me say clear, compile, run. So you can see we got hi 1 and then it is going for the inner loop now. So once you execute this hi, it will go for the inner loop where we are saying j is less than 3. So basically it will print this statement 3 times because the value of j is less than equal to 3. So it will iterate 3 times. And then again, it will go for the outer loop. So the moment this is false, it will execute I++ where it will make I 2. It will go back to the upper loop again. It will say, okay, now the value of I is 2. Is 2 less than equal to 4? Yes. it will go inside, it will print the value of high, which is high 2. Again, it will make the value of j as 1. And that's why it is incrementing again. Cool, right? So this is basically called a nested while loop. So that's it from this video, where we have talked about how to create a while loop, how to use a nested loops using while loop. Now, once we have seen while loop, it's time to move towards a do while loop. In fact, before we proceed, first of all, I want to remove this breakpoint because we don't want to debug anymore. And I want to remove the inner loop because we want to focus only on the outer loop now. Now, using this loop, we were printing high 4 times, and then we are printing by as well. Let me also remove by for now. And with this, I just want to run this code once again to see what happens. Compile, run, and you can see we got the same output, right? Okay, now what I want to do is, when you talk about while, what happens is, when you talk about this line, which is line number 7, it will assign the value of I as 1. When it go for the next line, which is line number 9 here, it will check for the condition. If it is true, it will execute this block. That means, if this condition is true, then it will execute. Otherwise, if this condition is false, it will not execute the block. That actually makes sense, right? That's how the loop should work. But there are some certain situations where you want to execute this block even if your condition is false, at least once. I mean, you want to run this at least once. Maybe something like you want to send a message to your friend, and if the service is not available from your friend's end, at least you should be able to send a message once at least. Okay, so that you can get the reply, the user is not available or something like that. So what I want to do is I want to execute this block at least once, even if the condition is false. Now, when I say condition is false, what it means is, example, if the value of I is 5. Now, when you make the value of I as 5, and if you run this code, you can see will not get any output. It's because the condition is false. So what we can do is, can we just cut this part from here and put it after the block? We can do this. And we can just also give a semicolon here because that's how you end this statement. Normally, when you write while at the start, the curly brackets becomes a statement. But then if you write while after the block, we have to end it with a semicolon. And we have to add one more, which is do. So we have to say do while. Now what it does is, it will execute the block at least once, even if your condition is false. Now, if you can see in this situation, first of all, let me just go with 1 again, and let's see what happens if you run this code. Compile, run, you can see we got the normal output. And the same output we got when we had a normal while loop as well. But here, if you make this condition false, I mean, if you say I is 5 now, which is a false, which will give you false here. But if you run this code or compile this code and run, you can see at least you will get the output once. This is important. So if you want to get the output even once for, even if your condition is false, you will be using do while. So yeah, that's the main difference between while and do while. Otherwise, it works in the same way. It executes, check for the condition, again executes, check for the condition, and the flow go on. Now, once we have talked about do while loop and while loop, let's talk about the next type of loop, which is a for loop. Now, if you go back to while loop, so let me just remove do here and let me put this back here. And okay, let me remove the semicolon as well. Now there's one more thing. If you talk about this while loop, if you can see, we have 3 things here. The first one is we have initialization, we have a condition, and then we have an increment. So basically we are doing 3 things on 3 different lines. And if we talk about any finite loop, so when I say finite loop, it means it is starting somewhere, it is ending somewhere. And we know when it is going to end. There are some loops where you're not sure when it will going to end. Example, when the user says enter, it will end. Maybe the network goes off, it will end. So based on some condition, it will end. Maybe you're trying to read a file. So in a file, let's say you have 1,000 characters. And we don't know how many characters we have. So when you open the file and when you try to read each character, so the loop will end when the characters end in the file. So we are not sure. That's why I'm saying it can be not an infinite loop, but somewhere we cannot determine when the loop will end. So at this point we can determine, right? But anyway, so we have 3 things here. We have a counter, we are initializing it, we are checking for the condition, and then we are incrementing it. So what if we can just write all these things in one line. What I'm saying is, can we just pick up this thing from here, cut, and paste it here itself? So on the same line, we are initializing the variable. And on the same line, I can give a semicolon. I can say I++. And of course, we don't have to do that here now. The only thing is, while loop does not support this syntax. While says I will only check for the condition. But then if you want to use this type of syntax, you have to use another type of loop, which is called a for loop. So in a for loop, you can mention 3 different statements in one line. Mind you, these are 3 different statements. Why? Is because we are using semicolons in between. So this is one statement here, this is another statement, and this is another statement. And you can see I'm just printing hi here, the same code. I just want to check if this works. Compile, run. Oh, we have not got any output. Oh, it's because the value of I is still 5. Let's make it 1. And by doing that, I can just compile this code and run. You can see we got all the values. Makes sense, right? So how a for loop works? So we have to set the initial value, which we have done here. And then we have to check for the condition. And then we have to increment or decrement. So let's say I want to print that in a decrement order. I mean, I want to print 4, 3, 2, 1. In that case, I will start from 4. And then I have to end. The I should be greater than and equal to 1 and I++. Sorry, I minus minus, because we are decrementing it. Compile, run, you can see we got high 4, high 3, high 2, and high 1. So this works. Okay, can we do something more here? Actually, we can. What if you want to start, let's again go for the increment part. So let's say I'm going for 1 and it should be less than equal to 4, and then I'm saying I++. See, most of the time we'll start with 1 itself, right? So that's how your normal number system works. As a human, we do that, right? But computer normally start their counting from 0. It's because of the binary format, because in binary we have 0 to 1. In fact, in the number system also, we start with 0, we say 0 to 9, right? In fact, once we start with the array concept, there as well, the number starts with 0. So in general, in computers, the number system starts with 0. So we can also say, let's start with 0. But the question is, if I start with 0, where I have to end it? Is it 4 or 5 or 3? Because we want to print only 4 times, right? So let's keep it 4, which is equal to 4. And then we also have 0 here. So let's try to compile and run. You can see we got 5 values. It starts from 0 and it is ending at 4. Okay, that is an issue. How do I stop it at 3? I want to print 0, 1, 2, 3. That's it, 4 iterations. So in that case, what you can do is you can stop it at 3. Now this is something which will take time for you if you're doing this for the first time. When you're starting with 0, you have to end before that. You have to end before the count. So if you want to do it 4 times, you have to end it at 3. Okay, now let's try this. I will say compile and run. You can see we got 4 times. Now, one of the common syntax you might be saying in most of the examples, or if you're referring a book or online content, you can also stop this as 4, but you have to say less than 4 because you're not including 4 here. You're saying less than 4, not equal to 4. So this is one of the common syntax. You can see it starts with 0 and it ends less than 4. And now if you try this, you can see we got 4 values. Make sense? Okay. Now let's try something else. So loops normally work well when you try to print some pattern or when you try to do something repeatedly. So what I will do is, let's try something. So what I will try is, I want to try this one. I want to try to print the number of days. I will say 1, 2, 3, 4, 5, 6 and 7 because we have 7 days. And also every day I want to print 24 hours. That looks good, right? We have talked about this example, right? So what I will do is, first of all, I want to print all the days. So I will say 1 to 7, including 7. So I have to say equal to. And then here I will just print the number. I will say, okay, I will say day 1, 2, 3, 4. Imagine day 1 means Monday, day 2 means Tuesday, and so on. So if I try to do that, I will say compile and run. You can see we got all the days. Now with days, I want to print the number of hours. Okay, I know that will be tricky. Or maybe we can actually print from 9 a.m. to 6 p.m. because that's most of the work hours, right? So let's say if I want to build a calendar, in fact, I don't want to print till 7. 5 makes sense because we have 6th and 7th day as holiday. So let's try this. I will compile. And then we got 5 days. In these 5 days, I want to print from 9 a.m. to 6 p.m. How do I do that? So I can simply print with the help of statements. I can say this is 1 or 9 a.m., right? Or I will simply say 9, and then I can say 10. I can just print this once again. So this is 10 and so on, right? I can print it till 18 because 6 p.m. is 18 if you go for 24 hours of clock. But then don't you think we are doing this thing repeatedly? I have to basically type so many lines. So of course we can use a loop here, right? So what if we can use an inner loop? We have talked about nested loops. Here we are doing it with for. So I can say for, and I have to give a count, right? So I can say j will start from where? Now this is tricky. Should we start j from 1? We can. So I can say 1 and j less than. So how many hours we are doing here? We are doing 9 hours, right? So I can say 9 and j plus plus, right? And then I can just give a loop open and loop close, and then we can print the hours here. Now what hours I have to print? I cannot print 9 because 9 is not 9. It will print 9 every time. For example, if I show you this, I'll say clear. In fact, what I will do, before printing 9, I will give a tab so that it will give some indentation before it prints. This is what I was saying. You can see we got day 1 and we got 9 hours here, but then it is printing 999. I don't want to print 999. Maybe I want to put an attendance here, or maybe a calendar where we can mark what we are going to do. So what we can do here is I want to say, okay, I should not be printing 9. After this space, I can say I want to print, let's say, value of j, but there j will print from 1 to 9. Let me show you what I'm saying. Clear, compile, run. So you can see it is printing 1 to 9. I don't want to print 1 to 9. I want to print from 9 to 18. In that case, can I simply add this with 8? Because it will start with 1. So 1 plus 8 is 9, right? It will start from 9. And every time it will increment the value of j. So you will get some other values. I will just compile this and run. Oh, something went wrong. Okay. Now what is happening here is we should have talked about this before, but we are never late, right? So what is happening here is we were expecting it will print 9, but what is happening is when we are saying that we are adding a string with a number, it will concatenate, right? So here we were expecting that j and 8, which is 1 and 8, will get added to get 9, but actually what is happening is it is getting concatenated. So we have to mention, hey, instead of adding a string to a number, the number, what you can do is you can put a bracket here. So I want this to resolve by itself. I mean, this should be resolved in a separate way. So whatever number you are adding here, 1 plus 8 will be a separate thing. And then you are concatenating that with a string. Let's try that, compile and run. Oh, it is working, I guess. No, it is not working actually. Oh, okay. We cannot add 6, right? Because it's the 17th hour which gets over. Okay, so let's say we are printing for 9 hours, which is from 9 to 5. Okay, which also includes the 17th hour. Okay, that's tricky. Okay, in fact, what should I do? I should actually print colon here, or maybe a dash hyphen from this hour to this hour. This is what happens when you take the example randomly. So I will say j plus 9. So what I was saying is this, from 9 to, yeah, this makes sense now. So you can see we have actually built a calendar for this week. So day 1, from 9 to 10, we can do something here. From 10 to 11, we can do something here. We can set a meeting calendar, something like that. So what I'm doing is we are printing j plus 8, which is 9, and then j plus 9, which is 10 for the first iteration. As the value of j increases, it will have different values here. Okay, makes sense, right? So this is what we have achieved in this example. So that's how basically your for loop works. Okay, this is nested for loop. We have seen that as well. Okay, now once you understood this, let me just comment this part. I don't want to do that. I have a question for you now. Think about this and let me know what could be the sequence here. See, when we write this in the same line, these 3 things, how do you think they're executing? Is it something like this is getting executed first, and then this one, and then this one. And later on, after executing all these three statements, it is executing this statement. What do you think? Okay, let me give you the answer. So the moment you execute the for loop, let me just, this is the best time to run a debug mode. So I will say run start debugging, taking some time to start the debug. Okay, so I will say step over. So you can see it is executing the for loop, but we have not started that yet. So let me start the for loop. The moment you start a for loop, you can see the value of I is 1. It has checked for the condition as well, but it has not incremented yet because the value of I is still 1. So that means these two things will be executed first, and then it will execute the block. And then if I say step over, it will execute the next iteration. In fact, what I will do? For the next iteration, I will say step into, the value of I is 3. Okay, it is not doing that. But anyway, so it is executing the body and then it is incrementing. Okay. So that's what I wanted to show you. Cool. So point to remember, it will execute this statement first. It will be done only once, and then it will check for the condition. Then it will execute the block, and then it will increment it. I mean, whatever you want to do in that situation, in that portion. In fact, if you want to skip any of this step, you can actually. So that what if you want to skip this from here? It's your choice. You can just keep it empty. The only thing is, since you are skipping that, if you want to make it work, you have to say I++. Of course, you have to increment somewhere. Otherwise, it will be an infinite loop. You can actually skip the initialization part from here, and you can write it outside. As I mentioned, your choice. It's just that you have to put the semicolon. That's compulsory. You have to have 2 semicolons there. And now let's compile, run. You can see it works. So that's how you can work with for. I hope you enjoyed. So we have basically seen 3 loops, right? While loop, do while loop, and for loop. Now the question is which one to use. In fact, during the discussion of these loops, we have talked about it, which one to use. But just to summarize things, see, if you have, of course, all the loops works in the same way, you can use any of them at any point. But the thing is, if you know how many iterations you want to go for, example, let's say if you want to print from 1 to 100, you normally use for loop. Because we know the numbers, right? Because in for loop, we mentioned all the 3 things: the initialization value, condition, and the increment decrement part. But what about reading a file? Because in reading a file, we don't need a counter, right? Because when you read a file, doesn't matter how many characters you have to pick up each character, right? So there is no initial point. It's just that you will read the file. The moment you have end of file, you will stop the loop. So using a while loop there makes sense. Can I use for loop as a while loop? Yes, we can. If you remember, we have seen a code where you can just give 2 semicolons, and in between the semicolons, you can put the condition. Even that works. When to use do while loop? Now, whenever you use a while loop, and if you think, hey, even if the condition is false, you still want to execute something at least once, do while makes sense. But as per my experience, most of the time you're going to use for loop. If you want to read a file, read database, while loop makes sense. And I have hardly used do while loop in my entire career. But yes, there might be some use cases where you have to use do while loop. So which is the best loop? In terms of frequency of use, it will be for loop. In terms of the usage for database, files, network, while loop makes sense. Once we have talked about the basics of Java, it's time to move towards some concepts. Now, at the start itself, we have mentioned that Java is object-oriented programming. Now, what do you mean by object-oriented programming? See, when you talk about object, in real world, everything is object, right? In fact, if I'm using a pen, that's an object. If I'm using a mouse, that's an object. If I'm using a sellotape, I don't know why I have sellotape on my table, but that's an object, right? So everything around you is an object. And the weird thing is, in the programming world, even they treat humans as objects. But that's fine. Everything is an object. Now, everything has 2 things. In fact, every object has 2 things. An object knows something, an object does something. Example, let's say if we talk about this pen. This pen is an object, right? So this pen knows something. So when I say knows something, it simply means it has some properties, some physical properties, right? You can see this pen, right? So we have a color for this pen. I'm very bad with colors, by the way. But we have a color for this pen. There's a height. There's a kind of pen. It also has a brand. I'm not sure which company pen it is. It doesn't matter. So there are some properties for a pen, right? And the same way, if we talk about this this remote. Okay, this has some properties: height, color, the number of buttons. So this is what a remote knows. And also a remote does something. Example, I can on my AC by pressing some button. So it has a behavior as well. So basically every object knows something, every object does something. And that's what we are going to create in Java as well. Now, whatever project you are making, you will be having different objects. Now, specific to Java, from now, it's also about thinking, okay? So it's not just about coding something. Even when you start making something, in your mind, you have to treat everything as an object. Example, let's say if you want to add two numbers, the first thing which should come to your mind is, okay, I need an object which can add two numbers. You're getting my point, right? Everything, you have to think in an object way. So if you come back to programming, if you look at this example, of course, we don't have an object here in this code, but you have to remember, whatever you want to do, you have to do with the help of object. So what we have discussed till now is there's a concept of object-oriented programming. So basically we have certain things here. We have a concept of object, and this object will have a property and this will have behavior. So every object will have a property and they also have a behavior. The properties can be multiple properties and multiple behaviors. Example, let's say as a human, if I'm an object, I know something. I know a lot of things. I know how to talk, how to walk, how to dance, how to type code, right? And I behave based on what I know. So I can dance because I know how to dance. So that's your property, but you know how to dance. That's a behavior. When you're dancing, when you're talking, when you're walking, right? So I know my age as well. I know a lot of different. So whatever I know here is properties. What I do is behaviors. Okay, but how do we create objects? So in Java, if you want to create an object, we have to first create a class. Okay. Now why we need object and class concept? So first of all, we have talked about object. Everything has to be done with the help of object. In real life, we can't do anything without objects. So that's how it works. So in Java as well, if you want to do something, you have to create an object. But how will you create an object? And who creates this object? So let's talk about it. Now, if we talk about the concept of object, who creates object in real world? Example, let's say if we talk about this table where I have my systems. Now, this table is created by a carpenter. Okay, so when you go to a carpenter by saying, hey, I want a table, carpenter will say, okay, I will give you a table, but tell me the exact dimensions. Okay, maybe the carpenter, the actual guy who is making this table, he's very technical. So we have to explain in technical details. And that's why we have some person in between who says, okay, you give me the details. Okay, I will forward it to the carpenter. So basically you give the details to that person, third person, and then that third person gives the detail to the carpenter. Because carpenter understands on technical details and you understand on the lay terms. I can say, hey, I want a table where I can keep my computer, where I can keep my monitors, my keyboard, mouse, mobile phone, and all the different things which I have on the table here. So that person, the middle person, will explain everything to the carpenter. Okay, that's the dimension a person wants. This is the height which I want. Based on my height, I want this table to be. And so all the details, right? So got the point. So how do you give that design? So as a normal person, you give a design in a particular way. And in programming, you can give that design in a class file. So you have to create a class file which will act as a blueprint for the carpenter. Or for someone who can create object for you in Java. Now, who creates objects in Java? It is your JVM. Again, what is JVM? What is JRA? We'll have a detailed discussion there. But at this point, understand this: we have a JVM who will say, okay, it's my job to create the object, but you give me a blueprint. Okay. So basically, you create a class file. Now, this class file gets compiled to create a bytecode. Now that bytecode goes to the JVM and that's where you get the object. Okay, so in the last video, we have talked about what are classes and object, right? And we have seen the theory of it. In this video, let's try to create a class and we'll also create an object of it. Now, first of all, where do we get a class and what class I want to create? As I mentioned before, in Java, whatever you do, you have to do that inside a class. So in that class, you'll be having methods, you'll be having variables. How do we do that? That we'll see in some time. But the first question is where we have to create a class. Now the class can be created in the same file. So example, in demo.java, we already have our class, right? We have a demo class. And here with this class, I can create another class here, and we can surely do that. So what I can do is I can create a class here, and I will name this class as calculator. Now basically imagine what I want to do here is I just want to add two numbers. So even if you want to add two numbers, we'll do that with the help of a class. Now what if you don't use a class, and normally how you do it? So let's try that first. I want to just add two numbers, and I will remove this extra comments from here. Now how do we add two numbers? It's very simple. You use variables. Let's say int num1 comma num2. So we got two variables here, and then we have to give them some value as well. So I can just come back here. I can give them values. I can say num1 is equal to 4 and num2 is equal to 5. Simple numbers, right? In fact, you know what works well is to have this in two different lines. Again, coding standards. If you have variables on different lines, it is much easier to read and much easier to maintain the code as well. Now, once you have these two variables, if I want to add these two, and of course, when you add these two numbers, you will get the output. You will get the result. So maybe you want to save the result somewhere. So I will say int result equal to num1 plus num2. So you can see we got these two values, and then we are adding them. Okay, so in result, we got the value, and of course you can print this value. So you can simply come back here and you can say result, print result. That perfectly works. Now the twist here is, I don't want to add these two values here. Of course, this code will work. I just want to see if this works before we do something. I'll say compile and run. So you can see we got 9. But I don't want to add these two values here. So how do we represent that in a separate class? It's something like, let's say if you want to call someone, you will not manufacture a phone by yourself. You will just buy the phone. Now this phone company, they will design the phone, they will make the phone. Example, if we talk about iPhone, let's say, nowadays they don't mention that on the back of the phone, but initial days they used to say, okay, let's talk about some other phone first. Most of the phones, doesn't matter how costly it is. So it is mentioned, it is where it is made. In the previous manufacturing hub was China, so most of the phone was having made in China, right? But then if you think about Apple, they are smart in this case. They say designed in California and assembled in China. So even they believe designing is more important than assembling. And that's what you have to do here. Because manufacturing of your object, which you do here, will be done by JVM. What we are concerned about is designing of it. So when you design it, you can just come back here and you can say class, and I will just name it as a calculator. I can just open the curly brackets and close. So this is basically where you will design your stuff. You will put your things. Example, if we talk about calculator, and if I mentioned that before, every object will have two things, properties and methods. You will do that in this particular calculator. Now what I want to do is I want to add these two values, right? So if you want to add, that's a behavior, right? That's an action. Action will be done with the help of methods. So here I will say public. So how do we get a method? So we have to specify the access to it, which is public. I want this to be called from anywhere else. And I want this to return me a value. So once that is called, it will perform some operation and it will give back the value. So I will say int, that's the return type. So whatever it returns, we have to specify the return type of it. As I mentioned before, Java is a statically typed language, which means you have to specify for all the data, what type of data you're working with. When you create a variable, you have to mention what type of variable you want to create. When you return, you have to mention what type of data you're going to return. So that's int. And what could be my method name? So a method will also have a name. So here I will say the method name is add, and this add will perform an operation. Now at this point, you can see I'm not passing any value. I'm just saying add. And when it calls, I just want to print in add. I just want to see if this really get called. Okay, so at this point, I don't want to add. I just want to see if this is getting called. And also, we are returning a value, right? And that's what the others it says. It says the method must return a result of type int. Okay, so I have to return something. So irrespective what type of calculation I'm doing, I have to return something. So I will say return. So that's how you return the value. You have to use a return keyword. And then you will give any value, doesn't matter, any integer value. So at this point, I'm giving 0 because we are not concerned about this value. But the question is, how do I call this add? Okay, so this is basically a class. A class will have methods. A class can also have variables. What if you want to create variables here? It's very easy. just outside the method and inside the class, you can just mention the variables. At this point, I just want to get a variable a, just to show you that how do we get a variable. We are not going to use this a anymore, but let's keep it there. So in a class, this is how you design your class. You put two things there. You put your variable and you put the method. The variable name is a, the method name is add. Makes sense, right? And here we are just adding these two values, putting that into result, but we are not going to use this anyway. So we'll comment this part and comment. So the ultimate aim now is how do we call that add method? That's tricky. So in order to call the add method, can we directly do that? Can we just directly call a method like this? So that's a method, right? Now, if you're coming from some other languages, it might be supported where you can simply mention the method name and it will work. At this point, you can see it is not working. We are getting the error itself. In fact, there are two types of way you can check the errors. You can directly see in the IDE if you're using it. Otherwise, you can just compile the code to see the exact error. It says cannot find symbol. Okay, that's weird. The add method is there, right? But it still says cannot find symbol. You know why? Because if you can see in the error itself, it mentions that the symbol add, which is a method, it cannot find that method in the location demo. Oh, okay. So when you call add, it's not able to find that in the same class. But it's not in the same class, right? In a different class. How do I mention that? Hey, you know, this add it belongs to a different class. For that, basically what it says is, the design is not enough. Basically, what you need is also the object. Example, let's say if someone comes in the world by saying, hey, no, we have this amazing idea and we want you to buy this idea. No one will buy the ideas, right? We buy the devices. No one will give you you will not buy a phone or an idea using which you can call someone. It says, you know, this device can call, but then you don't have a device to call. So basically we need an object. A physical object. In the world of programming, we need a virtual object. So for this class, which is a design, I want the object, the instance which I can use. How do I do that? How do I create the instance? Now for that, you have to come back here and you have to say, hey, you know, I have a calculator class and I want to create an object of it. So basically imagine calculator as a type. Example, if you want to create a variable like num1, you specify a type, right, which is int. So here as well, imagine calculator as a type, and then you are creating a reference of it, let's say calc. Now imagine calc as a variable. This num1, num2, they are also variable. The calc is also variable. The difference between these two is, this num1 and num2, they are called primitive values or primitive variables. It's because int and all those type, float, double, they are primitive. This calc is of type calculator. So we normally call them as a reference variable. So that's done. Let's say we have this calculator calc, and then using this calc, I can say calc.add, but still it will not work. The reason, we are just creating a reference. We are not creating an object yet. Okay, how do we create an object? Now, first of all, who creates an object? And every time you get an object in this world, you know, we are talking about carbon neutral. We are talking about how can we reduce the e-waste. In the same way, every time you buy a new phone, basically you are creating an e-waste, because when you buy a phone, the companies are manufacturing new phones. Okay, so basically you are increasing the e-waste. In the same way, in JVM as well, every time you get the object, it will consume some space. Okay, how do we do that first? How do we create an object? How do we consume that space? Now for that, when you want to consume this space, you will simply say, hey, you know, I want to create a new device. So you have to say new. But what type of device it will ask you? In that case, you have to mention, I want to create an object of type calculator. And you have to also give the round brackets. Now this is how you create the object. Okay, this is how you create an object. Of course, we'll talk more about this. What's the difference between this line and this part? But at this point, just to keep it simple, this is how you create the object. First, you mention the class name, then you mention the reference variable name, a variable name using which you can access the methods of calculator. And then you say new keyword, that's how you consume this space. But how much space you need, what are the variables you have to initialize, that can be done with the help of this thing. Now, it has a special method in Java called constructor. But what is constructor? We'll talk about that later. How it is different from methods, we'll discuss that in detail later. But at this point, with this line, we got the object. And once you got the object, you can simply call the add method. Your job is done. But will it really work? Let's try. So what I can do is I can just clear this and I can go back here, compile and run. You can see we got in add. Basically, you were able to call in add. That's great. Okay, but if you can see, this add method actually returns a value. So don't you think we should accept the value as well? If someone gives you something, you have to accept it as well. So here I can say int result. So whatever it returns, I will put that into this result variable and I will just print it. And let's see what happens. So compile, run. Oh, it works. You can see it says in add. And we are also printing the value of result, which is 0. Why 0? It's because we are returning 0. But what if you return something else? Maybe I want to return based on the values which I have here. Oh, that means here, I don't want to print something. What I want to do is, I want to create a variable called as, let's say, r is equal to, I want to add num1 plus num2. And then whatever addition I'm getting, I will just return the value. Now, it will make much more sense, right? Instead of returning 0, I should be able to return the value. So num1 plus num2 should be assigned to r, and I want to return the r. But the only problem is, let me just compile this code to see what happens. Compile, oh, we got errors. And I love errors because errors will teach you a lot of things. It says num1 and num2 cannot find which location in calculator. And we have to mention, hey, I was actually talking about num1, num2, which belongs to demo. In fact, the main method. So what you can actually do is, when you're calling add, can we just pass these two values? Something like this, 4 and 5, right? And then since you are passing those values, example, let's say if I ask you, hey, add two numbers. The obvious question from your side would be, what numbers? Give me the values first, right? So I will say, okay, add 15 plus 20. Then you will say, okay, that's 35. So that means I have to pass a value. So when I call you to add values, I have to give you the values. And then of course you have to accept those values. It's not like I'm giving you the values and you're not listening to me. So I have to accept those values. I will say n1, n2, different variable names. I have to give int. And then here, instead of adding num1 and num2, I will add n1 and n2. The variable name can be num1 and num2 as well. Just to differentiate between these two, I'm just giving different variable names. So the idea here is whatever value you're passing, 4 and 5, will be assigned to this n1 and n2. And that's how you can pass the value. Makes sense, right? And anything else? Let's try this. Let's see if this works. I will just clear this and compile. Okay, I've done compilation 2 times, my bad. So you can see we got 9. So it is working. Basically, whatever value you're passing, it is getting passed here. But there's one more thing. When you have those values in a variable, why you have to mention numbers here? We are hard-coding values, not a good idea. So what you can do is instead of writing 4 here, we can write num1. And instead of writing 5 here, I can write num2. Simple stuff. So whatever value you have here, you're passing it here. And then that gets assigned to num1 and n2. And then you're adding the value. Let's try. Compile. Run. It works. So what we have done is we have created the class. How to get a class? It's very simple. You say class and you mention the class name, which is calculator. And then in that class, you can create variables. You can create methods. This is how you specify what object knows, right? Variables, data, and what object does. An object can add 2 values. Now, how do we use this class? Basically, you have to create an object of it. So as you can see, this is how you create the object. You say, hey, JVM, I want a new object. You use a new keyword there. And then JVM says, okay, I will give you the object, but also tell me design. And this is how you mention the design. You say calculator. Now this will give you a new object of what type? Calculator. So you're assigning that to a variable called calc of type calculator. Example, when you say 5, that's an integer type. That's why you say int num2. This is an object of calculator type. So you will assign that to calc, which is a calculator type variable. Now, once you got the object reference here, you can just use that reference and you can call the add method by passing two values, return the value and print. Simple stuff, that's what we have done in this video. So till this point, we have seen some programming thing and we were able to execute them. We have talked about classes, variable, methods, and object creation as well. Now it's time to actually see what is happening behind the scene. Because if you understand what is happening behind the scene, then the further coding will make sense, right? So every time I introduce a new concept, we can actually relate what is happening behind the scene. Now to understand that, let's focus on some keywords, okay? If you remember, when we started this videos, at the start of the video, I mentioned that to compile the Java code, you need a tool, right? In fact, we have to do setup as well. And that tool is your JDK. Now, JDK here stands for Java Development Kit. Maybe I can just write it here. So basically, why do we need it? Why do we need a development kit? See, the thing is, when you as a programmer, when you type a code, you have to convert that code into bytecode, because ultimately, what runs on the machine is a bytecode. So of course, you cannot type a bytecode. I mean, you can, don't try it, but the idea is you will type the Java code, you will compile it, and it will convert into bytecode, which will run on a machine. But which machine? Now for that, we have one more term here, which is called a JVM. Now basically, JVM stands for Java Virtual Machine. So basically, this is your machine which runs the code. So of course, you have to compile the code with the help of JDK and you have to run the code on JVM. Now, apart from this, there is some more things in the picture. So what happens is, when you want to run your code, so what code I'm talking about? I'm talking about the bytecode here. So assuming that you have already compiled and you have a bytecode with you, you need to get a space. Okay, so let's say this is your space where you are going to run your code. And this space is basically your JVM. Now this is where you actually execute the code. Now why it is called JVM is because we have a machine, and to make the Java platform independent, we went for a virtual layer on top of it. So doesn't matter on which machine you have your JVM, it will work. The idea is to have JVM on every machine. Now JVM is going to run your code, and behind the scene computer will convert that into its own way and it will run. So basically, you need a JVM to run your code. But then what happens is, for your code, let's say this is your file here. If this is your file which you want to execute, most of the time, your code is dependent on some external file, not your files which you have created. Maybe you have created 5 files. Apart from the code which you have written, you have used some inbuilt classes, some inbuilt libraries. And that's where we need some extra things here. So maybe we need some extra files from which you are going to use in your code. Okay. Now question arises where you will find all this code. And that's where we have one extra layer here on top of it, which is your JRE. Now JRE stands for Java Runtime Environment. So basically we have a concept of JRE, which is Java Runtime Environment. Now in this JRE, you'll be having all the extra files. You need extra classes, inbuilt classes. It also checks your bytecode. Basically it validates your bytecode. Maybe you want to load a class. So here JRE will help you, but ultimately your code will run on JVM. So JVM is very important because that's where your code runs. But even to run your code, you need some extra files, and that's what JRE will provide you. And the name itself says, right, Java Runtime Environment. So it's an environment where you can run your code. And the beauty is, JVM is a part of JRE. So you can't simply say, hey, we don't need JRE, we need it. If you don't have a JRE, you don't have a JVM, right? So basically, every time when you say you have Java in your machine to run the code, you actually have JRE with it. So you have a JRE, and inside that you have a JVM. But then as a developer, you install JDK, right? Now JDK acts like an upper layer. So every time you install JDK, you also get this too as well. So the top layer here is your JDK. So JDK, when you install JDK, you will get the updated JRE, and also you will get the updated JVM. But by default, on a client machine, you will find JRE and JVM, which will have extra files and which will have where you can run the code. In fact, you might have seen this. Sometime when you install some software, it will say, hey, in this machine, I'm not able to find .NET framework, or I'm not able to find Java. It's because the software will be running on those particular softwares. I mean, the application will run on .NET platform or on Java. Of course, there are other platforms as well. Just to give an example, we have .NET, Java, And that's why, you install extra softwares, the same thing. If you don't have the updated version of JRE, and if you try to run some advanced software, it might not work. And that's why, sometime on Windows, it says Java is getting updated for the same reason, because to support extra, the new softwares. So this is basically your JVM, JRE, and JDK. So JDK will have everything, JRE and JVM. And in JVM, you execute the thing. Now, in the next video, we'll try to expand more on JVM. So in the previous video, we were able to work with a calculator, and basically we were able to add two numbers, right? So what we did is in this calculator, we have created this method called add, and then we have accepted two parameters, and then we were able to add them, and we were able to return the value. Now, of course, the place from where you are calling this method returns a value, and that's what you are saving in result, and you are printing it that. Now, in this video, let's try to understand more about methods. Of course, in the entire course, we will be using different types of methods. We'll explain how this method is behaving this way. But at this point, let's understand about methods more. So what I will do is, just to simplify this, I will remove this class, and I will also remove the entire section from here. Now, if you can see, by default, even if you have one class here, which is demo, by default, we have one method, which is main. Now, main is a method which is a start of execution. So it defines, hey, this is where we have to start the execution. So by default, we are anyway using a method, right? But then if you understand the actual development of any kind of product, it can be a car or a mobile phone or a software. Now, we normally create modules. Example, if you talk about a car, we have different modules there, right? We have wheels, we have doors, we have bonnet, we have engine. Right? So all these things come together to form a car. In the same way, if we talk about a big software, we break down the software into small parts, and we try to create those as a component. Now in Java, we can create components with the help of classes, right? So we can say, hey, if you want to build a car, maybe let's create a class called wheels. Let's create a class called engine. Let's create a class called seats, right? So all these things comes together. Now, every class here is, whatever class you work with, let's say wheel class. A wheel class will also have its own behavior, right? So we'll have some data, we'll have some behavior. So here, if you talk about behavior, if you want to define, hey, this is how the wheel will move, this is how the engine will work. Now, all those things comes under a behavior, and we do that with the help of methods. Just to simplify this, let's say I create a class, and I will name this class as ABC. It can be any component, or maybe I can say this is a computer. Of course, even a computer is made up of multiple components, but just to simplify things, let's say we have a computer. It's a class, okay? And then in this class, I can define the behavior, what a computer can do. A computer can run games, a computer can play music. So I can say, hey, I want this computer to play music. In fact, in my childhood, this is what we used to do. When we used to get computer to access, I was in my 11th standard when I got full-fledged use of computers. And at that point, when I say I got to use computer, what the thing I will do? Of course, we can use Paint, we can use MS Docs, which is the Word, or we can use some amazing media player to play music, right? So here, let me say this computer can play music. Okay. Now, how do we define that's a behavior? We do that with the help of a round bracket. And then this play music will do something. So we have to open the brackets and close. This is where you will define what is a behavior of this particular method. And every method, we also have to specify what type of access you're giving. Of course, we'll talk about access later, but at this point, let's make it public. I just want it to be accessed from anywhere. And also, a method will do something, right? So that's what we are doing here. Now, this method will do something, and it will give you something in return. Example, let's say if I ask someone here, so let's say if I have Harsh here, and if I say, hey, I want a pen. Now, at this point, as a external method, I'm asking Harsh to give me the pen, right? So what I'm expecting from Harsh, a pen, right? Maybe I want to just get some information. Maybe I can just ask Harsh, hey, can you just call someone to send this information? So at this point, if I'm asking Harsh to call someone, I'm not expecting anything in return. So what I'm doing is, when I say I don't want anything in return, is void. So of course, your method can give you back something. You can say a method can give you an integer value. A method can give you a pen as well. So this method, which is play music, is not giving you anything. It's just performing some operation. Now, of course, we can write multiple lines of code here to play the music. But just to keep it simple, I will say music playing or playing music, doesn't matter. So we are just writing this statement here. Now this is my method. That's how you define the behavior. We can have some extra methods as well. I can say public, and this is get me a pen. Okay, this is a method name I have. And this method will give me something. So I will say return. So what it will return? So let's say I want to get a pen, but at this point we don't know how to get a pen, right? So let's say I will return a 5 value. Now if we talk about this 5 is a number, right? Or maybe I can just return pen. Now if you can see, this pen is a string. Now string is a special type in Java, which is a combination of different characters. So we have to put that in double quotes. Now we are returning a pen. So here we can't say void, because when you say void, it means you're not expecting anything in return. But here we are doing that. We are returning a pen in a string format. So we have to say I'm returning a string. So whatever type you return here, you have to mention that particular type here. Makes sense, right? So basically we got 2 methods, and then it is also possible that when I say, hey, get me a pen, Harsh will say, okay, I will get you a pen, but you have to give me money first. Of course, right? No one will give you something for free. So I have to provide the money here. So if you ask a method to do something, it comes under your design, how you want to design it. Do you want your methods to accept something from you, or what type of data you want to return? So here I'm saying this get me pen will get some integer value. So let's say I'm passing 10. So normally one, or not 10, but a variable, which is num, or we'll say cost. So basically we have to pass a number, let's say 10. So one pen will cost you 10 rupees. And then if you want to call this get me a pen, you have to pass the value as well. Makes sense, right? Now we have 2 methods. How do we call them? So from this main, which is in some other class, if you want to access this method, the first thing you have to do is you have to create an object of a computer. As I mentioned before, every time you have a class, which is just an idea, right? Class is a blueprint, an idea. And if you really want to use those ideas, you really need an object. How can we use something without the object, right? Even if you want to call someone, you need a phone with you, a physical phone, not a virtual concept using which you can call someone. Okay, so let's say here we have to get object of computer. So we'll say computer comp. Of course, you can give any reference name here. We can also say obj, which is very common. So you can say computer obj equal to new computer. And that's how you create the object, right? So this is a line normally we use to create object, but only these 2 things are actually creating the object. Here, this is a reference variable. And now using this obj, I can actually call both the methods. I can call play music. So let's try with play music only. And let me clear this screen here. So we'll say Java C demo.java. And you can see we got the compilation done. Let's run this code. I will say Java space demo. It says music playing. So this is working. Can I call get me a pen? Let's try. So I can say obj dot get me a pen. But if you can see, get me a pen is asking you to pass a integer value. So I will pass 10 here, and I can just run this. The only thing is, if you say get me a pen, it returns a value which is a string format. That also means that when you call get me a pen here, it will return you something. It will give you something. So I will put that into a string str. So I can say string str. Of course, you can use any variable name, but that's a string. We are not using integer or double here. We are working with string. And of course, we'll have a separate session or separate video on string. At that point, you will understand that. Here, what I will do is I will just try to print this str just to see what it is printing. I hope it will print pen. And yeah, that's what we got. We got music playing and we got pen. Cool. Now there's one more thing here, which is what if in this cost, so let's say you're passing 10, that works. But then what if someone is passing, let's say 2? Now, of course, we'll not get any pen for 2 rupees, right? Of course, at this point, it will work because we're not doing any checking. I don't want to return a pen when the cost is 2. So how do we do that? I want the minimum value for this cost to be, let's say, 10 rupees. In that case, you can, remember we have talked about if else. So we can actually use if else here. So we can say if the cost is less than, or the cost is greater than equal to 10, then return pen. Otherwise, don't return pen. right? It's very simple. If the cost is more than 10 or equal to 10, then you have to return pen. Otherwise, don't return pen. If someone is calling this method, you have to return something. In this case, you have to write else return, and you can say return nothing. The weird thing is, at the time of recording, there's a phone called nothing phone. So basically what you're returning here, a nothing phone. Ignore my poor jokes, but yeah, so that's what you're doing here. You are returning nothing. And you can see I'm passing 2 here, and of course the condition will be false. It should return nothing. Let's try, compile, run, and you can see we got nothing. Okay, so this is working, and this is what we wanted. You can do one more thing. You can simply say, you don't even have to mention the else keyword. You can simply say return nothing. But then you will say, it will execute return nothing anyway, right? The thing is, the moment your code sees return pen here, it will just jump out of this method. It will not execute the further statement. What I'm saying is, if the value, let's say, is 12, not 2, 12, of course, this will pass the condition. And then once it is true, it will execute return pen. The moment you say return keyword in a function or a method, it will return the value. It will just go back. It will stop the execution. And that's what we will be getting here. So if I compile this code and run, you can see it says pen. It's not printing nothing. But yes, if the value is 2, in that case, this condition will be false. This one will be false. And it will not execute the return statement of if. It will execute return nothing. And that's why it will print nothing. Now, if you can observe, there's one difference between these 2 methods here. If you can see, we have get me a pen and we have main. The difference is of static keyword. And we have not talked about static yet. Now let me talk more about the methods, and this is important for the further concepts and very interesting. So let's say, again, let's go back to our calculator to get some more understanding of it. So I will say it's not a computer, it's a calculator. Of course, in a computer as well, we can do calculations, but just to keep it simple, let's go with calculator. So we got this class here, and let me also create the object here. And there's no compulsion that a class should have the variables and methods. We can keep it empty as well. That perfectly works. So you can see we got calculator obj equal to new calculator. And then here, I want to, let's say, add 2 numbers. I know you'll be saying we have done that before, but let me just do that once more and you'll understand what I'm doing. So you can see I'm saying public int, I want to add 2 numbers. Why int is because I'm expecting some return value, and it will accept 2 values. One is n1 and one is n2. And here I want to return the value. Of course, you can simply return the addition of it. So you have a choice. You can create a separate variable. What I'm saying is you can create a variable like result, and you can say n1 plus n2. And here you can say return result. This works. We can actually do a shortcut here. If you look at this variable, result is only used once. We have assigning the value, and then we are returning a value. So can we just do this? Can we just say return n1 plus n2? We don't have to create a new variable. Okay, so you will get used to it. Once you start making progress, you will get used to it. So you can see we got a calculator which can add 2 values and then returning the addition of that. This perfectly works, right? So what I will do here is I will come back to my code. I will say obj dot. I can call this add method which will take 2 values, 3 and let's say 4. So it will return a value, right? So I will say int r1. So int r1 is equal to this addition, and I can actually print this value. So let's compile this code. Not running directly. First, you have to compile the code and run. You can see we got 7. This works. So what we are doing is we are calling add by passing 2 values, which is 3 and 4. What if you want to add 3 values? Well, that will be tricky. So of course you will say, think about this. If you want to add 3 values, the first thing comes to your mind is, it's easy. We can change this particular method which accepts 3 values, right? And of course you have to pass 3 values, because if you pass only 2 values, your compiler will feel bad. Compiler will say, hey, you have a method which accepts 3 values and you're passing only 2 values. Not fair. Okay, so you will say, okay, I will pass 3 values, and that perfectly works. I will just compile this code and run, and you can see we got 7. Oh, we got 7 because we are still adding n1 plus n2. We are not adding n3. So let's compile and run. You can see we got 12. This is working. But there's only one little problem here. Not a little problem, actually a big problem. What if now you want to add 2 numbers? Sometime you want to add 3 numbers, sometime you want to add 2 numbers. Again, it will not work. Your compiler will say, hey, we are expecting 3 values and you're passing only 2 now. Unfair, right? Okay. How do we solve this problem? Maybe there is one solution which comes to my mind is, what if we can just create another method which can accept 2 values? I can say public int add 1, which will accept int n1 comma int n2, and this will return n1 plus n2. Now this perfectly works. The only thing you have to do is you have to remember what method you have to call, because add1 adds 2 numbers and add adds 3 numbers. Of course, you can make it more effective by naming the method name as add 2 numbers, add 3 numbers. Okay, we were able to solve that, but the problem is the moment you have more methods, you have to maintain the documentation for those methods. And also, it's very difficult to remember the method names. Add method looks much better, right? Instead of adding 2 numbers, adding 3 numbers. So can we do this? Can we have the same method name? That can solve our problem. Like this. Of course, I have 2 methods, but they have the same names. The only thing which is changing is the parameters. If you can see, this add takes 3 parameters. This add takes 2 parameters. So that's right. We can have the method name with the same name. The only requirement is they should have different parameters. Example, if you make it same parameter here, again, it will not work. It will say it's a duplicate method add. We can't do that. So basically, we need to have different parameters. And it's not like they have to be in numbers. They can also be of a type. What I'm saying is, what if you want to have the same method? I can just reuse my code here. And instead of int, I can also have a double value. So I can say double n1 and n2, and I can just simply return. The only thing is when you have double and int, you return with double, because double plus int will give you double. And that's it. So it's not just about the number of parameters, it's also about the type of parameters. So you can have different number of parameters, or you can have same number of parameters but of different type. Now this concept in Java is called method overloading, because you have 2 methods with the same name. In fact, 3 methods here with the same name. What is different is parameters. It is called method overloading. Now likewise, we also have one more concept, is called method overriding, where you also have the same name, but things work differently there. It's more about inheritance and a thing. At this point, we are focusing only on the overloading part. How about this? See, every method will have a name and parameters. What if you have the same parameter but different return type? Even that will not work. It has to be with the parameter itself. This return doesn't matter. What matters is the name and the type. Now let's try to understand what is there inside the JVM. So what I will do is I will just go back here and let me draw a bigger JVM, because that's what we are focusing now. If we talk about the outer box for this, that's your JRE, outer box for that is your JDK, but let's focus on JVM here. And I also name it JVM. Now what we normally do here is, this is where you execute the code, right? Now question arises, how exactly we are going to execute the code? Of course, there is something called a runtime or the runner which will do that. Here we'll focus more on the memory level. What happens when you create a variable, when you store a variable? In your memory or inside JVM memory, we can categorize into 2 parts. The first one is this. This is how it looks like. Of course, I want you to guess. So basically this is a area where you can store your data, and that has a feature which is last in, first out. Example, let's say if you send data, which is 5, 6. So let's say if you send data 5, 6, 7. Now the first value which entered was 5, second value is 6, third value is 7. Now when you try to get the value, you will get 7 first, because that is last in, first out. Now this is called stack. So basically you have a memory which is called stack memory. Now apart from this memory, you have one more which is you call as heap. Now on purpose, I'm drawing this type of image where it represents that it expands, right? So this memory here is your heap. So basically we have a stack and we have a heap memory. So in the stack, you store data in a different sequence, and in heap, you have an open space. Now, before we jump into this memory, how it works, let's focus more on this code, okay? Remember when we talked about calculator and then we have talked about these 2 variables? Now here, when you talk about this n1 and n2 variable, they are variable, but they are local variables, okay? Just to reiterate, those are called local variables. Now, what do you mean by local and what are different type of variables we have? So if I create a variable here, let's say num. Now in a calculator, we have a num variable. And then in a method like add, we have n1 and n2. That's right, the n1 and n2 are part of add method. Now here, the n1 and n2 become your local variable. And num here becomes your instance variable. That's right, the word is instance. Now what happens is, the moment you create this, the moment you have main, now the beauty is every method will have its own stack. That's right. It's not just one stack. Every method will have its own stack. And if you can see in this code, we have two methods, right? So of course we will be having two stack. What I will do is I will just redraw the stack to accommodate more data. So what I will do is I will just zoom it a bit. So let's say we have a stack here. Okay, this is your first stack, and a stack will have two sections. Okay, and basically it will have two columns and multiple rows, depending upon how much data you want to introduce. Now, if we talk about this main, this particular stack is actually your main stack. So I can say this is my main stack. Now in this stack, you will be having your data. So what data I'm talking about? If you go to the main method, if you can see, we have a variable a. Okay, now that's also a local variable. Okay, so I can say, hey, I have a variable which is called a here. So I'm just writing a there. Now what's the value? At this point, there's no value for a. So I will just ignore that part. Maybe let's not even mention that. Once we talk about string, then it will make much more sense. Let's start with the variable here. Maybe I can create some more variable just to understand. So I will say int data is equal to 10. So what I'm doing is I'm creating a variable, which is a local variable again, inside the main method. And you can see, we can say this is my data variable, and the value for that is 10. Straightforward, we can assign the value 10 because that's a value. So basically your stack will have a key and a value. A key would be name of a variable and value will be 10, the value itself. Now coming back to R1 here. Okay, let's ignore this obj as of now. And mind you, this obj is also a variable. So it will be a part of the stack. So data, obj, R1, they all are variable. So it says, okay, I want to have R1 as well. So I got R1 variable. But what is a value for R1? And that's where it will basically call the add method. Okay, so it will call the add method, but we don't have an add method in the memory as of now, right? So if you see in this memory, nowhere we have add. So basically what we have to do is it will create a new stack out of it. So we got another stack, and the name for this stack would be add. And of course it will have two sections and multiple rows. So two column, multiple rows. Now if you see, in this particular add, we have two variables, n1 and n2. So of course we have to define those two variables, n1 and n2. What are the values for these two variables? We are passing them, right? 3 and 4. The moment you pass these two values, it will go to n1 and n2. It will assign those values. So the value for n1 is 3. The value for n2 is 4. Okay, that's good. And then you are executing add method. So in add method, what we are doing is we are just adding those two values, 3 and 4, which is 7. It will return the value. Whatever value you have returned, it will return the value with this particular method to R1. So that's right, we got R1 as 7. I hope this makes sense. Cool. So we have done the changes there as well. So R1 is now 7. What else? Now what happens to this method add? We have called it, right? So there is a special method area where you have a different stack of calling methods. So when main call add will execute first. Once add is over, it will be gone. At this point, let's not talk about the function calling. Let's only focus on the data areas. So basically this is what we do there, right? But what happens with the object here? Now that's tricky. And what happens to this num variable? Where do we put the num variable? In the add stack? In the main stack? No. If you can see, num is not a part of add, is not a part of main. The beauty is you can actually print the value of, or you can use the value of, you can use a variable num inside a method. I can actually print the value of num here. So maybe I can set the value as, let's say 5, and I can actually use this num inside a method. See, using a particular variable and declaring the variable inside a method are two different things. At this point, we are using it. We are not declaring it inside a method. N1 and N2, they are declared inside the add method, but not num. And that's why if I can show you, if I compile and run, it still works. You can see we got num, which is 5. So we can use it. But the question is where it resides. not does it resides in add stack or main stack? The answer is, and that's where we have a heap memory there, right? Now inside the heap memory, what happens is, just focus on the line number 20 here. On line number 20, what we're doing is we are saying calculator obj. Now, if you remember, we have talked about this multiple times. This obj is not an object. Now people coming from C++, you might be having this urge of calling obj as object, but no, that's a reference variable, but that's a variable, right? Now this variable, where it will get created, it was declared inside main. So of course we have to say obj here, but the question is, what will be the value? Now for that, you have to understand what is happening here. Now when you say new calculator, it will simply create a new object. Where? It will create the object inside the heap memory. This is where you will get your object. And inside this object, you will be having two things actually. So let me just draw the first object quite bigger, and later on we can draw it small. So this is your first object. The object will have two sections. The first section will have all the variables, all the instance variable, not local variable. You know why? Because local variable are part of a stack. So they're part of the stack, not of heap. But if we talk about the instance variable, like we have num here, they are part of the heap memory. And this is where you can say variable name, num, the value for that is, let's say 5. We have assigned 5, right? And then this particular object will also have methods, and in this heap, we are saying this is an object of calculator. It will also have the method declaration, so it will have add method. But then it is only have the definition of it. The actual area which add will consume will be of stack, okay? If that makes sense. Of course, we can have extra methods as well. At this point, we only have one. Now this particular object will also have its own address. Let's say the address is 101. Of course, right? When you store the data, it has to get some address. Now that's 101. Of course, it will be a complex address. At this point, I just want to keep it simple, 101. Now this 101 will be stored in the stack. So every time when you say obj.add, the actual execution starts from stack itself. You say, okay, someone is trying to call. Example, if we talk about line number 21 here, we are saying obj.add. That means we are using obj object to call the add method, but it belongs to obj object, right? Which is the object here. So it will simply use this particular address. It will jump to the object and it will call the add method. So can we say there is a link between stack and heap? Yes, because of the address, right? And that's why you can use this object multiple times. And that's important. In future, we are going to talk about anonymous object as well. And we'll discuss why this link is important, and it will make much more sense. At this point, just imagine there's a link. Every time you say obj.add, you are going from main, looking at the stack, then you are jumping towards the heap to look for the object. I hope that makes sense. The good thing is we can actually create multiple objects. I can just copy this line, or maybe I can say code reuse, and I can create another reference, which is obj1, and we got a new object here. That's right. In total, we got 2 calculator objects. So with this changes, what we are getting is we will be getting a new object here. Let's say the address is 105, and it will have the method. It will also have num variable, and the value will be 5. Of course, you can change it, and you can have add method. Okay, this is num, okay, not n, but imagine that's num. And he will be having obj1 here, because in main we have one more declaration of obj1. It will have the address 105, and you can imagine there's a link between stack and heap. Okay. Now, when I say these 2 different objects have 2 different value or 2 different num variable, but they have the same value as of now, right? Example, if I come back here, you know what I will do? Just to simplify this thing more, I will just comment all the other print statements to see only one output. So here what I want to do is I want to print obj dot. That's right. If you want to even use the variable, the instance variable, you have to use the object name, which is obj1. In fact, the first object is obj. The second object is obj1.num. So you can see we got 2 objects and we are printing the value of it, each num value. And if I run this code, you can see we got 5 and 5. You know why? Because that's the value you have assigned. Now my question to you is, before printing the value now, if I say obj.num is equal to 8, you can see I'm changing the value of only one object. What do you think? Will it reflect on both the object or only one object? Let's try. So when I say compile and run, you can see it is impacting only one object. It's because there are two different objects, right? Example, let's say if I have this phone, this is Samsung, and let's say I have the exact other Samsung phone, and one of it, so let's say if the glass of one phone is broken, will it affect the other phone? Of course not. They are individual phones, and damaging one phone will not affect the other phone. So that's the important point to remember here. So yeah, that's it about the data area. So we have different areas. We have stack and heap. In this video, we'll talk about array. Now, first of all, why do we need an array? So in this video, we'll talk about the need of an array. If we talk about a variable, so normally when you create a variable, it's very simple, right? In a variable, you can store a value. Now, this can be of type integers, float, double, string, doesn't matter. You have a variable and you can store values in that. Example, let's say if we talk about, let's say int variable. So how do we do that? How do we work with int variable? So we say int I is equal to 5. So what happens is you have a variable here, which is I, which has a value 5. What if you have one more variable here, which is let's say j, and it has a value which is 6? Maybe one more. You have int k is equal to 7. So you can see we have three variables here, and you have three values. Now, first of all, why do we need three variables here? It's because we have three values. What if you can save all these three values in one variable? Now, why I'm doing that is because the moment you have more variables, you have to work with multiple variables. You have to remember those variable names. You have to document them. Instead of that, if you can save that in one particular variable, it will be easier for you to maintain the data. And also, it's not just three values. You might have 10 values. You might have 20 values. You might have 100 values. You don't want to create 100 variables, right? So for that, we can use a concept called array here. Now, how it works? We can create a simple variable, let's say num, and in this num, instead of storing one value, I can store three values. So let's say if I have 5, 6, and 7, I'm storing these three values. Of course, we can put comma to separate them, and then we can put them in a curly brackets. To represent that, this is a bunch of values I want to store, and I want to assign that to a variable num. Now, being a simple integer variable, it will not work. You cannot simply take an integer variable by assigning 4 values. Reason? The moment you create a variable here, it occupies some space. Now, if you come back to this particular variable here, of course, this will occupy some space. Now, in that limited space, you can't store multiple values, right? You have to mention somewhere, hey, this particular num here is not a normal variable. It's a variable which can hold multiple values. And the way you do that is by mentioning a square bracket. You mention, hey, that's an array which can hold multiple values. Now, if you want to imagine this, you can imagine an array as a tray of cups. So let's say from a kitchen, if you want to carry 4 cups with you to the hall, of course, you can carry 1 cup at a time, or maybe 2 cups because you have 2 hands. Or maybe you can carry just 4 cups by dipping your fingers in the cup. But the ideal way is you can carry a tray. Now that tray becomes your array, which can hold multiple cups. So that's your array. So why do we need array? Of course, if you want to store multiple values in one particular variable, we can use array here. The beauty is, it's not just limited to 3 values. You can store 100 values. It's just that once you define the size of an array, you have to stick with it. Example, let's say, if you want to define an array, let's say num1, and if you want this to be an array and you don't have initial values, here at this point, if we talk about these 3 values, you know what are the values are. But what if you don't know the values? In that case, you can say new int array. So you can specify, okay, so I don't know the values. It's just that I want to create an array. This is how you do it. I want to create an int array, and you have to also mention the size here, let's say 4. So this particular num1 will have 4 values, not more than that. Okay, its size is fixed. You can't increase dynamically. Now, once we know why do we need an array, let's continue with the example. Now, once we know why do we need an array, let's start the implementation. So in this video, let's try to create an array. Now, how do we do that? In fact, in the last video, we have seen a basic syntax. So let's use it. So we can simply we can mention the type of array we are using, which is int, and we can give a name to it. Let's say nums. And then we have to put a square bracket to define that's an array equal to, and then if you already have the values here, you can assign the values itself, or you can specify the values dynamically. So here what I will do is I will put a curly bracket here, And since I know the values, I can directly put the values here. Let's say 3, 7, 2, 4. So let's say we have these 4 values, okay? And now I got an array with 4 values. It's that simple. The only problem is, how will I use those values? How will I print those values? Example, let's say I want to print all the values here, or maybe even this first value. Let's say I want to print 3. Because at the start, if you remember, when I mentioned that instead of using 4 variables, I can use an array. In the 4 variables, it actually makes sense because every value will have a different variable name. It's easier to fetch here. How will you fetch the first element from an array? Now what happens is, if I want to represent that array in a memory structure, what happens is, see, if you have one variable, you can create one box, right? But if you have multiple variables, you have to create multiple boxes here. So 1, 2, 3, 4. Now this is your array, which is names, nums. Of course, the same code which you are doing. And then in this array, you'll be having these 4 values, which is 3, 7, 2, 4. Now what it means is, if you want to fetch the value, of course in one variable you have 4 values now. If you want to differentiate between all these values, you have to use some numbers, right? Some index numbers. The way you do it for the table columns, right? So we have numbers. In the same way here, we have to give them numbers. Now if you are assuming that this will be number 1, 2, 3, 4, no, that's not how your computer works. So array numbering starts with 0. The point, remember, it starts with 0, 0, 1, 2, 3. Now those are the index values. In fact, you know what should I do? I should convert that into different color. 0, 1, 2, 3. Now these numbers in yellow color are the index numbers for the array. Okay, so 3, 7, 2, 4, they are the values, but 0, 1, 2, 3 is the index. That means if I want to fetch the values, I have to mention nums. In this square bracket, you have to mention the number. Which index value you want to fetch. I will say I want to fetch 0. Now in this case, if we do that, let's compile and run. You can see we got 3. This is working. So whatever value you have here, you're able to print it here. What if I want to change this? I want to print, let's say, I want to print the value at number 1. So compile, run, you can see we got 7. So basically you can actually print these values one by one. Okay, that sounds good. How about updating the value? So let's say I want to change the value 7 here. I want to set 7 to 6. So basically I want to change the second value and I want the value to be 6. In that case, you can say index of. So when I say second value, it's actually 1 because the numbering starts with 0. So to say nums of 1 is equal to 6. Now that's how you change the value. And now if you try to fetch the same value here, let's compile and run. You can see we got 6. I hope that makes sense. So basically you can assign the value, you can print the value as well. What if you want to make it dynamic? Okay, how do I do that? I don't have these values, let's say, and then still I want to create an array. In that case, instead of using this syntax here, what you can do is you can say new int, and in this square bracket, you can mention the number, the size of the array, which is 4. Now this is another syntax. The only thing is by default, all the values of this array will be 0. So of course you got 4 boxes, but the values are 0. And if I don't set the value here, let's check what is the current value for the index number 1, which is 0. So all the 4 values are 0. I want to change the value. So what I can do is you can specify, I want to change the index value 0 to, let's say, number 4. And then nums of index 1. So for every index, you have to set the value. Let's say 8. And nums of 2 is, let's say, 3. I'm just giving random values. Okay, it's not like I have all these values prepared in my mind. But let's say for 3, the value is 9. Okay, so we got these values here. Now how it looks like in the memory, it's very simple. You got an array with 4 boxes. So the index value is 0, 1, 2, 3. And the actual value, so before assigning the values was 0, 0, 0, 0. But now since we have assigned the value, the value has been changed. The values are 4, 8, 3, 9. Okay, yeah. So 4, 8, 3, 9. Those are the values you have. Now, this is how you store the value. Now, if you can also fetch the value, let's see what happens. So at number 1, index number 1, we have value which is 8. And you can see we got 8. So this is working. But what if you want to print all the values? Now, that will be tricky. Let's try. So what you can do is if you want to fetch all the values, of course you can just print this statement multiple times, right? The only difference you have to do is you have to say index of 0, index of 1, index of 2, index of 3. And you can simply fetch all the values, right? So compile and run, you can see we got all the values. This is working, yeah? But don't you think we are doing the same thing multiple times? It's just that the numbers are changing that too in sequence. You know what we can do here? That's right, we can use a loop. So I can just remove all the extra statement just by using one statement. I can put that into a loop. Now the main question is, when I start a loop here, the loop will start, of course you have to say int I, but what should be the initial value for I? It should be 0. You know why? Because the index value starts with 0. And then less than, should I say equal to? We just have to say 3 there, because the size of the array is 4, you have to stop at 3, and I++, that's one way. Or you can say less than 4, whichever format you follow. Okay, and then just put that into a curly brackets. Now we can just shift this statement in the block so that it will execute. So basically we are using a for loop to print this. Now the only thing is, if you can see, we are mentioning 0, which means the loop will run for 4 times. It will simply fetch the index 0, I mean 0th element every time, or first element every time. We have to change this. We have to make it I so that the value of I keep changing here, and you will get new value at a time every time. So compile and run. You can see we got the values. So this is how you can use an array. Of course, there are a lot of things related to array. How can we create multidimensional array? Can we use a different kind of loop? So till this point, we were able to understand what is an array, right? So basically, we have seen this example where we have an array which has 4 elements, right? We have 3, 7, 2, and 4. Now, if you look at this, can you say this is array of elements? Of course, it makes sense, right? So we can say this is array of elements. Now, can I create something like this? Let's say I want 2 different arrays. So I got this as a first array, let's say 4 elements, and whatever elements we can have here. Let's say 5, 2, 6, 1. So we got this array. And then I also want one more array here. Right, let's say we got, in fact, we need 2 more array. And of course, they will have some values. Doesn't matter. I'm not concerned about the values as of now. We have some values there, okay? And of course, every array need to have a name for it. So can I say this is N1 array, this is N2 array, this is N3 array? We can give any name to an array, right? In this case, I'm just naming them as N1, N2, and N3. Okay, so if you're gonna have multiple values as one array, can we have multiple arrays combined to form one big array? What I'm saying is, can we just have an array of array? Something like this. I know that looks weird, but can I use a different color just to make you understand this? What if you can just have an array? So this is a big array which has 3 elements. And this particular array, the bigger element, let's say the outer array, we name it as nums. So this nums array will be having 3 different arrays. That sounds good, right? Now this is called multi-dimensional array. So ignore my spelling there, but this is called a multi-dimensional array. Now how will you represent this? It's very simple. If you want to represent this, we can simply say, hey, I have a nums array which is multidimensional, which will have array of array. The way you can achieve that is very simple. You just have to put 2 square bracket, because 1 square bracket represents that's an array. Now, can we say the nums array is of array? Yes, we can. And we have to mention the type as well. So it will be of type integer, let's say. And then you have to say new, and you have to mention again 2 square bracket. Now, but what will be the values here? See, if you have a single array, it's very simple. You can just say the size is 4. But here, if we talk about the size, how will you define it? So if you compare this particular thing, can we say we have one big array which has 3 internal arrays to it? So can I say this is 3 internal arrays, and each array has 4 elements. Let me repeat. In this big array nums, we have 3 small arrays, and each array has 4 elements. Okay, that's how you define it. Now, how will you assign a value to everything? So what you can do is, if you want to represent that in a good diagram here, what I can do is, I will just draw that once again. So we have one big box, and in this box we have 3 sections, and each section has an array, and each array has 4 elements. 1, 2, 3, 1, 2, 3. Simple, right? Now, how will you give numbers to it? So outer array will have number as well. So it will be 0, 0, 1, 2, and each array inside will be having their own indexing. Let's say 0, 1, 2, 3. Now let's say if I want to represent a particular element here. Now what element? So let me just zoom it. What element I'm talking about? Let's say I want to target this element. In fact, let me just fill some values here. 5, 2, 6, 1, 3, 2, 1, 7, 4, 8, 1, 2. Random numbers, okay, nothing in my mind. I'm just giving random values here. And now I want to target, let's say, the first value, 5. How will you target 5? What will be the output for? How will you find this value? So 5 here becomes 0, 0. Simple, right? Because this is 0th row, 0th column. If I want to represent this 6, so this 6 would be 0, 2. If you want to represent this 7, so what do you think? In your mind, if you can think about this will be 1, 3. And if I want to represent this 4 here, this will be 2, 0. This 2 would be 2, 3. Okay, that's how you represent the values here. Quite simple, right? So let's try to create this in a code now. So what I will do is I will just remove all the extra things from here. I don't want student anymore. And let me just simplify this stuff. All the code gone. And I'm just assuming that you are doing the code by yourself after watching each video. And that's how you do it, right? It's not just about watching videos. It's also about implementing it. So what I will do now here is I will just create an array of nums, but this will be a 2-dimensional array or a multi-dimensional array. And I can say int here. So we want 3 rows and 4 columns. Now there are different ways of saying this 3 rows, 4 columns, or I can say we have 3 rows and each row has one particular array of size 4. As simple as that. And here I can just come back and I can, by default, all the values are 0, right? And in fact, let me just do that. Let me print all the values. Now, how do you print it? We can use a loop here. Now, the only thing is we have to use 2 loops or nested loops. We have talked about nested loop before as well, but let's try. So what I will do is I will say int I is equal to 0 and I less than equal to, okay, I less than, now what should be the value? It should be 3 for the outer loop, and then I plus plus. And then for the inner loop, see, the outer loop will hover towards all the rows. Now we have to go inside the row as well. So to go to inside the row, we have to say j is equal to 0 and j less than 4 and j plus plus. And here, let me print the value. So I will simply say nums of. So what is representing the outer loop? It's I, which represents the outer box, and j for the inner box. Because for every row, we have to start from 0 again, right? Example, if you see here, it will start with 0, and then for every row, it will go for 0, 1, 2, 3, right? Once you reach 3 here, it will jump to the next row, and again it will start from 0, 1, 2, 3. Then it will jump to the last row, and then again it will be 0, 1, 2, 3. Right? So if you want to represent a number, you have to say nums of I and j, because I represents the row and j represents every column here. Okay, let me just run this code. Let's see what happens. I will say clear, compile, and run. You can see we got all zeros. Maybe you wanted to print this in a box structure. What you can do is, instead of printing ln, because ln will print on a new line, you can say, let me print a value and let me also give a space here for after every number. And then once you complete the inner loop, once you print one row, just come on the new line. So I will say just print ln, it will come on new line. Let's see if this works. Compile, run. Oh, we got it. So we got a 2-dimensional array, right? The only thing is I want different values here. So I can assign them manually. I think this is a good time to talk about how do you fetch random values. So we have this math class in Java, which will give you some random values, right? So this is a inbuilt class which will generate a random value. And to understand that, let me just go to random function. Random function returns a double value. So it returns a double value. If I store that value in temp, or maybe random, the variable name is also random. The only thing is we'll not get integer value. And also I guess the random function gives you a value which is in points, decimal points. Greater than or equal to, yeah, basically it will give you value less than 1. So what I can simply do is I can multiply the number by 100. Let's see what happens. So whatever value I receive, I will just multiply that by 100. Again, wait, I'm just doing some experiment here. Now once you multiply that, we have to also do a typecasting. Now we have to convert that double value into int. Now whenever you want to convert something, we can use something called a typecasting. So double value will get converted into int here. And I don't want this to be generated only once. So let's say initial value for, I'll just cut this part, I will use it later. Initial value for random is 0. And I want to find the new value every time to assign the values here. And I can simply use the same loop, right? Let me just print that statement so that I will have it somewhere. And I will just copy and paste it here to assign the values. This time I will not print values, I will assign the values. So I can say nums of I and j is equal to this value, this formula. I think this should work. I'm not sure what will be the value it will assign. You know, we don't even need this variable basically. But how will I know what value it is printing? So let me also print the value of what it is assigning so that I will know what is happening. So compile and run. Oh, it's assigning 0 values. Why? I think it should be typecasted after we do the calculation. Compile, run. Oh, got it. So you can see we got this random values. So what was happening before is we were typecasting the random values and then we were multiplying by 100. What we have to do is, since random will give you in point values like 0.12 or 0.74, all these 0 point values, we just have to multiply that by 100 so that you will get a double digit number at least. And you will simply typecast it later. Of course, it will have 72 point some values. I'm just typecasting it. And then, yeah, so let me just remove this printing so that you will get the exact box here. Compile and run. If you want single digit, I think multiplying by 10 should work. I'm just assuming, yeah, even multiplying by 10 works because we only want single digit. Yeah, that's how you generate random values. That's how you print it. Random values are fun. Yeah. So one of the library which we have used is math. Okay. We can do one more thing here. So while printing, we have used a normal for loop, right? Can we use a enhanced for loop? Can we? Let's try. So in enhanced for loop, what you do is you use a for loop and then from the array, it gives you the first element, right? Now coming back to our drawing board here, if we talk about this particular array or this array here, it will give you one value at a time, right? So we can simply accept that in an integer variable. But what if two-dimensional array? Here, if we talk about, hey nums, I want the first element, nums will throw the entire array to you. It will not throw one element, it will throw the entire array. And that's what you have to handle. So here you can say int, I will say n. Now n here is not a simple array, or it's not a simple variable, it's an array itself. It is coming from nums, okay? So let me repeat, n is not a simple variable, it's an array, a single dimensional array. So we have to say with square bracket. Now once you get the array, from that array, we have to get the first value. So we have to use one more loop here and you have to say m colon n. Now m is taking the value from the array of n and then we can simply print the value. So I will just remove this bracket. I will say print m because that's the element. And with that, I also want to give a space. And now here I just want to write in the second line. Okay, so both are doing the same thing. Let me prove. I'll clear this, compile, run. So this is printed by the first loop. This is printed by the second loop, the enhanced for loop. So that's how we use two-dimensional array with different types of loops. So let's say we have talked about multi-dimensional array, right? Now in multi-dimensional array, of course, you specify the number of rows you want. So if you look at the code here, we have specified what are the rows we have. And in each big array, we have an array, small array, which is of size 4, right? And then we were assuming that every row or every array inside the array will have the same size. Example, if you look at these 3 arrays here, they have the same size. But what's the guarantee that they will be having the same size? What if you have an array here which is of size 3, here you have a size 4, here you have a size 2? Can we do that? Can we have the internal arrays or the columns basically having less values? It is possible. So what I'm saying is this 4 is not fixed. We can simply say, hey, I don't know the number of columns I have. Yes, we can do that. So the internal array or the inside array can have different size of elements. Now this type of array is called a jagged array. So before this, we talked about normal or regular arrays where you have to specify the size. At this point, we are not doing that. See, we have to at least specify how many arrays we have, but internally, those rows, we don't have to specify how many columns we have. That we can manage. But how? How we are going to manage? So what we can do is, once you specify that I'm not sure about the number of columns here, which is jagged array, then we have to individually specify how many columns you have. What I'm saying is, you have to say index of 0 is equal to, for the first array, you have to specify how many values you have. So you have to say new int 3. So that's the first thing we have. And then likewise, we can specify the other values. I can say copy, paste, and paste. For the first index, I have the size, let's say 4. For the second index, I have a lesser size 2. So that's how we to manage this one. Now this is your jagged array. Okay, I mean this one. This is your jagged array, not a normal array. Because individually for every column, we are specifying what's the size of it. Now, if you try to imagine this in a new structure, let me draw it here. So you got a box. This is the outer thing. And in this, you have 3 rows. And each row will have a box. Now the first box will be of size 3. The second box will be of size 4. And the third box will be of size 2. Okay, so we have different size of array in different location. So for 0th index, we have 3. For the first index, we have 4. For the second index, we have 2. That's what we have done here. Okay, now once we specify that, the thing is, how will you save the value inside this? Now the problem is, the number of rows are fixed, but I don't even want to mention the number here. The way you can solve that problem is by saying nums of, or maybe you can say nums.length. This will show you the number of rows you have, but for every row, okay, in fact, you know what we should do? We should save that value somewhere. Or maybe we can say this, nums of I, for every row, I want to know the size. So now basically we are specifying the size of each array. So for the first array, I have 3 values. For the second array, I have 4 values. So for every row, what's the length we have here? That's what we are specifying. And now, while printing as well, instead of using normal for loop, let's use enhanced for loop. And the beauty about enhanced for loop is you don't have to mention the size anywhere. It will automatically detect where the values are. Okay, so if I try to compile this code and run, you can see this is the values you have. The first row we got 3, second row we got 4, and the third row we got 2. Okay. Now this is the jagged arrays. So once we know about jagged arrays, let's go back to normal array. What we can also do is, we can skip this part now. Can we create 3-dimensional array? We can. Every time you want to increase the dimension, you just have to specify extra square bracket and extra loops for every square bracket. So now you can imagine if I want to draw this, I don't know how do we draw this, but let's try. So we have the outer box in which you specify how many rows you have. We have 3 rows, 0, 1, 2. In this, you have an array of size 4. So 1, 2, 3, 4. And in each box, you have one more array here, which is of size 5. Okay, let me just do that in a small, let me expand this. And in this, we have one more array of size 5. Okay, this is index number 0, 1, 2, 3, 4. And then this is 0, 1, 2, 3. So if I want to fetch this value here, which has value, let's say 6. If you want to fetch this 6, you have to say 0, 0, 2, right? And of course, in every box here, we'll be having the same thing. We have the box here, which has 4 elements, and each box will be having multiple arrays. Yeah. So we have array here as well. And if I want to fetch, let's say the third element here, we have to say 1, 1, 3. Okay, that's how you fetch it. So the more array you create, it will create a box internally to it. So that's how the array works. Now this is not jagged anymore. This is 3-dimensional array. So I hope this makes sense. We have talked about jagged arrays and 3-dimensional array in one video. In this video, let's talk about the drawbacks of array. Of course, we have seen a lot of good things about array. We can store multiple values. And then we had some fun with the multidimensional array and 3D array, jagged arrays. But let's talk about some drawbacks. What I will do for that is let me remove the entire stuff and let's create a single array here. So let's say when you create an array of nums, and let's say this is of int type. So of course you have to say new int and you have to give a bracket and you have to specify the size 4. Now, first of all, before we talk about the drawbacks, the array in Java is an object. Okay, the moment you're saying new keyword, that means it's an object, right? It will be created inside the heap memory. But what it does is the moment you say this line inside the heap memory, it will occupy a space and the memory location it will take is it's continuous, okay, which means it will simply occupy the space continuously. And the problem with this is once you specify the size here, you cannot go back. So once you say 4, now you cannot expand the size, it's fixed. So in future, if you want to create or if you want to expand the array, you can't. See, one of the solutions what you can do is you can, at that point, if you want to say, hey, I want to increase the size of the array, just create a new array of that size and copy all the elements. That's a solution, but it will also consume some time and there will be some computation will be happening. So if you know the size is fixed, you can go with array. The second problem is every time you want to search something, it will traverse between the elements. So for searching, for inserting value, it does consume a lot of time. The last problem, which is, we mentioned about int here, right? But what if you want to have an array of different types? Let's say if you want to have integer, string, double in the same array. Unfortunately, you can't do that. I mean, there's a solution. If you want to have an object of student, integer, string, there's a solution of object, but that's not an optimal solution. So again, they are not really a drawback what I've talked about. That's how the array works. But then, when you say something is a drawback, you say that's a drawback because there's something new which came up, which has all these features. Now, the concept which I'm talking about is collections. Now, this is not a good time to start with collection. It will come in later. But just because of collections, we are talking about some drawbacks of array. But arrays are great. They are fast. You can store multiple values. But yeah, there are some things which might have been done to improve it. But that's where we have collections, right? We'll talk about collection later. And it's not like just because of collection, we'll not be using array anymore. They have different use cases. Every time you have a fixed size, and if you want to store multiple values, array will be the first preference. So once we have talked about array, basically we have talked about why do we need array and how to create an array, let's do something more with array now. In fact, in the previous video, we have seen how to create the array and then how to print the values. Now in this video, let's try to see if we can find a better way of printing this value. See, what is happening now is, let's say, of course we know the length of this array here, right, which is 4. It can also be 5 or any numbers I mentioned before, right? It can be 100, 200 or whatever size you want to mention, and you can insert the value. Now, before I do anything else, I just want to show you one more thing. What if the value of the size of array is 6 and you are assigning only 4 values here? Now, in that case, the other indexes will also have some values, right? Let's see, I just want to see what are those values before we continue. So compile and run. You can see we got the values, but then the last 2 values are 0. Remember, we have talked about this. By default, the values for the array or integer array will be 0. And that's what is happening here. And now what I want to do is I want to see if I can get this value. See, the thing is, why I should know the length of the array. It might also lead to errors. Example, if I say 7 here by mistake, and if I try to fetch the value, see, this is where it will give you an exception. Now, Till this point, we have not talked about exception. We have a separate topic. What are exceptions? At this point, just remember, exceptions are runtime errors. Okay, so the errors which comes in runtime. At compile time, there's no problem. When you compile this code, it will not blame you, it will not shout, but the moment you run this code, it will say, hey, something is wrong here. So that's exception. Now, what is the problem? The problem is we have 6 values. Index number starts with 0, it ends at 5, not at 6. And here it says index 6 is out of bounds. So basically we are trying to go beyond the limit. Okay, so how do we solve this problem? So instead of specifying the number hard-coded values, we can do one thing. You know, these arrays, they have a property called length. So we can simply use this length as a variable or a property, which will tell us what's the actual length of the array so that you will not make any mistake. The only thing you have to remember is you have to make sure that it's less than, not greater than. Okay. And I will clear this. I will say compile and run. You can see we got the values and there's no problem. The only thing is the size is 6 and then we are assigning only 4 values. Let me go back to 4 values and you can see we got 4 values here. Now this is one of the good addition in terms of the property which you can use. So that's about length here. Now what we can do is, let's say if I want to have a string array, or maybe let me create an array of student. Can we do that? So remember one thing. So if I create a student here, and of course I can create one object, I can create multiple objects here. And let's say I have a student which has some values. So let's say integer roll number, okay, and the string name and int marks. Of course, not a good way to maintain the records. We don't want to maintain marks, but just for the example, okay, so we have student and then we have these 3 variables, okay. Now mind you, these are instance variable because they belong to a class, not to a method. I just want to comment the entire section here. And what I will do is I will create student object. So let me create the first object. I will say student, s1 is equal to new student, and I want to assign all the values to the student. So I will say s1 dot roll number, which is 1, and s1 dot name, which is, let's say, Naveen, and s1 dot marks, which is, let's say, 88. Okay, so we got the first object. Now maybe I want to create more objects. What I can do is I can just copy this code and paste, and let's say 3 objects. So we want 3 objects here, and I will say this is 2, this is 3, and let's say roll number 2, let's say this is Harsh, and marks, let's say 67. And if I say this is 3, let's say this is Kiran, and let's say the marks is 97. Okay, so we got these marks here, right? And then basically I have 3 objects. Now I made one mistake here, if you can, I don't know if you have observed, but if you can see, I'm still assigning the values to S1. Don't you think it should be S2, S3? So it should be S2, S2, and S2. And here we have to say S3, S3, and S3. So basically we got 3 objects here. Now what I will do is I want to create an array of students, right? We have created the array of integers, but then how do we do that array of students? It's very simple. You say student, and then you have to say students because we are creating multiple students here. That's a variable name equal to. Now this students here is not one variable, it's an array. So you have to say array, and then we have to say new. Now in this case, when you say we have int, in the same way here, it should be student, right? Student array of, let's say, 3 student will be having. So all these objects, you know, we got 3 objects here, S1, S2, and S3. They will become part of this array. Example, I can say students of 0 is equal to S1. So the first object, the first reference is getting stored here in the first index. And likewise, we have, this is S1, S2, and this is S2, S3. So you can say we got 3 objects in the array. So of course you need these objects, otherwise this will not work. Now, if you are thinking at this point, we are creating 3 student object. No, we are not creating 3 student object. Most of the people have this confusion that on this line, we are creating 3 student object. No, we are creating an array which can hold student references. It will not create those objects by itself. You have to manually create the objects and assign to an array. Now this thing will make much more sense when we start working with databases. When you fetch data about a student, it will give you a lot of data. You can basically fetch those data in a student array. Now what's the advantage? The advantage is, let's say if you want to print all the details of a student. So what you can simply do is, you can use an array which will start with 0 and I is less than equal to, okay, I is less than students dot length, which we have seen, and then I plus plus. And then here we can simply print. But how do you print the values? So what you do is you have to print one value at a time. You have to say S1, because if you try to fetch the value of a student, it will give you a address format. Okay, example, let me show you something. At this point, let me just comment this section and let me print the student object itself, and let's see what happens. So if I try to print the S1 value, you tell me what will happen, what will be the output. I mean, think about that. I will just compile this and run. You can see it is not printing the value of a student, it is printing something else. See, in the upcoming videos, we'll solve this problem. At this point, it's printing the address and we don't know what this is. So what we can do is explicitly you have to mention s1 dot name, and you have to, maybe you can do a concatenation here, and you can say s1 dot marks. I don't want to print the roll number at this point, so I'm printing only this two. And now if you compile and run, you can see we got the student details. Okay, so can we do it here? So let me just uncomment this section. The only thing is you have to print this particular statement, cut and paste. Now the only problem is it will always refer to S1. We don't want to refer to S1, right? The student value will keep changing. So I can say students square bracket I, right? So this value will keep changing, right? This will be S1, S2, S3 in every iteration. The same can be done here. So I can say students of I. That should make sense. And let's see if this works. Let me go back here, compile and run. You can see we got the values. Right, so basically we can work with normal objects as well. Before this, we have worked with integer. Of course, you can work with string as well, but we just went one step ahead by creating an array of students. Okay, so I hope you got some idea regarding how do we create an array of students. In this video, we'll talk about for each loop. Now, why do we need another loop when we already have this particular loop here? Okay, for that, let's comment the entire section from here, because I want to use the simple example which we already have here, right? So if you remember, we have worked with this array which has 4 numbers. So let's work with normal integers. Now, if you want to print all the values, this is what we did, right? We used a normal for loop in which you have a counter I, which starts from 0 to the last value of the length of the array, less than that, which is 3. And we were able to print all the values. The only thing is, why you need to do the counter, and then you should also know the length of the array, and then you have to specify the index value here to fetch the value. I mean, this works, but then can we have a better solution for this? And that's where we got an amazing loop which only works with array and array type of data. So in future, we're going to talk about collection as well. In that also it is used. But since we only know arrays at this point, let's try to use another type of loop. Now think about this. Can we just say, hey, for loop, you know what I want you to do? Iterate between all the values and give me one value at a time. And of course, I will decide what to do with that value. Example here as well, we are able to fetch a particular value of an array, and then we can do whatever we want to do with that. Of course, at this point, we're just printing it, but we have an option of doing multiple things. Here as well, I would say, hey, for loop, you give me a value, not the index number. Give me the value. So for loop says, okay, let me try. So whatever value a for loop will give you, you can store that in n, a variable, but then from where you will get the value? You will get the value from the nums, which is the array. So I can give a colon and we can say nums. This is the syntax for each loop. I know this will be confusing at the start, but once you get used to it, you will love it. What is happening here is, if you compare with the upper loop, in the upper loop, we are using a counter. Here, we are not using a counter. We are simply saying, from this nums, it doesn't matter how many values you have, 4 values, 10 values, 50 values, I don't care. You just give me one value at a time. And that one value will go into n. Now you can decide what to do with that. At this point, just to keep it simple, we are printing it. Okay, so you can see I just got the value n and I'm printing it. No I, no counter, no increment, no need to check for the length, no exception, right? And this is the beauty about it, is it will just iterate between the nums and iterate till the last element. So if you had 5 elements, it will iterate 5 times. If you have 4 elements, it will iterate 4 times. And every time it will give the value to n, and that's what you are printing it here. Let me prove that. Let me just compile this code and run. You can see we got the values. This is better, right? You can also use this with the thing here, which we have done for student. I will just comment this part and uncomment the entire section from here. Everything is uncommented. The only thing is I don't want to use the normal for loop. I want to use the enhanced for loop. So normally, instead of saying that this is a for each loop, we say enhanced for loop. Okay, so what we can do is we can say for, and here, okay, the only thing is, with normal for loop, we use int because we want to maintain the counter. If we talk about the example which we have done for normal integers, here also we are using int because the type of values in nums is int. But now we are working with students, right? So here, when you say student, let's say stud colon. So we have to mention the student type, not int, because from the students array, you are getting a student reference and you will get the values from students. So it doesn't matter how many students you have, it will fetch one student at a time. And then with that student, you can print the same thing. So whatever you're printing here, you can print that here. The only thing is, this stud represent one particular student at a time. So you can simply say stud.num and you can just concatenate. So what we are doing here is we are doing concatenation. The student name, and then we are giving a colon. So to do that, we have to use a plus operator in between to concatenate. And I can also say stud dot, let's say marks. Let's see if this works. Now we are working with student, not with normal variables. Compile and run. That's it. You got the output. So you got Naveen and you got number. So this is your enhanced for loop. Yeah, some people do say it's a for each loop, but let's call it as enhanced for loop because in the latest version of Java, not the latest one, I'm talking about Java 8, which came way back, it has a for each method. So just to not get confused, let's call this as a enhanced for loop. Now, one of the reasons why people say it's a for each loop is because in other languages, this type of loops are called for each. And that's why in Java also people have a tendency to call it for each, but let's call it enhanced for loop. So I hope you got the idea and I would like you to work on this, practice this, otherwise it will be confusing. So practice this multiple times and you will get used to it. It's time to talk about a very simple concept and complex at the same time, because to use it's very simple, but when you try to understand what is happening behind the scene, that's where it gets complicated. So let's try to understand that in this topic of string. So in this video, let's talk about what is string. Now, basically we have worked with string before. Example, whenever you try to create a variable, we have to specify the type of it, right? Example, we have worked with integer, float, double, boolean. In the same way, if you want to store a character stream, let's say if you have multiple characters, something like this, let's say you want to store a name like Naveen. Now this Naveen is not a single character, right? It's a bunch of characters. And when you want to store this together, of course, you can use a character array. We will talk about array later. But then we can create a character array here, which is an array of different characters. Or we can create a string here. Now, how do we represent that in a string? Now, one thing to remember, whenever you talk about string in Java, you have to put that in double quotes. The way you work with characters, in characters you use single quote. Here we'll be using double quotes. So if you want to store Naveen, so you have to first put that into double quotes, and then where you will store this? Of course, you need a variable here, right? So what I will do is I will create a variable called name. Now this variable name needs a type. Now what type of this? This is of type string. Now one thing to observe, when you talk about primitive data types, we have int, float, double, character, boolean, and many more, right? Now all those actually starts with small letter, right? This string S starts with capital, which means that string in Java is not a primitive type. It's a class basically. If you go to string class, you will find string is actually a class. Okay, that actually makes some sense. But then when you say class, we have seen this, right? Whenever you work with classes and if you want to create object of it, we use a new keyword, right? We are not doing it here. So this does not look like a correct syntax. It works, but it's not something we are used to, right? Whenever you work with class, we normally create a new object. Okay, this works, but then why this will work, that we'll discuss later. At this point, if you want to go in a general sense, if you have a class, the way you can create a string is object of string is by saying new string, and you can give the round bracket. Now this is how you create a string variable or string object. Now basically this is a variable, right? Reference variable, which is referring to a string object. Now what might be happening behind the scene? So it's not that difficult. If you imagine this as your JVM, the big box, inside this, of course, you will be having your stack memory, right? Now this is your stack. And then of course, in this, you will be creating a reference variable, which is name, and then it will have some address. But this address or the object will be created inside heap memory. Imagine this is your heap memory. We should make this a big one this time. Let's say a bigger heap memory so that I can write some multiple things there. Now, the reason we are creating a heap memory in not a structured format is because there is no fixed size to it. It may expand depending upon your requirement. So we got a heap here. Now, when you talk about this line number 8, when you say new string, of course, it will create a new object for you. You got an object here, right? And it will have, let's say, some address. I will say the address here is 105. So of course, you will create a variable which is name here, and then the address is 105. So there's a link here. And of course, in this particular box, there's no data. It's empty, right? Okay, this empty makes sense actually. But then if you try to print this, let's see what it prints if you try to print this data here. I will compile this code and run. You can see it prints nothing. Basically, it prints blank thing. Okay, it's because it's blank. Now, how will you provide data? Now, in this case, what you can do is, in this new string, in the constructor, you can pass this string which you want to. Example, if I want to store Naveen, that's the data I'm storing. Ignore this original, this is given by the IDE, but this is our value, which is Naveen. So inside the string constructor, you are passing the data, which is Naveen, right? Now, if you try to print this, you can see we got Naveen here. Okay, so that means in this thing, we are creating the data, which is Naveen. That's what we are expecting as of now. Let's see if that works. Okay, now there's also a concept of hash and equals, right? So what I will do here is I will try to print the hash code for this one. So if you try to print the hash code, and if you run this code, you can say this is the hash code for this, depending upon data, depending upon some calculation. Now what else we can do here? So example, let's say if I want to concatenate this Naveen with hello. So let's say I want to print hello Naveen. What you can do is, of course, you can write a different statement to print hello, and then you can print name. But then string by default does not work with any other operators like subtraction, division, but only there's one exception, which is plus operator. So you can use string with plus operator. Okay, so let's say I want to print hello and Naveen both. So in this case, you can print hello, and then to concatenate, to mix these two, you will use a plus operator here. So you can simply say plus. And now with this, compile and run, you can see we got hello Naveen. I hope that makes sense. So we can use plus to print this. What else we can do? We have certain methods here which we can use. Now, since it's a class, of course, it will have some methods, right? So there are some handy methods here. Example, you can check what is a character of a particular location. So let's say I want to know what is a character at location 2, I mean index number 1. So if I pass index 1 here, it will give me a character at index 1. So if you look at this Naveen, n is index 0, a is index 1, then 2, then 3, then 4. And if you try to compile and run this, you can see we got a. So yeah, this is how you can basically use certain methods there, which is character at, or you can also concatenate two strings. Okay, so let's say if you concatenate my name with, I will give a space and ready. So basically what I'm doing is I'm concatenating Naveen with ready here. Let's see if that works. Yeah, it works. Can you see that we got Naveen ready? So that's how we can basically use this. Now, since strings are so important for the programmers, what we got here is, let me just remove this line. Yeah, so string is so important for programmers. What we got in Java is, instead of writing this new string, you can actually, directly write Naveen here. Even that works. So behind the scene, it will create an object. You don't have to worry about it. So when you say string name equal to Naveen, it will create the object for you. You don't have to worry about object creation and those stuff. So most of the time you will see this syntax. Hardly you will say string name, new string, and then Naveen. That's hardly anyone do that. So this is famous, and even this works. You can still try this out. And that's why before, when we were using string, we directly assigned the value it was working. So in the previous video, we have talked about string, right? Now we talk about this string. What might be happening behind the scene? Example, let's say if you store this Naveen, of course, it will be getting stored in the heap memory. But now what I want to do is, before printing Naveen here, let's say I want to append something. So let's say I will say name is equal to, I want to add my name with, let's say, Reddy here. I'm giving a space so that we can differentiate these two words. So of course, now when I say name, it will be Naveen Reddy, right? So basically we are trying to change the value. Now if we talk about integer, float, double, basically you can change values of it, right? And it actually makes sense. That's why we call them as variables. And here also we are trying to do that. But first of all, let's check if this works. So if I go back and compile and run, it works. You can see that the new data for the Naveen is Naveen Reddy, right? And that works. But what if I say that's not the case? You're not changing the existing string. Let me repeat. You're not changing from Naveen to Naveen Reddy. So if you're thinking there will be a variable here where you have Naveen, you're making it Naveen Reddy. No, that's not the case. That's not how string works. Okay, so what happens? So what I will do is I will just remove this part now. So what is happening basically? Since strings are used heavily in Java, now most of the time you try to reuse the strings, the same string. You'll be using multiple times. Example, let's say, if before I show you something, let's say I create a string here, which is S1 is equal to Naveen. And you can see we have a capital M this time. So these two data are actually different. Okay, so I will say string S2 is equal to, and I will say Naveen again. Now, what do you think? How many objects we are creating behind the scene? Think about this. Okay, so if you're thinking we got two objects, actually not. We got two references. We got S1, S2. Of course, in your stack, you'll be having S1, S2 here. But in total, you got only one object. And that sounds tricky here, right? And let me prove that point to you. See, what I want to prove is the value for this field and this field will be equal. The way I can do that is by saying sout S1 is equal to S2. If this is true, then they are same. So if I run, you can say we got true. That means the value for the addresses are same. In total, we got only one object. So here, what happens is we have a special area inside your heap memory. So this is your heap, that's your JVM, and that's your stack. So inside your heap, you will be having a special area called string constant pool. And by the name itself, you can see it says constant. That's right. Every string which you create, which you use in Java, which is a string literal, is actually a constant. You can't change it. Example, if I write something like Naveen here, I cannot change it. It's done. It's Naveen everywhere. Okay. So you can't change the data. So example, what happens is every time you try to use a variable here, example, if you execute the line number 8, it checks, okay, we need Naveen variable. Do we already have Naveen in the string constant pool? No, we don't have it. So let's create Naveen here. So it will create a string variable Naveen. It will have some address, let's say 101. And then the name variable here will get this address. So this name variable is actually referring to this particular address. Okay. Then it goes for the next statement. Let's execute this part. Let's ignore this line as of now. Let's focus on line number 12 and 13. So line number 12 says S1 is equal to Naveen. Okay, so it checks, do we have Naveen with capital N in the string pool? No, we don't have it. So it will create Naveen here. And let's say the address is 103. So it will store 103 here. Okay, now that makes sense, right? And that's why it is referring to that particular location. Now, what happens on line number 13? Line number 13 says string S2 is equal to Naveen. It will go to string constant pool again and check, hey, do we have Naveen with capital N? Yes, we do have. Now, it will not create a new object for you. It will simply use this address 103, okay? And that's the beauty. That's how you're trying to save the memory. Otherwise, you could have created multiple variables with the same data. So it doesn't make sense, right? And that's why it uses a string constant pool. Now my question to you is, what is happening here? Now, when I say you can't change the data, that means you cannot simply update this particular Naveen by Naveen Reddy. No, that's not happening. Naveen is still there. It's a constant. You can't change this. Now on line number 9, what is happening is it is creating a new object which will have a data which is Naveen Reddy. Let's say it has the address which is 105. So on line number 9, basically what you're doing is you are changing this address from 101 to 105. You're just changing the address. You're not changing the actual data. You are basically creating a new object. Okay. Now you might be thinking, what will happen to Naveen here? The thing is, now this particular object is eligible for garbage collection. It will be removed after some time, just to get some memory back. Okay, so point to remember is, once you create this object, you can't change it. And that's why we have some terms to remember. And the terms are, so there's a concept of mutable strings and immutable string. Now what is mutable means? Mutable means change, something which can be changed. And immutable means unchanged, or you cannot change it. So basically by default strings are immutable. Once you create the object, you can't change it. And that's very important to remember. It's immutable string. Okay, so whatever data you're creating here is immutable. But what if you want mutable string? And that's why we have two different classes in Java to use. Instead of using string, you can use something called a string buffer or a string builder. Now both are very similar with one difference. That difference we'll discuss later, but they both are similar and they both provide you a way to implement an immutable string. Okay. In this video, we'll work with string buffer. So what we have is we have a string and we have worked with it, right? So what I will do is remove everything and let's work with string buffer. So I will say string buffer and let's create a reference for it equal to new string buffer. Now when we talk about string buffer, of course, in this string buffer, you will have a string and which is actually mutable. You can change it. Now to make it more efficient, you know what string buffer does? String buffer will give you a buffer size, okay, which is of 16 bytes. So I can just try to print that first. I will say sb dot. So we can know the capacity of this string buffer. Even if it is empty, it will give a capacity of 16 characters and you got it there. In fact, you can also provide some initial string here. So let's say, if I say Naveen here, now Naveen is of 5 characters, right? This is how you basically create a string buffer. In bracket, you mention this string. So it will create a string buffer object. And the beauty is you can change this data. Okay. Now the thing is, if you talk about capacity, what it will be. So capacity should be still 16, right? No, it actually changes. If you can see, the capacity will become 21. It's because it will store my name and it will also give me a 16 space extra. Now, why it gives me that space is because every time you change data, and if it consumes a continuous memory location inside your heap memory, and what if there's no continuous location next? I mean, what if there's no location available? There's no space available. In that case, it has to relocate. So to reduce the relocation of the string, it gives you a buffer. Okay, so that's the capacity, and now we know how it works. We can also print the length of the string. We can say sb.length, and length is available in normal string as well. So if I compile and run, you can see the length is 5. So length and capacity are two different things. Okay, now can I append data? See, the ultimate thing was, can I change my data, which is Naveen in this case? The beauty is string buffer will give you a lot of different methods to do that. You can see we have a method called append. So you can use append and you can append any data which you want to. So let's say I want to append Reddy here. And of course I want to give a space between Naveen and Reddy. So you can append and you can print the data. So you can print SB as it is. First we have to compile the code, run, and you can see we got Naveen Reddy. That works. Next, what if you want to assign string buffer data to string? As example, if I do that, you can see it will give you error. It says type mismatch, cannot convert from string buffer to string. Of course, right? str is of type string. So in that case, you can get this string back. Do we have a method for it? Let's see. Yes, we do have toString. We can use that. I think that's the only method we can use. Yeah. So let's use toString. So basically, you can use toString to convert the string buffer data. I mean, it will get the string format, it will store in str and you can print it. Okay, we can use that. What else we can do with string buffer? If I come back here, if I say sb dot, you can see we have so many methods here. Okay, so we have append, we have chars, it will give you a character. We have done that. Okay, so we can also delete something. We can delete a character at an index. So let's say I want to delete a character at location 2. if you try to delete that data, compile and run, you can see we got, oh, something is missing. The V is missing there because that is at index number 2. Okay, so the idea is basically we can change it, and you can experiment it a lot. You can try to use different methods. We can delete, we can insert also in between. Let's say I want to insert Java at the start. You can do that. So you can say insert. You can mention the index value where you want to insert at 0th location and the data which you want to insert. So I will say Java space. Now what it will do is it will add Java at index 0. I mean, that is start itself. So if I run, you can say it says Java. Of course, you can add Java in between as well. Let's say I want to add after 5th location. I think that should work. After the space, it's 6. So let's try that. Compile, run. You can see Naveen Java ready. So it works. Okay, so yeah, that's how we can basically use insert. We have more methods to explore, and I would recommend you to do that. Can we see one more? We can also get this substring. Let's say if you have a very big string, you can specify the starting point, ending point using substring. You can set the length as well. So if you set the length of the stream, let's say I want to set the length of 30. So if you want to add your data and if you want to have a specific length, which is 30 here, it will save the data, which is whatever you have. Naveen Reddy will be stored and all the other values will be null. Let's see. So after Naveen Reddy, it will add some extra data here. Okay, so that you can replace that later. Cool. We can do that. We can also set minimum or maximum data. I think there's minimum capacity method which we can use. I think the method name is ensure capacity. Yeah. Okay. So we can say we can set the ensure capacity to 100. So by minimum capacity will be 100. Okay. That's how we have different methods. Now, what's the difference between StringBuffer and StringBuilder? So as I mentioned, we also have StringBuilder, right? There's only one difference. StringBuffer is thread safe and StringBuilder is not. Now, what is thread safe means that we'll understand once we talk about thread concept. So at that point also, we'll talk about difference between StringBuffer and StringBuilder. But whatever methods you have in StringBuffer, it's almost same as StringBuilder. So if you know one, you know the other one as well. Okay, so that's about StringBuffer and some of the methods of string. In this video, we'll talk about static keyword. From the start itself, when we have written the first code, we are looking at the static keyword and the question still remains, right? What is this static? So we know what is method is, we know what is return type, we know what is class, but again, the problem gets stuck here in static itself. Now to make you understand this, let's take an example here. So let's say we have an example of mobile phone and every mobile phone has a brand. So brand will be string, so it's a string brand and we can have a default value for it. We can have int, which is price, and then string network. Okay, and we can also make it for a specific brand as well, but let's keep it simple. Let's have a mobile phone, different brands, different price, different network, and we'll say name. Okay, now see, name itself of a mobile phone changes, right? So we used to say normal phones, then we got smartphones, and now we have foldable phones, right? So we can have a different name to phones nowadays. Every phone is called a smartphone now, because that's what we call. Initially it used to call mobile, then we used to call that phone, right? So we have a name here as well. What do you call a mobile phone? So now it's a smartphone. Okay, so if you want to work with this mobile phone, of course you have to create an object, right? So if I say mobile obj, if I will say mobile obj1 and equal to new mobile, and of course every mobile will have a different parameter here. What I will do is I will just remove this network just to keep it simple. We just want 3 variables here. obj1.brand, I want to set the brand here. Let's say the brand is Apple, since I'm using an Apple phone here. And then the price, let's say $1,500. And what else we have? We have a name. So what do you call a mobile phone? So currently, if we talk about Apple phones or any phones nowadays, we call them as a smartphone. Okay, I know this variable doesn't make sense, but just for the example, I'm saying name is equal to smartphone, right? Now, if you talk about this phone here, we have all these values, right? Now, of course, if I create multiple objects, it should have a different value. Of course, every object is different, so we can have a different value to it. If I come back to Apple, let's say the next phone is of Samsung and the price is, let's say, $1,700. And then we also call them as a smartphone. Okay. The only thing is you have to change it here as well, obj2, and then I can print the values as well. You know what I will do? I will just create a method which will print everything. I will say public void show. It should print all the details here. So it should print brand, so that I don't have to print that every time. And I will say price, and I will print name as well. Now by doing this, what I'm doing is, instead of printing it here every value, I can simply call obj1.show and obj2.show. So it will print its own value, not other values. And if I come back here, compile and run, you can see we got the values, right? Nothing complex here. The thing is, if we talk about these variables here, they are called instance variable, right? Now, if you create a variable inside a method, that's a local variable. But these are your instance variable. And every variable for a particular object is different, right? The value will be different. Now, what I want is, I want to have the name to be same for all the objects. See, because what is happening is, in your memories, so let's say we have a JVM, a big JVM, and inside this you have a stack where you have all the reference and locations and address, and then you have a heap memory. So in total, you can see we got two objects, right? One with mobile obj1 and one is obj2. And then of course they have the address as well. So this is 101, 103. And of course this will be 101, 103, and you will be referring that, right? So this is referred here, this is referred here. Now that's how we can basically use it, and every object will have a different value. But what if I want to have a common value for all the objects? The problem with this is, if I want to make sure that the name variable should not be a part of the object, because that's an instance variable now, it will be a part of the object, and every object will have a different value. I want this name to be common for all. How do I do that? Now, if you make this variable as static, now by doing that, what we are doing is, we are making this name variable common to all the object. What I mean by that is, let's say after some time, if I say obj1 dot name, if I change the name to, let's say, a phone here, just a phone, not a smartphone anymore. If you make this as a phone, and if you see the values, it will affect all the objects. You can see we are trying to change the name of obj1, but we are actually changing the name of obj2 as well. You can see this is also phone now. The reason is the static variable is actually shared by all the objects. So basically we'll not be having individual static variable for every object. We have a common variable which will be used by all the objects. Imagine there is a common variable here, name, and all the objects will be referring to the same variable. So if you change the value for this, it will affect all the objects. Okay. Now this is why we use static. Now the beauty is, see, why we have to refer brand with obj1, price with obj1 is because every object will have a different value for it. Now, don't you think name is a static variable and it will be common for all the objects? And that's why you can actually call name with the help of a class name itself. You can simply say mobile.name. So static variables should be called with their class name, not with objects. You can call with objects, but avoid it. And that's why you can see it gives you warning as well. It says the static field mobile.name should be accessed in a static way, which is using a mobile, the class name, which is mobile. Okay. So the point to remember here is static variables are actually shared by different objects. And if you want to refer to a static variable, you can use a class name. So there's a different area in your JVM where you have all the static variables. And here as well, I should say mobile. Now the thing is, in non-static methods, you can use static variables. There's no harm. Okay, and that's the point to remember. In the next video, we'll talk about what if you create a static method. Yes, we can do that. We can create a static method. And the question is, can I use instance variables there? Okay, we'll see that in the next video. But here, we talked about what is a static keyword. So static keyword means you are making something as a class member, not an object member. So static, this name here belongs to a class, not to the object. And that's why you were able to use this with the help of a class name. Okay. And then you're saving memory as well, because not every object will have their own value for it or their own copy for it. So that's about static variable. Now we know what is static variable, static methods, right? Now let's try to expand this more. To simplify this, what I will do is I will remove the static method for some time, and I will also decrease this code. Let's only work with one object now. And here, see, normally when you work with variables, so now we know that this is an instance variable and this is a static variable, right? The name. Now to instantiate the instance variable, what we do? Of course, we can instantiate the variables from here, but then what if you want to instantiate the variable on this line? If you want to give some value, not instantiate, if you want to initialize the variable, what you will do? So basically, we have seen one concept, right, which is constructor. So using constructor, we can say, okay, public mobile, and we can give some default values to it, right? So by default, the brand will be empty string, and by default, the price will be, let's say, $200, right? So this is the default brand, default text and default number, right, which we want to give. What about name? I can also give a default name to a name, which is phone in this case, let's say. And we can do that. We can initialize the static variable inside a constructor, and there's no harm in that. Now the problem is, every time you create an object, every time you create one more object, it will call the constructor, right? And don't you think it makes sense for this to initialize every time? But why name has to initialize every time? I feel that the name variable, which is static, should be initialized only once. What do you feel? Of course, the same thing, right? How will you do that? So if you mention that here, of course, every time you call the constructor, it will initialize. We don't want to do that. Now to achieve that, we have a special block called a static block. Now in this static block, we can basically initialize the variable, the static variable. Now the good thing about this is, the static block will be called only once. Irrespective how many objects you create, it will call the static block only once. So what I will do is, just to demonstrate that, I will create one more object here, let's say, and I will not assign any value to it, just to default values, obj2, second object. So it will call the constructor 2 times. It will call the static block only once. To prove that, what I will do is, I will just print something. I will say in static block. Now the syntax for static block is very simple. It's static keyword, and then you just open and close. There is no bracket or something. It's just a simple block. Okay, and in the constructor as well, I will say in constructor. Okay, and now with this, let me just compile this code. Okay, there is an issue. I have written one extra. Okay, I have removed the curly brackets from here. So compile and run. So you can see it is calling the static block only once, and it is calling constructor 2 times. There is one more issue. Why static block is called first? Even before the constructor, it is calling static block, and that's weird. Is it the sequence? Let's try. Let me just put this after the constructor. Let's see if this does make any sense. Anyway, Java does not follow the sequence, but just to confirm, you can see the static block is still getting called first. Now to understand that, let's go to the diagram here. See what happens, there are 2 words, and we only focus on one word. Every time you get the object, there are 2 steps. One, your class loads, and then your objects are, okay, so first your class loads, and then your object gets instantiated. So there are 2 steps. Every time you create the object, there are 2 steps. Class loads, and object will get initialized. The thing is, the class will load only once. So basically in your JVM, you have a special area here, which is called a class loader. Okay, and this will have all the classes which are loaded. And by default, of course, you don't have any class loaded, right? So the class will get loaded from your library to the class loader. And it will happen only once. So for the first object, when it sees, hey, there's object creation, it will load the class first, and then it will create the object. Now, every time you load a class, it will call the static block. Now, since class loading happens first, and that's why it will call the static block first, and then it will create the object, and that's why it will call the constructor after static block. Now, irrespective of how many objects you create, the class is already loaded, right? So you can simply create a next object without loading because it's already loaded. Now my question is, if that is how it is working, what if I don't create any object? I'm not creating any object now. So if you don't create the object, of course it will not call the constructor. But what about static block? It will not even call the static block. If you can see, we don't have any output. Oh, okay. So that means if you don't create the object, it will not load the class as well. But what if you want to do that? What if you want to load the class? How will you do that? Now for that, we have a special class inside Java, which is called a class. Yeah, that's a class. Okay, I know. Java has been weird. We have object class, we have class, but that's how it is designed. So Java class, if you go there, you can see it's a class and it has a lot of methods to it. One of the methods which we want to use here is for name. Now for name is a method which does one thing, which loads your class. And you just have to mention your class name. What's our class name? The class name is mobile. So in this, you can mention the class name. That's it. Okay, the only problem is it throws an exception. Okay, at this point, we have not talked about exception, but just ignore this line. We'll talk about this in detail later once we start with the exception concept. But as of now, just to make it work, I'm just writing this line. Ignore it. What's important is the class.forName will load your class. If I go to forName, you can see forName is a method and it's a static method. So you can directly you can call this with a class name. And this particular method, do they have any definition mentioned? Okay, so it says the system class loader is used. So basically it will load the system class loader to load this class. Okay, so which class? Mobile class. Okay, so now if I just write this line, it will not create the object, it will just instantiate it. Compile, run, you can say it says a new static block. Okay, that means you're just loading the class. So basically that's how you load your class. You can simply use this line to load your class. Normally when you build a project, you don't actually use this feature. Yes, there are some situations where you use it. Example, when we start with JDBC, we'll talk about this one, but we normally don't use it. I'm just using this just to show you how to call a static block, how to load a class. Okay, I hope this video makes sense where we talked about static block. So static block is used to initialize the static variables. So that's it from this video in which we talked about static block. In the earlier videos, we have talked about static keyword, static variable, static methods. And yeah, that's about static. Now, once we talked about static variable, it's time to talk about static methods. Now, what I will do is I will just try to remove all this content from here just to keep it simple. And let's make a static method. Now, the method which we have here show is not a static method, right? It's an instance method. It's because we have not mentioned a static keyword. Now, whenever you want to work with a non-static method, you need to create an object of it. Of course, if you want to call, you have to create object of mobile. In fact, actually we need those objects here. And yeah, let's keep it here just to use it. Now let me create a simple static method. So I will say public static void show1. Again, if you can see, I'm using a different method name just to differentiate it. And here, if I try to, first of all, I will just print in static method. Now, how do we call the static method? To call show, we have to get object, right? You can't simply come back here and say mobile.show. This will not work. If you try to call mobile.show, it will give you an error. It says, let's see the error. It says cannot make a static reference to a non-static method. That means you cannot call a non-static method with the help of a class name. And that's why you need object here, which you can see. We're using obj1, obj2. But can I call show1 from mobile? Let's try, and we can. You can see that there's no problem. So you can call a static method directly with the help of a class name. Okay, that's what we are doing here. We're directly calling it with a class name. Now the question is, this looks cool, right? A static method can be used directly with a class name. But can I use a variables here? Let's try to do the same thing. I will just copy this line and paste it here. Let's see what happens. The moment you do that, you can say there's no problem with name. So that means you can use a static variable inside a static method, but you cannot use a non-static variable inside a static method. The question is why? I mean, think about this. Brand and price, they are instance variable. That means it will be different for different objects. Now, when you call show with obj1, we know that in this show, when you are printing brand and price, you're talking about obj1. When you call show with obj2, you know that the brand and price will be of obj2. But then when you call mobile.show1, how do we know which object you're referring to? So this brand belongs to obj1 or it belongs to obj2. And that's why it says, hey, there's a confusion, right? Let's not do that. Let's not have a non-static variable directly getting access in a static method. It's not possible. This time I've added a directly keyword that means indirectly is possible. Now, how will you do it indirectly? It's very simple. What if you can actually pass the object itself? You can say, hey, I want to run show1 for obj1 object. Now, since you are passing the object, you have to also accept it here. So you can say mobile obj. And now since we have the object, I can refer that with the help of obj1.brand. I mean obj.brand and obj.price. So basically, we cannot directly use a non-static variable inside a static method, But if you have an object reference, then you can use it. Because now we can differentiate. So the branch which I'm talking about is for obj1, not for obj2. So that's how we have to do it. So that's how we work with static method. Now, if you observe here, from start we are using this, right? The main method is static. Why in this world we have a main static? It's because if you don't make main static, if this was a syntax, the problem is, if you don't mention static, that means main becomes a non-static method, which means if you want to call main, we have to first create the object of demo. Oh, that means you cannot call main without the object of demo. But the question is, we all know that main is a starting point of execution. If the execution has not started, how can you create object of demo? Okay, so there's a deadlock here, right? So to solve that problem, what we can do is we can make this variable as static. So to solve that problem, we can make this main method as static. The moment you do that, we are saying, hey, to call main, we don't need object of demo. Problem solved, right? So yeah, this is how we can solve this problem, and this is what static methods are. Anything else? I think it looks good. In the next video, let's try to see something more about static. There's a concept of static block. Let's talk about encapsulation. Now, I know that's a new term, but when we started with OOPS concept, now encapsulation is a part of OOPS. So when I say, let's implement object-oriented programming. So yeah, we have talked about class, we have talked about objects, and the next step is encapsulation here. Now, by word, what encapsulation means? We have the concept of capsules where we have medicines powder there. So basically, we can imagine capsule as something which is keeping it close, keeping it tight, and no one from the outside world can use it. That makes sense, right? So what we can do here is, let's design a class, okay? And let's name this class as human. I know we can use different names, but let's go with human here. And I know we are aliens, but let's say this is human. Now here, when you have this human class, a human will have some parameters, right? Example, if you remember, we have talked about this before. As a human or as a person, we know a lot of different stuff. So in your mind, you have a lot of different concepts, or a lot of things. Example, you know your name, you know where you stay, you know your favorite actor, you know your favorite trainer. Of course, you can use my name there, but just kidding. So we have different information, right? Now, can you imagine this, that all the information are actually stored in your brain as a variable box? I'm a big fan of Pixel movie, which is, I don't know the exact movie name, but Pac-Man basically eats people and then they become pixels. So you can imagine the data in your mind is cube, okay? And in that box, you have the data. Example, your name is stored in a box which name Naveen, or which name's name is equal to, and in the box will be having a value. For me, it's Naveen. Let's say if you're your favorite actor, so you'll be having my favorite actor, and the box inside the box will be having a value. So what I'm saying is, all the data is stored in your brain in the format of boxes, variables. Now, of course, you can use these variables, right? So let's say my name is Naveen, and let's say if I'm walking on a street, and if someone is asking my name, I might provide my name. What if someone is asking my email address? I might provide my email address depending upon who that person is. What if someone is asking for my children's name, my wife name, my family name, my Facebook password? No, I'm not going to share those things. It's because there's something called privacy, right? And yeah, I know a lot of people don't believe in privacy. But of course, no one should be able to get your data directly, right? It's not like your data is available for the entire world to see. It's there, it's closed. No one can see the data. Of course, they can see my Facebook profile, but no one can see the data inside your brain. That's important. If they want to know your data, they have to ask. And you can decide, do you want to share or not? In the same way, let's say we have this human class, and in this human class, we have a variable called age, and we have a string which is name. That's it, just two variables. And now, if I want to access those data, of course, I have to create an object of human here. And let's say this is the human object, new human. And once you got this object, with this object, you can fetch data, right? Of course, you can set the values as well. And for this particular object, I can say obj.age is, let's say, 11. And obj.name is, let's say, Naveen. I know that's not my age, but at this point, it's okay. So we got these values and we got this object created here. Now, what I want to do is, What if someone asks me, hey, human, or maybe someone is directly trying to fetch the data. Example, if I say sout and if I try to say obj.name. Now what we are doing is, just by using the object, anyone can fetch data. Okay, and this will work. Okay, it will not give any issues. I will say compile and run. You can see we are able to fetch data, and syntactically there's no issue. But then if you really think that we have to implement software for the physical world or the real world, it should match with the real world. Not all the data are directly accessible, and we want to control it. So one way to do that is, what you can do is you can make your variables private. Now, what do you mean by this private keyword? Of course, we'll have a detailed discussion later. At this point, private simply means this particular variable, which is age, is accessible only in the same class. Let me repeat. This age variable is accessible in the same class. The moment you make it private, it's private. No one from the outside world can use it. Of course, I can use my data because that's private to me. But you can't access my data because that's private to me, right? The same thing can be done for the name variable here. And if you observe, the moment I do that, we got an error here. I mean, of course, VS Code helps you there. VS Code says, hey, this variable age is not visible. You know why it's not visible? Because it's private. Now, going forward, this is what you have to do. Every time you create an instance variable, let me repeat. Every time you create an instance variable, make it private. No one from the outside world should be able to use it. Now you will say, hey, doing that, we are actually breaking all the purpose of building a software, right? If no one is able to access this data, then why we are even creating these variables? That's right. The reason why we're creating this variable is because we can store values and someone should be able to access them. They should be able to access them, but not directly. Okay, so there should be some indirect way. Yeah, we have an indirect way. So the way they should be able to access this data is with the help of methods. Example, let's say if you want to know my name, you have to ask for it. And I will decide should I share that data with you or not. So if you say, hey, what's your name? I will say, okay, I will ask my brain what's my name because most of the time I don't remember my own name. So I will say, hey, what's my name? My brain will say, okay, your name is Naveen. And then from my methods, which is my mouth or by using my handwriting or by typing somewhere, there is a way I have to share that data with you, right? I have some methods, behavior. I can talk, I can write, I can type. Now using those behavior, I can share the information. Okay, not like anyone can just come to me they will break my head and say, okay, I got the data. No, that's not how it should work. So how do I restrict it? So what we can do is we can make it private. We are restricting it. The only way to access them is with the help of methods. So what I can do is temporary, I will just comment these two sections and I will assign the value here itself. And we can do that. I will say name is Naveen. And then here, coming back to public, I will say public. I want to get data. I want to say, hey, get age. Okay. And of course, you can use any method name, doesn't matter. But let's say get age. And this will return an integer value. So I will say int here. And this will return. So this will basically return the age. Now the question is, can I access age here? And the answer is yes, you can. You can access the age variable inside a method of a same class. That's right. This get age is defined in the same class. That's why you are able to access that. And if you see age here or name here, so we are trying to get the data of another class. Demo and human, they are two different classes. Okay, makes sense now. Now we can also do it for the name. So for the name, I will say public string get name, and this will basically return a name. Okay, so we got two methods, get age and get name, and then we are returning the age and name. Now, if someone wants to fetch it, I can simply say, hey, don't call name, that will not work because name is a variable which is private. You can access the methods. You can say obj.get name. That's how you can fetch a value. Of course, you can also fetch the age. What I can do is I can just say plus, I can give a colon in between, and I can say obj.get age. Okay. Now I think we should be able to access it. Let's try and compile, run. Oh, it's working. Can you see that? We got Naveen and Levin. So the point to remember is every time you create a variable which is private, we are making sure that it is restricted. No one from the outside world should be able to use it. So this age variable, this name variable will be used by their own methods. That actually makes some sense. Okay, but there's one little problem here. What if I want to assign the value? What if I don't specify the value here? Cut and cut. Let's say we have the variables, but I don't assign the value. Now, of course, if you don't assign the value, the default value will be 0 and a null string. But I want to, how do I set the value? Now, for getting the data, we have said get. For setting data, can we say set? Let's try. So here for age, I will say public. Now, when you're setting the value, you're not getting in return something, right? So you will say void and you will say set age. Okay. Now, it's just that when you are setting the age, you have to ask, hey, what is the value? So maybe you can also accept a value here. Maybe I can say A, right? And then here I can say age is equal to A. Now what I mean by that is, of course, you have a method which is accepting a value, assigning that to age, but how it will work? So let's come back here, which the portion which we have commented. I want to set the age, right? So instead of setting the age to the variable, I can say obj.setAge. We are using a method now, not the variable. And in this particular bracket, you can pass the argument. And let's say the age is 30. So now we are passing the value. Now this value will be assigned to this A, and from A, this will be assigned to age. Can we do the same thing for string? Let's try. I will say public void set name. And of course, we have to also accept the name. But what's the format of name? It is string name, or I will say n this time. And here I can say name is equal to n. So whatever value you pass will be assigned to this n, and from n it will be assigned to name. Now the same thing need to be changed here. So I will just cut this part and I will say cut this part as well. I will say set name, and in the double quotes I will pass the name, and the name here is Naveen. Or maybe I'll use a different name this time. I will say Reddy. Okay, and now I will just come back here, clear the screen, compile, run. Can you see that we got Reddy and 30? So what we are doing is we are assigning the value with the help of methods here, and we are getting the value with the help of methods here. So that's how we can access this data. Now what we are doing is we are making your variable private, and then the only way to access them is with the help of methods, right? So basically we are binding our data with the methods. The only way to access that data is with methods. So no one from the outside world can use your variables directly. So somewhere we are encapsulating the data in methods, and that is encapsulation. Okay, simple stuff, right? So yeah, that's it from this video. Let's try to understand this more. What is this get and set methods? Can we use different names, or only this name will work? That we'll discuss. Let's try to understand what these methods are, or can we change their name? So get age, set age makes sense. But can we use some other names? Actually, we can. Instead of saying get age, we can say, let's say we can say ABC, and set age, we can say XYZ. We can do that, okay? There's no harm in that. The only thing is when you call these methods, of course, you have to change the name. I will say this is XYZ. So when you set the value, you have to call XYZ. And then when you fetch the value, you have to say ABC. And it surely works. If I try to compile this and run, you can see it works. Now the problem with ABC and XYZ or any name is your method name should define what is your intention. Because most of the time it's not just about writing code, it's also about reading code. When you write a code once, it will be read by multiple people in the entire lifetime of a software. Why not use proper words which explains what that method is doing? So instead of saying ABC, if I say get age, it is actually makes sense, right? It is much more readable what you're doing there, right? And as I mentioned before, it is not a compulsion to use the same name. But then as a Java developer, we have adopted this standard. Whenever you want to get the value of a variable, the method name would be get space the other variable name, the variable name, which is age. To set the value, you will say set, and you will use the variable name, which is age. Okay, so that's how we can use this. So this is called a getter. So for the variable, you say this is a getter. And when you want to set the value, so the method is called setter. So we can say that those are getters and setters. In fact, the beauty is if I delete the entire part, okay, let me just do that. I know we need to type that once again. Actually, you don't. Most of the IDEs have this amazing feature. You can just right click and there's an option of source. In fact, it doesn't matter which IDE you're using. You will see the option of source or insert code, something like this. So you will say source action. What do you want? You want to get, you have to say generate getters and setters for me. Click on that for both the variables and click on OK. You can see it will generate the methods for you. And you see that variable names, it's same. Get age, set age, and then we got get name, set name. Okay, and those are called getters and setters. And of course, there is no compulsion to have both the methods. You can only have get name. You don't want to have set name. That's your choice. There's no compulsion that there should be both. It depends upon you how you want to implement it. For this example, I want to assign value to age and name. I want to get the values as well, and that's why I'm using this row. So only thing is for every variable you need two methods, getters and setters. Okay, so yeah, that's it. But there's only one issue now. If I use the code which is given by the IDE, you can see this new keyword here. We got this. In this video, let's talk about this, because in the previous video we were doing something and then suddenly we got this keyword. So it's important now to talk about this keyword here. Now what I will do is I will just remove this, or I will just change this variable name back to A and N. And of course here we have to say A and N, right? And let me remove this keyword from here just to see if this works. Now if I remove this keyword from there and if I run this code, compile, okay, there is some problem with the variable names. I think we are still calling XYZ, so it should be set age, and we are still calling ABC, it should be get age. The same thing which we have done in the previous video. Okay, so if I save this and if I go back and compile, so compile done, running, done. So you can see we got the values, right? Now the thing is, when you talk about this variable like age, and when you're passing A here, we are using two different variables, right? Now, the point to remember here is this A variable here is a local variable. This age variable here is an instance variable, right? If you want to understand that with a diagram, you can just go back here. We have a stack memory, remember? We have talked about stack and heap. So we got a stack here and then we got heap here. Now, the moment you create the human object, we got this object here, human. So in this, we have a human object. And of course, it will have some address, let's say 101. So we got obj and the address is 101. That's the first object we got. And there's a link here, which we cannot ignore. And then we have some more variables. You can see if you execute, and of course, this was my main stack. Now we are executing which method? So if you say set age, we are executing set age method, right? Now set age will have its own stack here. Let's say we have a set age stack here. You know what? I just have to zoom it a bit. And here, let me create segments. So we got multiple segments here. And of course, this will be linked with this particular variable here. And don't you think this box, which is address 101, is an object of human? So it will also have the instance variable. How many instance variables we have? We have age and name. So we got age and we got name here. Now, if you look at the set age, now set age, this particular stack is of set age. Every method will have its own stack. And in this, we got a variable called A. And the value for A, which we are passing, is 30. So we got 30 here, okay? And then the same value, 30, we are assigning to age. That means we are changing this variable and we are assigning a value which is 30 there, if that makes sense, okay? So both the value for A and age is 30. And that's why when you fetch data, when you say get age, it will return the value of age in the object, which is 30 in this case. And that is perfectly working. Now the problem is, what if I just make this particular variable age as age? I mean A as age. Now what I want is I want my local variable and my instance variable both to have the same variable name. What do you mean by that is, if I remove this A from here, the variable name here will be age. So both the variable name, the local variable and the instance variable have the same name. Then it should work, right? What we are trying to do is, the age variable will get 30 here. So of course, in this stack, we got 30. And if you see, we are assigning age is equal to age. So I'm expecting that this age will get the value from this particular age. It should work, right? Let's try. If I go back to my code and compile and run. Oh, can you see that? The value for age is still 0. That means the assignment which we are assuming that it will be 30, it is still 0. Why? The reason is, if you look at line number 11, and if you see it, we are saying age is equal to age. The problem is, by default, now see, this age can be local variable, this age can be instance variable, right? Because the names are same. So can we do this? Can we say, it is possible that the age here is actually a local variable. It is also possible that the age is assigning value to itself. Maybe this age is not even an instance variable. That means this age is assigning value to itself. And this age here, which we have created, it is still 0. And that's why we are getting 0. How do we solve this problem? So somewhere we have to mention, hey, you know, this particular age here is not a instance variable. This is not a local variable. This is an instance variable. So remember this point, the preference will always be given to local variable. So in case of confusion, it is always the local variable. We have to mention by some way, hey, this is not a local variable, that's an instance variable. How do you mention that? So in order to say that's an instance variable, can we do this? Can we say human, can we create object here itself, obj1 equal to new human, and then we can say obj1.age. Now what we are doing is we are saying this age is an instance variable. And you might be thinking, hey, how can we use age with an object? See, we can't do that because we are in the same class. Okay, we were not able to do that here because we were in different class. But again, the problem is we are saying this age is instance and this age is local. This should work. Let's see if this is a problem or we have solved the problem. Let's run this. Oh, it is still 0. What is happening? Let's try to understand more. Now, when you execute this setAge method, what we are doing is we are creating a new object. Oh, that's the issue. We are basically creating a new object. Okay, how do we solve this problem? We don't want to get new object because the moment you create new object, what will happen here is it will create a new object, let's say 103, and this will also have age equal to, name equal to, and what value you're assigning here? You're assigning value which is 30. And then here in this set age, you will create obj1, which will have the address 103, and there's a link here. So the value which you are changing is of this age, not this one. We want to assign the value to this particular age. That means creating a new object is not a good idea. Okay, how do I clear this? Let's remove this. In fact, you know, this is a problem. This is creating a new object. Okay, if I don't want to get a new object, how do I access this obj? Oh, I got an idea here. What if with this 30, if I can pass the object itself, will it solve the problem? With 30, if you can pass this particular object and we can accept the object here, what type of object it is human obj, and then here we can simply assign the value. So what I'm doing is, if you observe correctly, we are not creating a new object. We are basically passing the reference of the old object. So here it will be not 103, it will be 101. Okay, so this obj1 here will get the address 101, and we can simply say obj1.age, and now we are not referring to this address, we are referring to this address. So we can change the age value 30, and let's see if this works. I hope this will work. Compile, run. Oh, it is working. It's working. So basically the important thing is, how do I differentiate between an instance variable and a local variable? Is by passing the object itself. But there's one little problem here. The problem is, if you read this line, it says obj.setAge, and then you're passing the obj object as well. Why we have to do this? Why you have to mention obj 2 times? Now Java knows this. Java says, hey, you don't worry. Why you have to pass the object 2 times? I mean, you're calling the method by using the object. You're also passing the object. Don't do that. Don't pass the object. By default, I will give you this obj. You don't even have to accept this obj. What if Java says, hey, don't worry, don't create the object, don't pass the object. I will give you the object. And that object, my friend, in fact, you know, when we had human here, we don't even need this human line here. We could have removed that and even obj would have worked. So your Java says, hey, why to even use this obj when we can simply use this? Now this is a keyword which represents the current object. Now when I say current object, what it means? The object which is calling the method. Set age is called by obj, which is this object. Here in this method, we can actually use that object with the help of this keyword. So this refers to the current object who is calling this set age. I hope that makes sense. So from this point, we are always going to use this, which represents the current object. Okay. So here as well, instead of using name or n, I should have used name. The only thing is we have to refer the first name here is this dot name, which is the object itself, the current object. I hope all this thing have made sense. This is what this keyword is. In this video, we'll talk about constructors. Now, what are constructors? Now look at this example here, which is of human. Now, when you talk about human, we have some variables, right? Of course, when you talk about these two variables, these are instance variable. And then we have seen in the image as well, basically, whenever you create an object, example in this, we are just creating one object. And that object is getting created inside the heap memory. You can see this is the object we got. And of course, with that object, we have assigned the value for the age. We have assigned the value for the name as well, which is ready, but I have not written it here. But we know that the object is created. Now, the thing is, when you create the object, if you observe the line number 29, on this line, when you create the object, what happens? When you create the object, in the heap memory, it will just create a blank object. Example, if I try to remove this, if I keep it empty, it will create an object with a value. So the value would be, it will have a variable which is age, and the value will be 0. And it will have a variable called name, and the value will be null, right? I will just try to print those things. What if I do is, I will just print the same statement before assigning the value, right? So I'm printing it here, and I will comment this section. So that's how you comment, right? I don't want this line to be executed. And now if I go back here and compile and run, you can see we got null. Null basically is when you don't have the data assigned to object type. That's right, string is an object type. We'll discuss about string later in detail. As of now, just remember, by default, the value for string is null, and the default value for integer is 0. Okay, that means if you don't assign these values, there will be default values. What I want here is, of course, there is a way you can assign the values later, but what if I want to assign the value when the object is created? That's right. On this line itself, I want to assign the value. That means the moment I get the object, I don't want to have a null value. I want to have some default values. Example, let's say by default, every object created, the name should be something else. The name should be, let's say, Babu or something else. I'm not sure. But can we have a default name? Can we have a default age? So let's say for my application, this application can be used only by those people who are 12 and above. So I can simply say, hey, the minimum age for this is 12. So by default, the value for the age should be 12. Can we do that? So how do we achieve that? Of course, we can assign the values here, or we can use something called a constructor. Now, how a constructor looks like? So a constructor looks like a method itself. Let me repeat, a constructor looks like a method itself. That means a constructor will have a name, a constructor will have the round brackets. Example, if we talk about methods here, we have a name and we have a round bracket. In the same way, for the constructor as well, we have to use that. So what I will do is I will say public. Now the only change is in the constructor, you don't specify the return type. Okay, so we can directly mention the constructor name here. But what should be my constructor name? Now there's a compulsion that your constructor name should be same as your class name. So what is my class name? It's human. And then since it looks like a method, we can give a round bracket and we can open and close the curly brackets. Now one thing I wanted to mention, you can see with the curly brackets are mentioned just, the opening brackets are just mentioned on the same line. And here the curly brackets are mentioned on the new line. Both works. Some people prefer to use on the same line. Some people prefer to use on next line. So anything works. Now in this constructor, I can assign the values. But at this point, let's not assign the value. I will just simply print the statement. I will say out. And here I will print in constructor. So you can see we are printing in constructor here. So that's our constructor. Okay, so let me repeat what is constructor. So constructor is a special method. That's right, because it looks like a method. It has the same name as a class name. So those are the rules you have to remember. the constructor will have the same name as a class name. A constructor never returns anything. So you don't have to mention int, float, or string, anything there. So just specify the access, which is public, and then mention the name, which is human. And in this, you can do whatever you want. Okay, so I'm just printing in constructor. So let me just try and compile. So compilation done, there is no problem. When I run this code, one thing to observe, nowhere, see, when you talk about these methods like get age or set age, all these methods, we have called them, right? So this is where you're calling them. Constructor, you can see we are not calling it, but still constructor will be called. Okay, so even if you don't call it, it will be called. Now, when it will be called, every time you create an object, it will call the constructor. So every time you create the object, it will call the constructor. Example, let's say if I create two objects, I will just copy this line and paste it here. Of course, I should have a different name for the reference, obj1. Now you can see we have two objects. Now, when you say you have two objects, and if I try to compile and run this, you can see we got in constructor 2 times. So every time you create a new object, it will create a constructor, or it will call the constructor. Okay, if that makes sense, what we can do is, if we can remove this line and I can assign the values. I can say age is equal to 12 and name is equal to, let's say by default, John. Of course, you can have any name, but let's say John. Now, in this case, I can see if these values are assigned. What I can also do is I can just comment this section. Let's say I'm not assigning the values. Let's see what are the default values. Compile, run. You can see we got John and 12. So by default, you assign this value. Okay, so this is where constructors are helpful. Now you might be thinking, hey, we can assign the values here itself, right? See, there's a idea, there's a standards which we follow. Whenever you want to perform any operation, always do that in a method. Don't openly do it in the statement like here. If you want to perform some operation like assignment or calculation, always do in the methods. And constructor is like method, right? So you can assign the values here. There's no harm in terms of compilation. You can assign the values here as well, but we have to follow standards, right? And also just try to think about something advanced. Let's say you are trying to connect with a database. Now in that scenario, your application is trying to connect with a database or the network. You need that connection, right? Now, where do you write the connection? You can write the connections in the constructor. And that's why this becomes very important. Now, if you remember, we have also talked about method overloading. So when you have two methods with the same name, but different parameters, those are called method overloading. Now, can we do that in constructor? That's tricky, right? Okay, so now we know what is constructor, right? But what about this? I mean, can I pass the values here? What if I don't want to assign values like 12 and John? What if I want to customize it? So what I want is every time I create the object, I should have an option of passing those values, not 12 and John every time. Can we do that? Of course, you can assign the values later with the help of set methods. But what if I have an idea where, hey, let's go with this object as well, the second object. And in the second object, I want to pass the values. The first object, I want it to be default. The second object, I want the age to be, let's say 18, and the name should be, let's say Naveen. Can we do that? If you can see, this line is giving you error. It says, hey, you don't have a constructor which accepts two values. So those two values of type integer and string, you don't have it. And if you go up, actually you don't have it. You don't have a constructor which takes two parameters. Can we do that? Let's try. So I will say public human, and I want this human to take two parameters. So I will say int a, comma, string name, and then here I can just come back and I can say age is equal to a. So not the default value which I want to assign here. I want to assign the value which is sent by the main method. So if you can see, we are passing 18 and Naveen here, right? So I can just go back here and age is equal to a, name is equal to n. Now, if you look at this particular constructor here, it is taking some parameter. So this constructor is called a parameterized constructor. Oh, I should say this is n. Now, what is the difference between normal constructor and a parameterized constructor is, in fact, this normal constructor is also called a default constructor. Now we'll discuss why this is called default constructor. So this is called a default constructor. This is called a parameterized constructor because we have parameters there, and whatever value you pass here will be assigned. Now you can use both syntax. You can either create an object by not specifying any parameter or arguments, and you can create an object with the help of values, which we are passing it here. So this is parameterized and this is default. Now what I will do just to explain this is I will just copy the same line and I will print the values for obj1 this time, not for obj1. So basically we are printing both, and let's see what the output is. Compile, run. You can see we got the first object drawn 12. The second object is not John and 12, it is Naveen and 18 because you are passing those values. Now what I will do is I will remove this part just to explain you something. See, when I mentioned that every time, let me just comment this section as well. See, every time you create the object, it will call the constructor, right? But then if you see, I have removed the constructor. Will this work? And it was working before. Remember when we started this example of human, we were not having any constructor. It was still working. At this point, your Java will say, hey, don't worry. If you don't mention constructor there, I will create a constructor for you. And that's why we say that's a default constructor. So behind the scene, you will get this constructor here, which is public human. This is what you will get, even if you don't mention. Okay. The only thing is it will be default. It will be blank if you don't mention. But if you want to do something, of course, you have to mention that explicitly. And we can use the same code, or I can actually ask my IDE to give me the code. So you can simply go to source and action, and you can say, hey, I want to create a constructor. But which constructor? So I want a constructor which takes both these arguments, and I also want a default constructor. Source action, I want a constructor which is default. You can see we got two constructors. There's only one change. The syntax which we have returned was a and name. And here if you can see we have age and name. And to make it work, we have to use this keyword. I hope you remember this keyword video previously. And that's how it works. It has the same way which works. The only thing is we have to assign the values here. I will say age is equal to 12 and the name is John. So that's how we can basically use a default constructor and a parameterized constructor. Of course, we can create some more constructor here. What if you want to just specify the name, not the roll number? So you can say, I want a constructor, source action, and I want a constructor which takes only name. So you can say we got a constructor which only takes a name. Now what happens to this type of objects? Example, if I create an object here, let's say the second object, and this time I'm not passing two values. I'm just passing one value which is name. In this case, the age will be 0. So what you can do is, even if you're accepting name, you can assign the age by yourself. You can say 12. You can say age because there is no confusion, or you can also say this dot age just to maintain the uniformity. Okay, so that's how we use constructors, default constructors, parameterized constructors. In this video, let's talk about this and super. Now this is a very super concept, so let's focus. So what I will do is I will just remove all this thing just to make it simple and clear this part as well. And for this, I don't even need this particular classes. So let me just close these files and keep it simple. Okay, so we have a very simple code here. Now what I will do is, just to understand this and super, I will create a class called A. I know this is a very simple name, but just for the example, we can take them. And then we got a class B. Okay, we got two classes. And then I'm also saying that this B class extends A. Of course, we are doing inheritance here, and it makes sense because we just talked about inheritance. And then what I will do is I will create a constructor for both. Of course, we can do that, right? Now, before creating a constructor, let me say if I create object of B, of course, we can do that, right? So this B class, we got an object of B class here, and we can do that. Let me create a constructor of B here. Now, how do we create a constructor? It's very simple. You specify public, and then you say B, bracket open, and then here, I will type in B. I'm just trying to keep it as simple as possible. That's why we have taken class A and B, and then a very simple statement. Now, what I will do is I will try to compile this code, and you tell me what will be the output. Compilation done, right? If I run this code, there will be some output, right? Now think about this. We are creating the object of B. Okay, we are instantiating it. And we have learned about this, that whenever you create the object, it will call the constructor of a class. So the object we are getting is of B, and we have a constructor, which is B here, which prints a statement. So of course, I'm expecting that it will execute the constructor, and it will. And that's why you got in B. That perfectly makes sense, and we have talked about this from a long time. The twist here is, what if I have a constructor in A as well? And here I'm printing in A. Now, what do you think will be the output? Because of course, we are creating the object of B, not A. So it should call the constructor of B, and that makes sense. But if you compile this code, you will see something strange. If I compile this code and run, oh, it is also executing the constructor of A. Now that's weird for us, right? Because we are creating object of B, it should only call the constructor of B, but it is also calling the constructor of A, and that sounds weird. Now we'll understand that, but at this point, just remember, whenever you create object of a class, it will call the constructor of subclass and superclass both. A is a superclass here, B is a subclass, it will call the constructor of both. Why? We'll talk about it in some time, but it calls the constructor of both. Now let me just add a twist here. In B, let me create a parameterized constructor, and we have seen that, right? So what is parameterized constructor? A constructor which takes a value. Let's say this is n, okay? And here I will print in B int, because we have a constructor which takes a integer parameter. I'm just printing int just to differentiate between these two statements. Now with this, if I compile this code and run, what do you think, what will be the output? Compile and run. Still it is in A and in B. Why not in B int? Is because when you are creating the object, you're not passing any value here. Basically, you are calling a default constructor. But if you pass a value, let's say 5, in this case, you are specifically mentioning, hey, I'm creating an object of B and I'm passing an integer here. So it will call the constructor of B, which takes integer. Now by doing this, if I run this code, you can see it is printing in A and in B int. Okay, that actually makes sense. It will call the constructor of A. But what if I also have a parameterized constructor in A as well, which takes n, and it also prints in A int. Now, since we were not having a parameterized constructor, it was calling a default constructor. That's what I'm assuming at this point. Now, when you have a parameterized constructor for both, for A and B both, now there is an expectation that it will print in A int and in B int. And that's what I'm thinking. I'm not sure what you're thinking. Let's try. Let's see if this works. Oh no. What is happening here? It is calling the parameterized constructor of B. That actually makes sense. But why the default constructor of A? It should have been called this one, right? Let's understand why it is first of all calling the constructor of parent class. Why in the first place? The thing is, and remember this point, every constructor in Java has a method which is there, even if you don't mention, okay? And that method is super. Now this method is there even if you don't mention. You can imagine that's like a John Cena. I don't know if you know the John Cena memes, but that's just that you can't say it, okay? So super is there, you can't say it. Even if you don't mention super, it is there. So by default, every constructor, the first statement is super. And every constructor, not just this one, every constructor. Here as well, super, okay? So every constructor will have super. Same goes for A as well. It will also have super and super. Irrespective of which class it is, it will have this statement super. Even if you don't mention, it is there, okay? That's a point to remember. Now let's try to understand how it is working. Let's do a dry run. The moment you execute this statement, what is happening? It is calling the constructor of B, which is parameterized. So it is calling this particular method. So when you execute this method, the first thing it sees is super, not the system.out.println. What it is saying is super. Now what is super? Now super method simply means call the constructor of a superclass. So let me repeat. Super means call the constructor of a superclass. Now what is there in a superclass? This is a superclass. It is calling the constructor of a superclass, but which one? The parameterized one. Sorry, the default one. If you can see, we are saying default. We are not passing any parameter here. So it is calling this particular constructor. And that's why it is printing in A. And that's why if you can see the output, it is first printing in A. And then once it executes the A constructor, it will execute the remaining part of B constructor, which is this part, in B int. And that's why we got in B int, okay? That means if I don't want to call this constructor, if I want to call the parameterized one, we have to do only one change, which is, what if in this super, you pass a number? So n is a value, right? It will have a value. The same value you're passing to this super. Now what we are saying is, hey Java, I know you're going to execute this superclass constructor, but I'm passing a parameter there. So now this time you have to call the parameterized constructor. By doing those changes, let's compile and run. Here we go. It is printing in A int and in B int. So super is a very handy tool. It's there already. You don't have to mention that. But if you want to make some changes, of course you have to mention. So if you want to pass a parameterized constructor, then explicitly you have to mention super. I hope that made some sense. Okay, now what I want is, I want to call the default constructor of B. Okay, I'm not passing any parameter here. I'm calling a default constructor of B. So of course, if I execute this, if I compile and run, you can see it's printing in A and in B. Why? It's because when you are calling the default constructor here, in default constructor of B, it will execute first. It is calling this super. That means it is calling this particular constructor, which is printing in A, and then it is printing in B. It will continue with this execution of constructor B, right? But what I want now is, I know you got the point. What I want is, I want to execute in A int, and then I want to print in B. So the output which I want is in A int in B. So how can we play with that? So what if here, if I pass a value, let's say 5 or any number, doesn't matter. If I pass a number, it will try to create object of B with a default constructor. It will execute the default constructor. But now we are calling a superclass constructor by passing a value. So which constructor will be called? Of course, the second one. And it will print in A int in B. Let's try, compile, run, and that's what we got. So that's how we can play with super. And that is fun, right? Now I have a question for you. Maybe you have observed it or not. See, in B class, when we are saying super, it actually makes sense because we have a superclass for B. Okay, this is A here is a superclass. But when you say super for A, what is a superclass for A? We have not mentioned anything here, right? Okay, now that's why we have to introduce a new concept here. Every class in Java, let me repeat, every class in Java extends the object class. So object is a class in Java, which has a lot of methods. We'll talk about those methods later. But every class in Java extends this class, even if you don't mention. So even if you don't mention this, it is extending it. Again, you can imagine this as a John Cena. It's there, you can't see it. Okay. So even if you don't mention or you mention, it's the same thing. So when you say super here, you're basically calling a constructor of the object class. Okay, in object class also we have a constructor. This is what you're calling. Cool, right? So even if you don't mention it, is there. Now you might be thinking, the B class must be extending A and object both? No. B class extends A class extends object. So this is multi-level inheritance. Okay, there's no multiple still now. Okay, so yeah, that's how it works. We have object class. So this super represents the constructor of the object class. So yeah, so we have talked about super, but what is this? Okay, now let me introduce this here. The output which I want now is, I want to execute both the constructor of B. Okay, so let me just keep it default now. Let me say super. I want to execute both the constructor of B. So I want only one object, okay? With one object, can I execute both the constructor? Of course, I want to execute the constructor of A, which is default, but I want to execute the constructor of both B. So what I'm saying is, I want in A, I want in B, and in B int. Is it possible? For that, what we can do is, see, we are creating the constructor. Let me pass a value here. Let me pass 5. So of course, by doing that, what we are doing is we are calling the constructor, which is the parameterized one, and we are calling super. And that's why it is calling the superclass constructor. But then we have one more method called this. We have talked about this keyword, right? Now what this will do is, this will execute the constructor of a same class. Let me repeat. This will execute the constructor of a same class, which is this one. We are not passing any parameter, so it will call the constructor of a same class. And then this constructor is calling the constructor of a superclass. Let's try if this works. Compile, run, and you can see that we got in A, in B int. I mean, of course, this will execute first, this method, but this particular method, B constructor, is executing this, which is the default constructor. The default constructor executes the super, which goes here. It will execute in A, it will execute in B, and then in B int. So that's what is, which is this keyword and also this method and super method. So this method executes the constructor of a same class. Super method executes the constructor of a superclass. In this video, let's talk about the naming conventions. Now, if you see the code which we have written till now, somewhere I was using capital letters, I was using small letters. When to use what? And then what if you want to join two words? How will you make it more readable? Now that's where Java says it follows a naming convention of camel casing. So basically it uses camel casing. Now what camel casing means, or let's talk about in general, how do we name our classes? Now whenever you create a class name should start with a capital letter. So when you talk about class, it should start with a capital letter. Example, if you want to create a class called calculator, the C should be capital. Now on the other hand, if we talk about variables or methods, so for variable and methods, what you will follow is you will start with a small letter. Example, if your variable name can be marks, a variable method name can be show. So it will always start with small. Class, capital, variable, method, small. In fact, we also have a concept of interfaces, which we'll discuss later. So if we talk about classes and interface, we'll have to make it capital. Let's say interface is runnable. So basically, this is the convention which we follow. Class interface, we have capital letters. Variable methods, we have small letters. We also have a concept of constants, which we have talked about. So when you talk about constants, it will have a capital, but all capital. Example, if we talk about a value of pi, if we talk about a constant of brand, so doesn't matter what your constant is. So you can have all capital here. Now, why do we do this? We do this just to see and understand what could be the thing which you're doing. Example, if you see this type of things, you can guess, hey, it can be a class or an interface. If you look at this, you know this is a variable. If you look at this, you know this is a method. And when you look at this, you know these are constants. It makes your code much more readable. And that's important, right? It's very easy to write a code which works. It's difficult to write a code which anyone can read. And that's why you should follow this convention. So this is how you use naming convention. But what if you have a word which has two letters? Example, if you talk about show my marks. If I want to do this, so you have to say show my marks. Because if you say show my marks, it is actually a bit difficult to read, right? So what you can do is, every time you combine words, make sure that the first letter of the second word or the first letter, make it capital. It makes it much more readable compared to small letters. Now this is what camel casing means. You know, we have camel, so it goes up and down. So we have small letters, then we have in between, we have capital, small, again we have capital. So this is camel casing. Now apart from this, there are different languages which follow snake casing rule where we use underscores. Example, in some languages they follow snake casing, they use underscore. And people who jump between different languages, they get this tendency of using underscore. So again, Java will not give you any error, but if you follow the Java pattern, Java developers will not like this. So if you're writing a code where you have a Java team or everyone works on Java, try to follow camel casing. And but again, it will not give you error. It perfectly works. Underscore works in the names, but that's what we follow. We follow camel casing here, not snake casing. Yeah. If you have the class name, which is again, I want to say my data as a class. So you can say M is capital because that's a class name. Now I will show you some names and you have to guess what those are. Example, if I say age, that's variable, right? Okay. What if I say data? What is this? This is a constant because everything is capital. Okay. Yeah, in terms of constant, if you want to say my data, which is a constant, you have to use my data. But again, everything is capital, right? So at this point, you can use underscore just to differentiate this. And again, these are the good practices which I'm showing you. How about this? If I use something like human, but I use a round bracket. Any guess? Yeah, that's a constructor. Why is it a constructor? It's because the first letter is capital. That means it represents a class name. And we also have a round bracket, method like something. So that's a constructor. So this is a naming convention which we follow, and try to use good names for your variables, your classes, your methods, so that it will be easy for others to read. Okay, so now we know how to create the object, right? So we have a class, let's say we have a class A, and then in this class A, we have a show method. Now, how do we call show method? That's very simple. First, you have to create the object of A, and then you can call the show method. Now, what happens behind the scene? So of course, you have your big JVM here, and then in this, you'll be having your stack memory, and then you'll be having your heap memory as well. Now, in this heap memory, so if you look at line number 14, it will create an object Let's say the address is 101. And then in this, you will be having a variable or methods. We don't have a variable as of now. So let's say we have a method which is show. So of course, in order to call this show, we need object. So we have done that. And then we have obj here. The address will be 101 and it will refer here. And then every time you want to call show, basically you have to say obj.show. That's how it works, right? Okay. Now, just to clear the things, this obj here is not called the object. It is called a reference variable, right? So this is your reference variable. Why it is called a reference variable? Because it is referring to an object. The object is here. So this is your object. Okay. So the question is, if I want to create this object, is this line compulsory or do we have a shortcut? Now to understand this more, let's also use a concept of constructor. So let's say we have a constructor here, which is A, and then I'm just trying to print something here. It says object created. So of course we know every time you create the object, it will call the constructor as well. So it should print. So if I compile and run this code, you can see it says object created and it is printing in a show. Now, actually, if you look at this line here, there are two steps, not one. Example. So let's say if you create a local variable called marks, okay? And then you set the marks for it. You set the value for it, let's say 99. Everyone hates this type of people, right? Anyway, so we have this variable. So what we're doing is we are first of all declaring the variable and then we are assigning a value. The same thing can be done for this thing, right? We can do it in two steps. We can declare the object and then we can say obj equal to new a. Now this is called reference creation, right? This is where you're creating a reference. And then this is where you are creating an object and assigning the value to obj. That means this is, when you say new a, this is where you create the object. Let me show that. Let me remove everything from here and say new a. This is object creation, not the entire line. When you say new a constructor, that is your object creation. The moment you do that, in your heap memory, of course, we don't have all this data now. So ignore all this data which is there. Let me just remove this. This is not there. Imagine there's no object. So this line will create an object. Doesn't matter what's the address, let's say 501, and it will have this show method. Okay. The only thing is we are not doing anything. We are not creating any variable inside stack. Example, when you say int marks, the moment you do that, it will create a int variable called marks here. The value will be blank, and whatever value you want to assign, you can assign that here. But if you can see, we are not doing anything here. We are just creating an object that is created inside the heap memory, nothing in stack. And if you don't trust me, let me just show you the proof. If I compile this code and run, it says object created. This is the object. And this type of objects are called anonymous object. You know why? It's because this type of object don't have a name, right? What do you call when you have a reference? It is called a referenced object, okay? Because there's a reference in the stack. So when you say obj, there's a reference here. For the anonymous object, there's no reference. The only problem with this type of object is you can't reuse them. Once you have written this line, you got the new object in the heap, how will you use it? That's the problem, right? So you should use this type of object only when it is required. So let's say if you want to call show, you can actually call this, okay? So you can say new a dot show. This is object, right? This is object. So using the object, you can call show. The only thing is you can't use the same object again. So if I compile and run, it worked. The only thing is you can't use this object once more. So if you write this line once more, what will happen? Now, I mentioned that you can't reuse it. What happens when you do that? You can see it says object created. So it has created two objects. Every time you say new a, it creates a new object. So wherever you want to use a normal object, you can use this type of objects. Now let's talk more about OOPS concept. Now OOPS basically stands for object-oriented programming. Now in object-oriented programming, we have talked about object, class, encapsulation, right? Now let's talk more concepts. Now, one of the most important thing in the concept of OOPS is called inheritance. Now, what is inheritance? Now, there are two words actually here which will confuse people, is and has. Now, what these two words are? Now, if we talk about a computer, now, of course, computer itself is an abstract concept, right? Now, a computer can be a laptop, a computer can be a desktop, a computer can be a mobile phone. That's right. So even if you talk about this phone, this is a computer in the form of mobile phone, of course. And the computer itself is an abstract concept. No one owns a computer. You basically buy a hardware, which can be a desktop, laptop, or a phone. Now, can I say that if we talk about a desktop, so I'm talking about a desktop which is this big and it will have certain parts, right? A desktop will have a motherboard, a desktop will have a hard drive, CPU, RAM. So when you talk about this thing, it is desktop has a motherboard, desktop has a hard drive, it has a CPU, right? So the important keyword there is has. If we talk about a house will have a TV, a house will have a sofa, AC, bed. So all those things what a house has, right? So has is an important word. But at this point, let's not focus on has. In this video, let's talk about is. Now what is? Okay. So example, if we talk about a laptop. So can we say a laptop is a computer? So what it means is laptop got its features from a computer. So can we take another example here? If we talk about a car, let's say if we talk about a Fortuner, which is very famous in India. So this car is actually a car, right? So Fortuner is a car. So that's how you represent something. You represent a device or a physical entity by referring to its upper model, or you try to take the features of it. Now, coming back to the inheritance concept in real world, example, let's say, if we talk about the human world, when I was in my 10th standard, so just for the example, okay, not that important, but when I was in my 10th standard, I did my 10th in 2005. At that point, Nokia released a lot of smartphones, right? Of course, Nokia is not there anymore, but Nokia was one of the most important factor in the smartphone industry. Now, when they came up with a smartphone, one of the most famous smartphone which they built is 6600. I'm not sure if you have seen that. I'm not even sure if that you're that old. Maybe you were not even born in that year. But yeah, so it was 6600. Amazing phone. If you can just search on Google Nokia 6600, you will see that phone. Now, a lot of my friends were having that phone. It was costly phone at that point. It was around 10,000 rupees. And I was not having any phone. So they used to ask me, hey, which phone you have? I used to say, hey, I don't have a phone. But then I realized, hey, till when I will say that? The thing is, next time when people used to ask me which phone I have, I used to say, I have 3310. Now, I was not having any phone. Now, this is my father's phone. And we know the concept, right? Father's phone is yours phone. In fact, in general world, we say, our parents' property, it's your property. Whatever they own, it's yours. I don't believe in that, okay? I'm not a big fan of inheritance or nepotism, but yeah, you get everything. So I used to say I have that phone. Okay, so this is inheritance. Now, how will you use this concept in programming? Now, in Java, what you have is you have different classes, right? Example, if you create a simple class here, let me get a very simple class. Let's say we have a class here called a calculator. Now, what features a calculator will have? A calculator will have some variables here, and then it will have some methods. Let's say method is add, method is sub, okay, and then method is multi. So we have different methods here, or let's also have division. Why division should be left there. So we have all these methods, right? And it is working. So you can basically create object of calculator and you can access all these methods. No harm in that. But what if you want to create an advanced calculator now? Of course, let's say if someone comes to you and say, hey, you made an awesome calculator and now I want you to create a scientific calculator or advanced calculator. Now you have a choice. You can edit the same class. But there's only one thing. What if you enhance the same class, you add some more methods here. Now you want to give calculator to someone asking you for the calculator object. They basically access all the basic features and advanced features as well. So it is good to create a separate class. Okay, so you can get a separate class and you can say advanced calculator, right? And then this will have all the advanced features. Of course, it will have all the basic features and it will have the advanced features as well. So we have basic features, advanced features, both. But don't you think you need to define these basic features again and again? Why? We already have those features here, right? We already have those features here. Can I just use those features in my new advanced calculator? So what I'm saying is, basically, this advanced calculator is going to inherit the properties and features from calculator. So I can also say, advanced calculator is a calculator and it will get all the features of calculator. Okay, it will make much more sense once we start coding. But what we are doing here is we are doing inheritance. So basically inheritance is a very important feature using which you can just copy the feature from the upper class. So this is your, can I say this is a parent class? So this is a parent class and this is a child class because child class is accessing the features of parent class. Okay, so whatever I earn it's my money plus my parents' money is my money. That's how the system works, right? We can also say this is a superclass. We have different words for it, that's it. And we can say this is a subclass. We can also say this is a base class, base, and this is a derived class. So it depends upon how you represent that. If you say this is a parent class, then you have to say it's a child class. If you say that's a superclass, then it becomes a subclass. If you say this is a base class, you have to say this is a derived class. That's how it works. Okay. Now this is what inheritance is. So in theory, we have talked about what is inheritance, right? Basically, you can just use the features of a superclass. Let's try to implement that in this code. Of course, we'll not be working with humans anymore. Let me just remove the entire code from here and all gone. And let me also make sure that this is empty. Gone. So we have a very simple method which is main here. Now what I want to do is I want to take the same example of calculator here. So let me create a class called calc. And of course I can just create this thing in some other files as well. That actually makes sense. But just to keep it simple, I'm using the same file here. So we got a class called calculator. And in this I can add some methods and some variables. So let's say I will define some methods here. And I will say public int, it can add two numbers. It will accept two integers as well. I will say n1, n2. So we got two variables, right? And then I can just return n1 plus n2, okay? Now let's say in this calculator, we have two methods. One is add and one is sub, which is sub here. And there will be a subtraction operation. So we got two methods, right? Now, one thing to remember, if you look at our file explorer, every time you get a file, it also creates a class file. So for every class in your code, it will have a class files. We have used a calculator, a computer, human, student before, and that's why we have all these classes. What I will do is I will just delete them. Okay, so you can see all these classes are gone. In fact, let me also delete the demo one to see what happens. And that's fine. You can also delete all the class files. So every time you compile the code, it will also create a class files for you. Let me show you that. So I will say Java C, and if I mention the file name, which is demo.java, the moment I say enter, it will create two class files because we have two classes. If I go to Explorer, you can see we got demo.class and we also have calc.class. Now, when you run this code, if you say Java and if you say demo, it will just run the class files. And as you can see, we don't have any code here for calculator, so it will only run the demo class. And that's how it works. So if I just try to write this code here, which we already have, and if I try to create object of it, let's try creating object of it. In fact, let me do one more thing before we start. For this example, let me cut this part and create a new file. And let me say this is calc.java. And yes, we have this code here. So you can see now we have two files. And before I continue, I will just delete this class files again. Okay, class file deleted. And now let me just compile this code once again. So if you can see, when I'm compiling it, it is only compiling the demo file. It is not compiling the class.java, right? But when I create an object of it, if I create object of calc obj equal to new calc, of course, if you want to use it, we have to create object first. And now if I recompile this, and let's look at the class files, we got the class file for class as well. So if you are not using calc, it will not compile it. It will just say, hey, my responsibility is to compile the Java file. I'm doing it. But if you want to work with the class, the calc.class as well, or calc.java as well, you have to create object, and that's how it compiles. Now, once the compilation done, you can simply save the value in R1, or you can say obj.add. It will add two numbers, let's say 4 and 5. And then we can also find R2, which will be result of subtraction. So I can say sub, I will say 7 and 3. Okay, so you can see we got these two methods. And when you try to print the values, I will print R1 and I will give a space. And I also print R2. So basically I'm just printing two values back to back. And if I say compile again, because we have made some changes, and run, you can see we got 9 and 4. So 4 plus 5 is 9, 7 minus 3 is 4. And that's what we are getting here. Everything is working fine, right? Now there are two conditions here why we are going for inheritance. The first one is, what if you want to add some extra features? So let's say if someone is asking you for, hey, Naveen, I want a calculator and I want two features, addition and subtraction. What will be the cost? I would say, okay, I will charge you $10. Now let's say if the same person comes back and say, hey, I want a calculator which has 4 features, addition, subtraction, division, multiplication. And maybe at this point, I want to charge $15. Now, of course, I can add those two methods here, or I can create a new class. You know why? It's because if I edit the same file, if I add more features here, I can't sell calculator for $10 now. I have to make a new product for $15. I don't have calculator. I have advanced calculator, which does 4 operations. I want both the models. I want to sell the $10 calculator and a $15 calculator. That's one reason. Okay, so let me just do that. So let me create a new calculator, and I will say this is advanced calculator, which has all the features, .java. And in this, I will basically have 2 more methods, which is public int multi, which will take 2 values, and it should return n1 into n2. And likewise, we'll have 1 more method here for division. So this is div, and division, we have to say slash. That's it. So we got advanced calculator, which has 2 features. But now, if I create an object of advanced calculator now, instead of normal calculator, I can access multiplication and division. I can't access add and sub. And that's why you can see we got an error here. It says the method add is undefined for type advanced calculator. That means in this, we don't have add and subtract. So what do you think? What could be solution here? Think about this. So one solution which I can see is just write those 2 methods here. Of course, we can do that. Okay, we can just copy and we can paste it here. But don't you think we are writing the same code again and again? Now, when you repeat the same code, it is called redundancy, right? We have same code multiple times. And redundancy is a crime. So make sure that you don't repeat the values. You don't repeat the methods, definition, and classes. The point is, if I don't define it here, how will I access them? That's where the inheritance concept comes into picture. So inheritance says, hey, don't worry. If you already have a class called calc, you can simply say extends calc. Your job is done. Okay. So you simply say advanced calculator extends calculator. And now all the features of calculator comes in here. And there's one more beauty. Even if you don't have this Java file, that's fine. For inheritance, you need a class file, not a Java file. So even if you delete this, it will still work. Okay, so that's the first reason. Even if you don't have a code ready with you, even if you don't have a Java file, you can still use a class file. Okay, so that's the beauty of inheritance. We are simply saying extends calculator, which is this class. Now, what do you think? Will it work? Let's try. So you can see there's no problem. Add and subtraction working. We can add some more variables here. I can just copy this code and paste. Not on the same line. This is my R3, this is my R4, and I can just say this is multiplication. Okay, so multiplying number like, let's say is 5 and 3, okay? And then dividing the number, let's say 15 by 4. Let's do this. And now when I perform this operation, of course, I want to print R3 and R4 as well on the same line. I'm lazy to write multiple lines of code here, and R4. So we are printing everything in the same line. Let's try what happens. Compile, no problem. Run, it works. You can see that addition is 9, subtraction is 4, multiplication is 15, if I'm not wrong, yeah. And division is 3. So 15 divided by 4 will give you a quotient of 3. Okay, cool. This is working, right? So this is how we use inheritance. So important thing here is, this advanced calculator here is called a subclass. This calculator here is called a superclass. And to inherit, we use a keyword called extends. Okay. And this is basically a relationship of is a. Advanced calculator is a calculator. And that's why we say is an important word there. Cool. Can I have multiple classes inheriting each other? We can. That we'll see in the upcoming videos. At this point, we just went for a simple inheritance where we just use the feature of a superclass. You can say parent has all these 2 features. Child is just extending it or using it. I can say this is nepotism. So basically we were able to do advanced calculator, which uses a feature of calculator, right? So this is extends. Now what if in future, let's say we got one more requirement. We want to build a, let's say, scientific calculator, and I don't know the operation, so I will just say advanced calculator. I'm very bad with names, so I will just use this. And this advanced calculator will have extra feature. Let's say it also has a feature of finding the power of a number. Okay, so let's say public int. I can simply say power. Now what do we mean power? Let's say 3:2. I want to do that. So it will take 2 numbers. The first value n1 and I also want a power, let's say n2, and let's say this will return. Okay, how do we do the power? So basically we have a math class. I can just simply use it. Math dot, we have a function of power. It just take double value, but that's fine. I will just pass integer. Double also takes integer value, n1, n2. And the problem is it also returns the double value. If you can see, power returns a double value. So what I will do is, let me return double value, okay? So you have a choice. You can return double value, or you can just typecast it with int, and you can do that. Otherwise, double is okay. So you can see we have a power function which takes this method and it calculates. Now the thing is, if I want to create object of power, where I will do that, I will just create that in demo. I will say, hey, if someone wants to try very advanced calculator, they can do that. Okay, it's just that very advanced calculator, if you can see, we don't have any other methods. Okay, now that's an issue, right? Now I know in your mind you have a solution, right? You have a choice. You can just add, you can just type all these methods here, or we can come back here and say extends. Okay, now it will extend what? If we can also say calculator, but then this will only have addition, subtraction, division, multiplication, but not the feature of advanced calculator, which is, oh, it will not have this two as well, because this two is there in advanced calculator. It will only have add and sub. You can see multi and division not found. In fact, I should also have R3. In fact, this should be of type double. Double R5 equal to obj dot power by passing two values. One is, let's say, 4 raised to 2. At least we know the output. It should be 16. And I also want to print R5. Oh, we are printing everything in one line. Great. And you can see multi and division not working. So if you want to make it work, you can't just extend calculator. You have to extend advanced calculator. So you can see we have multiple hierarchy here. So very advanced calculator is extending advanced calculator. Advanced calculator is extending calculator. So if you try to compile this code, let's see if this works, compile and run. You can see it's working. You got 16 at the end. You got 0.0 because we are returning a double value. This works. So if you try to imagine this, what we are doing is, so we have a calculator, and then advanced calculator is extending calculator, and then we got very advanced calculator which is extending from advanced calculator. Now this is when you are saying multiple, where we are doing inheritance, right? So this is called multi-level inheritance. So basically we have multi-level inheritance here because we have multiple level. But in the earlier example, we were having just two, right? So we were having this two. Now, when you say only two classes, this is called single level inheritance. And I know I became a doctor there, but you got the point, right? So if you have multiple layers, that is multi-level inheritance. And when you say single, that is single, when you have only two classes. Now, the very advanced calculator here is taking the feature from advanced calculator. Advanced calculator is taking the feature from calculator. So by default, all the calc stuff will come to very advanced, and that is multi-level. So in the last video, we have talked about what is single level inheritance, and then we have talked about multi-level, right? Now, what is multi-level? So when you have the class which is getting inherited by someone else, and then something else is getting inherited by something else, that is multi-level. Now, can we have a different structure here? Let's take one more example. So if you say we have A, we have B, and we have C. Now this is multi-level, right? And of course, when you have A and B, that's it. This is single level. But what if you have A and B, and then you have C, where your A is your parent? In fact, in this situation as well, if you try to expand this one, here as well we have this A as a parent, and then this B becomes a child. Now B becomes child for A, but then B is also a parent for C, right? So C becomes child here. Now in the same way, if we talk about this A, B, C here, we are saying both are parents. So we have A as parent and B as parent, and then C becomes a child. So C is inheriting from A and B both. Now, is it possible in Java? Let's try. In fact, it is possible in other languages like C++. Let's try in Java. What I will do is, I will just go back to the same class, okay, same file demo. And here, let me get a class called A. And of course, A will have some methods. This should be capital A, and then class B and class C. Okay, we have this three classes here, okay? And let's say C is, okay, let's try this first. If B extends from A and C extends from B. Okay, this works. We can say there's no problem here. But what if I want the C to extend from A and B both? As you can see, this syntax is not working. It gives you an error as well. You can't put a comma when you say extends A comma B. Okay, does it mean we can use extends B? No, even this will not work. So it doesn't matter what combination you do, multiple inheritance in Java will not work. Yeah, so this thing will not work. Multiple inheritance will not work. But the question is, why? So let's try to understand that here. Now let's say if you go back to this particular example here, let's say you create object of B, okay? In this scenario, if you create object of B, let's say obj. Now obj can call all the methods of B and A both. So let's say in B, we have a method called show. Okay, let's say there is a show method. And then from obj, you're trying to call show. Will this work? Yes, this will work. Let's say in A, we have a method called ABC. Now, if you try to call obj.abc, yes, this will work. But what happens, when you say obj.abc, it will try to search for it first in the B class. In B class, we don't have it. So it will say, okay, I don't have that method. Maybe my parent class will have. So it will go to A by checking, hey, do you have ABC? Parent will say, yes, I have. Now, in this case, it will work. The same thing is applicable for C as well. Let's say if you create object of C, which is obj again, and then if you try to call a method, let's say A has a method called X, B has a method called Y, and C has a method called Z. So let's say we have Z method. And then when you try to call Z, this will work because in C itself we have the method. If you say obj.y, will this work? Yes, because it is coming from B. Now when you say obj.x, it will also work because it will call from A. So first it will search in C. In C we don't have X. It will go to B. In B also we don't have X. It will go to A. Yes, in A we have X. Okay, it works. But now if you come back to this example, let's say if you get object of C as obj. So let's say this is C object. Okay. And then if you, let's say in this A, we have a method called show. Okay. And that's how we're working. So let's say if you call show now, of course, C will say, okay, I don't have a method show. Will this work? Let me ask my parent. So it will go to A. A will say, okay, I have show, problem solved. This will work, right? In general, I'm not talking about Java. Let's say in general, this is how it works. Now let's say we have in B, we have a method called X, okay? Now it will say obj.x. Will this work? Now it will search in C. In C, we don't have it. In A also, we don't have it. In B, we have it. So this will also work, okay? But what if there's a method called Y, which is there in A and B both, okay? And now if you're trying to say obj.y, the problem is from C, we don't have it. And A and B both has this method. Which one you will choose? That's a confusion, right? It is almost same like, let's say if you want to call someone, your phone is dead, and then now you want to call, so you can ask your parents, and both the parents has a phone. Which phone you will choose? Now, if you chose your dad's phone, your mom will feel bad. If you choose your mom's phone, your dad will feel bad. Again, I'm just giving an example here. I'm not saying it literally happens, but in fact, they will be happy that you're not using their phone. But yeah, that's a confusion we have here, right? Now, this problem is called ambiguity problem. Okay, so ambiguity simply means we have a confusion here, which one to choose. Now, this problem is there in multiple languages, which supports multiple inheritance. Java says, oh, that's a problem. Let's remove the feature itself. Okay, I know that's a weird way of solving the problem, but yeah, they have removed the problem itself. So it's not like they found a solution. They said, instead of finding a solution, let's remove the feature. That's right. In Java, multiple inheritance does not work. Okay, so it's a very famous interview question. Do we support multiple inheritance in Java? And the answer is no. There is an indirect way, not actually a way, it's just that it is possible by going all through steps. But yeah, that's how Java is implemented. In new versions, they have done something which changes it with the help of interfaces, but we don't know interfaces yet. So let's say Java does not support multiple inheritance. Oh, okay, this makes sense. So once we talked about inheritance and method overloading as well, right? We have talked about method overloading. In this video, let's talk about method overriding. That's right. So we have two different method overloading and method overriding. So let's talk about overriding here. So for that, what I will do is I will just try to keep it simple again, and let's use the class A. And inside this class A, let's say we have a method. So I will just remove this part. And here I will say public void show. Just to keep it simple, I'm using a very simple example here, which is show, which prints something. Let's say it prints in show. Okay. Now, if you have a method inside a class, of course, you can create the object and you can call the method, right? And we have seen that. So let's say if I go back to my main method, if I say a obj equal to new a, and I can simply say obj dot show, and it will work, right? And it should work. That's what we have done from a long time. So let's compile this code and run, and you can see it prints in show. Just to keep it simple, we have went with a very simple example. Now what I want to do is I want to get a class which is class B, and I want this class B to extend class A. And of course, when you talk about inheritance, this method of show, it also will be available inside class B, right? So if I create object of class B here instead of A, it will also work because that's how inheritance works, right? So if I go back, compile and run, it works. You can see we got in show. What I will do now is I will also print in a show just to differentiate that this is getting printed in the A class, okay? Now the thing is, what if you want to have a different definition of it? Okay, why do we need different definition? Let's say we got two methods here, public void config. So let's say we have this method which is called config. I don't know what it will do. Just to keep it simple, I will just say s out and I will say this is in a config, okay? And let's say they have different implementation, they have different statements. At this point, we are not focusing on statements. We are here to understand the concept, right? So let's say it does something, show method, and config does something. And I can actually call both the methods, not just one. I can call config as well, okay? And if I compile and run this code, it works. You can see it says in a show in a config. Now let's say I want a different definition for show, okay, not for config. So basically what I want is when it comes to B and when I call show, it should print in B show. How do I do that? How do I change the execution? So what I want is when I call show, it should not call the show of A because show of A will print in A show. I want to use config as it is. So I can't even remove this inheritance. If I remove this and if I define the methods, of course I can define show, but then I want this config to be coming from A. So of course you have to keep it. You have to say class B extends A because we want config. What we don't want of A is show because it is printing in A show. I want to do something else. In that scenario, you can say public void show. You can write the same method name or maybe a different name. You can say in show one, and you can print here in B show. I mean, of course you can do this. The only thing is if you execute this code now, it will still print in A show. You know why? It's because we are calling show and both these methods are different. One with name show and one with name show one. Okay, that means if I call show one, then it will work. Then it will print in B show. But what I want is, I want them to have a same name. I want this method, which is show, should override the method here. Is it possible? And the answer is yes. In Java, we get this amazing feature where you can basically override the methods of the parent class. So of course you want everything except this part. Okay, I mean, except this show method. I want config, but I don't want show. Now let me give you one more example here. Remember when we talked about inheritance, I have used an example where I was not having any phone in my 10th standard and my father had a phone which is 3310. Now, if you ask me at that point which phone I have, I used to say 3310 because that's my father's phone. But after 2 years, when I was in my 12th standard, I got my own phone. I got Motorola C168. Again, not a smartphone, but it was good. It was a very slim phone. So if you ask me which phone I have, I will say I have Motorola C168. My father still had 3310. So here, if you can see, if someone asks my father will say I have 3310. If you ask me, I have a choice of saying 3310, but I will go for C168, which is my phone. Right? So you always give preference to your own features first. Example, if you call show here, it will execute the method of B instead of executing the method of A. So basically this method show overrides the method of A here. And we can simply execute, compile, and run. You can see it prints in B show. Now this will make much more sense when we say we are creating not a, but we are creating a calculator, which has a method called, let's say, let me remove config for some time. Let's say we have a method called add, and this will return a value, okay? And here, instead of printing this, I can simply accept two values. I can say int n1, comma int n2. And here we have done this before, and that's why I'm writing this code very fast. I can say return n1 plus n2, okay? So if your class, which is, instead of saying B, I can say advanced calc, which is extending calc. It will also have some features, but let's say I want to add two numbers, which will also take int, and it will have the same parameter, okay? Because in method overloading, we have seen it can have the same method name, but different parameters. Here in method overriding, it will be same name, same parameters as well. I mean, same type of parameters, not the name, doesn't matter name. Let's say n1, n2, and it will have the same name, same number of parameters, same type of parameters, but it will have a different behavior. Let's say n1 plus n2 plus 1. I'm just adding extra 1 there. So what I want is, if I comment this section, okay, at this point I'm not overriding it. I just have add method inside calc. And if I create the object of advanced calculator by saying advanced calculator obj equal to new advanced calculator, and if I try to call the add method by passing 3 and 4, of course 3 and 4 is 7. So if I get this value somewhere, if I say int r1 is equal to, and if I print the value for r1, and again, since we have done this code before, I'm just typing it fast. Now what do you think? What will be the output? I'm passing 3 and 4. So of course, it will first search for this method add inside the same class. Of course, we don't have that method. So it will go to the upper class by saying, hey, calc, you are my parent class. I'm searching for add with you, and yes, it is available. So basically we can just compile this code and run. You can see we got 7, and that actually works. But now I want a different definition for add. I just want some changes. Instead of adding those two numbers, it should also add 1 at the end, okay? So if I compile this code now and run, it will print 8. So this add is overriding the add method of calculator. Okay, just remove this statement, that's extra. So this concept is called method overriding. So this method is overriding the method here. I hope that makes sense. Right? In this video, let's talk about packages. The thing is, whenever you have a file, doesn't matter is it music files or documents or code, we normally put them in a folder, right? And then we create a folder structure as well. In fact, I remember in my college days when we used to store different songs, we used to create different folders. Like, we have a songs folder, then inside that we have rock songs, DJ songs, sad songs, romantic songs. And in fact, in that as well, when you go to sad songs, we can have normal sad songs, ultimate sad songs. Okay, now that's exaggeration, but we do that, right? We create a structure there. In the same way, when you talk about Java project, you will not be creating 1 or 2 files, right? It will be having multiple files. Sometimes your project can have, let's say, 200 files, 300 files. Okay, maybe most of the time when you have a complex project. Now, how will you put all these files in one folder? You can put everything in one folder. Now, if you see our project structure here, what we did is we have this folder called codes, and in this codes, we have all the files. In fact, we only have 3 files now, but just imagine we have more files. Imagine we have 100 files. It's okay to put them in one folder, but it's always better if you can create a structure where you can have few files in one folder and few files in another folder, and then you can have a folder inside a folder. Now, normally this type of pattern in Java is called packages. Normally you store files in a package. So yeah, that's right. The folder is package here. And of course, one package can be a part of another package, the way you have folders inside a folder. So how do we do that here in Java? So just to make you understand, let's say we have these 2 files, advanced calculator and calculator. Now these 2 files are related, right? They both work for the calculator. So it is a good idea to put them in one folder. Now how will you do that? You have an option here of creating a new folder. That's one way. Or what you can do is you can just come back on top of your class and say, you can create a package. So the keyword which you use to create a package is called package. And you can put this class in that particular package. Let's say the package name is tools. Right. So of course you can create any package name, but it should make some sense. So you can see I'm saying that they are tools. Okay, and the thing is, you can see we are getting an error. It says that declare package tools does not match the expected package. The thing is, you don't have calc inside the package. In fact, most of the IDEs will give you an option of directly, if I click on quick fix, yeah. So you can see most of the IDEs, doesn't matter which IDE you're using. In VS Code, we have this option. In most of the famous IDE, you will get this option of doing something, some red symbol or something like that. Here we have an option of quick fix. If I click on that, it says move calc.java to package tools. Okay, that is a good idea. We can click on this and you can see it created a folder called tools. And now we can actually move this to tools as well. The only thing is when you do that and when you go to this particular class, okay, it has already done the changes. You can see I have not written this. It is already there thanks to VS Code and the IDE. So basically you get this here. So it's always a good idea to put your classes in a package. You can create a complex structure. If you want, you can create one more folder here. Let's say we got a folder called database or maybe DB connections or DB classes. Or maybe you can simply say DB. Now this DB will have all the database connections. So let's say if you want to create some files which will connect with MySQL, Oracle, or it does something with database. So you can put all those classes in database folder. Okay. Now that's how you create a project structure here. Okay, the only thing is if you have this structure here, let's say if you have calc and demo, advanced calc, and if you can see both are in a package now. The only problem we will face is if you go to demo and you can see demo is not a part of any package. Normally you put the main class, so the class which has a main method separately outside the package so that you can easily access other classes. Okay, when I say easily access other classes, can I do that? Can I create object of calc here? So if I say calc obj equal to new calc, which was working earlier, if you remember our previous examples, it's not working now. You can see it says calc cannot be resolved. What's wrong? The problem is demo and calc, now they are in two different folders. You can't directly access it. Okay, so when I say you cannot directly access it, do we have an indirect way? Yes, we have an indirect way. So what you can do is if you see this bubble, it says import calc. That's right. If you want to use calc in your particular class, you have to say import calc. But then calc belongs where? Calc belongs to tools.calc. So basically you have to mention the package name and then you have to mention the class name, whichever you want to import. And now you can see there's no issue. How about advanced calculator? If I want to use advanced calculator obj1 is equal to new advanced calculator, okay, now you cannot access this one. You know why? It's because we have only imported calc, not advanced calculator. How will you import this? You're right. Just come back here and say import tools.advanced calculator. So whichever class you want to use, you can just import them. In fact, Java internally has a lot of classes. Example, let's say one of the classes which we are going to see in future, which is let's say list. Now when we use list, which is an inbuilt class or inbuilt interface, what is interface, we'll talk about that later. Or maybe at this point we can talk about, let's say, ArrayList, which is a class. When we use ArrayList and when you create object of it, I will say list is equal to new ArrayList. Now the moment you do that, it will also come from a package. You can see it is now given by the IDE, it is auto completing it. But if I remove this line, you can see it will give you error. It says ArrayList cannot be found. So we have to import this one as well. And this belongs to a package. Now that package is import java.util.ArrayList. This is you have to import. Now you might be thinking why we have two dots here, java.util, how it looks like. So basically we have a Java folder. Inside Java folder, we have a util folder. So it's the folder inside the folder. And Java has multiple folders. If you can see Java dot. We have applet folder, we have AWT folder, beans folder, lang folder, IO folder, and all these things. So in general, whatever class you use in Java belongs to a package. Let me repeat. Whichever class, inbuilt class which you use in Java belongs to a package. Now you'll be saying, okay, everything makes sense, but don't you think string is also a class? And one of our favorite class, which is system. System is also a class, right? So when we are using system, we have never imported it. So when I say system.out.println, there was no need to import the package. But does system belongs to a package? And the answer is yes. If I go to system and if I go on top here, can you see that? It says package. So this class, system class, belongs to our package java.lang, but we never imported it. The thing is, by default, every Java file will have java.lang by default imported. So even if you don't mention that, it's there. This line is there even if you don't mention. Now the thing is, it's actually this, not this line. What is by default is this, java.lang.star. Now what is this star? Now in one particular folder, if you have multiple files, and if you want all the files, you can simply say star. Just like we have tools here. In tools, we only have 2 files and we are importing both. So can we just do that? Yes, we can. So we can simply put a star here, our job is done. And by doing that, I've also removed the list. We don't even need that, ignore that. So basically, if you want to import all the files, you can say star, okay? So that's how you can create a package in Java. As I mentioned, you can create a folder inside a folder. Example, let's say if I have a folder called other. So let's say we have other folder and this tools actually belongs to others. So now if I move this, you can see we have tools inside other. Now how it will look like when you talk about your calc. So you can see it says other.calc. So you have to, if you want to go inside the package, normally in folder structure we use slash, here we use dot. So it is others.tools.calc. Okay, that's how you have to import it. And of course you can say star, it will import everything. Now my question to you is, if I say import other.star, now is this 2 line same? Or can I remove this? Of course, right, when you say star, it should import everything. But no, if you can see, it is giving you error. The reason is, when you say others.star, so star simply means all the files, not all the folders. Okay, so in other, if you have some files, let's say if I create a new file here, I will name this as a.java. The moment you do that, you can see this a class belongs to other package. Now you can easily use a, but not calc. So if you say a obj2 is equal to new a, this will work. It's because you are saying others.star. It will import all the classes, which are all the files in the other folder, not inside a folder, which is tools. So if you want others, tools as well, so you have to mention others.tools.star. So that's how basically you use a package structure. Now there's one thing, not important at this point, but since we're talking about package, let's talk about it, because you will be seeing those type of structure multiple times. When you create a project, a big project, normally you deploy your project on the server somewhere, right? And maybe you're creating a library. That's right. What you do is, when you create a project, it's not always for your use. Sometimes you create libraries so that others can use your files. Now, in this case as well, you will create a package and then you will give your package to others. The only thing is, when you are sharing your package to the entire world, it should be unique. It should have a unique name. Let me show you something. I will go to a website. Now, this is one of the websites where you can get the libraries. Now, libraries simply means if you want to do something and if you don't want to write the code entirely by yourself, you can use some libraries. And most of the time we do that. Example, let's say if I want to connect my application with MongoDB, which is a database. So I can simply search for MongoDB driver sync. This is a driver which we use to connect Java with MongoDB. So you can use this package in your project. Okay, let me select a version. So this is the package. Okay. Now the thing is, when you talk about this package, what should be the name of it? So this name should be unique on the internet. Now, how will you make something unique? That's a tricky point, right? So when you are creating a project, how will you make it unique? So one way to do that is by reversing your domain name. That's right. Of course, right, when you're building a library, you will also have your website, your company website maybe. So let's say if we talk about a company like Google. So if I'm working for Google and if I'm creating a library, so what I will do is I will say this belongs to a package. So if I'm making a project for, let's say, Google, and I'm making a calculator or advanced calculator, so I will say com.google.calculation. Now this is my package name. Okay, so by making com.google, I'm making sure it is unique, right? Only Google can own this domain, right? It's their domain. So that's how you do that. So depending upon your project, you will see this type of packages. In fact, in future videos, we will be using some packages which have com dot something. It means they have just reversed the domain name just to make it unique. But again, for learning purpose, you can name your package anything you want. Example, the way we are doing here, package other, but it should have a meaning. That's important. Now, once we talked about packages, it's a good time to talk about access modifiers. Now, one of the access modifier we have seen, in fact, we have seen two, private and public. Apart from this, we have more, we have protected and default as well. So in this video, let's try to explore them, or one or two videos. So what I will do is, initially I will start with public. Now, what is public basically? Let's go to demo. And we were trying to import the packages, and of course we should do that, right? Anyway, we don't have to do that. Java.lang, it comes already, so we don't have to worry about it. And now what I will do is, I will just go back to my class A. Let's work with class A now. And in this class A, you can see the class A is public, okay? And it belongs to a different package called other. And in this class, I will just create a variable called int, let's say marks. So we have this variable called marks, and the let's say initial value for marks is 6 because we just want to access this, is it working or not. Now, how will you access this variable? So you can just go back to demo. So we have A, right, which has this code, which is simple class, and then we have a marks. Let me go back to demo, and in this, I want to access it. So I will just remove all these lines. Just want to work. In fact, tools is also not I need now. Let only work with other. And in this, let me create an object of A. Now, can I create object of A? Yes, we can, because we can access it. And then I'm just trying to say obj.marks. Now, when I try to do that, you can see it gives you an error. It says the field A.marks is not visible. I mean, that's weird. It's there, right? Marks is there. The thing is, it is not public. Now, when it is not public, you cannot access it outside the package. You can see that that's the issue we got. Now, what if you have a class in the same file, or maybe in the same package? Let's say in the same package, which is of demo, I will create a file called b.java. And in b.java, let me just say, because they're in the same package now, so no package is same package basically, I will try to create a variable called int, let's say marks. Now let's see if I can access this marks in demo. I will just go back here, and I will repeat the same sentence, same line in fact, same statement with the help of B object now. This is B. The only thing is we have to use a different object name because we cannot have same. And using this obj, can I access marks? So you can say there is no issue. Even if marks is not public, it's no issue because they are in the same package. The moment you have a different package and if you don't mention public, it will not work. Okay, that's the issue. You can see it is not working. Now, if you want something to be accessed outside the package, always make it public. And that's why methods, most of the time they are public. Variables should not be public, but methods should be public. Example, if I say public void show here, now show is accessible. I can use show from anywhere. Example, if I can come back here, obj.show, this will work because that's public. But if I don't write public there, it will not work. Now that's one. So public means it can be accessed from anywhere. Okay. Now, apart from public, we also have private. So if I talk about private, can I use private anywhere? Private variable can be used in the same class, irrespective of the package. Okay, package is a secondary part. It can be used in the same class. I can't even use outside the class. Example, let's say if you look at this B and if you look at this demo, they're in the same package, right? But now if I create a private variable here, if I make this as a private variable, which you should always mark your variables as private. The moment you make it private, even if they're in the same package, you can't access it. So private variables can be used in the same class, irrespective of the package. It's on the same class. Now let me reiterate. When you talk about public, it can be used from anywhere. Okay, you can see this table. Public can be used from anywhere. Private can be used from the same class. Okay. Now, apart from public and private, we have two more. Okay, let's talk about those now. Now, if we talk about this A, if you don't mention private, something should be applicable, right? If it is not private, it is not public, what is it? So by default, there is something called a default access modifier, okay, which is also called private protected, but we'll talk about that later. But it is called default. Now, default simply means it can be accessed in the same package. It's as simple as that. It can be accessed in the same package. Example, if you talk about this B, when private was not there, it was able to be accessed in the same package. So we got private, which can be accessed in the same class. We got public, which can be accessed from anywhere. And then we got private, which can only be accessed in the same class and default in the same package. Okay. Apart from this, we have one more. which is called protected. Now what is protected? Now let's say we have this class A, which has, let's say if I make this variable as protected, okay? And then I'm going back to demo, and inside this demo somewhere I'm creating a class in the same package. Basically, it doesn't have to be in the same class or same file, in a different package basically. Let me create class called C, and then I'm saying that this class extends A. Now in this class A, so you can see this is protected. Can I use protected in some other package? You can see marks is protected. In the other package like demo, again marks is not working. So basically, if you make it protected, you can't use it outside the package. Before coming there, in fact, you know what we should do? Let's try to create a class here itself. Let's say a class called launch. And in this class, let me have a method which is public void ABC, let's say. And let me try to create object of A equal to new A. And see from here, can I try, if I try to use marks, let me just print marks, obj.marks. Okay, it is working. So it works in the same package, but it doesn't work in other packages. Okay, so you can see demo is another package. But what about a subclass? We have class C here, and then if I try to create a method public void ABC, and you can see this class C looks same in both the packages. The difference is this is a different package and it is extending A now. And now if I try to access marks, it works, there's no issue. You cannot access marks outside the package, but you can access marks outside the package, but it should be a subclass. If you can see, C is a subclass of A. Now if you see this image here, this is how image looks like, right? Let's talk about private. Private can be used in the same class, nowhere else. Protected can be used in the same class, in the same package, in the other package but subclass. Public can be used everywhere. Default can be used in the same package. Okay, it's that simple. So this is how you specify the modifiers. Now, how do we use and which one to use? Basically, the idea is very simple. Try to make your classes public, which we are doing. And of course, we don't have a public here. The thing is, you can't even make this class public because you cannot have two public classes in the same file. And the general idea is in one file, you should have only one class. So try to make your class public. Next, try to keep your variables, the instance variables private. The methods most of the time will be public. But if you think there is a method or a variable which should be accessed only in the subclass of other packages, use protected. Try to avoid default. Default is not something we should be using. I know from if you check all this thing, we are promoting default a lot, but don't do that. Don't use default stuff. Example, this is default. Either make it private, public, protected or public. Don't keep it default. Default simply means you don't know what to give the access. So keep it private, protected or public. In this video, let's talk about polymorphism. Remember, we have talked about method overriding and then we said there is something more. This is where we are talking about. So we have a concept of polymorphism. Now, this is a very important concept in terms of OOP, and most of the languages which implements OOPs has this concept. Now, what is polymorphism? Now, basically, as a concept, it has two words. One is poly, second is morphism. Now, poly simply means many, and morphism means behavior. Now, what it means is there is something which behaves differently in different situations based on situation. Let's say as a human, you behave differently at different occasions, right? Example, at home, I behave differently. At my office, I behave differently. When I'm with my friends, I behave differently, right? So that situation changes me in the same way, because the name also changes, right? At home, I'm a son, husband, a father. At office, I'm a colleague, I'm a boss, I'm an employee. With my friends, okay, they use different words, but then let's not mention that. So the important thing is your behavior, your name changes at every place, right? Your behavior changes based on that. In the same way, in the world of object-oriented, we have a concept of many behavior, polymorphism. So the same object or the same reference will have different behavior based on how you create the instance of it. Now, to implement this, there are multiple ways in different languages. But before we go into the implementation, let's talk about its type. So there are two types of polymorphism. One is called a compile time polymorphism, and second is called a runtime polymorphism. Of course, they have different names. Some compile time is also called early binding. Runtime polymorphism also called late binding, but we have these two words, compile time and runtime. Now, what do you mean by compile time? See, if you can define your behavior, so the behavior is defined at compile time, that is compile time polymorphism. If the behavior will be defined at runtime, that is called a runtime polymorphism. So when you compile the file and when you know what thing will be get executed at the compile time itself, it is compile time. Now, which method will be executed will be decided at runtime, that's runtime. Now, we have done two examples here, which is overloading and overriding. So if we talk about overloading, it's a part of compile time, because at the compile time itself, example, let's say if you have two methods, you have, let's say, two methods, which is add, which takes two parameters, int and int. And then we have one more method here, which is add. And when you say int, which takes three parameters. Now, both this have the same name, but different parameters, that is method overloading. Now, which method to execute? Will you execute the first or second method will be decided at compile time. Now, let's say you have two classes, class A and class B, two different classes. And class B extends class A. We have talked about this in method overriding. And let's say you have a method which is add, which takes two parameters. And also here we also have the add method which takes two parameters. Now, out of these two, which one will get executed? It will be decided at runtime. So that is called a runtime polymorphism. In fact, there is one more concept which we are going to discuss in the implementation when we talk about dynamic method dispatch. At that point, this thing will get more clear. But just to generalize, what is polymorphism? Polymorphism means many behavior. So your behavior of your reference or your execution will change based on some situation. If it is compile time, which is your method overloading, where you decide based on the parameters at compile time itself. In runtime, you're not sure which method will be called because both the methods have the same name, same parameters. Now in this video, let's talk about dynamic method dispatch. Now once we have went through what is polymorphism, we have also mentioned that it is same thing, multiple behavior, and we have two types of polymorphism, which is compile time polymorphism, runtime polymorphism. Now to implement runtime polymorphism, let's try one more example here. And we do that with the help of dynamic method dispatch. Again, to keep it simple, we'll use a simple class like class A. And then we got class B, and let's say class B extends class A, okay? And let's say we have class C. And again, we have discussed most of the topics, so let's make it quick. So we got class C. So if you can see, we have class A, which is getting extended by B and C both. So you can say class A is parent, and we have two child there, one is B and one is C. Now what I will do is, in this A, I will create public void show, okay, and this show will print, let's say, in a show, okay, and we'll be using class C a bit later. As of now, let's only focus on class A and class B. Now my question to everyone is, okay, let's remove this class C just to remove the confusion. Let's go step by step. So let's say we have these two classes, class B extends class A. Now my question to you is, how do I create an object of class B? And of course, we have talked about this from a long time. I can say B obj equal to new B, and that's how you get the object, right? And of course, using this obj, I can call show, there is no harm, compile this code and run. You can see we got in a show. Now this is how you create the object, right? Now there is one more thing. Can I create a reference of A, an object of B? Is it possible? Since B extends A, so you can say B is a child of A. So can I refer this obj as A and the object is B? Now when you look at this obj, what is this obj? It's a variable, right? And what is a type of a variable? The type is A here, right? So the obj type is A, but the implementation is B. Okay, that's the point to remember. And this perfectly works. Now if you want to imagine this, let's go with this one more example here, which I will write here. Let's say if I create a class called computer, and of course class computer has some methods, okay? And then class laptop, and we all know that laptop is a computer. So I can also say laptop extends computer. Yeah, we can say that, right? And now, if I say laptop is a computer, if I want to create object of a laptop, of course, how will you do it? It's very simple. You will say laptop, let's say lap is equal to new laptop. So let's say instead of saying lap, we say obj1, and then I can just call all the methods. But my question is, can I refer this obj1 as laptop? Yes, it is a type of laptop. And I can also say this is a computer. And that's what you do, right? When you look at the laptop, you can say, hey, that is a laptop, but that's also a computer. We are referring that as a computer. So we are referring this obj, which is an object, as a computer. But technically it's a laptop, right? In the same way, we can refer this obj of type A. So we can mention the type as parent, but the object can be of child, okay? So I've just created this laptop computer just to show you. Let me remove that. So yet it is possible to create a reference of a superclass and the object of a subclass, okay? And this will surely work. Let's compile, there's no issue. Let's run, and you can see it says in A show. But the twist is, if I have the same method, and we have talked about this in method overriding, if I have the same method, and if I say this is in B show, now what it will call? Will it call in A show or in B show? As per the method overriding, it should call in B show, but look at the reference. Reference is of type A. That's tricky, right? Let's try. In fact, what I will do now is just to, first let's run this code and I will show you something. You can see it says in B show. Let me initially set the object of A itself. And then let's go step by step. So I will say compile and run. It says in A show. In fact, I can call this obj show once more. But before calling obj show, what I will do is I will make one change here. I can just come back here and you can say obj is equal to new B. That's right. We can assign a new object to the old variable. Okay. Now, if you want to understand this with a memory, of course, we have a stack here. Right? In this stack, we have different variables and then we have a heap memory here. Now, initially, when you say obj, that's your object, right? And it will create object of A. So 101 is object of A. I'm talking about line number 24. Okay, line number 24, we have this line. So that's an object here and it will have some methods. The method name is show itself, right? And this will have a value which is 101. So I'm talking about line number 24, okay? On 24, this is a link. Now, when you say obj.show, line number 25, obj.show, at that point, it will look, okay, so obj.show, that means I have to call the show method of object A. So this, my friend, is an object of A. And now, on line number 28, we made some changes. That is, now this particular object is referring to the object of B. So we got one more object here, which is, let's say, 103. And this is an object of B now. Okay, this will also have a show method because that is what we mentioned there. And now, since we are changing the value here, this will be replaced by 103. There is no 101 anymore. That means this link is broken and we got a new link. Now on line number 29, when you say obj.show, it will call this show method of B. So it's not about what is a type of the object or reference. You can say type is still A, but the object is B. And that's what you call the B show. Let me compile and run. You can see at first for this line, it is printing in A show. For this line, it is printing in B show. Likewise, if I create another class here, class C, which extends A, and if I have the same method, I will just reuse my own code. And if I say this is in C show, what will happen? If I just go back here and say obj equal to new C, and if I say obj.show, what do you think what will happen if I run for the third time? And that's of course, right? Different object will have a different behavior. Remember runtime polymorphism? And you can see we got in C show. So the same object, which is obj.show, is behaving differently with different objects. Polymorphism, right? So if you say obj.show, we are not even sure. So when you compile this code, at that point, we are not sure obj.show will call which method of which class. I mean, method of which class. It will be decided at runtime, and that's what is called runtime polymorphism. And all this concept is called dynamic method dispatch because that's dynamic. Which method it will call, we are not sure. Okay, and that's how it works. So point to remember here is, irrespective of what type of object you have or what type of variable you create, it's of type A, but it all depends upon what object you have. And it is only possible when you have inheritance, okay? You can't simply say we are creating a new class D, and you will say, okay, not demo, class D, and you can't simply go back here and say obj equal to new D. This will not work because D is not extending A. If you can see, if you can verify, D is not extending A. So this will not work. This will only work when you have inheritance. So only you can have a child objects for the parent variable, which is a obj, parent type variable. Let's talk about final keyword. Okay, so the keyword we are talking about now is final. Now basically final keyword can be used with a variable, a final keyword can be used with a method, and a final keyword can be used with a class. And we'll go step by step. So let's start with the final with variable. Now when you make a variable, let's say if I create a variable called num, and if I say the value for num is 8. And of course, when you make a variable, of course you can change the value later, right? So initially the value was 8 and now you're making it 9. There's no problem, right? And of course you can print the value as well. So if I compile this code and execute, the recent value is 9. Now there's a concept of making constants, right? So what is constant? So if you make your variable constant, you can't change the value of it. Now the way you can do that is by using a final keyword. Now in different languages we use different keywords. I guess in C++ we use const. In Java we say final. So the moment you make your variable as final variable, the variable becomes constant. So once you assign the value, you can't change it. Okay, that's important. And that's why you can see we got an error here. In fact, you can also get this error by compiling the code. You can see it says cannot assign a value to a final variable. So that's final variable num. Okay, so because num is final, you can't change the value. And this is actually very important. So whenever you have a value which you think will not change, try to make it final. It's a good practice to make final variables, is because you will not get any unexpected output, because if you think the value should be constant, then why do you even change it? Example, if you want to make a variable for pi, we know the value of pi, right? Which will not change. So it's good to make that particular variable as final. So it's always a good idea to make a final variable, because that's what a good practice is. So we have talked about what is final variable. So final variable simply means making constants. Now let's talk about final method. In fact, even before final method, let's talk about final class, then final method will make much more sense. So at this point, I will just remove this part. So now we know what is final variable is, right? So what I will do here is I have a class here called, let's say, calculator. Okay, now I'm making this class, and in this, or maybe let's keep it simple, let's say A. So I got this class A, right? And now in this class, I have some methods. Let's say the method name is public void show, and you know what? Let's make it calculator just to make it much more sense. And I will also say public void add. This time I will not return the value. I will just print the output here itself. I will say A into B. And then I will just simply print A plus B. I'm just adding it here itself, right? And then we got the method which is show, and here we are saying public, here we are saying in calc show, okay? So let's say we have this class here, which is calc, and then we have these two methods. And if you want to make it work, of course, you have to get object of calc. You will say calc obj equal to new calc. And with this object, you can basically call both the methods. You can say show, you can say add, and you can pass two values, 4, let's say 5, right? Now with this, let me just compile this code and run. Compile, no problem, and run. You can see there's no issue. It is printing in calc show and 9. Now what if someone else is trying to create a class called advanced calculator, and maybe they're trying to extend, they're trying to inherit the features from your class, which is calc, okay? And by default, it's possible. Anyone can inherit your method or your classes, right? Because it's available. What I will do is, I want to stop this. I want to say, hey, no one should be able to extend my class. You want to stop the inheritance. How will you do that? So if I make this class as final, you can see it will give you an error. It says the type advanced calculator cannot be a subclass of the final class. That's right. So once you make your class final, you are basically stopping the inheritance. Okay, so basically when we talk about final variable, it means you cannot change the value of it. When you make a class final, it means no one can extend it. You're stopping the inheritance. Okay, that makes sense. Now what if your class is not final? So of course anyone can use it. And maybe you don't have an issue of people using your class for inheritance. The problem which we have is someone will create object, okay, of not your class but advanced calculator, and they will use your features. And you are okay with it because ultimately you're printing your own class name, which is in calc show. Or maybe I can say by Naveen. Okay, so maybe this calculator is by Naveen. So if I compile this code and run, it will print my name. At least I'm getting the credit. But what if someone says, hey, I will use your feature of addition because there's no credit mentioned, but I will have my own credit here. So I will create my own show method overriding, remember? And I can simply print by John. I'm not sure who John is, but let's say if the person says by John. Now what will happen is when you execute this show method and add, you can see add is my implementation, but they are just overriding show method and it says by John. I don't want this. I don't want anyone to override my method. How do I do that? How do I stop method overriding? In that case, you can make your method as final. Now, when you make your method final, which we talked about here, when you make your method final, no one can override it. You can see we got an error. Cannot override the final method. Okay, so that's how we can use final keyword. We can use final keyword with variable to make it constant. You can use final keyword with a class to stop inheritance, and you can use final keyword with method to stop method overriding. So I hope final makes sense now. In this video, let's talk about object class. Remember when we talked about inheritance, I also mentioned that every class in Java extends the object class. So in this video, let's try to understand what is that. So what I will do here is, first of all, I will create a simple class, let's say class A. So every class in Java extends the object class, right? So even if you don't mention it is there. But what is there inside this class? So what I will do is, first of all, I will say, let me create object of A here. I will say A. And okay, so we got the object. But then using this object, you can see we can call so many methods. We have not defined any method in this class, but still we have the access of equals method. Then we got notify, hash code, notify all, toString, wait, so many methods, right? Now what they do, so let's understand that. So what I will do is, in fact, instead of this, I will say laptop class, just for the example. And here also, let me get object of laptop here. So I will say laptop obj equal to new laptop. Okay. Now I will try to create some variables here. So I will say private int, let's say price. And let me also create a string variable here, which is private string brand. Okay, so we got these two laptops. I can say model as well. So we got model and price, right? So if you talk about MacBook or Dell XPS or Lenovo laptops, or it doesn't matter which laptop it is, we have a model and we have a price here. Now, if you talk about this particular laptop here, let me set the values to it. And time, what I will do, I will just remove this private so that I can access it from outside here. And I can say, okay, so I will say obj.model. I will set the model as, let's say, Lenovo, I don't know, is it a laptop yoga? Maybe. And then I will say obj.price is equal to, let's say, $1,000. Okay, so I got a laptop, I got the values, right? What if I try to print the object? What happens behind the scene when I try to print the object? Of course, we tried this before and it was giving some weird output. Let's understand what that output is. Now, if you try to concentrate on this output, of course, this is not the values which we set, but it prints laptop, and it actually makes sense because obj is a laptop object. And then we got the @ symbol, and then we got some weird numbers. I'm assuming they are hexadecimal values because you can see we got A, D, F, they are part of hexadecimal numbers. Okay, so these are hexadecimal format, but what is it? Let's try to understand that. Now, what if I say, every time you try to print the object, it by default, behind the scene, it will call the toString method. Let me repeat. Every time you try to print the object, it will call toString method, even if you don't mention. Yeah. And okay, by doing those changes, let me just run this code once again, compile and run. You can see it prints the same thing. That means, yes, it is getting called. But what toString is doing? So if I go to toString, now, first of all, toString is not my method. If you can see in laptop class, we don't have any method called toString, but in the object class, there is. You can see we got a toString method, which returns a string, right? That's what we are printing, right? It returns something. What it returns? It returns the class name. If you can see, it says get class. Get class method will give you the class name. Then it calls get name. So class name, okay? that is laptop, okay, is working. And then we got @ symbol in between, okay, that also makes sense why we got @ there. And then it prints something in hexa string. That's why we got hexadecimal values here. But what exactly it represents? It converts the number into hexadecimal string, and that number is actually hash code. Now what is hash code? If you go to hash code, again, it belongs to the same class. And behind the scene implementation for hash code works with it basically generates the hash based on the values you have, okay? Now hash is a very simple concept in terms of cryptography and anywhere. It tries to create a single string of all the data which you have. So let's say if you have an object which has 5 variables, it will apply a hash algorithm and it will generate a string, a number string, which will be of fixed size, okay? To know more about hash code, you can just go to YouTube and search for what is hash, or go to Google and search for what is hash. But at this point, we are returning a hash code. Okay, that's what we got here. Okay, now the thing is, we are trying to print this, right? So by default, it is calling toString, and that's why we got this output. But what if, when I try to print the object, it will print something which I want? And one thing we know, that if you don't have a method in your class, it will call the method of a superclass. But what if I create that method here itself? So the public method which returns a string, the method name is toString. If I implement this method, and if I return something, if I return say, hey, that's it. And if I clear this and compile and run, oh, it says, hey, you know, it's not printing the laptop class name and hexadecimal values. It's just trying to call toString, which is this, and it is returning, hey. It's not going for the superclass here. That is awesome. Now let me also try by deleting this thing, okay? Let's not call toString by ourselves. Let's see if it is getting called automatically. It is happening, right? Now, whatever you want to return, you can do that here, right? What I want to return is, I want to return the model information with a colon in between and the price, so that it will print that particular data. Compile and run. You can see it says Lenovo Yoga $1,000. Okay, so that's how we can basically work with the object class methods. If you don't mention, it will be coming automatically by the object class. Now there's one more thing. Let's say if I create one more object of laptop, and this time let's say the values are same. Let's say this is object 1, object 2. This is the object 1, 1. Okay, don't give me suggestions. Yeah, this is 2 and 2. Now if you compare these two objects, are they same? Yes, the values are same. But do we have the objects which are same? Let's try. How will you compare this? So what I can do is, I can just create a Boolean variable here. And I can say result is equal to, how do I compare obj1.obj2, or obj1 is equal to obj2? Let's try. I mean, we can use double equal to between obj1 and obj2 as well. Let's try to print the result and let's see what happens. If I compile this code and run, oh, it says false. Okay, maybe using double equal to is not a good idea. Let's use some inbuilt methods. If you can see, obj1 actually has a method called equals. It checks for the equals. Okay, that's great. It checks for the equals of obj1 and obj2. Okay, let me try this. I hope this will work. Compile and run. Oh, it is still giving you false. Why? The objects are same, right? The thing is, if you go with the equals method here, you can see in our class we don't have equals, and the equals is actually coming from the object class. It basically compares the two objects by their hexadecimal number. We don't do that. So we want to compare them based on their values. So one thing we can do is we can implement the equals method by ourselves. So we want the equals method which will return a Boolean value. The method name is equals, and it will accept only one object. I will say this as an object of the same type, laptop, because we are comparing laptop with laptop. I will say this is other. And then the object which is calling this equals is this object. And we have passed one more object here, which is other. Or maybe I can say this is this and that. So this is that object, this object. So we are comparing two objects. Now, how do I compare? I can check if this dot model dot equal. So when you talk about this model, it's a string, right? Now string has equals implemented properly. So we can use string equals to compare this string. And this dot, we are comparing that dot model, right? We are comparing two strings here. And we have to also compare the price. this dot price is equal to that dot price. Now why I'm using equal to for integer? Because that's how it works, right? And we have to also say open and close. If this matches, then I will return true, else I will return false. Simple, right? And since we have only one statement, I can actually do this, right, in one line. You can see I'm just comparing the values here. I'm comparing these two strings, which is model, and price. It will not use the equals of object class. It will use the equals of my own class. Let's see if that works. Compile and run. Oh, it works. Can you see that we got true? Now, if I change the value, let's say it becomes yoga 1. And if I try to compile and run, you can see it says false because we have a different value. Cool. Okay, in fact, I can actually simplify this more. Why to even mention if else? Anyway, this is returning true and false, right? What I can actually do is the entire stuff from here, you can cut this part and say return the entire string, because the string itself will compare and it will return true or false. I can do that in one line. Yeah, this is one way. But there are some rules in Java if you are trying to do equals. When you say two objects are equal, of course they should have a same value and they should also have a same hash code. So what I mean by that is, don't define the equals and equals method by yourself. You can use your IDE and you can say source action, and you can see it gives you an option of generate hash code and equals. Click on that, select all the variables which you want to compare and click on OK. It will generate the equals method for you, and you can see it does multiple checks. We have only checks for the value, but what if you want to check if the object is not null? Maybe you want to check for the class name as well. Maybe you want to check if the model is not null before comparing. So it does multiple checks for you. It's a good practice. And that's why I say sometimes you have to prefer your own IDE output. And it also implements hash code. This is how the hash code is generated. Basically, it takes your data and works and applies some algorithm on your data to generate the result. This algorithm can change. You can implement your own algorithm, but of course it should have all the variables which should comes into play. Example, let's say I have one more string here which is serial number, and I am okay if two objects have the same model number. Same model, same price, but different serial number. That's okay with me. So maybe you can just skip this serial in your equals and hash code. Okay, that's the important thing. The thing you have to remember here is the object class has multiple methods, and we have worked with toString, which is here. In fact, we don't even have to mention toString here. We can right click and we say source action, generate toString with both the variables. Okay, it will generate a toString for you, which gives you a much better output than what you can type. Now I know by asking the code from your IDE, you get these 2 extra annotations here, in fact 3. This is actually, we'll discuss that once we talk about annotations. At this point, this is not needed. It's not compulsion, but it has some importance, which we'll discuss later. Yeah, that's how we can use object class. We can work with hash code, equals, toString, and yeah. In this video, we'll talk about what is downcasting and upcasting. Now, before this, we have to understand what is typecasting. So let's say we have a double value. So let's say double D is equal to, let's say 4.5. And then, of course, I can print this value. I can say D, and we all know what will be the output. It will print 4.5. But what if I want to save this value somewhere? Okay, so example, if I say int is I equal to D, can we do that? Can we have the double value inside integer? Of course, it will not support, right? Because 4.5 cannot be stored in integer. So yes, we can at least store 4 here, right? So maybe we can remove 5.5. We can at least store 4. But how will we do that? By default, Java will not allow you that, because Java says a type mismatch cannot convert from double to int. It's because it says, you might lose data, and we can say, hey, that's okay for me. I'm okay to lose data. So what you can do is you can typecast it. So you can say, hey, I don't care what value you send, just send that in the integer format. I'm okay with it. Okay, so this is typecasting. You are converting the type of a value, right? Now by doing this, if I try to print I, let's see what happens. Of course, we are storing that in integer, we will lose data. So we are losing 0.5, but that's okay. At least we got 4. Now this is called typecasting. Now coming back to the world of oops. can we do this in OOPS? So let's try. And we have talked about inheritance. We have talked about how can we have methods in two different classes? How can we override those stuff? Now, just to keep it simple, what I will do is I will create a class here and we'll name this class as, let's say, A. Again, I'm just trying to keep things as simple as possible. We could have gone with other names as well, like calculator or something. But just to keep it simple, let's say we have these two classes, class A and class B, and class B extends A. So we are basically trying to achieve inheritance here. And now with this, what we can do is we can create object of A. Of course, we can do that, right? We can create object of A and that perfectly works. Now in these two classes, I want to have some methods. Let's say in A, I have a method which is show, or maybe I will say show1. And in B, I can have a method which is public void show2, right? And then I will just print something here. So I can print in a show, and now you know what I will say here. See, we can write any complex logic, right? But the idea here is to understand the concept. So that's what you're focusing. So in B show. Now what I want to do is using this A object. So if you can see, we are creating this obj of type A, and also the object is also of A, right? And now with the help of this obj, and you can see I'm not trying to achieve method overriding here. There are two different methods, show1, show2, two different methods. And I can call show1. And you can see I can only call show1. I can't call show2. What's the reason I can't call show2? It's very simple. We don't have show2 inside A. And A don't even know B exists. Okay, that's a fact. B knows what A is, but A has no idea what B is. I hope that is not the scene in real world. Your parents knows you. So let's try this. Compile and run. You can see it says in A show. But now my question to you is, can I have the reference of A an object of B? And then we have seen that it is possible. I can actually create this. I can have a reference of A an object of B. We have done that in dynamic method dispatch. We can basically do this, right? Now what we are trying to do here is we have an object of class, subclass, and then we are trying to assign that to a parent class. Now we can actually say, hey, you know what you can do? Please typecast it. So whatever object you're sending is of child class, but typecast it with A, which is a parent class. The same thing we have done for the integer and double, right? Now when you are doing this, we are basically going up, right? Which is, if you try to compare this A and B, A is a superclass, B is a subclass. So we are trying to say object is of B, but refer to A. So we are going up, which is upcasting. So this concept here is called upcasting. And of course this will work. There is no issue. You can still call in A show, because in B as well, we got the same method. Even if you have the object of B, it will still work. Okay, so this is called upcasting. So even this is not compulsory. It is something which happens implicitly behind the scene. So you don't even have to mention the casting part. It normally works. So this is upcasting. Now what is downcasting? So let's say I'm creating a reference of B. Now why we have to go for downcasting first of all? See, using this, even if the object is of B, using this obj, I can't call show2. If you can see, the object is of B and the method show2 belongs to B, but still you can't call it. Reason is because the reference is of A and A has no idea what is this show2. Okay, so to solve that problem, what we can do is we can create a new reference, let's say obj1, but then I want to use the same object. I don't want to get a new object. Of course, you can do this, but you're getting a new object. Can we do this? Can we say obj1 is equal to obj? Now the problem is, even obj is referring to a new B object, but the problem is it is referred to A. It's the type of obj is A. So it's the same problem of double and int, right? Similar. So what we can do is we can do a typecasting here. We can say, hey, I know this is reference of A, but the object is of B, right? So whenever you assign, I want the type to be of B. And that's how it works. This is called downcasting. So this obj is the parent object or parent reference. You are downcasting it to the child reference. Now using this new obj1, I can call show2. Okay, so this is downcasting. This is downcasting. This is upcasting. In general, they are called typecasting. Okay. So you don't have to actually remember these terms every time, upcasting, downcasting. After some time, you get used to this concept. You will implicitly use those things anywhere you want. But yes, while teaching, we have to use some words. So upcasting, downcasting. So yeah, that's about this concept. But remember this, we can create a parent reference and child object, and we can also come back to the child reference here. In this video, let's talk about abstract keyword. Now, what is abstract? So before that, let's understand something. So we know what is class, what is object, what is inheritance, and how do we do overriding of the methods, right? Now with those knowledge, let's talk about abstract keyword. So for that, what I will do is I will create a class here, and let me name this class as, let's say, a car, okay? Now in this car, you will define some methods. Let's say if we talk about car, a car can drive, of course, right? A car can play music as well, public void. I mean, that's what we do, right? We also play music in the car. You know, some people, they don't start their car before playing the music, or they don't set it on a drive mode before they play the music. Okay, so we have these two methods, let's say, or maybe we can add some more methods in the car. Maybe you can sleep in your car and other methods. But let's say we have these two. We have drive and we have play music. And of course, in this method, I can define some statements. Let's say when I say it is playing music, I can say play music, or we can write multiple statements. Logic is not important. The important thing is the concept. Let's focus on that. So let's say in the play music, we have this statement. And in drive, let's say at this point, I'm not sure. I want to build my own car, but I'm not sure how can I drive a car. I know how to implement play music, but I don't know how to set up the engine. I'm manufacturing my own car, so I don't know how to set up the engine, how to set up the wheels. But a car should drive. That's what I know. And that's why we call it a car, right? If you don't have a drive feature, then why you will call it a car? You can say it's a home theater. Anyway, now if I want to use this car, I can simply create an object. I can say obj, car obj equal to new car, and then I can call the methods. I can call both the methods, obj.drive and obj.play music. Of course, we have two methods, so I should be able to call them. Now, if you observe, in the drive, we are not doing anything. Why we are not doing anything? Because I don't know how to implement drive. But I know how to implement play music, so I'm able to create this object and I'm able to call these two methods, and I think it should work. And if I go back and run, it works. It's not like if you don't define something, it will not work. It's working. The only thing is when you're defining this method, you are actually not implementing anything here. You're not writing any statements. So it's valid in Java syntax term. But as a feature, I mean, just imagine you're buying a new phone and your phone says it can do this feature, feature 1, feature 2, feature 3, but then none of the feature works. Of course, you will not buy any phone like that, right? In the same way, if we talk about this car, you are writing a method here, which is drive, and you're not implementing it. Why someone should be able to create an object of this? Why in first place, someone should create a class itself, right? When you don't know how to implement it. See, the thing is, when you build an application, you have a structure which you follow. You design your application. I'm not talking about the thing which you see on the screen. I'm talking about when you build an application, you design on paper. What are the classes you need? What are the methods you need? Now, at this point, you know how to play music, but you don't know how to drive. Now, in that case, should I remove this method completely? If I do that, then how will you call it as a car? So what you can do is you can say, hey, you know, I am creating this method drive, but I'm not sure what should I implement it here. So instead of defining it here, so when you open the curly brackets and close, you are basically defining a method. So instead of defining a method, you can basically declare a method, which means you can put a semicolon at the end. When you do that, you are declaring a method. That also means that the drive feature you had declaring, but it is not working, and no one should be able to create object of it. Okay, again, we'll see that in some time, but when I declare it, it is giving you an error. Now, first of all, why you will declare when you are not defining anything? Maybe I have this mindset, someone else can just come back and they can say, they can implement a car. Maybe they will build a wagon, let's say, and a wagon will extend my car, and it is the wagon's responsibility. In fact, you know, instead of saying wagon, let's say WagonR. It's a very famous car if you search online. So we have this WagonR car, which some of them don't like. Not a big fan of it, but okay. So let's say we have this car, WagonR extends car. In fact, I have a car which is smaller than WagonR, which I love. So we have this class WagonR extends car here. And what I want here is I want this WagonR to implement the drive feature. See, if you think, car is just an abstract concept, right? No one actually buys a car. What you buy is a real car. Like WagonR or BMW GLS or Toyota Fortuner or Ford EcoSport, right? So you buy a real car. You don't buy a car. This is just a concept. So when I say drive here, a car don't know how to drive, but then when you create a real car, that car will know how to drive. So I want this wagoner to be responsible to define this method. Okay, so I can just copy this and paste it here. And here, instead of declaring it, I will define. So what I want is, I want this wagoner to implement it. Of course, the other feature like play music can simply be extended, but not drive. Drive should be implemented here. And wagoner, I mean, the company who built wagoner cars, it's their responsibility to define the method here. I can say driving. Of course, they will write a complex logic, but just to make it simple, I'm writing one statement. So they are responsible to define this method, and we're not doing it here. Now, if you want to declare a method, you can see we are getting an error here. You can use an abstract keyword. So when you say abstract, it means I'm just giving you the abstract idea of a car should have a drive feature, but I don't know how to implement it. Now, when you are using my feature and when you call your vehicle as a car, it should have a drive feature. Or whatever object you're creating is a car, you need to have a drive feature. And that's how you make it. So you make a public abstract void drive. So you have to use an abstract keyword if you want to declare a method. Okay, here we are defining it. But if you can see, even if I do abstract, it is giving you an error. It says the abstract method drive in type car can only be defined by an abstract class. Okay, what it simply means is, if you have an abstract method can belong to only abstract class. So that means you have to make this class as abstract as well. So you can have abstract methods only in the abstract class. And whichever class is extending the abstract class will have this drive method. If you don't do that, it will give you error. Example, if I change the method name, you can see it will give you error. It says the type wagoner must implement the inherited abstract method car.drive. So if you are extending an abstract class, you need to define it compulsory, otherwise it will not work. So you have to define, you have to basically override the method. Now, when someone creates an object of a car, in fact, first of all, you can't create object of abstract class. Point, very important point. And that's why you can see we got an error here. It says cannot instantiate the type car. It simply means you cannot create object of car. So the point, remember, you cannot create object of an abstract class. Okay, but then can I create a reference of abstract class? Yes, that is possible. You can say car obj, that is absolutely correct. But if you want to create an object, you have to create object of not car, but wagoner. Okay. And then with this obj, you can call drive, you can call play music. And we have talked about dynamic method dispatch. And we know when you call drive, it will be calling drive of wagoner, not of car. Anyway, it is declared, right? So basically, that's how you can create an abstract class. That's how you can create an abstract method. And basically, that's how you can restrict the creation of the object here. Now, a few more points to remember. Is it compulsory to have an abstract method in the abstract class? I mean, we know that it is compulsory to have the abstract method. You need an abstract class, right? But is it compulsory to have an abstract method in the abstract class? Let's do that. If you comment this section, okay, you can say there's no problem. It's not like an abstract class should have abstract method. Abstract class can have abstract methods. It can have normal methods. So you can have an abstract class which only has abstract methods. You can have abstract class which has only implemented methods, which are non-abstract methods. And you can have an abstract class which can have both normal methods as well as the abstract method. And you can create multiple abstract methods. Okay. Example, if I can come back here and say, hey, I want a car to fly. I don't know when this is possible. But in the movies, you see that, right? So a car jumps from one building to other building. Okay, and I hope you know the movie name. But anyway, so if you talk about this abstract method, which is fly, and you can see I'm declaring it here. Now, when you declare a method and when you say you have an abstract class which is getting implemented or which is getting extended by another class, it becomes compulsory for you to define one more method here. So you can say public, not abstract, you can say public void. You have to define fly as well, otherwise it will not work. So you can say flying, okay? And now with this, you can call the methods. You can say obj.fly, and this should work. Compile, run, and you can see it says driving, play music, and flying. Now there's one important thing here, which is what if when you are creating this class wagoner, and then you're not able to implement fly, what will happen? First of all, it's compulsory to define all the methods, okay? All the abstract methods. So you can see in this class, we have 3 methods, but only 2 methods are abstract. And that's why it says it should define fly as well as drive. But we are not implementing fly. So you can see it says the type wagoner must implement the inherited abstract method car.fly. But what if you don't do that? So in that case, if you have a class which is not able to implement all the methods, in this case, even this class becomes an abstract class. So you have to make it abstract class. And you can see there's no error. But the problem now is you can't create object of abstract class, right? So maybe you have to create a new class here by saying updated wagoner, which can also fly. And this will extend. Now, which class you want me to extend? The car or the wagoner? Of course, wagoner, right? Because you will get this drive feature from wagoner. So you can simply extend it with wagoner. And then here in this class, you can basically create object of fly. In fact, if you are using IDE and if you're lazy to type, you can come to this error and you can say quick fix, add unimplemented methods, and it will do it for you. Okay, and here we can say flying. So even you can do that. The only thing is now the object will not be of wagoner. The object will be of updated wagoner. Is it the method class name? Okay, it should be updated, right? So that's how you can create an object. So again, we are not creating object of abstract class. We are creating object of the class which is not abstract. Okay, now since we are calling this class as abstract class, even this class should have a name, right? So normally we call them as a concrete class. So we can say this is a concrete class. Okay, so we have abstract class and then we have concrete class. So you can create object of a concrete class, not an abstract class. So I hope this makes sense. That's about abstract keyword. So let me just reiterate, abstract keyword can be used with methods if you want to declare them. And if you have any abstract methods, you have to make a class as abstract. But again, on the other hand, if you have abstract class, there is no compulsion that abstract class should have abstract methods. An abstract class can have normal methods also. I mean, all the normal methods, no abstract methods. Even that is possible. Next point, remember, we cannot create object of an abstract class. If you want to create object, you have to get a class which implements all the methods, a subclass which implements all the methods, and then that class will be called as a concrete class and you can create object of it. So that's about abstract keyword. In this video, we'll talk about inner class. That's right, a class inside a class. I know that sounds weird at first, but let me go with that. See, most of the time when you build an application, you might have a scenario where a class will be used only for that particular purpose. Okay, so let's say you have a class A and then that class needs variables, so we can do that. Example, we have a class A here and this class A can have variables, this class can have methods. So when you have this class A, this class can have variables, this class can have methods, right? Now these variables and methods only work for this class A. So if you want to access them, you have to get a class first. In the same way, let's say if you have a class where that class is totally dependent on class A. There is no other need for it. In that case, you can create a class inside the class. Okay. The way you do that is by defining a class like A and then you can define a class called B inside it. Now, just the way you have class A here, I can create a variable that works. We can say variable age and then we can have method as well, which is public void show. Now we have these two things. We have a variable which is age and then we have a method which is show and then we have a class as well. So imagine a class having all three things, a variable, a method and a class. And inside this class, let's say I create a method which is public void config and in this config I will print something. Let's say in config just to print something. Okay. And I'm trying to make this example as simple as possible. That's why I'm using this class name. In real life, don't do that. Make sure that you use proper class names. And so let's say we have this scenario. Now question is, how will you call this config? So it's very easy to call show. In fact, I should print something here just to see what it prints in show. Now question to you is, how will you call this show? And then we have seen this, right? You simply have to create this object of A and then you can call obj dot show. I mean, show will perfectly work, right? If I compile this code and run, you can see it says in show. Now I want to call config. How will you do that? Of course, you will say if it is a class B, then you have to get object of B to call this config. Let's try. If I try to create object of B by saying B obj1 new B, you can see it will give you an error. It says B cannot be resolved. Oh, it's not able to find B. The thing is, B is not openly available, right? B is a part of A. So if you want to refer B here, you need to say A.B. So B belongs to A. That's why you have to say this. Okay, now why I'm doing this? So when you say if you compile this code, and if I go back here, can you see that we got two classes? And we have seen this, right? Every time you compile a code, you will get those number of class files. So you got a class file for demo, that makes sense. You can see we have demo.class. You will get a.class as well because A is a class, but we also got, B is also class, right? It should have its own class file. And that's right, we got it. We got b.class. The only thing is B belongs to A. So the dollar symbol separates these two. So it says B class belongs to A class, and that's why it's A$B. Okay, that makes sense. So if you want to access B, you have to say A.B. That's how you access it, and you can say obj1. You can say there's no problem in declaring the variable. The problem is when you say new, now how will you do it? If you say B, it will not work again. It will say cannot able to resolve B. In that case, if you say A.B, no, that's not the proper syntax. The thing is, if you want to create object of B, you need object of A first. Now you will say why? I say it's very simple. If you want to call B, if you want to call this show, now show is a method, right? It's a non-static method, which means if you want to call show, you need object. In the same way, if you want to access this variable age, you need object. In the same way, if you want to create object of B, you need object of A because that is a non-static method. Okay, so I'm focusing more on static here, right? Can I create a static class? Yes, we'll see that in some time. But we got this object here. And now using this obj1, I can call the config method. If you want to create object of a inner class, which is B in this case, you need to first specify where it belongs to. So B belongs to A, and then you need object of a outer class, which is obj here, to create object of inner class. And once you have that, you can simply call these methods, and that will properly work. You can see what in show and in config. Okay. Now we have also focused on a static class, right? You can also make this class as static. And we all know when you refer it to a static class, you don't need object. So basically you don't call this with the help of object. You can directly refer with A.B. Now this will work only when the class is static, the inner class is static. It will not work for non-static class. Now, can we really make static class? Yes, we can, provided it's an inner class. If it is outer class, you can't make outer class static. You can see it will give you error. It says illegal modifier for a class A, only public, abstract, final are permitted. So basically you can't use static here. Static can be used only for the inner class. Okay, I hope that makes sense. So yeah, that's the concept of inner class. Now, once we know about inner class, let's talk about anonymous inner class. I know that sounds weird, right? Anonymous. Anonymous simply means something which doesn't have a name, okay? So what I will do is I will just try to remove everything here and let's work with this particular class, okay? And in fact, I needed a class. Let's say class A is there, okay? And inside this class A, I'm creating a method which is public void show. Again, just to keep it simple, I'm using simple names here. And here I will print in a show, okay? And if I want to call A, of course, I will simply say A obj. You need to create object of A. And then I will say obj.show. Let's see if this works. Compile and run. It works. You can see got in a show. That perfectly works. Now the question I have for you is very simple question. What if I want to change the behavior of show method? Okay, that means I want it to do something else. Now I know in your mind you have the idea, right? We can simply create a class which is B, and this class B will extend A. So basically we are trying to do method overriding here. In this B as well, you will be having the same method which is show, which will print in B show. We just want to do something else, and by doing something else, what I mean by in this code is I'm just trying to print something else. But of course you can do whatever you want. I just want to change the behavior of this show method. So we created a new class called B, and here what we can do is we can create the object of B, but the reference is of A. So what we are doing is we are overriding the behavior of show. And then you will say, hey, we have already talked about it, right? We have talked about method overriding. Hold on, hold your horses. Let's see. If I compile this code and run, it says in B show. But now if you think about this class, now first of all, as we mentioned, every time you compile a code, it will create all the class files. See, we got A, B because of the previous code. Let's delete that. You can see we got b.class as well. Now you will say, what's the harm in that? See, the harm is the only purpose of this class b was to extend a class to override the method, and maybe it will be used only once. Now, of course, if it is using multiple times in different places, of course you should create a different class. But what if we know that this class will be used only once, only for this particular use? In that scenario, why to create a new class? Oh, then you will say, if you don't get a new class, how will you get a new implementation? Okay, let me show you something. What if I can simply come back here just before the semicolon and I can define what should be the new implementation? I know this looks tricky, but just be with me. See, till this point, we have seen that first you have to create a class and then you create the object, right? And that's what we are doing from a long time. But now this is the first time when I'm saying, I want to create object of A, but this is the implementation. This is the design for it. Don't go for the original design. I will give you new design. The new design is, I will use the same method name or same method here. The only change I want to do here is it will print in new show. I will just provide some indentation so that it will look better. So what I'm doing here is I'm providing a different implementation for show method. Okay. And let's see if this works. I just want to see, compile, and you can see that it says in new show. It is not going for the original method. So we are providing a new implementation here. Now this is called inner class. Okay, you will say, hey, how it's a class? We are not using a class keyword, right? That's right. We are not using a class keyword and we are not even giving a name to it. And that's why it is a inner class, because this class is created inside the demo class. And also there's no name for the class. And that's why if you go back to your files, can you see this? We got demo. Inside that we have a class, but there's no name for it. And since we don't have a name for it, it says 1. Of course, if you create multiple classes, it will have a different number. It will say 2, 3, 4, and list goes on. And since we don't have a name, it is called anonymous class. So this is anonymous inner class, which we are going to use a lot in the upcoming videos. Once we talk about interfaces, once we talk about functional interface, Lambda expressions, this is very famous concept. So just get used to it. Now, if you want me to type this code once again, I will do that for you. What I will do is I will just go back here. See, it is not difficult. It's just that you're unfamiliar with this concept and it will take some time. Okay, so what you do is just before the semicolon and after the constructor, open the curly brackets and close. This is your class. And in this class, you provide the method, which is show. And whatever you want to do in show, you can do that here. You can say I'm printing in new show. And then you can call this show. So when you call this show, it will call the show of the new implementation, not this one. Okay. And yeah, that's how it works. So that is your anonymous inner class. Okay, so we have talked about abstract class. We have talked about inner class. In fact, we have talked about anonymous inner class. Can we just use both? Let's try. What I will do is I will just make this class as an abstract class because I want to create this method show as an abstract method. Okay, let's say this is abstract. Okay, and then let's say I'm not doing all those things. Now I have a question for you. If I want to create an object or if I want to instantiate A, can I do that? Of course, in the abstract class we have seen, we can't do that because you can't instantiate the abstract class. And we have found a solution as well. You can create a separate class by saying extends A, and then you can provide the implementation here. You can just go here, quick fix, implement the method. And one more thing, you might be saying that I'm reviewing this line multiple times. It's just that we have not talked about what is @override. We have a separate topic on that. So at that point, we'll discuss that. So here, I just want to say in B show, okay? And then of course, I can create the object of B, and that's done. With the help of this object obj, I can call show. Again, we have seen this in abstract class concept, but I want to talk about something else. So you can see it says in B show. Now, if you look at the entire purpose of this class B is to implement the show method. That's it. And if you are using this method only once, then why to even create this class? Can I use something else? Can I use anonymous inner class here? Okay, so what I'm saying is I can simply say new A, and okay, it's not working, but can I provide the implementation here? and I can create a method which is public void. In fact, I will just simply paste the code because we already have that code with me. And here I will say in new show. So what I'm doing is I'm providing the implementation for the abstract class here itself, okay? And you might be thinking, we are still getting new A, right? Is it the object of an abstract class? We can't do that, right? How we are doing this? The thing is, this is a class here, right? The anonymous inner class. And we are creating the object of not A. We are creating the object of this anonymous inner class. That's a point to remember. So most of the time when we have interfaces or abstract class, we use this concept. So if you want to implement the interface or the abstract class only once, then you can use anonymous inner class, and this perfectly works. So let me just try it out, compile this code and run. You can see it works. So we can use anonymous inner class for the abstract class as well. In fact, if you have multiple methods, you can still do it. If you, let's say we have one more abstract method here, which is public void, let's say config, we can create a method for config as well. And since we are using an IDE, it gives you the method. So you can simply use this and you can print in config. So it's not just for one method. If you have multiple methods, you can provide the implementation in the anonymous inner class. In this video, we'll talk about interfaces. Now, before we start with interface, let's talk about the abstract class. Now let's say I create an abstract class here. So we'll say abstract class A. And in this class, let me create some methods. Now we all know in the abstract class, we can create our abstract methods and normal methods as well. But let's say if I have abstract class which only has, let's say, abstract methods. If I say public abstract void show, and we have public abstract void config. Now when you have abstract class with two abstract methods, of course this works. There is no compulsion to have non-abstract methods here, or we call them as concrete methods. There's no need for them. Now, whenever you have a situation where you have an abstract class which only has abstract methods, we have another way of doing it. Now see, all this are decided at design time. So when you make an application at designing, you specify things, okay? What are the classes I need and what are the abstract class we need? So you create this hierarchy of system. Of course, we'll talk about that hierarchy in some time. Why do we need it? But at this point, we create a hierarchy. And when you have a class which only has abstract methods, the other alternative for that is to create an interface. So instead of creating an abstract class, we can create an interface. Most of the time we use this interface in project development. So let's understand that. So we have the interface A. Now you will say, what is changing there? Now, first of all, interface is not a class. Okay, so that's the main difference between abstract class and interface. And by default, every method in the interface is public abstract. So these two keywords are actually not required because anyway, they are public abstract. So even if you don't mention, they are by default public abstract. And that's why if you can see, when I put a semicolon just after the method, there is no error because behind the scene, public abstract is there. Now this is your interface. So interface basically means it's like a class, just that all the methods are by default public abstract. Okay, but then how will I use this? How will I instantiate this? The same problem was there with abstract class, right? We cannot instantiate it. Now, if you look at this, how do I instantiate? Let's try. So I will say A, obj. See, there's no problem in creating a reference of it. So that also means we are creating a type. The way you create classes. So let's say if A is a class, you can say A obj. So A is a type, right? In the same way, here, the interface A is a type. Okay, this works. But the moment you try to create object for this, it will give you an error. It says, if you see the error, it says, cannot instantiate the type A because it's interface. You can't instantiate it. Okay, what's the solution? The solution is, see, first of all, why do we create interface? We create interface so that we can design something. We can say, example, let's say if you ask me about how do we create a table, I can say, or maybe if you ask me how to reach somewhere. So I can say, go straight, take a right, go straight, take a right, take an auto, take a bus, get down at the next stop. So what I'm doing is I'm giving you the path, right? I'm giving you design. You have to literally take a walk. I will not walk for you. I will just show the directions. In the same way, interface says, I will tell you what are the methods you need, but I will not implement them. It is your job to implement. So when I say your now, I'm talking about classes. See, ultimately, you create object of a class. Interface just show you the design. So here what I can do is I can create a class. Let's say class B. So we have a class B here, and then in this class, I want to implement these two methods. Now, in terms of abstract class, we say extends, right? Because class extends another class. Here, A is the interface. We have to use a different keyword here. The keyword which we use is implements. So whenever you want to implement the interface, you say implements keyword. And when you say implements, it becomes compulsory for you to define both the methods. Okay? If you fail to define both the methods, by default, your class also becomes abstract. Okay, but we don't want to create abstract class, right? We want to create a concrete class. We want to create object of B. In that case, it's your job to define both the methods. Okay, there's one way you can use a shortcut here. You can just go back here and say quick fix. It will ask you to implement the methods. Or you can do the hard work. You can say public void show, and then you can define something here. I can say I'm defining in show, and then we can define another method as well, which is config or public void config, and here we can define in config. So basically what you're doing is you are implementing both the methods. As I mentioned before, if you fail to implement these methods, or this class becomes an abstract class, but we are implementing it, right? Now, when you implement, basically you can't create object of A, but you can create object of B, and you can say it works. And now using this obj, I can call show, I can call, what other method we have? We have config. So we can call both the methods, and that perfectly works. If I compile and run this code, you can see it says in show, in config. Okay, what else? Can I have, so the way you create variables here, also the way you create methods here, can I create variables? Now, first of all, we don't define variables, right? We declare them. So we can actually. So if I say int, let's say age, that's a variable. I don't know why I'm taking this age variable every time, but let's say we have int age here, and let's say we have string area. So that's the area name. But you can see we got an error. That means I cannot create variables? That's weird. I just said we can, right? See, the only thing is, every variable in the interface, we can create actually those variables. The only thing is they are by default final and static. So all the variables inside the interface are by default final and static. Okay, so that means we have to first initialize the variable. So when you say it's final, we have to initialize the variable, right? Okay, that's not my age, but let's say 44, and let's say area is Mumbai. Okay, so basically what we're defining is we are defining the age, which is 44, and the area is Mumbai. Now these variables are final and static. Now, first of all, since they are static, which means we can directly use the interface name. Remember, when we use static variable, we don't have to use the object. Example, if I want to print the value of name or area here, I can simply say A is the interface, A dot area. I can directly use it, not with the object. And if I compile and run, it works. You can see we got Mumbai. If I try to change the value of this, if I say A dot area is equal to, let's say if I want to change the area to Hyderabad, it's not working. You can say it says the final field, that's right. The area is final. It is static. We are using directly the interface name, and it's also final. Okay, so that's one thing you have to remember. Now you might be thinking why it has to be static final. See, first of all, you don't instantiate the interface, right? Whatever you instantiate is a class, and you're not doing extends, you're doing implements. What you get in implements is only the methods, right? You don't get the variables there in implements. So that's why it is static, because we want to use the interface name, and final, because interface objects or interface don't have their own memory in the heap, right? What you create object of is of B, not of A. So if you don't have your own memory, how can you have a non-final variable? So this is interface. In fact, before talking about the need for interface, we have one more thing to add here. So let's say if I have an interface and I'm creating a class which implements one interface here, can a class implement multiple interface? Example, let's say if I have interface which is called X, so if I say interface X, so B class implements A and X both, and the answer is yes. If you can see, there is no error here. The only thing is whatever method you define here, so let's say the method name here is run, you can see we got an error here. The only thing you have to do is you have to define run as well. So you will say public void run. So basically we can have one class implementing multiple interfaces. Now that's not the case with abstract class, right? Because in abstract class we can extend only one class. In interface, you can have a class implementing multiple interfaces. So here I can simply print running. Okay, so what we are doing is we are using multiple methods here. We have 3 methods coming from 2 different interfaces. This interface says 2 methods, show and config, and this interface has only 1 method, which is run. And you can see we got 3 methods here. There's one more thing. Let's say we have one more interface, which is called interface Y. Now the thing is, when you talk about class and class, a class can extend another class, right? What about interface? Can we do interface and interface? What keyword we have to use here? See, whenever you have interface to interface, we say extends. So interface Y extends X. So inheritance is valid here as well. Now in this Y interface, you will be having a method called run. So that's the inheritance. Okay, so you will get this declaration in the interface Y as well. Let me show you. If I remove this X and if I keep Y, even now we have to use run. Otherwise, if you remove run from here, if you comment this part, you can see it will give you error. It says, the type B must implement the inherited abstract method run. Okay, but we are implementing Y, right? It's just that Y extends X, so we have to use run. Now, point to remember here is whenever you have a class to class, we say they extends. Whenever you have class to interface, basically a class is implementing interface, so we have to say implements. And whenever you have interface to interface, we say that extends again. Okay, this is the point you have to remember. So again, I will uncomment this part. Okay, now there's only one thing you have to remember. Whenever you create a reference of A interface and object of B, which is a class, I can only call 2 methods, which is of part A. If I try to call run with A, it will not work because A has no idea what run method is. If you can see, in A we don't have run. In fact, what I will do is I will just remove this code for time being. Yeah. And then if you want to implement run, if you want to call run, in that case, we need to create the reference of X, which is obj1 is equal to new B. Now with this obj1, I can call run. But again, I can't call two other methods. Okay. So that's one thing you have to remember. Okay. Now once we are good with this, let's try to understand what's the need of the interface. Let's try to understand what is a need for the interface. Now for that, let's take an example here. So let's say we have a class here. And so the example which I'm trying to take here is for the developers. Let's say when you join a company, of course, as a developer, when you join a company, you want to write code, right? You want to build application. And if you have seen the trend, whenever you join a company, most of the company will give you a laptop to work on. And luckily, if you get a MacBook, that's great. So they give you a laptop, right? So that's the thing, right? If you want to work in a company, let's say if you go to an office and if you want to work there, you will say, hey, I want a laptop. So in this case, let's say you are a developer. Okay, so I will say you are a dev, right? Of course, you're a human, but let's say you're a developer. And then as a developer, what you do, you make applications, right? Or maybe I can say you write code. I will say dev app. You develop applications, right? Now, when you say you are developing an application, of course, you will say coding. Okay, you're building an application here. Of course, as a company, if I want to build a product, I have to hire developers. Now, in this case, let's say if I hire a developer, let's say developer name is Naveen, and then if you say new developer, and with this object Naveen, I can say Naveen.dev_app, right? So I want Naveen to develop application. And if I compile this code and if I run, it perfectly works, right? Now let's say, if I say, hey, I will make an application, but I need a laptop first. I cannot work without laptop, but we don't have laptop, right? So what I will do is I will create a laptop class. I will say class laptop. And in this class laptop, of course, in a laptop, what you do is you write code and I can say coding, right? In fact, what laptop, when you say code, it basically you code, then you compile, then you run. So you do all those stuff, right? So I'm saying code, compile, and run. And now, as a developer, what I want is if you ask me to write a code, what I will do is I will just say, hey, give me a laptop. So basically, you have to accept a laptop object here. That's right. You can also pass the object. So this developer will say, give me a laptop. and then I will write code. So here, instead of saying this, you can simply say lap.code, right? Now, since you have a laptop object, you can basically call this method called code and it will work. So what I'm doing is, I got two classes here, which one is developer and second is laptop. And inside laptop class, I have a method which is code. And then once I pass this object, I can simply code, right? Now, the only thing is when you ask a developer to write a code, developer will say, hey, give me a laptop. So that means first you have to create an object of laptop. So I will say laptop lap is equal to new laptop. So we got a laptop object. Of course, every developer needs a different laptop object. So let's say if you hire 5 developers, you need 5 laptops to give them. Okay, I will say lap here. Now this should work. There's no problem. If you can see the code, everything should look good. If I run, you can see it still works. So basically we are saying code compile run. So what you're doing is from the main method, you're calling dev app, which is here, and then you're passing the laptop object. Okay, so you're passing this object here. And when you accept this object, you're calling the code method. So it will call this code method and it will execute this part. Everything works well, right? Now the only thing is, do you really need a laptop? See, in some companies, they give you a desktop, right? So if you go to the office, they will have a desktop where you have a monitor, you have a desktop, a good desktop which works. So why, as a developer, you are asking for a laptop? What if company wants to give you a desktop? You can't say, hey, I cannot work without laptop, right? You should be able to work on any computer. So let's say you also get an option of desktop there. In fact, in desktop as well, I can do the same thing, but I will say faster. Right? Desktops are always faster than laptop, right? So you can see when you're coding, it says code compile run faster because it works fast. Now, what if a company says, hey, we don't have laptops with us, but what we have is we have desktop. I will say desk is equal to new desktop, and they don't want to pass the laptop object. So when the company says, hey, Naveen, you have to work, you have to make an application. And what we are giving you is not laptop, we are giving you a desktop. Now Naveen will say, I can't work. You can see Naveen says, I can't develop application because my application only needs laptop. You can't do that. So writing laptop here is an issue. We can't do that, right? So how do we solve this problem? And that's what, when I was talking about abstract class and interface, I told you about the design thing, right? So when you make an application, you have to make it more flexible. Here, what you're doing is you're doing a tight coupling here, which is you are saying that developer is dependent on a laptop. No, developer is not dependent on a laptop. Developer is dependent on a computer. A computer can be anything. A computer can be a laptop. A computer can be a desktop. So if you want to improve this example, what you can do is you can create a class called computer. Okay, and in this computer class, you can say public void code, and basically, I want to keep this empty because I don't want to write a code because computer does not exist, right? It's just a concept. And I can say a laptop is actually a computer. So when you do that, the advantage is, in fact, desktop is also a computer. So when you do that, what happens is, now both this laptop and desktop, they are computer. So when I'm creating a reference of it, so can I say computer lap is equal to new laptop and computer desk is equal to new desktop? We can do that, right? We can create a reference of a parent class and object of a subclass, and that's what we are doing here. Same thing can be applicable here, right? As a developer, you are focused more on the computer, not on a laptop or desktop. The moment you do that, you can say everything is working. There's no problem here. It's because what you are passing here is desk, right? Which is desktop basically. But that is referred as a computer. And what you are referring here is a computer. There's no mismatch here. You're passing a computer reference, you are accepting a computer reference. But when you call code, it will be called based on what object you're passing. So basically we are passing desktop object. So when you say code, it will call the code of the desktop, not of the laptop. Let me show you. So if I compile this code and run, you can see it says faster, that's desktop. But now if I pass a laptop, let's say company decided to send you a laptop, and now when you compile and run, you can see it says code compile and run. There's no faster here. That means that's laptop code. So that's how you design the application, right? To make it loosely coupled, where your developer object is not dependent on a laptop or desktop, or it is dependent on a computer. any computer will do. A mobile phone also do because that's a computer. Now there's one change. See, if you look at this code, we're doing nothing, right? So instead of defining it here, can I simply declare this? And we know when you're declaring it, we can make it abstract. And since your method is abstract, you can also make your class abstract and problem solved. And that's the importance of abstract class, right? You can create that abstraction layer where you say, we are not working with laptop and desktop. In real world as well, we do that, right? Sometimes we don't mention rose or lilies or sunflower. We simply say flowers, right? We don't say apartment or a villa or anything. We say house, right? So we try to generalize things in real life, in virtual world as well. It's good to generalize things instead of specializing things. There's one more. Don't you think we can also use interface here instead of using abstract class? So we are using interface. We don't need public abstract. The only change you have to make is instead of using extends, we have to say implements. And that's the beauty of interfaces, right? I know we have written a lot of code. Maybe you have to watch this video once again to understand and try it by yourself. That's when you will understand the power of the interfaces. And what you are creating here is not the classes reference, we are creating interface reference. Yeah, and that's the importance of the interface. In this video, let's talk about enums. Now, enums are named constants which we create. So basically, if you try to have some constant example, when you talk about error codes or if you have worked on a networking concept. So let's say when you send a request to the server will give you some status, right? If it is accepted the request, if it is rejected the request, or the resource not found, the 404 error. So basically, we have these numbers for every type of data you get from the server. And also we can have a name for it. Now, when you know that we have a specific error codes or when you have a specific constants which you want to use, instead of creating a different object by yourself, you can create an enum. Now, how it looks like, let me just give you a simple example. So let's say we have enum here and I'm saying I want to go with enum of status. So I will say status. Now in this status, I can have different constants which I want to use. Now, of course, you can create a class and you can create multiple objects of it. So let's say this status can be of running state, of failed state, success, pending. So you can have all those things. And of course, you can create a simple class called status and you can create multiple objects, right? But just to keep it simple, we can use enum where we can define all the names constant. And this is pre-built, okay? Example, let's say if you talk about status, I can have status like running status. I can have status, and of course you can separate them with the help of comma. You can say running, then we can have failed, then we can have pending, and let's say success. Of course, you can change the sequence, doesn't matter, but you can have this constant. Now the advantage for this is, if you want to use an application where you want to return a status to the client, that status can be running, the status can be failed, pending, or success. Instead of returning a string format or a specific object, you can simply return this status. Now, how easy it can be? It's very easy. You can just go back to your main method and you can say, I want to have a status. So you can create a status reference, which is S, let's say. And this is same as what you use normal variables. Example, if you want to say int I, and then you assign the value as well, right? Let's say 5. So we have this int as a type, then we have this I as a variable, and then we have a value which is 5. In the same way, you can have a type as status. That's right. This is a type of it. So all these are objects. Now this is something different in Java. Now if you're coming from C++, in C++ we directly create the status and we have all these constants. And it treats enum in a different way. But Java says, oh, everything is class here. So basically the status is a class here. I know that sounds weird, but yeah, that's how it is implemented. This is a class and all these are actually objects of status. So by default, you got 4 objects and you can use any of the object here. Example, I want to use, let's say, status dot running. Now that is my object which is assigned to S. Now, of course, you can print this S here and it will print the running status. So I can say compile and run. You can say it says running. So basically you can use any status here. Now, what are this? Just to reiterate, these are actually named constants. So instead of using numbers or string, we can use named constants. It will make your work a bit easy. Again, I'm not saying you have to use this everywhere, But if you have a scenario where you want to use constants, we can use this concept. And you can use any constant here. We are using running. I can also use failed, even that works. Compile and run, you can see we got a failed status. But yes, if you try to use a status, let's say no idea status, now if you can see, this status don't have any no idea, and that's why you can see we got an error here. It says no idea cannot be resolved or is invalid field. That's right. So you can only use those status which you mentioned here. Now in other languages, we have one more thing, all this actually has a number. So basically you get numbering for it, maybe 1, 2, 3, 4, so that you can pick the status based on numbers. In Java, it starts with 0. So this is 0, 1, 2, 3. And if you want to get that, you can actually do it. So, once you get a status, you can use a method called ordinal. So different constants here have different numbers. This is based on the numbers, right? The order of it. So this is first, second, third, fourth, right? But when you have 0, 1, 2, 3. So when I try to get the ordinal of running, of course, it will print 0. And that's what you want to see. So you can see we got 0. But yes, if you change it to success, which is 3 in this case, you can see we got 3. In fact, you can also print all. What if you don't want to print 1? You want to print all here. So what you can do is, instead of getting one status, you can get all the status first of all. Because if you say status.success, it will only give you one status. But what if you want to get all? So in that case, instead of saying this, you can say status dot. So there's a method here. If you can see, we got values, and that's right. Why we got methods is because the status is a class and you get some inbuilt methods. Now from where we're getting these methods, we'll talk about it in some time, or maybe in next video, but you got methods. So you can see status.values will give you what? Okay, so let me just jump to values just to see what it will give you. So status.value will give you an array. You can see it gives you an array. So on this side, we have to say this is not a normal variable, this is a array. And for that, maybe I can say SS just to have a different name. And once you got this array, you can print all. How? You can just come back here, you can print all. Let's try. I'm not sure if you can get all here. No compile time issue, run, or it is printing the address or something, ignore that. Okay, so what you can do is you can specify the index value. I can say 0, it will print running. Yeah, it works. But then what if you want to print all? And we have seen it, right? We can use a for loop here. Now, which one? I will use enhanced for loop. So I will just cut this part. I will use enhanced for loop here. And every time you iterate, of course, it will give you status, right? So what is this array? This array is of type status. So it will give you one status at a time. So you can say status S colon SS. And here you can print the status. So basically it will print all the status for you. So you can see it is printing all the status. Now with this S, you can also print the order of it just to see how it works. So you can say s.ordinal, it will print, yeah. So it will also print the order of it, 0, 1, 2, 3. Yeah. So let's expand our example of enum with if else and switch. Now, as I mentioned before, these are constants, right? So basically when you have this constant, can we just compare them? We can actually, the way you compare normal variables or strings. So let's take an example here. Let me just remove int variable there, and let me also remove the array. Let's keep it simple now. So let's say I have a status here and s is equal to, and the status which I want to set is, let's say, pending. Okay, initially the state will be pending, and this value can be coming from anywhere. Maybe you called a method which returns this success or this status, and you want to check what is a status, and based on that you want to print some value. Example, if it says running, I can print all good. If it is failed, I can say try again. If it is pending, I can say please wait. If it is success, I can say done. So how do I know what is this value? For that, we have to compare, right? So you can say if the s is equal to status dot running, if this is a status, I will come back here and I will print all good. And I can say if else, I want to check for the second one. I will say if status dot, if it is matching with failed, I can print try again. Else if the status is equal to, s is equal to status dot, let's say pending. Now in this case, I can say please wait. Else, of course, you can also do if else if here, but we only are left with only one status. So I can say else, I can print done. Okay, so basically you can actually compare the status with the help of if else, and we can just come back here, say compile and run. You can see it works. It says please wait because the status is pending. But what if you got a status which is running state? In that case, it will print all good. Okay, so this is how basically you can work with if else. But what if you want to work with switch? Because see, in switch there is a limitation which a switch can support, right? It supports integer, string, and many more. But here the question is, does it support enum? And the answer is yes. So what I will do here is, instead of using if else, I will just reuse the code, but I will use a switch here. And in this switch, you can pass the status as it is. There's a change compared to if else, which is when you say case, in if else you basically have to use the status as well. But in case you don't have to do that, because anyway the S is of type status, right? So it knows whatever you're passing is basically part of a status. So you can directly use the constant itself. So I can say running. If it is running, I can just print this statement. And of course in switch we have to also put a break, and then we can check for the second case. So that's case failed, and here we can have try again. So of course you have to say break here as well. What else? We have two more. In fact, let me just delete the entire stuff from here, if part. I'm so lazy, I can just reuse this. So the next status is what? Pending. In pending, I can say, please wait. And then the last one is success. In fact, for success, instead of even writing the case, we can say default. And here we have to give a colon and we have to say done. So basically whatever we have done with if else, we can also do it with switch. And switch actually makes much more sense here. Because we are working with constants, right? So switch looks good in the case of enums. And now the question is, will this work? Let's try, compile and run. It works. You can see it says all good. But yeah, if I change the status to, let's say, success, I just want to see if it prints done. Yeah, we got done. So this also works with switch. So that's how we can use if else and switch with enum. If you remember, we have talked about enum, and I have also mentioned that enum is a class, right? So does that mean we can extend any other class? The thing is no, that's a thing which is not suitable here. You can't extend enum with any other class. Apart from this, everything is same. That means you can define methods, you can define constructors. That's right. You can create constructors. You can also create your own variables inside the enum. And that's what we are going to do here. Okay, so what I will do now is, and there's one more thing. If you remember, with enum, we have used certain methods, right? Example, if I come back here and if I say status was the object S. Okay, here, let's do it here. So if I say S dot, you can see we'll get some methods here. And we all know that by default, every class in Java extends object, and that's why you will get the hash code and then toString methods, which is here. But what about these methods? Ordinal, name, and then compare to. Now from where you are getting all these methods? So by default, enum in Java extends a enum class. Okay, let me just prove that to you. I will just print it here as dot get class dot get. So what I'm doing is I'm getting the class name and the superclass of it. So I'm just trying to print the superclass of our class enum, and I will just compile and run. You can see it is enum. So enum in Java extends enum class, and all those extra methods you get it from enum class. Okay. Now once we are good with this, let's treat our own class as enum, and I will do a different example here. Instead of using status, let's try to use laptop, because we have to use some constructor and stuff, which makes much more sense with the laptop. And let's say we have some laptop models, which I love. Example, MacBook. Then we have Dell XPS. Then we got Surface. Not a big fan of Surface, but let's say Surface. The Microsoft laptops. And we have ThinkPad. I used to love ThinkPad when it was with IBM. But anyway. Okay, so we got these constants here, right? And then what we can do is, let's say for every laptop, I want to define the price as well. Now, how can we do that? So what we can do here is, just after this MacBook, because that's an object, right? So just after this, I can say, hey, MacBook will cost you, let's say, $2,000. XPS will cost you around, let's say, $2,200. XPS is a bit costly. And Surface is, let's say, $1,500. I'm not sure the cost. And let's say ThinkPad is $1,800. So we got this cost for these laptops here, right? And then, okay, it gives you an error, but we'll solve that error in some time. Now, first of all, what is that error? See, we are trying to say that this is a price, but how will your enum will know that you're talking about a price here? Now, in this case, what we can do is, let's create a variable int price so that we can have an instance variable. And then if you observe here, don't you think this is a constructor? You can say it says that a constructor of laptop. That's right. We can have a constructor here. So when you create the object by passing a value, that's what we're doing here. We are saying these are the objects we have. And this is a constructor where we are passing a value. Okay, that means I can simply ask my editor, hey, I need a constructor here, which takes the price. And yeah, we got a constructor. And now you can see there's no error. That means whatever value you're passing here will be assigned to this price. And the beauty is, this laptop is a class and all these are objects, and every object will have a different value for the price. It's not like once you define price for one object, it will be applicable for all. No, that's not the case. And once you have this, let's get back to our main. And here, let me create a laptop lap is equal to, and let's say by default, maybe I want a MacBook here. And once you got the hold of MacBook, let's say I want to print lap, which of course it will print MacBook. Let's try once. Yeah, it prints MacBook. I also want to print the price of it. Oh, now that's tricky because the price is private. And we have seen that. Make sure that your variables, the instance variables are private. How do we access this? Now, one way to do that is with the help of getters and setters. The only problem is, can we use them here? Yes, we can create our own methods. So what we can do here is I can right click and I will say, hey, I want getters and setters. Basically, you can change the value as well. Okay, so that means if I want to print the price, I can just come back here and I can print lap.getPrice. Now this is specifically for MacBook. So if I use a different object here, I will get a different price. And with that, if I try to compile and run, you can see we got 2000. Now, what if you want to get all the laptops? Okay, let's try. So I will just comment these two sections. First of all, you need to get all the laptop. That means you need arrays. So it's the laptops. Or in fact, what you can do? You can directly use a loop here and you can say laptop lap colon from the laptop. So this is the enum. You want all the machines or all the constants. So how do we get all the values? So we have seen this, right? We can use values here, which will give you the array, and one by one you can fetch the value. So what you can do is you can print the object. And also you can print the price. Let me print the price. How do I get the price? So it's a lap.getPrice. Okay, I hope this will work. Let me just verify once. Yeah, we can do that. So I'll say compile, run. You can see we got all the values. And at any point you can change the value as well. Okay, so you try that. So try to call setPrice and pass a particular value here and your price will change. Okay, there's one more thing. What if I don't specify the value for surface? Let's say we have a surface here and then I don't mention this value. Now what will happen? You can see we are getting an error. Why? Before it was working. The thing is, see, by default we have a default constructor, right? The moment you mention a parameterized constructor, it says, hey, if you want to get a constant, you need to set the price now because you have a parameterized constructor. There's no default constructor here. So you can say, okay, I know how to solve that. You can create a default constructor here. So you can just right click and say source action. Yes, I want a constructor without the price. Okay. And you can see we got a default constructor here and it's your choice if you want to specify some price here. So you can say price is equal to, let's say minimum $500. You can specify those things. And now if you can see the price for surface will be 500. Even if you don't mention, you will get a default constructor. And the beauty is, you create 4 objects, it will call the constructor 4 times. This constructor 3 times, and this one once. Let me just prove that point. I will just try to print something here. I will say in laptop. And let me also print the object name itself. I can just say, okay, this dot. So we got a name here. Let's try to see if this works. Compile and run. Okay, so that we got the name as well. So it says in laptop MacBook, in laptop XPS, in laptop ThinkPad, but not Surface. Is because Surface was created with the help of default constructor and we are not printing anything there. Okay, so that's how we use it. And mind you, we are using it as a private constructor, not a default or the public. It's because we are creating the object in the same class itself. And that's how the private constructor works. You can create the object in the same class. In this video, let's talk about annotations. Now, annotation simply means a supplement to the compiler or to the runtime, or we also call it as a metadata. So basically what happens, when you write a code, sometimes you want to interact with a compiler by saying something. Of course, it will not change the way your code will work. It's just that we want to supply some extra information to the compiler or to the runtime. How do we do that? So let's say we will go for a normal class here. So let's say we have a class A, and then we got a class B. So basically I'm trying to go for method overriding here. So of course we have to extend a class, and then this will have a method which is show. And then in this show, I'm printing, let's say, in a show. And the same thing I can do in B as well. The only thing is we have to change it here. Now, what we are doing here is we are overriding the show method of A with the show method of B. And then we have seen this before, right? Okay, let's create the object of B just to understand this. So I will say B obj equal to new B. And then I can call obj.show, and we all know what will be the output. So if I compile this code and run, you can see it says in B show. Perfect. Now, let's say I change this method name. Okay, not show, but something else. I will say show the data which belongs to this class. Okay, so normally in Java, we give a meaningful name to a method, right? And sometimes your method name can be big. And yes, okay, I know this is exaggerated, but sometimes you do have a big method names with 2 or 3 words or 4 words. And then of course, if you want to override this particular method, we have to type the same thing here. So I will say the data which belongs to this class. Okay, so again, I'm just trying to override the method of A class with the method of B class, right? And then of course, we have to call this now. So I will just try to get it from the suggestion. Okay, so if you can see, I'm just trying to call this method, and what do you think? What will be the output? Of course, we have overridden the method, so it should call in B show, right? So if I compile this code and if I run this code, oh, it is printing in A show. Now we were expecting in B show. In fact, I wanted in B show, but we got in A show. Now this type of problems in programming is called bugs. Okay, bugs are simply logical problems where you are expecting something else and you got something else. Example, you want to say 2 plus 2 and the output is 4, but you got 5. That is logical problem. It's not a compile time issue. It's not a runtime issue. It's the logical. It's the logic which you have written is wrong. And one of the most difficult problem to solve is logical problems. We always say in programming that, you spend less time in coding and more time in debugging. That's what is happening here. So of course you have only 2 classes here and it is easy to debug. But if you have a lot of classes, it will be very difficult. Now, how will you debug? Of course, we are trying to call the method of B class, but we got the method of A class, right? How will you solve this problem? So let's try to understand the method name. On purpose, I changed the method names, okay? I know it might be visible for a few people. You can see in belongs here, we have S. In this method, I don't have it. And sometimes you can miss it, right? And then when I'm calling it, I'm passing S. On purpose, I was calling the method of A class. This type of problems can arise when you write a code. So what you do is, you can show your intention to the compiler, and compiler will help you here. Of course, right, whenever you make a mistake, compiler gives you error. And looking at the error, we can easily understand, hey, I did something wrong, and let's go back and solve this. So what if you can ask your compiler, hey compiler, you know what I'm doing here? I'm trying to override the method here of class A, and if it is not happening, let me know. So you can show your intention, and you can show the intention with the help of annotation. There are a lot of inbuilt annotations available in Java. One of them is override. So you can simply use @ here and you can say override. Now you are saying by doing this to your compiler, hey, I'm trying to override the method. And your compiler says, you know what? There's no method called show the data which belongs to this class in the A class. And then you will know, oh, I made a mistake. And then you can solve this problem just by putting S. Of course, you can compare these 2 methods and you can say, I got the problem. So of course, you have to solve the problem. So compiler is helping you by showing the problem, right? At least you got some help. And solving the problem at compile time is much better than solving the problem at runtime or when you deploy the application to the users. And then users will give you a prompt, hey, you made a mistake. So let's avoid that embarrassment and let's solve the problem at compile time. So at override is one of the way you can do that. And now if you try to compile and run, you will get in bshow. Now, apart from this override, we have different annotations as well, which we normally use. In terms of core Java, we don't use most of the annotations. Of course, you can create your own annotations, but in general, we don't use much. Now, once you start working with the frameworks, example, when you talk about Hibernate framework or Spring framework, at that point, it is mostly driven by the annotations. Now, there are some annotations which works on the methods. There are some annotations which works on variables. There are some annotations which works on class level. So example, there might be some annotation which you will be using on class level. Example, if I say deprecated. Now, this is one of the annotation we have. Now, what we are saying that we have this class A. Deprecated simply means you can use it, but don't use it. It is deprecated. Soon it will be removed from the Java language, or there is a better alternative for this. So you can mark your class as deprecated so that if someone tries to use your class, they will get to know that this class is deprecated. Now, apart from this, you can also use, okay, these are all class level annotations. In fact, we are going to see one more when we start with interfaces. Okay, so if I try to use something on the method level, let's see what we have. So we have save varargs for the variable arguments. We have suppress warning if you want to hide the warnings. Once we start with Hibernate framework, we'll also see transient. Functional interface we are going to see in the interface concept. Yeah. In fact, when you create your own annotations, we can also set the retention. So example, let's say whenever you use an annotation, till what level you want to set it? Do you want to set for compiler level? That simply means if you set a retention for compiler, it means once the code is compiled, the annotation will not make any sense after that. But if you say annotation is applicable for runtime as well, so after compiling as well, when the code is running, at that point also the annotation will be applicable. So we have different options there. And of course, this will make much more sense once we start working with frameworks. So yeah, that's about annotations. And so we have different annotations. And remember when we were doing method overriding, and if you ask, example, let's say if I remove this part, and if I ask my IDE to generate an override method, so I can just go back here and say override, I want to override this particular method. By default, it will give you at override. Okay, so that's you have to remember. Now let's talk about functional interface. And we know the functional interface is an interface which has only one method. So let's create one. So what I will do is I will create the interface here and I will call this interface as A. Okay, and in this interface, let's create one method. Okay, only one method. So I can say public abstract void show, and public abstract is optional. So we can simply say void show, right? And then I can implement this. I can use how do I create the object of this? Of course, we know we can create a class. We can implement this interface and then we can create the object of it, right? Now this interface is called a SAM, which is single abstract method interface, or we can call this interface as functional interface. And to specify that this is a functional interface, we can use an annotation, which is a functional interface. By doing that, we are making sure that we only have one method here, okay? See, if I don't mention functional interface and my intention was to have a functional interface, but if I write one more method here, which is run, okay, there's no error here and we want errors, right? So if you have an intention of creating only one single abstract method interface, which is only one method, and then by mistake you return two methods here, you want compile time errors, right? So if you write it functional interface, you can see it will give you error. It says invalid functional interface annotation. A is not a functional interface. So it's good to specify the annotation here by specifying a functional interface. But then why we are giving so much importance to functional interface? We'll understand that in next video. But let me create the object for it, okay? Now, of course, I can't simply create a obj equal to new A. That is not possible because we cannot instantiate the interface. We can do one thing. We can create a class here called B. We can say B implements A. And we can basically define this method, which is public void show. And then here we can print in show. Of course, you can do anything here. But just to keep it simple, I'm saying in show. And now, instead of creating object of A, I can create object of B, which is possible, right? And then I can call obj.show. This is one way. The another way of implementing this is we have already seen, which is anonymous inner class. So what I can do here is instead of using this class here, I can just remove this entire stuff, or maybe I can just comment this part and I can come back and by say, hey, I want to instantiate A by defining its own implementation here. Okay, in fact, if I just say enter, curly brackets open, close. Okay, so you can do this. And then here itself, you can define the method, which is public void show, and you can define whatever you want to do, which is in show. So what we are doing is, instead of creating another class, we are using anonymous inner class, and we know how to use this, right? And then I can print show here. Let's see if this works. Compile and run. You can see we got in show. Now, since it is a function interface, now we are talking about Java 8 features. So till this point, everything was good till Java 7. Now in Java 8, they have done something awesome. They made sure that Java is no more verbose. Now what is verbose means is specifying everything, making a detailed code. It's good most of the time to read the code, but sometimes, you need to shorten the code to reduce the number of lines, to reduce the bugs and all those stuff. So in Java 8, we got this amazing feature called Lambda expressions, and we can use Lambda expression only with functional interface. Now let's try to use Lambda expression here. So what we are doing is we have a functional interface, and then we have discussed about it. Functional interface is an interface which only has one method. And then we were able to instantiate A with the help of our anonymous inner class. And yeah, we were able to call the method. Now, how do we use Lambda expression here? Now, Lambda expression says we just simplify the anonymous inner class, okay, only for Lambda expression. Now see, if I tell you, okay, just try to imagine this. If I tell you that there's an interface called A, and there's a method called show. So in your mind, there's an interface A which has a method show. And if I ask you to do this, if I say, try to complete the sentence. If I say A obj equal to, now in your mind, A obj equal to means there should be new A, round bracket, curly brackets open, and then public void show. Now, how you know that this is new A? Because it's A object, right? We're trying to instantiate the interface here. Of course, you can't instantiate the interface, but we're trying to instantiate a class of interface here, a class which implements the interface. So basically, when you say A obj, this is something you can imagine, right? This is something you can think about. In the same way, now since you're talking about the interface A, which only has one method, you also know that the method name is show, which returns nothing. It's a void type, and it's also public by default. So from here till here, you know it, right? So if you know it, even compiler should know this, right? Why you as a programmer need to type this code? What if Java says, hey, don't worry, I'm there. You just don't have to type all those things. You just say bracket open. I will understand what you're trying to do. The only thing is you have to put that arrow here. That's it. This is called a Lambda expression. This arrow here is a Lambda. Okay, and this is the entire expression we have. Okay, so just to redo the same stuff, what we are doing is we are removing from here till here, and since we are removing this one curly bracket here, we have to remove this one as well. So first let's remove that curly bracket, and then we'll remove the entire part from here, and then we have to put an arrow. So by doing this, we are asking our compiler, hey, I will not type the code. I will simply say A obj equal to, it's your job to complete the sentence. See, behind the scene, the compiler will do it for you. It's there. Behind the scene, new A, public void show is there. It's just that syntactically, the code is getting reduced. This is called a syntactical sugar, right? Where you are reducing the code. Okay, so this is how it looks like. And also, if in this method you only have one statement, see if you have multiple statements, you need curly brackets. But if you have only one statement, you can skip that as well. In fact, you can skip the semicolon as well because it's not doing anything. And you can write everything in one line. And look at the beauty. You can reduce the code just like that. And I know you still have that doubt in your mind. Will this work? Let's try. And it's working. You see that this is Lambda expression. Okay, can we do something more with this? Of course, I want you to re-watch this video, the cutting part, and try it out. Now can we do something else here? What if the show method actually accepts a value, which is, let's say, int I, okay? And then from here also you have to pass the value. The only problem is, how will you accept the value here? Now, instead of making the changes here, what I will do is I will just go back to our previous syntax so that I can show you step by step what we are doing. Okay, so again, I'm passing an integer I here, and then we have to pass the value here. Now, this is not a method which is not taking any parameter. We are taking a parameter, so you have to accept it here as well. So you have to say int I on any variable name, doesn't matter. And then whatever you want to do with that variable, that's your choice. Let's say I want to use it. It's your choice if you want to use it or not. But I'm printing in show I, the value, whatever the value of I is, which is 5 in this case. Let's try to run this code to see, is it working? Yeah, it is working. You can see we got 5. Now, can I use a lambda expression here? And the answer is yes. What you can do is, again, from here till here, we don't need that. And we can remove this curly brackets as well. The only thing you have to do is you have to put an arrow here. We don't need this semicolon. We can just put everything in one line. And that's what we have done. And yes, even if you have variables, you can do that. Not just one variable. If you have multiple variables, you can put multiple variables here. Let's say int j as well. And then here also you can accept int j. It's just that you have to pass 2 values. Let's say 5 and 8. We are not doing anything with j, but it's your choice if you want to use it or not. As of now, we are working with only one variable, so let's stick to that. Let's pass only one value, and let's write only one. Let's see if this works. Compile and run. It works. You can see that we got in show 5. Now there's one more thing. You don't even need to mention the type of the variable. You know why? It's because we have mentioned it here, right? When you know that the variable type is int, why to mention it? Okay. And one more thing. If you have only one variable, you don't even need this round brackets. You can simply mention the variable name here. Oh, we have reduced the code so much. Okay, so let's try to compile this code and run. It works, right? Now, let's do something more with this. Now, let's say, what if you have a method which returns something? What if you have a method which accepts multiple values? So let's try to do the example for that in the next video. But if you see the files here, okay, this is the older one. Let me just delete all the class files. Just to keep it simple, delete. And let's recompile the code here. Compile. The moment you compile, you can see it is creating only 2 files. A.class and demo.class. Of course, behind the scene, there is an anonymous class, but it is not creating a class file for you. So it saves the amount of files which you create. Of course, the demo.java file will be quite heavy now. If you compare the file size before using lambda expression, after using lambda expression, the demo file size will increase, but it will not create a new file. Okay, so less files to manage. Okay, so that's how we use lambda expression here. So let's try to create some more methods which return something else. So let's say, instead of creating show, let's work with add, which returns an integer value. It will take 2 parameters, int I and int j, right? Let's say we have this. And even before we go with the lambda expression, let's try to create normal objects. I will say a obj equal to new a. And then you can also go with creating a different class, or we can go for an anonymous class. Now we are used to it, right? And the method name, which is public int add, which accepts 2 value, int I comma int j. And now you want to return I plus j, right? Of course, we can create a different variable. We can add, we can return. But again, just to reduce the number of lines, we are just saying return I plus j. Okay, and then once you have this, we can simply take the value in result is equal to obj.add, and we can pass 2 values 5, 4. Okay, and then we can print result. Simple stuff, right? Now, if I go back here and if I see if this works, compile and run, you can see we got 9. So this is working. Now, can I use a lambda expression here? Let's try. So first of all, let's remove the entire part here. This is not needed. And since we are removing this curly brackets, we can remove this one as well. So remove and remove. And then we just have to put a arrow here. Okay, I just missed one semicolon. Okay, so one more thing, as we know that this is optional. I mean, we only have one statement, right? So we don't need to put curly brackets. So we can remove that one as well. Things are working. Okay, let me just run this before removing it to see if everything is working. Compile and run. Oh, it's still working. And now I can do one more thing. We can remove these curly brackets. Now we can write everything in one line. As you can see, there's one thing. Whenever you have one statement and that to the statement is return, you cannot write return, just return. So you have to remove that as well. So whatever you mention here actually becomes a return type. Okay, so when you have one statement which is return, which is an expression, you can see I plus j is an expression, it becomes a return type or return value. One more thing, you can remove this int and int as well. And you can see the code is so small now. And that's the beauty of lambda expression. And one more thing, so let's say if you are calling a function or a method by passing the object, you can also pass the lambda expression. In fact, once we start with the topic of collections, we'll see that how do we pass the lambda expression as the argument. Okay, and that will be quite fun. So yeah, so even if you have a method which returns a value, you can still use a lambda expression there. So some points to remember, lambda expression only works with a functional interface. If you don't have a functional interface, it will not work. Because see, if you have multiple methods, let's say add and subtract both, and when you write this type of line, which method you are implementing? Is it add or is it sub? That's the confusion, right? And that's why it is not allowed. So lambda expression works only with the functional interface. So yeah, that's about a function interface which has a method which returns something. In this video, let's talk about different types of interfaces. So when you talk about different types, what are the options we have? So basically, we can divide the interfaces. So we'll say type of interface. We can divide interface into three parts. Okay. The first one can be, we can call them as normal interface. The second one is your functional interface. And the third one is your marker interface. Now this functional interface is also called as SAM. So why it is called SAM, we'll discuss in some time. But let's talk about interface here. Now when you talk about interface, at this point we know that in interface we can only declare methods, right? The thing is, after Java 8, we also got an option of defining the method in the interface, but we'll see that later. At this point, we only know that in the interface we can only declare methods. So all the methods in the interface are public abstract, right? Now, whenever you create the interface, which has normal interface where you have multiple methods, it is called a normal interface. So example, if you create an interface here, and let's say the interface name is ABC, and in this interface, if you have two methods or more, that is normal interface. So whenever you have an interface with two or more methods, that's normal interface. And by doing this, you might have guessed it, right? What could be the functional interface? Now, basically, before talking about functional interface, let's talk about SAM. Now, SAM stands for single abstract method. Okay, so that simply means if you have the interface, and let's say the interface name is ABC again, and in this interface, if you have only one method, that is called a single abstract method interface, which is SAM, and we can also call it as a functional interface. Now, why it is called functional, that we'll understand in the next video when we talk about functional interface. We have a separate video on that. And next one we have is a marker interface. Now, what is marker interface? A marker interface is an interface which has no methods. That's right, a blank interface. Now, why someone will create a blank interface is to update something to the compiler. So let's say if you want to talk to a compiler by saying, please allow this. Example, in Java, we have this concept of serialization, which means you can take the object and you can store the values of the object in your hard drive. Let me repeat. You can take the object, let's say object has multiple values. So we can create, let's say in your heap memory. Okay, I will do that here. So let's say in your heap memory, you got an object and this object has different variables A, B, C, and this has some values. Let's say A value is 10, B value is 20, C value is 30. And then if you want to save this data in the hard drive, let's say we have a hard drive here, and if you want to store this data, we can use a concept of serialization. And then you can destroy this object. The thing is, why we are saving this object is because what if you want to recreate this object later? So let's say when you're playing a game and when you're playing this game, you want to save the game. Now, when you save the game, let's say when you're playing this game, the game takes around 4 GB or 5 GB in your RAM. But when you save the game, it will not consume that much of memory, right? It will consume around in KBs. It's because when you restart the game after closing it, of course, when you restart the game, you will get a default values. Now, if you want the old values, you want to resume the game, you will simply load the current stats. So let's say after some time you close the game, now game is no more, but you have a file in your hard drive and now you restarted the game. The value for A, B, C will be 0, 0, 0. What you can do is you can load these values from here. Now this is called deserialization. So this is serialization and this is deserialization. Okay. Now by default, every object is not allowed to do that. So it is not allowed. Okay. You have to give the permission. How will you give the permission? So you can simply create a class and you can give the permission with the help of marker interface. So we have a lot of marker interfaces in Java, serialization or serializable. Then when you talk about the advanced part, also we have some interfaces, but it's important. Okay. So whenever you see an interface which is blank, that's a marker interface. And maybe in the upcoming videos, when you talk about some frameworks, we'll talk about different marker interfaces, but that's what it is. So what is normal interface, which has more than two methods or two or more than two methods? The functional interface, or SAM, only has one method. Now this is actually important for the upcoming videos, and try to understand this. Every time you have an interface which has only one method, we can use some extra features with it. In this video, we'll talk about exceptions. So before you understand exception, we have to first understand different types of errors. So basically when you talk about errors, we have different types for it. The first one is your compile time error. Now what these errors are. The second one you have is you have runtime errors. And the third one is logical error. Now how do we describe this? Let's say if I write a statement here, and if I try to print something, and if I make a spelling mistake, let's say if I make this as a capital P, of course your IDE gives you an error here, but even if you compile this code, you will get a compile time error. So it says error cannot find symbol print. Now this type of errors are actually easy to solve because your compiler will show you, hey, you made a mistake here. So this is capital P, this will not work. So you will know, okay, I have to make it small and then it will work, right? Of course, when you compile this code, you will not find any error now. So when you get an error like this is syntactical errors and also a compile time error, which are very easy to solve. The second type of error we have is runtime. What is runtime error now? In fact, let's talk about logical first and then we'll come back to runtime. Now, logical error means everything is working. There's no compile time issue, everything is working, and then what you did is you added two numbers. Let's say you added 2 plus 2. And of course, for this, the output you were expecting is 4 and the output will be 4. And that's very simple, right? But what if you did some calculation, not a simple code like this, you did a multi-line of code where the output is not 4, output is 5. Now it is working, there is no compile time issue, there is no runtime issue. It's not like at runtime it is getting stopped. But the output you are getting is wrong, right? So you got 5 where you wanted 4. Now this type of errors are called logical errors. Also sometimes we call them as bugs. So even this type of problems are actually difficult to solve because you need to do a lot of testing. If you heard about this, whenever you make an application, you have to test your application as well. So in that case, you will do testing, you will check for the inputs and outputs and everything. So maybe you will able to solve this problem. But the thing is, from the developer side, you do check compile time issues, which compiler will help you there. You do proper testing where you can solve logical issues. Now, once everything is tested, you can ship your product to the client and client is happy. There is no compile time issue. There is no logical issues. Now, runtime issues are a bit different. The problem is, in runtime issues, what is happening is everything is working. I mean, compile time issue, no problem. Your code is working as well. But suddenly, because of some reason, the code just stopped working. You got errors. Okay. Basically, whenever you get errors, runtime errors, your execution normally stops, and that's an issue. Let me give an example here. So let's say you made an application where your application opens a file, a TXT file from a C drive, okay, or maybe a home folder in Unix system. Till this point, it was working because the file was there. And now let's say you deleted that file. So yesterday night you were doing some experiment with your system, and then the file is no more. And now today when you are trying to use the application is trying to find the file. The file is not there. It will give you a runtime error. The execution will stop in between. Now you will say, what's the big issue, right? You can restart the application. Yes, you can. And everything will work provided the application is not that critical. If you are using a calculator and calculator stops in between, that's okay. You can reopen it. When you're playing a game and suddenly the game stops, you can do it. But let's say you are into a game battle where you will get, let's say, $1 million if you win, and suddenly your game crashes. Now we don't want that, right? We can also go for some applications which are critical. Example, let's say if we talk about medical softwares, you have all those scanning machines, and then where you go inside the machine and then it scans, right? It throws some rays or some things. I'm not sure about medical terms, but what if the software just stops in between? Risky. What if you're in a plane and then the plane software stops working? Very, very critical, right? So you have to make sure that even if you get the errors, runtime errors, it should not stop your application. I'm not saying there will not be a runtime error. I'm just saying we need to handle the runtime errors. So these runtime errors, we can call them as exceptions, and basically we need to handle the exceptions. Okay, so handling the exception is very important, and that's what we are going to do in this set of videos. So in this video, we have talked about what is exception. So exceptions are basically runtime errors. It's not like we are going to stop the runtime errors. Of course, we'll try to check for the conditions. When you try to open the file, first you have to check is the file exists. If the file exists, then you try to open the file. Those are the things you can avoid runtime errors. Let's say you're dividing a number by 0. So when you divide a number, and if you divide it by 0, it will give you exception, runtime error. So even before divide, if you can check if the denominator is non-zero, then divide. So those are the checks we can do. But in case if there's an exception, you have to handle it. Now let's try to handle the exceptions. So now we know what is exception. Let's try to handle them. So what I will do here is, first of all, let's create exceptions, right? That's why then we'll know how to handle the exception. Now, even before we talk about handling the exception, what type of statements we need to handle? So for that, what I will do is, let's talk about statements. See, statements can be of two types. Statement can be of a normal statement, and a statement can be a critical statement. Okay. See, in real life as well, we try to think about situations which are normal, and we try to think about situations which are critical. Example, let's say if you're walking with a kid on the street, or let's say in the mall or in the restaurant, and then of course you will grab the hand of a kid, right? But what if a kid just runs? In that case, if it's a restaurant, you will not be that panicked, right? You will try to say, okay, kid is roaming around, and then you will try to catch the kid. But what if the same situation happens on the street, a busy highway where you are holding the hand of a kid, but kids try to run? In that case, you will jump to grab the kid because that situation is critical. In the same way, when you talk about statements, it can be normal statements and critical statement. Example, if I write a simple statement here, which is int I is equal to 9. Now this statement is normal statement because we know what may go wrong here. Everything looks good, right? So this is a normal statement. But what if you say int j is equal to I divided by, or maybe I can say 8 divided by I. Now this statement can be critical if you look only this statement. Now why this is critical is because if the value of I is 9, that's completely fine. You will get the output. Example, if I just come back here and if I try to print the value of j, in fact, you know what I will do? I will just make this 18 so that you will get some output instead of 0. Compile and run. This works, right? But what if the value of I is not 9, it's 0. Now in this case, first of all, let me just clear the screen so that we can see the output properly. And you can see we got an error. It says exception, runtime error. Exception in thread main, which is, the exception is this, arithmetic exception. So if you can see, it's arithmetic exception and the message is divided by 0. Now the moment it happens, it actually stops the execution. Let me show you that. If I try to print by here, you will see if I try to run this code and run, you can see it is not printing by. The reason it is not printing by is because at this point, the execution has just stopped, okay? So that's why it is always better to handle the exception. Even if you know nothing may go wrong, if you think that's critical, handle it. How? That's a question. To handle the exception, what you can do is, you can put this type of statements in some other block. Now, first of all, let me just declare the variable here by 0. And then this is a statement which is critical, right? So what I will do is, I will just put that in a separate block. So I will put that in a separate block, something like this. And now what I'm saying is, hey Java, just try to execute this code. Okay, if it works, that's fine. Otherwise, execute the other part. Don't stop the execution. The way you can do that, you can say, hey Java, try to execute this statement. So I can say try to execute. Okay, so Java will say, okay, now I know that you are just trying to execute. If it's not working, then I will continue with the normal execution here. But then what if Java tries to execute this and there's an error? In that case, it will throw the error. And you, as a developer, you have to catch the error. So in this case, you will catch the exception. The moment it throws the exception, it is throwing you an object and you have to accept it as an object. So you will create an object or you will refer that with an exception class. So this exception here is a class and you are referring that with any object will do. It's not just E, you can say obj as well. But most of the time you will say E because it makes sense, right? Exception E. You can say obj as well, that perfectly works. But let me say E here. And if you want to print something, you can do that here. So whatever handling stuff you want to do, you can do that in the catch block. So I will simply say something went wrong. Okay. So what I'm doing is I'm trying to handle the exception. If it works, that's great. If it is not working, it will execute the catch block. Now let's say the value of I is not 0. The value of I is, let's say, 4. In this case, you can see there's no exception. So let's try to execute this with the value 4. And if I run this code, you can see it says 4 and by. There's no problem with the value. We got 4 because of this statement. And we got by, of course. But then what if something will go wrong? What if the value of I is 0? Now in this case, this will throw the exception. So it will execute the catch block, and I'm expecting it should print something went wrong. Let's try, compile and run. Oh, can you see that? It says something went wrong. Now even if something goes wrong, the execution is still happening. The value of j is 0 because before the execution of this try catch, the value of j was indeed 0. Right? That's how you handle the exception. And again, you don't have to put all the statements here. You can put normal statements in try as well. That completely works. But it's better to put only critical statements inside try block. And you can write multiple try blocks. So one we have it here. What if you have some few more statements here? You can try catch that as well. That works. So I hope you got the idea what is try. Try will basically try to execute the statements. If everything goes good, it will execute the remaining statement. If something goes wrong, if there's an exception, it will execute the catch block. So point to remember, the catch block will be executed only in case of exception. Otherwise, catch block will be skipped. So that's it from this, where we talked about try catch and we have seen how to handle the exception. Okay, so we know that to handle the critical statement, we have to use try block, and inside that, if something goes wrong, it will execute the catch block. Otherwise, it will simply execute the remaining statements. Okay, that makes sense, right? Now what I will do is, I will try to print the exception as well. So that's why you can actually print the exception. So we are saying something went wrong. Let me just remove one dot from here so that we can save some space. And after this, I want to print the exception as well. I want to see the message, what it says. So to do that, what I will do is I will compile this code and run. You can see it says something went wrong. Okay, that because we are printing that. Apart from it, the message which you are printing here, which is E, it says arithmetic exception. Oh, okay. That means apart from exception, we also have arithmetic exception. Cool, that also makes sense. So just try to remember this point that apart from exception, there is one more class here which is called arithmetic exception. We'll see that in some time. Now what I will do is I will try to create some more exceptions here. One of it is this. If I create an array, let's say the array is of type integer and let's say nums, and I will say the size of this array is, let's say, 5. Now in this case, when you have a size 5, of course, by default, all the values are 0 of this nums. And you can fetch the values. Let's say at this point, I'm trying to print the value of nums of 0 or 1, let's say 1. Of course, it will be 0 because the values are 0. And I will also try to print the nums of 5. Now see, when you say nums of 5, what value you will get? Now, first of all, the size of this array is 5. And then if you are saying you're trying to fetch 1, that means you're fetching basically second element because the index number starts with 0. So 0, 1, 2, 3, 4. Oh, so for the 5 elements, the index number ends at 4 and we are trying to get the value from 5. Okay, so basically we are going out of bound. Okay, so let's see what happens if we do that. First of all, I just want to make sure that I don't have this exception 0 here, or maybe let's keep it 0. I will say compile and run. Of course, you will get an error because the dividing number, which is I, is still 0. Let me just make it 2. See, the problem is the moment you get exception here, it will directly jump out of this try block. It will not even execute the remaining try statements. Okay, and that's why we have not seen those outputs. Now what I will do is I will just try to compile this once again and run. This time, if you can see, we got a different exception. Yeah, it says something went wrong. That actually makes sense because it is executing the catch block. But look at the exception. The exception is array index out of bounds exception, which means the size of your array is limited and then you are trying to access the element outside it. And it says that. It says index 5 is out of bound for the length 5. Okay, makes sense. So basically, apart from arithmetic exception, we have array index out of bound exception as well. But I have only one issue. The issue is why we are printing something went wrong. See, you try to show the message to the user as well. And if you can see the problem is with the user. What if the value of I is coming from the user? What if the value of this 5 here, nums of 5 is also coming from the user? Now user is not sure what is the problem here. It says something went wrong. You have to be very specific here. You have to say, hey, you cannot divide a number by 0. So user will know, okay, the values which I'm entering is actually wrong. I should not be entering a denominator which is 0. Okay. Or maybe you can say, you're trying to access the element outside the array. The user will know that, you have to be in your limit. I want to print a customized message here. So if I print here something like this, if I say cannot divide by 0, that looks like a good message. Okay, let's not print this E anymore. Let's only print cannot divide by 0 and let's see what happens. Okay, clear. And I will keep the same error. The error is still with the array, not with the denominator. But if you run this code, you can see it says cannot divide by 0. Now that's weird because I'm trying to fetch the value which is outside the limit and it says cannot divide by 0. That's wrong. The error makes sense when the value of I is 0, right? So if I compile this code and run, now this works. You can see it says cannot divide by 0. But then if the value of I is not 0, in that case as well, it is printing cannot divide by 0. It's because the moment you get the exception in try, it can be from this statement or this statement, it will execute the same catch block. And in the same catch block, we have the same message. See, what you can do is before printing, you can actually check if you can check the type of this E, is E arithmetic or is E array index out of bound, and then based on that, you can print a different message. That's one way. Or what you can do is, you can ask your Java itself, hey Java, I want you to handle different exception. So you can be very specific here. Instead of saying exception, I can say it is arithmetic exception. Now I'm being very specific here. I'm saying, I'm not talking about exception, I'm talking about arithmetic exception. When arithmetic exception arises, print this message. But what if there's an array index out of bound exception? Let's see if we are able to handle that. So if I compile this code now, okay, first of all, let me just make this I as 0 and let's see what happens. Again, I will compile and run. You can see it says cannot divide by 0. That makes sense because we are able to handle the exception. And you can see we are printing by as well. That means we are handling the exception. But if you make this as 2, and if we try to compile this and run, oh, you can see that we are not printing by. There's an exception. You can see there's a cross symbol as well. It says array index out of bound exception. That means we are not handling it. Even if you mention that in the try block, if you don't have a catch block for it, that means you are not handling it. How do we handle that? So in that case, what you can do is you can write multiple catch block. So you can write catch here. And in this catch, you can mention array index out of bounds exception. That's right. We have to create one more catch block in which you'll be having a different type of exception. And here we can print stay in your limit. Again, I'm just trying to be witty here, but you can print appropriate message, whatever you want to. Now, if you try to see what happens, if I compile this code once again and run, you can see it says stay in your limit. There's no abnormal exit of the code. It is executing everything. And this time it is executing the catch block, the second catch block, not the first one. But what if you make this 0? Then, and again, it goes in sequence. Okay, so in try block, it goes in sequence. It will first execute this statement, which may throw arithmetic exception. And if that works well, it will go for this one. This might throw an exception, which is array index out of bound exception. So let's see if that works. Compile and run. You can see it says cannot divide by 0. So you can basically have two different exceptions here. Now, what if there is another type of exception here which we are not sure about? There are a lot of exception classes. It's not like we only have these two. In fact, in the next video, we'll try to understand some of the famous classes or famous exception classes. We'll try to work on that. But at this point, there are multiple exceptions and we are handling only two. It's always a good idea to handle all the exception, but we are not sure what exception it can arise. So in that case, to be on the safer side, at the end, you can handle something with exception. Now, exception handles everything. If you remember the concept of inheritance, where you have a parent class, child class, so exception is a parent class. It can handle all the exceptions. Okay. Now you can say something went wrong because even you are not sure what went wrong. So you can say something went wrong. Now, if there is some exception which you are not handling, in that case, it will execute this part. To give you an example, let's say I create a string here, string str, and let's say the value of str is null as of now, and by default it will be null. And then here, what you're doing is you're trying to get the length of this string. So what you can do is you can print string str.length. Now, if you try to find a length on a null string, it will give you a different type of exception. First of all, I just want to remove this exception. I don't want exception on line number 13. I just want it to work so that it will execute this line, which will give you exception. And let's see what happens. If you say clear and compile and run, it says something went wrong. Now, what went wrong is because there's a new type of exception. In fact, here it's a good time to actually print E, because it should print something, some exception, so that we'll understand. I'll try to print this, and you can see it says something went wrong, because that's what we are doing here. And then it prints the exception, which is null pointer exception. Now, this is one more exception. Like this, we have a lot of exceptions, and we'll understand that in the next video. But then before that, we have one more thing. What should the sequence here? The sequence is, whenever you have a child and parent, make sure that your parent is at the bottom. So you can see exception is a top class, right? Parent. Let me show you how it looks like. So if I go to arithmetic exception, now arithmetic exception is a class which extends runtime exception. So runtime exception is a parent class for arithmetic. But if I click on runtime exception, you can see it extends exception here. So exception is a parent of parent. And in fact, this exception actually extends throwable. So there's one more class called throwable, which is like the topmost class. And yeah, so that's how basically the hierarchy looks like. In fact, I will show that in the next video as well. But make sure that you have at the end. But if you try to keep this on top here, it will create an issue, because the exception can handle everything, right? At this point, if you get the exception, it will try to search for a catch which can handle this exception. And it looks at exception by saying, hey, exception can handle everything, right? Then why we even need this too? And that's why it says, it says this exception cannot, it's unreachable. Can you see that message there? It is unreachable because everything is handled by this exception. So it's a practice, or it's compulsion to have the parent class at the end. Now, as we have seen, exception is a superclass, right? And in that we have a lot of subclasses. Now let's try to understand the entire hierarchy. In fact, we'll not talk about all the classes. Let's try to give you the general idea. And with this idea, you'll understand, okay, what class belongs where and which exceptions are compulsory to handle and which are not. Okay, that's an important point to remember. So on top, we have the object class. Now, why it's on top? Because every class in Java extends object. Even if you don't mention, it's there, right? So let's give the respect to object class. Now, below that, we have one class called throwable. Now, if you remember, while searching for the class, we have seen exception class extends throwable. So that's on top. One more trivia here. Most of the names which ends with able are actually interfaces, okay? Runnable, serializable, clonable. But coming to exception, throwable is also able at the end, but it's a class. Okay, that's the only exception which I have seen till now. Now below this we have two, and okay, that sounds weird because we have only seen exception, right? So we have exception here. And apart from this, we have one more which is called error. Okay. Now, why we have not talked about error yet? We are only talking about exception. The thing is, when we talked about runtime exception, we have mentioned that it is something you can handle. Okay. So exceptions are something which you can and you should handle. Errors you can't. Okay. When the errors hit, it will simply stop the execution. Normally it doesn't happen, but if it happens, you can't do anything with that. Example of this, it can be the thread dead. What if your thread dies? Example of this can be IO error. Something goes wrong with the input output. We have a few more, which is your virtual machine error. It can be one of the example I can give you here is what if you have out of memory. So what if your memory is not there? So how can you handle that? Okay. So this type of errors you can't actually handle. So this is something, it's there. It will not happen, but we cannot handle that even if it happens. What you can handle is exception. Now in exception as well, we have multiple options here. So we have the first one, which is runtime exception. So we have the subclass of exception is runtime exception. And on the other hand, we have a lot of different exceptions here. Example of this could be SQL exception. Example of this could be IO exception and many more, but we are just trying to understand the simple one. So we have this too. We have many more, as I mentioned. Now in runtime exception also, we have a lot of different exceptions here. We have seen most of it. In fact, we have seen arithmetic exception. Then we have array index out of bounds exception, and then we have null pointer exception. Now all this comes under runtime exception. This is null pointer exception. Now the thing is, why you have to remember this thing? Not everything you have to remember, but few of them. See, all the runtime exceptions are actually called unchecked exceptions, and all the other here on this side, they are called checked exception. Now why they are unchecked and checked? Most of the time when you write the line, your compiler will not force you to handle the exception. Okay, it will say, hey, it's your choice to handle the exception. So all the runtime exception, all the classes here, it's your choice if you want to handle them or not. But whenever your compiler sees that there is a line which can raise an exception which is not runtime exception, example, it can raise a SQL exception, IO exception, in that case, it will ask you compulsory to handle the exception. If you remember, when we were trying to load the class with the help of class.forName, on the right side of the method we have mentioned, it throws the IO exception, right? So it was forcing you to handle it, okay? Okay, we have not talked about throws yet, but we'll talk about it. So basically, these are all checked and these are all unchecked here. And there's something you should not be worrying about. It will not happen most of the time. And this is something you have to handle by yourself. So I hope this diagram makes some sense. This is the top class, which is there in every Java code. And this is your throwable, which is a parent class of exception and error. In exception, we have a lot of different exceptions. If you get SQL exception in your code, you have to handle it compulsory. IO exception, compulsion. Apart from this, if you have a runtime exception, it's your choice to handle it or not. But as a good programmer, if you want to keep your client happy, please handle the exceptions. Now let's try to understand a keyword called throw. Okay, so basically we have two keywords here. One is throw, second is throws. We'll see them one by one. So what I will do here is, first of all, I will just reduce the number of lines we have so that it will be easy for us to understand. I will remove all the exception. Okay, I will stick to 1, which is divided by 0. And let's put only one statement here. Let me also remove this one because it's not needed. We only want 2 exception, arithmetic, and if something goes wrong, which we have not handling, that will be handled by exception. Okay, so let's say when you divide this number, of course, the value of I is 2, so everything is good. And you know, most of the time people will put curly brackets on the same line and it normally works. And this is basically preferred. Okay, so let's say when you do this execution, of course, there's no exception here because we are dividing by 2, right? So if I try to compile this code and run, everything is smooth. You can see we are dividing the number 18 by 2, which is 9, and that's what you got here because we are printing the value of j, and then we are printing by. Everything is normal. Now the thing is, what if I'm dividing this number by, let's say, 20? Now, in this case, when you have a greater number, of course, you can divide 18 by 20. Now, the quotient here would be 0. If you can see, the value is 0. And there's no exception. But what if you want to create or you want to generate an exception? Maybe you are doing something here. Let's do this thing. Let's say the value of I is 0. So, of course, you will print cannot divide by 0. Now, instead of printing cannot divide by 0, what you can do is, let's skip this part. Let's say, let's not print any error. Let's handle the error. If someone is trying to divide a number by 0, I want to divide the number by 1. 18 divided by 1. Okay. So what I'm doing is I'm not printing anything. I'm just trying to handle it. It will print some output. So if I compile and run, you can see it says 18. Okay. I don't want to print error or something. If someone enters a denominator 0, I will say maybe I can also print here. That's the default output. So that if it prints 18, it will also print that's a default output. If you can see, if I do that. So it will say that's a default output and it will print 18. Okay. Now, what I want is every time there's an exception, it should do this thing. So it's not just about printing the message. You can actually handle something. Example, let's say if you're trying to connect to our internet and then the network is not there, of course, it will throw the exception. So instead of sending a message to the user, we were not able to connect to the server, you can simply retry, right? So what you're doing is you're trying to handle the exception. Here, we just tried. Of course, this is not a good logic. I'm just trying to make you understand how we can do it. One more example. Let's say you have 2 databases. One is a primary database, second is a backup database. You're trying to connect to a primary database and something goes wrong. Of course, you will not simply tell user, hey, we are not able to connect to the primary database. You will simply try to connect with the backup database. And that's what you can do in the catch block. That's what we are doing here with this logic. Now let's say you are dividing a number by 20. Now in this case, it will print 0. Okay. But what if you don't want to print 0? You want to print the default output is 18. Maybe you want to do that. That means what I'm saying is, even if the catch block is not getting called, I want to call the catch block. Because in the catch block, you're basically trying to handle the exception. And if you don't have the exception, it will not call the catch block. That is not something we want. So to solve that problem, what you can do is, you can basically check if the value of j is 0. Okay, because we don't want 0. In this case, if the value of j is 0, you can basically call the catch block. But how do you call a catch block? Catch is not a simple function, right, where you can write catch by passing a message. No, it's not a normal function or normal method. What you have to do is you have to basically use a keyword called throw, and you have to create an object of arithmetic exception. So you can do that. You can simply say new arithmetic exception. It's a class, right? You can create the object. It's that simple. Now what you're doing is you're basically trying to create an error here. You're trying to throw the error. So this is the exception you got the object, and you are throwing. Now since you are throwing, catch will catch it. Okay, let's see if this works. Compile, no issue, run. Oh, can you see that it says that's the default output. It is printing 18. So you got 0 here, but then we are checking. If it is 0, then throw the exception. Okay, maybe you want to connect to another database which you have written the code in the catch block. So you can do that here. Okay, you can literally call the catch block with the help of throw keyword. There's one more thing. What if you also want to print the message? Somewhere here you want to print E. Now by default, if you try to compile this code and run, yes, it will say arithmetic exception, but you can see it is not printing the message. I want the message as well. Remember it was printing slash by 0 or divided by 0. I want to print such messages. So you can actually pass a message in the constructor. You can say, I don't want to print 0. Okay, something like that. Whatever your message you want to send, you can do that in the constructor. So you can say, it says, this is your message. I don't want to print 0. So if you want to send a message, put that in a constructor. It will do it for you. Don't worry. You don't have to manually go and type the message. So whatever message you have, every time you create this object, you can pass the message. And that's how we can use a throw keyword. So just to reiterate, throw keyword is used to throw the exception, okay? And then catch block will be catching it. Now basically we were able to throw the exception here, right, which is arithmetic. Now if you can throw the exception, and what if you want to throw your own exception? Let's say I don't want to throw arithmetic exception, I want to throw my own exception. Can we do that? Can I say my exception? You can see straightforward it says my exception cannot be resolved. That's right, we don't have any class called my exception, but I want my own exception here. Or maybe I can say, instead of my exception, I can say Naveen exception. You know what? Naveen actually means new. Okay, so it's a term which means new. Okay, anyway, so I want to have a new exception here. The way you can do that is by creating a class which is called Naveen exception, and done. Oh, okay, we have to also create a constructor because we are sending a message. So what I will do is I will create public Naveen exception which accepts a string str. Okay. String, that works for me, and still it is not working. It says no exception of type Naveen exception. Oh, I have created a class, right? The class is there. What's the problem? I have created my own exception and it's not accepting it. See, the thing is, you can't simply create a class and call it as exception. See, exception needs special features, right? And we all know if you want to get something, you have two choices. You can actually build something, or you can just get it from your parents. So I can simply say extends exception. So what we are doing is we are getting all the features from the exception. Okay, so you can say Naveen exception, extend exception, and now it is not crying. Okay. Now the only thing is, if you try to compile this code, okay, not this one, compile first and run, it says something went wrong. Oh, that's weird. Why something went wrong? I want actually to print. Oh, okay. The thing is, you are throwing Naveen exception, but you're not catching Naveen exception. I want to print this one. That's a default output. So what you can do is, instead of Naveen arithmetic exception, you can say Naveen exception here, and you can accept the object, and then you can print this message. That's the default output. And also you want to print E to get the message. The message is this: I want to print something. Now if I try to compile this code again and run, oh, it works. Can you see that? It says that's the default output, and the error is Naveen exception. Okay, that's good. Where is this message? I don't want to print 0. The thing is, the message which you have sent actually is received here. But this output, when you try to print E here, is actually handled by the exception class. Okay, this should know that you are accepting a string. So what you can do is, if you go to exception, even exception has a constructor which takes a string, and we all know how to call a superclass constructor. We have seen that, right? So I can simply say super and pass this message. So whatever message you are accepting here, just pass the message to the exception and they will take care of it. You don't trust me? Let me show you. Can you see that? It says Naveen exception and it prints the message as well. The message is, I don't want to print 0. So that's how it works. You can create your own exception. So just to reiterate, Navin exception is not a part of Java. I'm creating my own exception, and yes, you can do that. The only thing is you have to create a class with the exception, and this class need to extend exception or runtime exception, your choice. Let's try with runtime exception. And if I clear this, compile, run, it works. You can extend exception or runtime exception. And the only thing you have to do is if you're accepting a message, you have to pass the message to the runtime exception constructor. And that's how it works. Now in this video, let's talk about throws keyword. So we have talked about throw keyword. Now it's time for throws. Now this is not a plural form of throw. It's not like if you want to throw multiple exceptions, you will be using throws. A lot of people have this confusion. Throws has a different working. So before you understand throws, what I will do is, let's talk about a scenario. Let's say you are writing a method. So let's say the method name is D. Now, of course, in this method, you will write certain statements, right? And it is possible that all these statements, there is one statement here which is critical. So let's say this statement is critical. And we know whenever you have a critical statement, it is always better to write try catch. So let's say we have a try here for this, and we have a catch block as well. So just try to imagine this in a coding perspective. Let's say we have a statement which is critical, and then you try to handle that with the help of try catch. And we're doing that in a method D, okay? And let's say we have one more method here which is called E. And in this method as well, you are writing some statement out of which there is one statement here. Let's say the first statement itself, which you need to put that in try catch. Okay, because this statement is critical. Okay, so if you observe, we have two methods here, which is D and E. Both have a statement which is critical. Now, of course, it makes sense to write try catch in each of the method, or we have one more choice here. What you can do is, let's say we have a method which is C, and C method is calling D and E both. Okay, so C method is calling D method and E method. Of course, in C, let's say we have some more statements. Let's say we have method C, and in this you have multiple statements, out of which the two statements are calling D and E. Of course, you can call methods, right? And then we have some more statements here. Now, if you try to observe the situation, what we are doing is we are trying to handle try catch by ourselves, right? In the D and E. But what if you could say, hey, you know what? D and E both have the same exception. So both have a critical statement. They will rise the same exception. So instead of handling those exceptions inside try catch in each of the method, can we just handle the try catch in C itself? So what you can do is you can put try here and catch. So when you are basically calling those methods D and E, you can put them in try catch because both of the methods has a critical statement. In fact, the entire method becomes a critical methods, right? Because when you're calling it. So instead of handling those things here, let's not handle using try catch here. Yes, we have a critical statement, but will not handle the exception in D and E. You can handle the exception in C. Okay, but then even if you work with this, it will give you an issue. It will say, okay, there's a problem with D and E, but still it will stop the execution. So one thing you can do is you can write here throws. So you can say throws exception, and same goes here. You can say throws exception. Okay, so by doing this, what you're doing is you're saying, hey, whatever problem arises in D and E, they will not handle it. They will just send the exception to the method who is calling it. Sometimes we just call ducking the exception because we are ducking it. We are not handling it, the method which is we are into. Let's say D and E says it's not my responsibility. So the method which is calling D and E, which is C in this case, will be handling those exceptions. Okay, and in C, of course, you have to have try catch. If you don't have a try catch in C, it will again create a problem for you because it will stop the execution. Now we have one more thing. What if you're not doing try catch here? So of course, some method will be calling C, right? So let's say B is calling C method. Okay, now in this case, what you can do is you can put try catch here. And let's say if you don't want to do try catch here, we have a main method. Now, let's say main is calling B method here. Even main can have a try catch. So basically, you can go up the ladder and you can write try catch in whatever method you want to write. So if you write try catch in main, then B says, okay, even I will throw the exception. C will say, even I will throw the exception. I will not handle the exception by myself. C will say, I want B to handle it. B will say, I want main to handle it. And of course, your D and E both says C will handle it. Okay. Now that is called ducking the exception for a particular method, but it is done with the help of throws keyword. Now this makes sense for checked exceptions, okay? See, for unchecked exceptions, it's not compulsion for you to handle the exception, but whenever you have a checked exception, example, if you talk about IO exception, okay? Now, in terms of IO exception, which happens when you use input output, let's say you're reading something from the file or you're writing something to the file, or when you're doing SQL, which is database connectivity, at that point as well, when you're firing a query, it might raise an exception. In that case, you will be getting a checked exception. And we know, we have talked about this, in checked exception, if you write that statement, it is compulsory. Example, remember we have worked with one of the thing which is called class.forName, and in which you can mention the class name. Let's say my class name here is demo itself. So basically what you're doing is you're writing this statement, and this statement says it might throw, or it will throw, a class not found exception. Now, class not found exception is also comes into hierarchy, where this is a checked exception. So it is asking you to compulsorily handle this exception. So you can put that in a try catch. So you can put that here and you can say catch. Now, which exception we have to handle? The name of the exception is class not found exception, and you can print not able to find the class. In fact, let's write a class called calc here. And you know, we don't have a calc class nowhere. Okay. Now, if you try to run this code, compile and run, you can see it will say not able to find the class. Now, which class we're talking about? Calc class is not there. In fact, I can also print the error message here with this. So compile and run. You can see it says class not found exception. Which class? Calc. It's not there. But if you do it for demo, there is no issue because we do have a demo class here, right? So if I compile this and run, you can see it works. It says the default output, blah, 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 but there's no exception. There's no problem with this, okay? So in fact, we can also put this, we can just cut this part, and let's say we are doing that in a separate method. So let's say we have a class A, and in this class A, we have a method which is public void show. And in this show, we are doing this. We are trying to load the class demo here. And of course, we have to call this. Now, what I will do is I will just try to remove everything else so that we can make our code simple and remove this custom exception as well. And you can see we have a very simple code now. And if you want to work with show, of course, you have to get object of A. You will say A obj, and then you will say obj.show, okay? And now, if you try to work with this, when you say compile and run, you can see there's no problem because anyway, we are not printing anything. We're just trying to load the class. Of course, if you write a static block here, that will surely work. Let's try to do that as well because we have seen this. Let's create a static block and I will print class loaded. In fact, you know, the weird thing is, anyway, we are writing main method, right? So the class will be loaded anyway, but still, we're just trying to see if we get some output. Again, the class loaded is not happening because of the load. It's only because the main method is there in the demo. So anyway, it will be called. But the idea is we are trying to print something. But what if I try to work with a class called calc? Now, in this case, if you try to work with calc, it will give you an exception. You can see it says not able to find the class, which is calc. Okay, cool. And now, what if I don't write try catch? So what I'm doing is I'm saying, hey, I will not handle the exception. So in this case, you can simply go back to shows and say throws class not found exception. And you can see there's no problem now because this statement knows that show is basically throwing the exception. So show says, I'm not responsible to handle the exception. You know, when you work for a company, there are some employees, they don't take responsibility of what went wrong. They will simply say, hey, talk to my manager, right? So the same thing is happening here. It says, hey, I'm not responsible to handle the exception. Talk to my manager, which is main because main is calling show. So it is main's responsibility to handle the exception. And that's why you can see we got an error here. It says unhandled exception. Okay, so now you have two choices. What you can do is either you can write try catch here or you can say throws class not found exception. Okay, so you have this choice. This is not recommended, okay? Never do that with main. Because if you see, when you're throwing the exception for main, the problem is, who is calling main? It's JVM. Now you are asking JVM, hey JVM, you have to handle this. Not a good idea because JVM will say, okay, if you throw it to me, I will simply stop the execution. So it's not a good idea to throw exception for main, but yeah, for other classes, let's say for show, because we know who is calling show. It's your main method, so main will be handling it. So don't write throws here, okay? You can just use try catch. In fact, you can ask your IDE, you can say quick fix, surround with try catch and done. You don't have to do anything here. And this might be new, print a stack trace. Basically what it does is it prints the entire stack, which method is calling which method, and you can actually track the entire method calls so that you know because of which method the problem has been arised. Okay, so if I compile this code and run, you can see this is the entire stack. So basically your main is calling show, and behind the scene we are calling class.forName, which is behind the scene is calling this and that. So there's a hierarchy of method which is getting called. That's what the print stack trace does. So it's helpful to debug the application, but it's also good if you want to print a message. Okay, so yeah, that's about ducking the exceptions and using this throws keyword. In fact, we are going to use this a lot in the upcoming sessions, so you will get used to it. Now it's a good time to talk about how to take input from the user. I know you have been waiting for this for a long time because we have talked about different concepts. And maybe you had this question in your mind, okay, everything looks good. We talked about objects, classes, inheritance, polymorphism, but how do I take the input from the user? Because in between as well, I've mentioned that what if this value comes from the user? And at the same point, you might be thinking, how? Okay, so let's try to answer that in this video. So basically, if you want to print something on the console, see this is a console, right? On the right hand side, whatever you have here, it's a console. And if you want to print something on the console, what you do is you say system.out.println, right? Now you have to understand this first. See, println is a method. Now, if I ask you just to think about it, println method belongs to which class, or it's a method of which class? Now, this is an interview question. A lot of people say that it is a class, it's a method of system class, but that's not the case. See, if I press my control button on Windows and command on Mac, and if I click on this, if I hover on this println, if I click on it, you can see it gives you its definition. It says println, and println method belongs to print stream. So print stream is a class, and println is a method of print stream. Okay, that means if you want to call println, you first have to create object of a print stream. But okay, don't worry, you don't have to create an object. The beauty is, the object is actually already created. Can you see that? We already have an out object, and that's why we are using this object from a long time. So out is the object of print stream, but this object is created as a static variable inside the system class. Okay, it's inside system class. Now, since it is static, so we can use out with the help of system.out. And once you have the access to the out object, you can call println. And that's what we have here, system.out.println. So if I want to print something, if I want to print, let's say, hello, of course I can do that. And I can just compile this code and run. It perfectly works. Now, let's say I want to take the input from the user. I have to say, hey, enter a number. Now, in this case, when a user enters the number, how will I accept it? That's tricky, right? So what do you think? What could be a solution here? What is a method we have to use? Now, by any chance, if you're coming from C, C++, we use cout, cin in C++. We use printf, scanf in C, right? And it's straightforward, right? They are straightforward methods. But in terms of Java, when you say system.out.println, it prints, right? It is out. And that's why it says out. It is outputting. So to input, there should be in, right? Let's see, do we have in? So if I go to system, and if I scroll down to out, yes, there is an out here, and need to find in. There is also in, if you can see. In is a static method, and this object in is of type input stream. Oh, we do have it. Okay, so if I go back here, and if I try to use system.in. Oh, there should be a method, right? Because to print, we have a print method. For the input, there should be read. Oh, there's read. Okay, great, it works. So you can see we have a read method. And read method returns a int value, right? It returns an int value. That's great. The only thing is it might throw an exception. And if you can see which exception, it's IO exception. And we know what is IO exception now. So you have a choice. You can handle the exception. And this is checked exception, which means you have to handle it. It's your job to handle it. Compiler will force you to do that. So you can either use try catch here, or you can be evil and you can say throws exception. Not a good idea, but it works for this code since we are learning, so we can do that. But when you are making an application, don't do that. Try to use try catch here. Okay, so system.in.read will give you the integer value. That's great. What I will do is I will just put that in a variable called num, because it returns a value, right? Read will give you the value. So you have to put that in a variable. And once you have the variable, you can perform any operation if you want, or you can print it. That's your choice. Let's go back here and compile. No problem. If you try to read, oh, it says enter a number. I'm excited. Let's enter 5 and enter. Oh, we got 5, but we also got 3. Now that's weird. I don't want 3 there. Okay, let's try another number. Let's see with 3. Oh, we got 51. What is happening here? The thing is, the system.in.read actually gives you the ASCII value for the number you enter. Example, let's say, if I run this code once again, and if I enter capital A, it prints 65. So every character on your keyboard has an ASCII value. The same way for capital A, it is 65. For small a, it is 97, I guess. For 0, it is 48. Example, if I enter the value 0, it is 48. For value 1, it is 49. So list goes on, right? So basically, it is not giving you the exact value. It is giving you the ASCII representation of that value. Okay, that is tricky actually. So one solution you have is, what if you subtract the number by 48? Or maybe it's not 48. You subtract the number by 48, not by 48 minus num. It is num minus 48. And now if you try to run this code, you have to first compile this code, compile and run. Let's enter number 5. Oh, it works now. Can you see that? Because now we don't want ASCII value. We want whatever ASCII value you're getting, we're subtracting it, right? So if I enter 6, okay, if I enter 6, it works, okay? Now, it works. So we were able to manage it, right? This is not an ideal way of taking the input, but that's what Java provides you. Java says, we will give you this method read, which will give you ASCII value. What if you want to get a bigger number? What if you want to get, example, if I give a bigger number here, let's say 55, you can see it only gives you 5 because it reads only one character at a time. Oh, that means if you want to read multiple characters, we have to use a loop. But let's not do that. Let's not take headache off by ourselves. So Java says, don't worry. I will give you a specialized class to work with this. So instead of using system.in.read, we have a special option, which is, there's a concept called buffered reader. Now, buffered reader is basically a class which works with IO, okay? And it belongs to a package java.io. So if you want to use buffered reader, you need to import this package. So IO exception, buffered reader, both belongs to IO package. Now, whatever class we have used till now, most of them belong to java.lang, which is auto import. But if you want to use any class which is not there, you have to explicitly mention the package name. Okay, so let's create object of buffered reader. So we'll say buffered reader bf is equal to new buffered reader. Okay, but what next? The thing is, if you want to read, we have to actually pass the in object. Can you see that? If I go to constructor of buffered reader constructor says, okay, I will work, but first you have to pass an object of a reader. Okay, now which reader it is talking about? So basically, there is one more class which you have to work with. I know this code will be a bit lengthy because that's how Java has implemented it, but let's use it. In fact, there is a better way as well, which we'll see in the next topic. So we have to pass the input stream reader. So we have to get object of input stream reader. Let's say in this case, and I will say new input stream reader. Okay. And whatever object you're creating here, just pass it here. Your job is done. But there's a problem. You can see input stream reader also needs an object of input stream. Okay, in this case, what you can do is, it needs object of input stream, right? And if you remember, when we talked about in object, it is input stream object. So what you can do here is, you can pass system.in. I know it is a bit complex, and that's why in later version of Java, they have introduced better solution. But I just want to show you this option as well, which was there and people were using it for a long time. Okay, so you have to say input stream reader in, and then you have to get object of input stream reader. Then you can create object of buffer reader by passing the object of input stream. Now, once you have it, you can create a num variable and you can use buffered reader to read a line. So you can see we have a read line. The only thing is, read line will give you the string. Okay, we don't want string, we want integer. So to do that, we have to use a special class called integer.parseInt, which we have seen already, and integer.parseInt, not in. Okay, so whatever string you're getting, basically you will get a number in the string format. You just have to convert that into integer. And now if I try to print number, it should work. Otherwise, we have wasted so much of time. Compile and run. Let's enter 55. It works. Doesn't matter how big your number is, it will accept it. You can see we got the number. So basically, this is how you take the input from the user. There's another way which I will show you in some time, but the important thing is whenever you use buffer reader, it is trying to access input stream reader. And the beauty is buffer reader can take the input from anywhere, not just from system keyboard. It can also take input from the file, from the network. And you can mention wherever you want to take the input from, you can mention it here. You can mention the file, you can mention all the other stuff. Now the thing is, buffer reader, whenever you're using it, it's actually a resource. Now why it's a resource is because, let's say when you are trying to read from a file, of course file is a resource, right? And when you open the file, it is your responsibility to close it. When you open the network, it is your responsibility to close it. When you open the database connection, it is your responsibility to close it. How will you close it? So once your job is done, at the end, you can just come back here and say bf.close. Can you see that we have a close method? So it is always a good idea to close the resources. Again, it's not compulsory. It will not give you error, but a good practice is close the resources. Okay, otherwise you are leaking resources, you are leaking the file, you are leaking data, you are keeping the resource busy. And the thing is, if you are using a resource, no one else can use it. Okay, so don't do that. Don't be an evil person here. So you close the resource. Okay, so this is how you take the input. And I know you are waiting for the better way of doing this. Let me show you a simple way. So instead of using buffer reader, we can use one more technique here, which is a scanner. Now scanner was introduced later in Java. So if you can see, if I go to scanner class was introduced in 1.5. So people before 1.5 were using buffer reader. I know, bad days, but yeah, we got scanner here. We can create object of scanner, let's say SC. We can use any object name, doesn't matter. And we can say scanner. Now scanner takes the system.in, that's constant because we have to mention from where you're getting the input. Are you getting the input from the console? Are you getting the input from the file? You have to mention that here. And once you get the scanner object, the beauty is in scanner, you can say sc dot, and there are so many methods. Can you see that we got next line, which will give you string. You can say next int. Oh, that means it automatically gives you integer value. You can also say next short. It has so many methods, but we are going to use next int, not next line. Because if you use next line, you have to pass that into integer. So let's use next int, which will not create a lot of headache for us, and run, enter a number 567, and we got it. So I know scanner looks much better than buffer reader, but yeah, it was introduced later. So people before that were using buffer reader, so we have seen it. In fact, in the next video, we'll try to understand more about how do you close resources. Okay, and that's why we are teaching this concept now, because now we know what is IO exception and all those stuff. So yeah, you have two choices of taking the input from the user. You can use buffer reader or you can use a scanner class. Okay, now in this video, let's try to implement try with finally, or try with resources basically. So what I will do is I will just remove everything else. Of course, we'll do this once again. We'll try to use buffer reader because we love it, right? Okay, we are not throwing an exception as of now. We are not writing any code for that. Let me remove that as well. And here, what I'm going to do is, let's try to understand try. Now, if we talk about try, of course, in this try, you can do whatever you want. Normally, we put the critical statements, right? And then if there's a critical statement, which is throwing an exception, what you execute is a catch block, right? And we know how to write a catch block. The thing is it compulsory to have a try with catch? There's no compulsion. You can write try, but you can see if I don't mention catch, it gives you an error. The thing is, if you have a try and if you don't want to mention the catch, you can basically write finally here. So yeah, so try can be used with finally. If you don't want to write catch, if you don't have a such scenario where you want to handle the exception, you can write finally. But then what's the use of try when you're not catching it? Of course, right? Try is responsible to handle the exception, and when it will simply throws the exception, which will catch it, and then it will solve it, or it will print something. Finally, what finally is doing? See, the thing is, even if you have a catch block here, let's work with catch block. And in this catch block, I will say exception E, and then let me create a scenario which is int I is equal to 0. I know you'll be thinking I'm using the same example. Just for simplicity, I just want to keep this thing simple. And here I want to say j is equal to 18 divided by I. I don't know why I'm using 18 every time. It's just because we have used it before. Now we know this will throw an exception, so it is our job to print something here. So I will say get lost. Oh, sorry, it will say something went wrong. Ignore that, get lost. So something went wrong, right? Okay, so if you get the exception, it will call the catch block, right? Now, sometimes what happens, you want to print something, you want to do something which should be executed irrespective if you get the exception or not. Example, let's say, if I want to print by, here in the try block, the thing is, if you compile this code and if you run this code, you can see it says something went wrong. It is not printing by. You know why? It's because in the try block, the moment you get the exception here, it will call the catch block. And that's what is not printing a by. It will directly jump out of the try block, right? So one of the solutions you can have is you can just write this in catch block as well. Okay, so that irrespective if you get the exception or not, it will print by. So you can say it is printing by in the catch block. But if you don't have the exception, it will print by, which is coming from the try block. Okay, so at least you're printing by. Now, of course, in the real project, you will not be printing by. In real project, you will do something. There are some set of statements which you want to do irrespective if you get the exception or not. Now, instead of doing those things here, one of the amazing things we got is finally. So what you can do is, you can write your statement inside finally. Now finally has this amazing feature which is irrespective if you got the exception or not, it will execute the finally block. So in case of exception as well, it will execute the finally block. Let me show you that to you. Compile and run, it says by, no problem. Even if I get the exception, compile and run, it says by. So finally block. Now this block will be executed irrespective of the exception. Okay, and the beauty is you can actually skip the catch block if you just want to use try and finally. But why you will do that? Why in this world you will write try with finally? You're not handling the exception, right? See, finally makes sense whenever you want to close the resource. That's right. Whenever you want to close the resource, that's where you will be using finally. Okay, what I'm talking about is, let's say we are not doing this. We are using a variable called num, and the value for num initially will be 0. And what I want is, I want to take the input from the user. And we know how to do that, right? So basically we have to get object of buffer reader. Of course, we can use scanner here, but let's use buffer reader. So buffered reader, br equal to new buffered reader. And we know if you want to work with buffer reader, first you have to get object of input stream reader. We'll say in is equal to new input stream reader, which will take the object of system.in, right? And here you can basically pass this in, which you have created here, okay? And using this buffer reader, basically we can say, okay, we can, num is equal to br.readLine, and then we have to pass it, right? We have to say integer.parseInt. Okay, now it says it might throw the error, right? But then you will say, hey, we are handling, right? No, actually we are not handling. We don't have a catch block here, right? So basically we are not handling the exception, and that's what it says. So what we have to do is we have to either handle the exception or we can quick fix and throws. Okay, this time it is throwing two exceptions, number format exception and IO exception, because we are passing it. Okay, that's fine with us. Okay, and let's say I'm printing the num value as well. Now, after doing all those things, we know one thing, right? Whenever you open the resource, example, the buffer is a resource, right? It's always better to close the resource. Now, my question to you is, where should I close the resource? Should I close the resource in try block? If I'm handling the exception, should I do that in the catch block? Of course, we have to write two statements, right? Instead of that, the finally block is normally used to close the resource. So whenever you want to close the connection, whenever you want to close the resource, always use finally block. It is meant for closing the resources. Okay, the only thing is, can you see that we are creating the reference inside the try block? The scope is getting over itself here. So what I can do is I can declare it outside and I can use it inside. So when I declare outside, even the finally block can use it, and I can make it null initially. And now you can see there's no problem. So basically, we are closing the resource in the finally block. So point to remember here is the finally block is used to close the resource. It can be for file, for the input, for the connections, network connection, database connection, everything. Finally will be used for closing it. Makes sense, right? Okay, before I go ahead, I just want to do one more thing. Don't you think we are passing in here? So can I, instead of passing in, can I pass the entire statement? See, ultimately we need object, right? An object is created by this line here. So actually we can do this. So we don't need this line. So most of the time when you read somewhere, it will show this type of statements, and that's completely fine, it works. Okay, now one more thing. So try with finally works, you can close it here. But you know, we can actually optimize this more. In the later version of Java, they have introduced a new concept, which is try with resources, where you don't even have to mention finally block. That's good, right? But how will you do that? So what this says, in the try itself, create a round bracket, and then you create your declaration. Whatever object you are creating, create them inside the try block. I mean, inside the brackets, and you have to declare that as well, buffered reader. So you will not mention that here now. So what I'm doing is I'm creating the object in the try itself. Now what's the advantage of this? The advantage is once the try gets over, this resource will be closed automatically. It's because if you go to buffered reader extends reader, and if I go to reader, you can see it says closable. And if I go to closable, it is auto-closable. So whenever you have a class or the interface which is auto-closable, it means that will be closed automatically with the help of try. You don't have to do the closing manually. So this is try with resources. So you have this syntax option. You can use try with finally. That depends upon how you want to implement this. I prefer to use try with finally because I know which resources I'm closing. And sometimes you have multiple objects created. So it's good to use finally. But if you think you can make a shortcut, this also works. So this here is called try with resources. In this video, we'll talk about threads. Now, what are threads? Now think about this. When you run the application, of course, the software which you have written, it will be running on an OS, right? And below the OS, you have a layer which is called hardware. So if you want to represent this, what we normally have is we have a software which you build, of course. So let's say this is your software. And this software basically runs on an OS. Of course, on this OS, you'll be having multiple softwares, right? And underlying, there is a hardware, right? So this is where you have the physical set. Example in this, you will be having your CPU, you'll be having your RAM. This is what we use to run applications, right? Now, if we talk about RAM, RAM acts like a temporary memory for your processing, and your CPU is basically something which executes something, okay? So let's say in your software, even if you want to add two numbers, let's keep it very simple. Let's say if you want to add two numbers by saying 2 plus 2, now that operation will go to OS and OS will say, okay, you want to add two numbers. Let me just send the request to the CPU. Of course, CPU will do the processing, right? Now CPU says, okay, that's a task. I just have to add two numbers. It will do some processing and then you got the output. The thing is, for a simple operation, it's so simple, right? But then what if you are running a big software? Let's say this is your software, and apart from this, you have multiple softwares which you want to run on the same OS. Now, of course, in your system, you'll be having multiple softwares, right? And then sometime you want to run that at the same time. So that means OS should support multiple software working at the same time. So can we say that's multitasking? Right? So we have multiple tasks running at the same time, okay? Now, most of the modern OS does support that. The thing is, it's not like they are executing this at the same time. So on the CPU, there's a concept of time sharing. Example, let's say there's software 1, there's software 2, there's software 3. Let me just remove this part for time in here. So let's say if you have 3 softwares here, which you want to run on the OS, they will be going in time sharing. So your OS can say, hey, the first software you execute. It will say, okay, second software, now you execute. And then they will be executing parallelly by sharing the time, okay? That's one thing. So that's why we can achieve multiple tasking. And that's why, at the same time, you can browse a web page, you can listen to a music, you can type a code. So you can do all those things at the same time because you have a concept of multitasking. But if we talk about one single task, okay, what if you want to break down this task into multiple things? It is possible that in the same software, you have multiple processes or multiple things to run at the same time. Let me give an example here. Let's say you are writing something on the editor. So we are using VS Code, right? Now, the moment you write something on VS Code, let's say if I say A, B, C, you can see the moment I type it, it is showing me it is showing the text on the software. It is also showing us the error, right? So that means these two things are happening at the same time. Maybe we can also enable some sound effects. The moment I type A, it should create a sound effect. So we are doing multiple things at the same time in the same software. So that means it's not just about multitasking. It's also about dividing your task into small things, the smallest unit. How can we do that? And that's where we have a concept of threads. So in the same task, in the same program, you can have multiple threads running at the same time. Okay, so example, when you play game, any game which you play, maybe Mario or cricket or football. I'm talking about video games, okay? Now at that point, what happens, if you talk about football, let's say, if you have multiple players running at the same time, the ball is moving at the same time, the audience is cheering at the same time. So you have multiple things happening at the same time. So that is possible with the help of multiple threads. In fact, if you see your activity manager on Mac, or if you go to task manager on Windows, you can see whatever task you have. Example, I have a Discord helper here. We got login window, we got code helper. So all these softwares are running, right? Stream Deck, Zoom OS, Zoom software, everything is running. Now all those are tasks, and individual tasks, if you can see, we have threads there. So the kernel is consuming highest number of threads, 524. Then we got Java, because we are running Java behind the scene. So Java is using 42 threads, right? So in a task as well, you have the smallest unit. The beauty is they can run parallelly. And they are lightweight basically. They also share the resources. It's not like if you have 42 threads, they will consume 42 different resources. No, multiple threads can share resources. And that's why threads are important to understand. So in the upcoming videos, we'll focus more on threads. So I hope you got the gist, what is threads. And yeah, just to redefine, that's a smallest unit which you can work with. And of course, you can run multiple threads at the same time. Now, once we know why we need threads, let's try to create multiple threads here. And of course, to create multiple threads, it's not like just because we have a concept of threads, we are going to use in every application. What if I say most of the time you don't even create threads by yourself? See, when you build applications, we use certain frameworks, right? Now, behind the scene, these frameworks will create threads for you. So if you work on a big project, there's a high chance that you will not even write threads by yourself. But then it's always better to get hands-on on some underlying concepts, right? So let's do it here. So what I will do is, let's go for an imaginary concept here. Let's say I have a class hi, whose job is to print hi, okay? Or maybe I will just say a class A, whose job is to print hi. So what I will do is, I will try to create a function here, public void show. And in this show, I want to print hi. Nothing fancy, just hi here. The only thing is I want to print this hi multiple times. So I will simply use a loop here. I can say int I equal to 1 and I less than equal to 10 and I plus plus. Okay, and then we are putting this inside a loop. So of course, when I call this particular function, which is show, of course, it will execute hi 10 times, right? Now let's say I just copy this code and I paste it here. Now what I'm trying to do is, we have two classes with the same concept almost, because they both have the same method name, which is show. Both are running a loop for 10 times. The only thing is the second loop actually prints hello. The first function here prints hi. The second one prints hello. That's the only difference. And of course, the class name is different. And now I will go back to my main method. And here I want to create object of these two classes. So we got A class, we got B class. Let's create object for them. So I will say A obj1 is equal to new A. So we got the object for A. And then I can say A obj2 is equal to new B. And we got the object for B. Okay, simple stuff. And now I want to call those methods. Of course, I can simply say obj.1.show and obj2.show. So basically what I'm doing is, I got object of both the classes and I'm calling the show method. And I'm thinking it should work, and why not? Why it will not work? We have done so many Java codes till now, everything was working. Let's see what happens. So I will compile this code and you can see there's no problem. There's no compile time issue. And if I run this code, oh, okay. We got the output, right? So we got all highs here and we got all hellos, right? Now that's how your system basically works. You know, your execution will start from main. Main will say, okay, when your JVM is executing the Java code, it will start the execution from main. And from main, it says, okay, this is the first line which I want to execute. The first line is simply create the object. Now behind the scene in the heap memory, you will get this object, okay? Now the second line says, okay, create the B object. It will say, okay, B object done. And since everything goes in sequence, it will complete this task, these two tasks. Then it will go for the next statement, which is calling the show method of A class, right? So it will say, okay, now I have to actually move. So if you try to imagine a pointer here, not the pointer in different languages, I'm saying just saying which statement is getting executed. Okay, where is your executor here? So the executor says, okay, my job is to execute this show method, right? So the executor will directly jump to this method, which is show. Okay, now it will start executing this method. But when you are executing this method, there is a hold on demo, right? I mean, the main method is not continuing now. So main will continue for the next statement only when the previous statement is done executing. So once you complete the show method execution, then only it will go for the next show, right? And that's what it will do. So it will execute this show here. It will run this loop for 10 times and it will print high 10 times. Now, once this show method is done with its work, it will go back to the main method and it will continue for the next method calling. So that everything basically goes in a sequence, right? Now, what I want to achieve here is I want to say, hey, when obj1.show is getting executed, at the same time, parallelly, I want to execute this show as well. Okay, so if you want to execute two things at the same time or two behavior at the same time, since methods are behaviors, we can use something called threads. Okay, so we can say, okay, I want to execute these two objects, but then they are not normal objects. You can't execute normal objects in multiple threads, or you can't execute normal object execution simultaneously. So you have to use multiple threads here. So how do you make your normal objects as threads? Now that's tricky, right? It's actually very simple. If you want to make these classes or these objects as threads, just extend with a class called thread. It's that simple. The moment you extend with threads or with a thread class, now this class is not an ordinary class. This is a thread. Okay. The same thing you can do for B. So you can say thread and extends thread. Okay. And then you can come back here and our job is done, right? Now we don't have normal classes. We have threads. Oh, is it so simple? Okay, let's see. Compile and run. Oh, it's not that simple. You can see they are still running in sequence. They are not running in parallel. What I want to do is I want these two methods to run parallel. So while it is printing high, it should also print hello on the side by side. Okay, it's not working. So what I'm imagining with my code is what should happen is, see, there is a main method, right? So main will continue its work here. So main will keep executing everything. Now there will be a point where main wants to execute the show method, but with two different threads. So I want a show method here and I want a show method here. Of course, this show method, the first one is of A, the second one is of B, but then your main, when calls show, it should be with the new thread. So I want this to be a new thread. I want this to be a new thread. Okay. Now, just by mentioning that this class is thread, it will not create new thread for you. Basically, we want two threads. Now, the way you do that is by not calling show. What you have to do is you have to call a method called start. Because when you are thinking that at this point, I want to start a new thread. We want to start a new thread here. We want to start a new thread here. We can do that with the help of a start method. So we have to call this method. And that's what we are doing here. So we have to say start for both the threads. Okay. See, we are saying that those are the obj1, obj2, but they are threads now. Now the only thing is, when you call start, it should also say start, right? Why it is show? Now the thing is, behind the scene, when you go to start, so you can see if I go to start, start is a method belongs to a thread class. So of course you can do your work here, but the thing is it will create new thread for you, but it will call not the start method. Even if you call it, it calls a run method. So this thing you have to remember, in every thread, you need to have a run method. That's how it works. So when you say start here, it's almost like, when you are, when you want to participate in a race, right? So we have multiple lanes there, right? So we have multiple lanes, multiple people are waiting to start their game here. And of course you took a position to run, but then you will not run. You will wait for it, right? What you will wait for? You will wait for some volunteer here to say start, right? The moment they shoot a gun or they say start, you go, right? In the same way, the moment you say start here, it will execute the run method. Okay, that's the point you have to remember. Okay, let's see if this works now. We have done everything what we could have done to make it work, and let's see it works. Oh, okay. Still not working. Now what is happening here? See, the thing is, what if I say they are actually running parallel? The only thing is, when we are saying that, see, we are starting with this one, right? obj1. And then we are assuming that obj1 will execute one high, and parallelly, the second thread, which is the B thread, will execute hello at the same time. But the moment you give some time, because the machine is so fast now, the moment I have given some time to the A thread to execute, it is executing the entire thing at the same time. Okay, let me show you what I'm saying. What if I do this for 100? Okay, and let's see what changes. So if I compile this code and run, if you can see, if I scroll up, things are happening in parallel. Okay, so you can see we got few highs here, and then we got few hellos, and then we got few highs, we got few hellos. Okay, things are running in parallel. So these two methods are actually running at the same time. Yeah, so what happens is behind the scene, there's a concept of scheduler. Okay, so in your OS, we have a concept of scheduler. Now scheduler will say, okay, if you want to execute something, you have to come to me first. Now it doesn't matter how many threads you have in your system. Of course, in my machine, I have shown you that in the last video. If you go to activity monitor, you can see we have so many threads here. We have 524 threads running, and only for one task. In total, I got 2,382 threads. Now, of course, you can't execute all at the same time, right? Now, the thing is, nowadays we have multi-core CPUs. So you have multiple cores there, right? And the beauty is you can execute multiple threads at the same time. So you can execute, let's say, if I have 4 cores, I can execute 4 threads at the same time. If I have 8-core CPU, which is octa-core, I can execute 8 threads. But we have 2,394 threads now. How will you execute all? So of course you can't execute all at the same time, right? So they go for a time sharing. So scheduler in between. So let's say this is your OS here. Okay, so there's a concept of scheduler which is responsible to basically allow a thread to execute. Let's say we have multiple threads waiting to execute, okay? So let's say we have 8 threads here, and then we only have 2 cores available. So on your CPU, basically, you have only 2 cores, right? So scheduler knows you can actually run only 2 threads at the same time. So what it does is it basically allows, let's say, this thread and this thread to execute. And then after they execute, they will allow this thread and this thread to execute, right? So it is scheduler job to allow which thread to go to execute on the OS, okay? And that's why, so when your scheduler allows some time for your threads to execute, your thread might be executing this number of iteration at the same time, okay? And that's what is happening here. So basically we are running multiple threads at the same time. So yeah, that's how you create multiple threads with the help of the thread class. Okay, now let's try to execute this thing simultaneously. So what I want is, of course they are running at the same time, but what I want here is I want to execute hi and hello one after the other. So example, if you can see the output here, we are printing so many highs and then we are going for the hellos, right? How do we do that? See, the thing is you cannot control your scheduler. You can only suggest your scheduler to give the priority. So yeah, we have a concept of threads priority as well. Example, we have 2 threads, right? We have obj1, obj2, and we have a concept of threads priority. So let's say, I just want to understand what is the current priority of the thread. So I can say obj1 dot, there's a method called get priority, which will give you the current priority of a thread. Okay, let's try to print this. Let's see what happens. Compile, there is an issue. Okay, we forgot to put 1 round bracket, and compile this code and run. You can see it is printing all this thing, and we got thread priority where? Yeah, it's here. So you can see we got 5. Okay, so since we are starting the threads after printing the priority, you can see that's why we got the value first. But we got the priority as 5. Now what is this priority? What's the range basically? So the range of the priority goes from 1 to 10. So 1 is the least priority, 10 is the highest priority or maximum priority, and 5 is default priority, which is normal. Okay, so by default, every thread will be having a normal priority. So what you can do is you can change the priority of a thread. Maybe you want the second thread to have a higher priority. So you can say obj.set priority, and you can mention the value. So of course you can mention 1, which is the lowest, or you can mention 10, which is the highest, or you can use some constants. So thread class has some constants which we can use. Example, we have max priority, we got min priority, we got norm priority, right? So if you want to specify maximum priority, you can do that with the help of this constant. Otherwise, you can also say, let's say if you want to set the priority 9, so you can say max priority minus 1, that will be 9, right? But then by doing this, it's not like you will get all hello first and then it will be high. So even if you see, we are printing hi, and then it is printing hello, and it's still hi, hello. It's working in simultaneously. The only thing is, when you are specifying that the priority for this thread is the maximum, you are basically suggesting to your scheduler, hey, this thread should get a highest priority. It's not like scheduler will give you that priority. Scheduler different scheduler have different algorithms to work with. And if it feels okay, now we have multiple threads and they are reaching to a point at the same time, scheduler can say, okay, now I will say the priority. Or maybe a scheduler will also see who will take the lowest time. So if there's a thread which will take less time, so it might go for that one. So again, as I mentioned, different scheduler has a different algorithm to work with. Using priority, you can only suggest what should be done. Okay, that's one. So we know now how to set the priority and get the priority. Apart from that, if you still want to make this work, one thing we can do here is, after printing hi, see what is happening is, as a scheduler will give you some time to execute, right? So let's say scheduler says, hey, thread A, you can execute for, let's say, 1 millisecond. And we were assuming that in 1 millisecond, it will print one hi. But no, my machine is so fast. In fact, most of the machines are so fast nowadays, right? In that 1 millisecond, it is executing this number of highs. How do I control this? So one thing we can do is, after printing every hi, let's ask our thread to wait. Okay, so the way you can do that is by using thread dot. There's a method called sleep. Now in this sleep, you can basically mention for how much time you want this thread to sleep. So you have to specify that in milliseconds. So when you say sleep, you are asking your thread to wait. Wait for 10 milliseconds and then continue. Okay, so what we are basically trying to do is, once you print hi, this particular thread, the A thread will go into wait stage, right? Waiting stage. And then the B thread will execute hello. And again, once B thread done its work, you can just put a sleep there as well. Now the only thing is, this sleep method will throw, remember we talked about checked exception. So this sleep method basically throws a interrupted exception. So what you have to do is, we have to put a try catch, or we can say throws, but let's put try catch here. So with this suggestion, I can say surround with try catch and our job is done, right? And just to simplify this, what I can also do is, I can put this in one line. So you can see we got try catch, and then just to reduce the number of lines we have, I'm just writing that in one line, the catch block. The same thing can be done for the hello as well. And you can see we got the sleep here as well. So we got two threads, and now I hope it will work. Let's compile and run. Okay, you see that we are getting hi, hello in sequence. If you start from here, you can see we got hi, hello, and then go on. But if you can see, this is where you got two hello at the same time. Now it is possible that after doing this calculation, after doing this iteration of hi, hello, two threads are going back to scheduler at the same time. And scheduler has given the chance to hello first. So it all depends upon how you work with threads. Not you can only make multiple threads. It all depends upon your scheduler how to run this. And that's why when you play games, sometimes, you can see some of the characters are not moving in a sequence or not in sync because the threads are not working properly there. So as a programmer, you can just optimize it more. Okay, you cannot control it. One thing I can do is, if I want the hello to come after that, maybe I can just put a sleep here as well, maybe of 2 milliseconds. So I just want both of them to start with a gap in between of 2 milliseconds. So compile and run, and if you can see, I hope there will not be any hi, hello which got 2 time print. You can see now it's all ones. It's because there's a gap in between hi and hello who reaches to the scheduler at the same time. So yeah, that's how you can optimize. Again, as I mentioned, we are just trying to optimize it. There's no guarantee that you will get this output every time. Oh, we got it. Can you see that? We got 2 hellos here. Again, my idea was just to optimize it, and it depends upon your scheduler how to work with this. Or maybe I can just, if I make it 5, then we can control that. So try this out and let me know how it is for you in your machine. So we have understood two methods, two things from this video. One is the priority. So you can set the different priority for the threads, min priority, max priority, and normal priority. And you can set any number between 1 to 10. And by doing this, you are only suggesting to your scheduler to give the current thread maximum priority if you set it that way. And then we have talked about sleep. Now, when you say sleep, it actually goes into a waiting stage. Again, we'll talk about what is that waiting stage or block state a bit later. But yeah, that's a stage it follows. There are multiple ways to create a thread. One thing we have seen, which is of thread by extending a class by thread, but we have more options. But why do we need more options? Now think about this. Let's say this class A want to extend some other class. Let's say we have one more class here. And the class name is Z. And I want this to be a parent class and A to be a child class. So I want to basically make this A as thread, as well as I want to make this as a subclass of Z. And we all know, right, the multiple inheritance in Java is not possible. So how do we solve this problem? So this idea of extending a thread is not actually a good idea. So the other option we have is, okay, let's go back. The other option we have is if you click on this thread, if you observe, thread is a class which implements Runnable, okay? And if you go to Runnable, you can see we have the method called run. Now this is important, right? If you remember, in the code which we have written, we have went with a class name, or we have went with a method name called run, right? That actually means that if I implement a Runnable here instead of using a thread, even this should work, right? Because it has a run method. So what I will do now is, instead of extending with a thread, I will simply implement it with the help of an interface called Runnable. Okay, so both the side. Now I have a choice of extending a class as well if you have some other class, because we can have a class which is extending another class or implementing an interface at the same time. But the point is, you can create thread like this as well. You are making this class A as Runnable. Okay, now by doing this, how can we work with this? The moment you go down, first of all, let me just remove this. We don't need this code. In fact, before I continue, I just want to make some more changes to the code. The first thing I'm going to change is, instead of having, let's say 100 iterations, let's go for 5 iterations so that we can see the output fast. And yeah, that's the thing. Okay, so the start will not work. You know why the start will not work? Is because in the Runnable interface, we don't have a start method. The start method before was coming from thread class. Okay, that's weird. So we can't use this, right? See, the idea is, if you have a Runnable class, example, this A is actually a Runnable class, right? A class which is implementing Runnable. So in that case, if you want to work with start, you can't do that. So in that case, what you can do is, you can create 2 different threads. You can say T1, this is your first thread. And then you got T2, this is your second thread, right? So we got 2 threads here. And instead of saying obj1.start, we have to say t1.start, because we know that start method belongs to a thread. And problem solved, right? You can see now we are able to call start. Now let's see if this works. I will just go back here and compile, run. Oh, that's weird. We have not got any output. See, the thing is, yes, we got 2 threads. Yes, we are saying start. It's actually creating 2 threads behind the scene. But it's not doing anything, because these 2 threads have no idea about this obj1, obj2. They have no idea about these 2 classes. So in that case, what we do is, if you go to thread constructor, you can see thread has multiple constructor. One of the constructor takes a Runnable object. That means obj1 here is actually a Runnable object. Let me prove that. So instead of using A, can I use Runnable? And we have seen that, right? We can create a reference of the interface and object of a class. Even here, we have to say the reference of the interface and object of a class. Okay, so what we can now do is, in this particular constructor of thread, we can pass obj1, and here we can pass obj2. So we are passing the Runnable object in the thread class or the thread constructor. Now there's a link, right? So when you say start, it will know that which run to call. So this start will call the run of these 2 classes. Let's see if this works. I will say clear, compile, run. Oh, it worked. Can you see that? We got hi, hello, and it is working. So basically, whenever you want to create a thread, we have two choices. You can extend a thread class or you can implement a Runnable interface. The only thing is this Runnable interface will not have the thread methods. In that case, you need to create a separate thread object and then we can use these features. Okay, now if you remember, we have also learned about Lambda expression, right? So let's reduce this code by implementing Lambda expression, okay? And let's do that step by step. Now, if I ask you one thing, the entire class A, why we are creating this class? We are creating this class is because we want to implement Runnable, right? Okay, that makes sense. How about if I remove this class? So of course, this Runnable will not work. Example, let's say, if I comment the entire section here, okay, even this part, if I comment the entire section, you can see this will give you an error. So I want to create a Runnable obj1, but I can't create A because we don't have A. So can I say new Runnable? Of course we can, right? We have seen how do we use anonymous class to create the object. So imagine this is anonymous class, right? Now in this anonymous class, we have to implement the method which is there in Runnable. Now, which method is there? The same method which we have here. So can I just copy this code from here and I can say copy and paste. Let me remove the entire comment section. So basically what we're doing is we are trying to instantiate our interface with the help of an anonymous class here. And in this class, which has a method which is run, and basically we are basically implementing this Runnable here itself, right? Okay, that works. Let me just try if this works before we continue. So I will say compile and run. It worked. Can you see that we got the output? Okay, that's great. Okay, what else we can do? Can we do it for the second one as well? Yeah, we can, right? But before we go for that one, can I convert this into a Lambda expression? And we have seen that, right? Lambda expression works whenever you have a functional interface, and Runnable is actually a functional interface, which means I can use Lambda here. And in Lambda, this is optional. So I can remove this. I can put an arrow here and I can remove this bracket as well. Okay, this looks cool. And I can just put that back here. Okay. So as you can see, I have written everything in one line for the try so that it will be over in one line. And now, can we just do it for the second object as well? Of course, I can just copy this code. And the only thing we know we need to change is the hello part, right? So from hi, we have to make this hello. That's the only change I have to make. And I don't even need these two classes now. I can remove them. And see the number of lines we have reduced. And also, if you know that this class will be used only once, so this makes much more sense to use, right? The anonymous class, and we can convert that into Lambda as well. So this is the Lambda version of it. Cool. And now we can simply run this and this should work. Compile and run and it works. And that's the beauty about Lambda expression, right? And you can reduce the number of lines you have and there's no extra classes. See, it will be tricky to type the entire thing from start to end because till this point what we are doing is we are trying to convert the anonymous class into Lambda expression, which is easy. But typing the Lambda in the first go will be difficult. So just try it out multiple times. You might make mistakes with the syntax, but ultimately you will get used to it. So those are two options we have, creating with the help of extending with a thread and by implementing the interface Runnable. In this video, we'll talk about race conditions. Now we have talked about threads, right? And till this point, everything looks good because now we know that threads are important. If you want to execute multiple things at the same time, threads will be useful. Now, sometimes we create 2 threads, sometimes we go for multiple threads, maybe 8 threads, 10 threads. It depends upon your application. And as I mentioned before, there are certain times when you actually write threads by yourself. Otherwise, most of the time, your frameworks will do it for you. Okay, let's say you create your own threads, okay? And then we know that threads are good. On the other hand, we have one more concept, right? So let me just write it down here. So if we talk about a concept like threads, threads are important, we know, right? Apart from this, we have one more concept, which is called mutation. So if I say mutation here. Now, what do you mean by mutation? Mutation simply means that you can change something. Example, if we talk about variables. So primitive types, variables or object type variables, we can change them, right? Example, if you have int I. So let's say if I say int I is equal to 5, and then Later on, I'm changing this value of I. I'm saying I plus plus. Maybe after some time, I'm assigning the value for I to 6. I can change this value, right? And it is actually useful to mutate a value. And of course, that's what we do with data processing, right? So when I say you got data, you want to process it, most of the time you might want to change the value of your variable. And that makes sense, right? So that is mutation. But then if you remember, when we talked about strings, we have mentioned that strings are immutable, right? So there are some concepts which makes them immutable. So which is good, mutation or immutability. At this point, if you can change something, mutation looks good, right? So yeah, so till this point, mutation looks good. But then let's try to discuss something more. What about threads? Threads are good, of course. If you want to make things faster, threads are good. But then what if you mix both of this? What if you are doing mutation with multiple threads? Will this work? So what I'm saying is, what if you have two threads, let's say T1 and T2, and both are trying to work with the same variable I. So T1 changes the value of I, T2 changes the value of I. Now it will create instability in your code. I mean, think about this. But what if you just have one bank account and you got two debit cards? Of course, as a single person, you cannot use two cards at the same time. But what if you have given the other card? Mind you, I'm talking about the same account. So we have one bank account and we have two cards. What if you give one of the card to your friend and then you went to two different ATM machines, okay? And now you are trying to withdraw the money. So let's say in your account, you have 10,000 rupees and both of you at the same time, at the same second, you try to withdraw the money. You try to withdraw, let's say 7,000. So in total, you're trying to withdraw 14,000 rupees. The balance is only 10,000 rupees. So that's an issue, right? If you try to do things simultaneously. And we'll also do that in the code as well, just to see what happens. So threads and mutation together is not a good idea. Okay, and that's why if you are working with threads, always try to make sure that you work with data which are immutable. Or if you think that there's a method which can do some mutation, make it thread safe. Now, what is the concept of thread safe? So thread safe simply means, so if I say thread safe simply means that only one thread can work with that at one point. Example, if you have a method, let's say show, and the show method, so there are two methods who are going to call show, T1 and T2. So only one of them can be able to get into show at one time. So if T1 is executing show, T2 cannot execute show. Okay, that's the restriction we can add. But how? Let's see that in the code here. So what I will do is, first of all, I will remove these two threads, or maybe we can just use these two threads as they are. So you can see we got two threads here. The only thing is I want to make sure the iteration is not for 5, the iteration is there for, let's say 1,000. And maybe I don't want to print something, I don't want to apply a sleep method, let's keep it clean. And let me just clip this clean as well. So you can see we got two threads and both are doing something. But as of now, you can see we are not writing any code here. The for loop is basically empty. So what we can basically do here is, first of all, what I want to achieve, just a very simple thing. Let's say I have a class here called counter. And in this counter, basically I have a method which is public void increment. Okay, so that's the increment method we have. And then let's also create a variable. So let's say the variable is count, okay? And by default, the value for count will be 0 because that's an instance variable. And then inside this increment, I'm just saying count plus plus, okay? So basically what we have is we have a class called counter, and in this we have a variable called count. And then every time someone calls increment, it will be doing count plus plus. And of course, if I call increment once, the value for count will be 1. If I call increment 10 times, the value of count will be 10, right? But then what I will do now is I'm going to call this counter or this increment method multiple times. So before we even use it, let me create the object of counter. I will say counter C is equal to new counter. And then from this two threads, what we have, we can simply say C dot increment. So basically I'm going to call increment multiple times. Now you tell me how many times we are going to call it. So of course I'm saying that increment in both the threads, and each thread is going to do this increment for 1,000 iterations, right? Now when I say 1000 and 1000, in total, this increment will be called for 2000, right? Okay, let me just reiterate. We have two threads. Each thread is calling increment 1000 times. So in total, the increment will be called 2000 times, right? So if I go back here, and after it starts, I just want to print the value of count. Let's see what's the current value of count is. Now you tell me what will be the current value of count. So if I compile and run, now when I run this code, I want this to be 2000, right? Let's say what happens. Oh, it's only 116. The weird thing is every time you run this code, you will get a different output for this. What's happening? See, what we are trying to do here is, let me just do that on my pad here. See, we got a main thread, right? This is your main thread. And on line number 34 and 35, what we are doing is we are creating two new threads. We got T1 and T2. Now T1 jobs is to call increment 1000 times, right? And T2 job is to call increment 1000 times. And ultimately we want this count variable to be around 2000, right? But the thing is, the main is doing nothing, right? In main, we are saying, hey, just print the value of count. Now, we were expecting that T1 and T2 will complete their work and then main will print count. But that's not the case. Anyway, we have two threads, right? T1, T2, and they are running anyway. Now, when these two threads are running in any case, now T1 and T2 they're running, right? Main is doing nothing. So main says, okay, my job is done. I have started these two threads and now I will simply print the value of count. So in between the iterations, maybe T1 has done some iterations, T2 has done some iterations, main is printing count anyway. We have to ask main, hey, don't print count here. Let them come back. So as main continues, let them come back. Let T1 and T2 complete their work by doing 100 iterations. When T1 comes back and T2 comes back, after this, just try to print the value of count, and I'm sure at that point the count will be 2000. So what I can do is, how do I ask main to wait for T1, T2? So one thing you can do is, you can say T1.join. Now join is a special method which allows your main thread to wait for the other two threads to come back and join. Okay, so if at this point, if you want to wait for these two threads, you can use join there. Okay, but the only thing is join may throw an exception. So I can simply say add throws declaration. You can see we got throws exception. Anyway, we have done with the join and now I think it should be good. We should be able to see 2000. So if I compile and run, oh, okay, we were expecting 2000, but we got, okay, now we got 2000. Now we got 1746. And that's why, threads are sometimes be unpredictable because they have a different behavior and unfortunately cannot control directly. So what is happening here? The example which we have taken before, which was about the bank account, it is possible then when we have two threads, so we got T1 and T2, they both are executing the same method. And in this method, what is happening? So when I say increment, it is actually getting the value of count. If you see, we are saying count plus plus, right? It's actually two steps. First, it will get the value of count, the current value of count, and then it will say, okay, count is equal to count plus 1, because that's how count plus plus works, right? So there are two steps. Get the value for count, and whatever new value you get, just add it with 1 and then assign it to count back. So let's say when T1 reaches to count, the value of count is 0, right? So if I just say this is the count value is 0, then 0 plus 1 is 1. So the new count value is 1. Again, if we iterate this part, so this will be 1. The value of count is 1, right? So T2 goes there. T2 says, okay, give me the value of count. It says 1 plus 1 is equal to 2. Now again, T1 goes back. T1 says, okay, new value is 2. I will say 2 plus 1 is equal to 3. And that's how the iteration should go, right? But what if both the threads reaches to this count at the same time? So let's say T1 and T2 both are reaching to the count at the same time. They both got the value, which is 3. They both said, okay, 3 plus 1 is equal to 4. We got two iterations. I mean, we called increment 2 times, but the incremented happens only once. Okay, that's what happens when you have two threads working with the same variable or shared variable. Oh, okay. So mutation and threads are not good. And every time you run this, you will get different output. Now, how do you make this consistent? Okay, you might be thinking why we got 2000 here is because maybe your threads are not going to the increment at the same time. Okay, so that's might be the case. In fact, if you go with a bigger number, if I go with 10,000 and 10,000, you can see it will lose a lot of different bits in between. Compile and run. You can see 7,000. We are losing 7,000 values. We got 8,000 values lost, right? And the chances of getting 20,000 is way less now. So the point is, this is not a good way. Now, how do you make sure that only one thread works with that at one time? That's what you can do, right? So example, when T1 is working with increment, T2 cannot work with increment. Okay, so T2 has to wait. In that case, you can use a very simple keyword. You can use a keyword called synchronized. You just use this one keyword. Your Java will make sure that this increment will be called only by one method at a time. So if T1 is working with increment, T2 has to wait. So if I compile this code now and run, you can see we got 20,000. Now it doesn't matter how many times you run this, you will get 20,000 because now both the threads are not going to that method at the same time. That's how we used two threads with the shared variables and you make them as synchronized. So basically we saved ourselves from the race condition. Now in this video, we'll talk about different states of a thread. Now, if you remember, we have started with creating a thread, then we talked about the thread is running, and then we have talked about sleep method. We have talked about join method. So basically, we were playing with the thread states, right? Where the thread was running and then we asked the thread to wait, come back, right? So what are different states available? Let's try to understand that. See, every time you create a new thread, that goes into a new state. Okay, so this is your new state. Now, apart from this new state, we also have something called a runnable state. Okay, so we have a runnable state. Now, after that, we also have a running state. Then we have a waiting state, or we can also say block state. And then the last state is dead. Okay, so we have all these states available for the thread. Now, when you say new state, what exactly happens? So when you create a new thread, example in the code, if you remember, when we said thread T1 equal to new thread, at that point, it becomes into a the new state. Now, the moment you say start, we have this method which is start. So when you say start, it goes to a runnable state. So maybe we can say start. So when you say start, it says it goes into runnable state. Now, there's a difference between runnable state and running. The difference is when your thread is actually running on the CPU, that is running state. But when your thread is executing and then it is waiting for the scheduler, that is into runnable state. So example, when your thread is running with the help of run method, that is your running state. Now, what if while you are running this and then maybe you want to keep it on hold with the help of sleep method? So that goes into waiting state. Now, apart from sleep, we also have a method like wait, which can make it go into waiting state, right? So when your thread is running state, you can also say wait. Now wait will take it to the waiting state, right? Now how will you come back? Now you will come back with the help of notify. The only thing is when you say notify, you will not come back to running state. You will go into runnable state. Now whenever the scheduler is assigning you the task or whenever scheduler says it's your turn, at that point it will go into running state. In fact, if your thread is running and if you want to keep it there, you can also say stop. There's also stop method available, but that is deprecated. Actually, don't stop threads. Okay, it will create instability in your software. But yeah, once the thread work is over, it will automatically go into stop state. You can also send a thread from the runnable to dead, even with the help of stop. Even you can do that. What else we have here? Okay, so basically we have this option. So whenever you create a thread, that goes into a new state. And then when you say start, it goes into runnable. Now, depending upon your availability of your CPU, that goes into running state. Now, while running, it will execute certain things. And then at that point, if you want to say wait, you can do that with the help of sleep, or you can do that with the help of wait. Now, the only thing is when you say wait, you have to use a notify method to come back. The only thing is when you say notify, it will not come back to running state. It will go to the runnable state, right? So it goes from the waiting to runnable. From running to waiting, waiting to runnable, that's the cycle it follows. And then again from runnable to running state. Yeah, these are the states available. We have this number of states in threads, especially in Java. Now let's talk about collection. The funny thing is, in this topic, we have three different types of collection. It starts with small c, which is a collection API. So let me just write it out somewhere. So we have a concept called collection API. Then we have a collection, and we have collections. Now, this is the only thing I think it's confusing in this topic. Now, when I talk about collection API, I'm talking about a concept. When we talk about collection, I'm talking about an interface. And when we talk about these collections with S, it is your class. Okay. So if I say, hey, something belongs to collection API, that means it belongs to this concept. If I say collection, I'm talking about the interfaces. And then there are some classes which implement this. And then we'll talk about collections, which is a class. And it has multiple methods to work with. Okay. Now, why I'm talking about collection here? So the thing is, whenever you want to group the elements, right? Let's say if you have one value, you can store that in one variable, right? I can simply say int num is equal to 5, and I'm happy, right? The only thing is, what if you want to have multiple values? Now that's what problem creates. How do you store multiple values? And I know you know the answer, right? The answer is array, and we have worked with it, right? So I can simply create a nums here, which is an array. And I can say new int and bracket. I can mention the size, which is 5. Now, this is your array, right? And it perfectly works. Okay, then why we are talking about this collection topic? See, the thing is, if we talk about working with data, if we talk about working with algorithms, there is a concept called data structures, right? And I hope you have heard about that in multiple places, right? Data structures are very important. The way you fetch data, the way you store data is very, very important. Now, sometime, example, let's say if you store data in a box here. Now, sometime you want to save data and you want to fetch the last element. Okay, so whatever element has been inserted last, you want to fetch that. Or maybe you have another type of data where you want to insert data in this values, and the value you want to fetch is the first value, right? So this is where I'm talking about the last in, first out. And this is where I'm talking about first in, first out, just like a normal queue, right? Example, if you want to take a ticket, you stand in a queue, right? In the same way, this concept which I'm talking about here is queue. The concept which I'm talking about here is stack, right? Now, apart from this, there are multiple data structures which you want to work with, right? And we can actually implement all these data structures with the help of array as well. There's no harm in that. So as a programmer, you need to do it, right? And it's good, it's fun. The only thing is when you work on a project, you don't want to actually work with an array where you create the structure by yourself. And that's where they thought, hey, can we just create an API? And the beauty is it actually introduced in the second version of Java 1.2, the collection API, where you can actually work with all these data structures. Apart from this, we also have linked list, right? So you can work with all these things by using some inbuilt classes. So it makes your work much, much easier. And also when you want to fetch data, when you want an expandable array, that's right. The thing is the array which we have worked with, it is fixed size. Example, if I create an array of size 5, it will be 5, right? You can't extend it. What if you have a scenario where you want to expand an array? Maybe you want an array of 7 now. So of course, in the existing array, you can't do that. Okay, now that's one problem. Of course, you can find a solution for this as well. What you can do is you can create a new array, let's say nums2, and you can say new int, and you can mention 7 here. So you got a new array of size 7, and then you can copy all the elements from the above array. But the thing is, you have to manually create an array, you have to copy the array, and sometimes it becomes complex to do all these things. What if you can just get a class or this feature where you can create an array which is dynamic, right? So it's quite exciting to work with collection API where you can store data and you can use different algorithms to work with it. What if you want to sort the array? What if you want to create an array of unique values? What if you want to have an array, 2 arrays, one where you have all the keys, one you have all the values? Okay, so an array, of course, as I mentioned before, in array you can do it, but then what if you can get some API using which it will help you in writing a code? Now that's where we are going to use collection API. Of course, array makes sense in most of the cases when you know that the length will be fixed. So you will be using array. Now, whenever you have a specific requirement of different algorithms and structures, that's where you will be using collection API. Okay, now once we know the theory of collection, let's start the implementation. And of course, this will make much more sense once we do it. So if you talk about collection, and now I'm talking about the collection interface now, right? Remember we talked about collection API, which is a concept, right? So in this concept, we have multiple classes interface to work with. So the first interface we are exploring here is called a collection interface. And if you can see, the collection interface belongs to java.util package. As we have seen before, most of the classes which we have used belongs to java.lang package, and that's why we have not imported them. But if we talk about this collection interface, it belongs to a java.util package. In fact, when you talk about all the collection classes interface belongs to this package, which is java.util. Okay, so we have to import that as well. So you can do that with the help of import, and you can mention the package name and the interface name, which is collection. Now, once you say collection, you can create a collection of numbers, let's say, and then I can say new. Okay. Now, the only problem here is I can't say new collection, right? Because collection is the interface, right? Now, you might be saying, hey, it's simple. You can just create anonymous class, provide the implementation. Maybe I can try. But then if you can see, the collection interface has so many methods, and we have to define all the methods. See, when you talk about API simply means a library or some feature which you can simply use it. You don't have to implement them. Then what's the use of using an API, right? So what I will do now is I will remove the entire part. I don't want to define this method by myself. The second option we have is, if you don't want to create your own class, can we use some inbuilt classes? And that's right. We have so many classes available which you can work with. So if I want to represent this, so basically on top, we have something called a collection, right? Now this is the interface which we are using. Now there are certain more interfaces which actually implements the collection. One of them is list. We have queue. We have set. So all these classes or all these interfaces basically implements or basically extends the collection interface. And individually, these interfaces have their own class implementation. Example for list, one of the most famous one is ArrayList. So we can use this. For queue also we have different classes. For set we have a very famous class which is called hasSet. So we have different classes implementation. Example for queue we have something called DQ which we can use. So for list we have ArrayList. Apart from ArrayList we also have linked list which we can use. If you have worked with data structures before, we have a concept of linked list as well. And then in most of the languages we implement them by ourselves, right? But then in collection API we get the implementation. In fact, in set also we have something called a linked hasSet. But then the most famous one or simpler one is to use ArrayList and hasSet for the set. Now, apart from this, if we talk about the concept of collection, the concept I'm talking about, collection API, we have one more thing to work with. We have something called a map, right? And map has multiple implementation, which we'll see when we start with map. Okay, so at this point, let's try to use either list or we can use set, but let's start with set list here. So what I will do is, instead of saying new collection, I can say new array list, and you can see this is a class. Ignore this angular bracket. I know it is coming from multiple times, but ignore that time bin. So we got this collection nums equal to new array list. Now in this nums, basically we can add values, okay? Now how do we add values? It's very simple. You can just simply say nums dot. Let's explore the methods. You can see we have method like add, we have methods add all, contains, equals, for each. Okay, we'll see for each as well, which is very interesting. Then we have notify all, remove. Then we can also convert a collection into array. We have two array there. And then we have a wait method. But at this point, I just want to add the values, right? So I can just come back here and I can say add. And in this add, I can add values. So let's say I want to add value, which is 6. So since this is numbers, I'm expecting that this will only have numbers. So I will just copy this code and I will try to add multiple values. So let's say this is 5, this is 8, and this is 2. So basically we got this value, right? Now ignore this yellow zigzag lines here. We'll talk about that later. Okay, but yeah, there's an important concept which is coming up. But at this point, I got this collection, right? And I want to print this. Now, if you have an array, of course, you can also create array with these elements. But the problem there is you cannot simply print an array, right? You have to use a loop to print each element. But that's not the case with collection. I can simply come back here and I can say sout and I can print nums. And you can see if I try to run this code, if I say compile. Okay, so when you compile this code, there's no error, but you can see there's a warning here. Again, we'll talk about that warning in some time. But let's run this code and see what happens. And you can see we got the output. So we can directly print a collection. That's a beauty. Okay. Can we print this value one by one? Actually, we can. Okay. So what you can do is you can use a loop here. So I can say for we can use index values. Let's see, do we have index option here? So I can say nums dot. If I say get, unfortunately we don't have the indexing for collection API or collection interface here. No issue. I can use enhanced for loop. Remember we have used enhanced for loop with the loop. So I can say int n colon nums, and I can print each n value. So I don't have to do this. Again, how do we use index? That we'll see later, but at this point, this should work. Okay, the only problem here is, okay, let's talk about the problem which we are getting this gray, this yellow line here. See, the thing is, when you talk about a collection, when you're getting nums here, right? See, in array, you specify the type as well. You say int nums, right? So you know that in this nums, you'll be having only integers. But when you talk about collection, nowhere we have talked about the type of it, how it will work. Okay, and that's where what you have to do is, you can mention the type. And that's the error you're getting here. Because it says the values which I have added here is not actually numbers. These are object type. That's right. As we talked about integer, float classes, all these classes basically extends the object class. And by default, the collection API works with objects. And this 6, 5, 8, 2, they're not integers, they are objects. And that's why you cannot store that into integer. How do we solve this problem? So if you want to solve this problem, we can use a concept called generics. Okay, now how it works. So basically, where should we mention the type? Maybe what they could have done is, this is what they have done in 1.2, 1.3, 1.4, but they realized one problem, right? Which is by default, all the values here are objects. So how do we specify? Maybe they could have created some extra classes by saying integer array list, integer collection, string collection. What if you have your custom class like student? So it will be difficult for them to create all the classes, right? So what they did is they have given you one option where you can use angular brackets here. So just after the collection, use the angular bracket, and in that you mention the type of element you want to work with. So we are working with integers. So integer is basically a class, which is a wrapper class for the int type, because int is primitive, integer is a class, and collection normally work with objects, not the primitive values. So if you want to store integer numbers, which is you have to use a class integer. And you can see now there's no problem. There's no yellow zigzag lines. And we got, there's no error here as well. Let's see if this works. I will say compile and run. And you can see we got the values. Now, one more thing, why this type here is so important. See, it also helps you to remove the bugs of your code. Now, what bugs it can be? Example, let's say, if I don't mention integer here, okay, let's say if I remove this part and everything is object, right? And then here, what I'm doing is we can use enhanced for loop. The only thing is I can't use object here. I can't use int, I have to use object. And then I'm converting this object into integer. So we can do that by typecasting it here. So I'm just typecasting it to integer. In fact, we can do it outside as well. Let me just do that. So I will say int num is equal to, I'm getting a num variable again, and I'm converting this n to the integer type. Okay, so you can see we got num. And what if with this num, I'm performing some operation? Because I want to perform the operation, that's why I can't use object. And now if you try to work with this, you can see again we got the warning because we are not using type there. And if I run this code, it works, there's no problem. But what if by mistake, you're doing the code and you have added a number, but that too in double quotes, let's say 5. Now what will happen? Okay, so let's see. If I compile this code, there's no problem. If I run this code, we got an exception. And it's bad, right? And this is also runtime exception. This is runtime error basically. We don't want this. And that's why I think this type of problem should come in compile time itself. So if you mention the type with the help of generics here, and if I mention integer here as well, now if you can see, we will get the compile time error, not runtime error. And that's why if you compile this code, okay, you can see we got a compile time error. And that's why it is better to put this type every time. So whenever you work with collection, always mention the type there. Cool. So that's how we use array list, and it has multiple methods. Now the only problem is we are not using the we're not able to get the index value, right? See, the thing is, if we talk about array list, as I mentioned in the diagram as well, array list is a class, if you can see here. So it's basically a class which implements a list, right? And if you talk about this list does have a method called get, because list works with index values. So which one to use? Should I use a collection here or a list? Say if you just want to add values and fetch, collection makes sense. But if you really want to work with index value, instead of collection, we should use list, because list supports index value. And you can see now I'm working with list here. And now if I want to print a particular index value, let's say I want to fetch the second index value. So I can say nums dot get. As you can see, we have a get method, and in this get you can mention 2. So which is, it will give you 3, it will give you 8, which is at index number 2, right? Let's try. I will say, in fact, let me just not print this loop, compile, and okay, run, and you can see we got 8. So if you want to work with index, you can use list, and list has some extra methods. So if you can see, I can say nums dot add was there. We got get. We can also set the value in between with the index value, and anything else. Yeah, we also have index of. So if you have an element, if you want to know the index of it, example, let's say I want to find the index of this 2 value. So what I can do is I can say sout. We'll say nums dot index of. I want to print the index of 2, right? So 2, I'm talking about the value now, or maybe this looks like quite confusing. So I will say 5. So index value is 1. If I compile and run, you can see we got 1 there. So yeah, it has multiple methods, and I would recommend you to explore more methods of list. And that's how you work with list and array list. Now to this point, we have talked about list, right? Now list is one of the collection API concept. It supports index values, right? So we can create a list and we can work with indexes there. The only thing is, when you talk about list, of course, it's great. It does support multiple values. Example, let's say, and that's a feature. Okay, I'm not talking about the drawbacks of it. So I can say I can add an element, let's say 6 again. If you can see, I have two elements with the same value, which is 6. Now, if you're wondering what is this E here, again, this is given by my VS Code. It simply means element. And if you see, if I try to run this code, if I compile this code and run, you can see, okay, we're not printing all the values, is it? No, we're not printing all the values. So I will just remove these 2 lines and focus only on the for loop here. And let's see if this works now. So I will say compile and run. You can see we got, I guess we are doubling as well, right? Anyway, you can see we have a list which has same values. So yes, your list does support repeated values. But sometimes you want to have a collection where you can only have a unique values. Remember when we talked about the collection as an interface, it is also extended by a set interface. Now set supports unique values. Okay, so what I will do now is I will have the same values, okay, but instead of using list, I will say set, and let me import the package for this. I will say control space enter, and we got a package for set as well. And then I want to specify not an array list. Okay, because see, the thing is, if we talk about set, yes, set extends collection, but the class which implements set is different, and the class name is hash set. Okay, I can import the package for this as well, and done. Apart from this, the syntax will remain same. We also specify the type here, the generic type, which is integer. And okay, let me remove the list import. Let's only have set and hash set. And you can see we can have the same method add also here, and we can print all the values. The only thing is here I will be very specific that I'm working with integers. Let me remove this, and I also want to print the value num. That's it. Okay. Now when you have these values, let me just compile and run. You can see now the value is 2, 5, 6, 8. First of all, we can't have a repeated value. You can see 6 and 6. We only got 1 6 here. The second thing is it is not following the sequence. Remember, if you can see, the sequence is 6, 5, 8, 2. But we are getting the values in sorted format. Is it really sorted? Let's try. What I will do is I will just make this. Okay, first of all, we know that we cannot have repeated values. I mean, we can add it. It's just that it will not have the same value again. Let me just make this as 54. I will make this as 82. I will make this as 21. And this is, let's say, 62. Again, we have a bigger values now. Let's see if they are really sorted. I will say compile and run. If you can see, it's not actually sorted. It's 82, 21, 54, 62. Okay, it is not sorted, and it is not even going for a sequence. And that's how this set works. set will not give you value in this sorted format. Okay, it basically uses, and it also doesn't have index value. Example, if I say nums dot, for list, remember we had a get. Here we don't have get. I mean, we don't have a get which takes element. We do have a get class, but we don't want it. We want a get method using which you can specify the index value. Set does not support index value. So certain things to remember for set. So set basically is a collection of a unique value. If you see documentation, it says a collection that contains no duplicate elements, and it does not even have a index value. Is it not mentioned anywhere? Anyway, so you can't have index value. And remember when I mentioned about collection API, it was introduced in 1.2, and also it is also called collection framework. Okay, instead of saying API, you can also say it's collection framework. Cool. So this is your set, and that's how it works. What if you want a sorted value? So instead of using has set, we can use something called a tree set. So let me import the package for this. Import. And now if you try to work with this, so you can see we got all the sorted values. So basically this tree set actually extends, if you see, it extends an abstract set and implements a navigational set. And if I go to navigational set, you can see this interface actually extends a sorted set. And that's why all the elements in this tree set will be sorted. Okay, it is a set, but then it is sorted set. So it depends upon what type of elements you want to work with. If you want to trace a particular element, then tree set makes sense. But if you want to have a set which will have only unique values, there is no need for ordering. You can go for has set there. One more thing, instead of saying set here, we can also say collection. Even that works, because anyway, the tree set implements set and set extends collection, right? So we can use that as well. One more thing to add, if you look at collection, and if you look at our diagram, on top of collection, we have one more interface which is called iterable. Since we can iterate between the elements, right, with the help of enhanced for loop or we have different options. So it actually extends iterable, and if you go to iterable, we have an option called iterator. So that is one option. You can use a iterator method, which will give you a iterator itself. Let me show you how that works. Instead of using a for loop, I can say nums.iterator, right? So we got the iterator. Now this iterator will give you the iterator back, the iterator object. I will say this iterator is integer. I will import the package, and here I can say values equal to. So from this iterator, I got all the values here, and then from this values, I can print the values. I know that sounds weird, right? But let's do that. I'm not using a for loop. So how do you print all the values? So basically values has a method called hasNext, and it also has a method called next, which will give you the next element. Okay, it will give you next element, but it will only give you one element, right? I can put that in a loop to get all the elements. But which loop we have to use? In fact, what I will do is I will just try to print this next element. But the problem is it will only give you one element. How will I use a loop here? Because see, if I use a loop, I need to know how many elements we have, right? So one thing we can do here is we can use a while loop, because it has a method called values.hasNext. Now hasNext will tell you that do we have a next element? Okay, and let's try if that works. Compile and run, and you can see we got the values. So even this, we can also use iterator. That's also an option, and that's why we got the topmost interface, which is iterator. So that's how we use set, iterator, and tree set. We can also try it with the linked has set, but then yeah, internally they work differently, but you can get the values. Okay, so we have talked about list, we have talked about set. Of course, we have different classes as well for different structures, and this is a famous one. Now there is one more which is called map. Now map is not an implementation, or it does not extend collection interface, but it's a part of collection concept, collection API, right? So what I will do now is let's work with map here. But why do we need map? See, the thing is when you work with list, let's say we have a list here and list of values we have. Okay, so we have list of values. Let's say the values are 56, 23, 67, and 92. Now we have these values, right? And let's say if you work with array list here, or if you work with list, basically for these values, if you want to work with these values, you need to work with the indexes, right? We have to say 0, 1, 2, 3, right? But sometimes it's better to have a name or a different kind of index instead of having 0 and 1, 2, 3. Example, let's say if we talk about phone book, we have a name and a number, right? So can we have something like this? I want to say these are my students' marks, right? So I want to say this marks belongs to Naveen. This marks belongs to, let's say, Harsh. This marks is belong to Sushil. And we got Kiran. So instead of having index value, can we have a name to it? Okay, instead of having index value. So can we do it? And that is possible with the help of a concept of key and a value pair. So we have a key and a value. So example, this value, which is 56, 23, 67, 92, they are values. And the key for this is Naveen. The key for this is Harsh. The key for this is Sushil. And the key for this is Kiran, right? And we can achieve these two things in one data type or data structure, which is called a map. So what is map? Map is basically a collection of, not map, map is a collection of key and a value pair. How do we achieve that? So what we can do is we can remove the entire section from here just to keep it clean. And let's work with, okay, we don't even need these imports now. So let's create a map. So where you can create a map is map. And okay, let's import the package for this, again, java.util. And we can say this is students, that's a map of students, and new. Now map itself is an interface, if you can see, and it supports key and a value pair. Now if you remember when we talked about array list, it was having E there, right? Because it represents elements. In map we have KV. It is just a character representation of what you are going to insert. Now this K and this V can be replaced with data types like string, integer, float, or we can have student, string, whatever the type of you want to work with. So now we have to look for a class which implements this. So the class name is hashmap, right? And in this as well, we have to mention the type of it. The type of key we are working with is string, and the type of value you're working with here is integer, okay? And of course, it can be anything. It can be string, student, it can be student, string, that's your choice. Whatever data you're entering, but we got this map here. Now, once you got this map, I can simply add some values here. How do we add values? It's very simple. You say students dot. Now we don't have an add method. We have a put method. So we have to use put, and we can specify two things, the key and a value. And as per our diagram, we have seen the key I want to insert is Naveen, and the value is what, 56. And likewise, we can have all the values here, copy, paste, paste, paste. And this is Harsh, and the value here is 23. This is Sushil, the value is 67. Kiran, it's 92. So we got all this key and a value, right? And then if you want to print it, you can actually do it. Before this, we were using list, and then for every value here, we were using index, but now we have a logical name to it. It is much easier to work with names, right? So I will say S out, and here, let me print the students. Basically, I'm printing the map itself. I will compile this code and run, and you can see we got a map. We got Naveen 56, we got Sushil 67, we got Kiran 92, and Harsh 23. Now, one thing to observe, even this is not following a sequence. You can see we got Naveen first, then we got Sushil, we got Kiran, we got Harsh. Okay, looks like more of a set, right? Let's explore more. Okay, so we can do that. Otherwise, if you want to fetch a particular student, only one student, you can say students dot, you can say get, and in this get you can specify the key. Let's say I want to get the marks for not all the students, but let's say Harsh. I can specify the key here, and if I compile this code and run, you can see we got 23. That's the marks for Harsh. Okay, we can do that. Okay, one more thing. I want to print all the values. But then what I will do now is, let me say, during my school days, we used to, after the exams, when the paper is checked, we used to get the paper back to calculate the marks, right? So we used to turn the page, we used to calculate each and every marks. And at the end, once we add all the values of all the marks of each question, if that marks is more than the marks which you got on the paper, which is checked by your professor, we used to go and correct it, right? Of course, if you got extra marks, then you don't go there. But let's say Harsh got 23, and after calculation, we have changed it. So let's say students.put, and now I'm saying Harsh, and the new value is, let's say, 45. There were a lot of mistakes in the paper. So let's say we got 45 here. Now tell me, will it add a new student as Harsh, or will it replace the existing value? Let's see what happens. If I compile this code and if I run, you can see for Harsh, we only got one Harsh here, which is 45. We don't have two Harsh. That means the key cannot be repeated. Keys are unique. the values can be. Example, I can have 2 students with the same number. And of course, we do get same marks, right? If you copy it. Anyway, so we cannot have keys repeated. So can we say these keys are actually a set? That's right. And the values are list here. So we have a set and a list combination to get a map here. Okay, so what I want to do now is I want to print all the values, and that's why you can see there's no sequence here because it's a set. Okay, I want to print all the values but one by one. I want to use a for loop here. Can we do it? The problem is we don't have, see, if you work with list and if you use a for loop, it will give you one value at a time, right? There's no one value here. We have 2, key and a value. So what you can do is, first of all, let me just get all the keys and let's see how it works. I will say students, I want to get all the keys. So do we have a method which will give me all the keys? If I go down, 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 yeah, you can see that we have a key set. Oh, we were right, it's a set. So I'm printing all the key set now. So if I compile this code and run, oh, okay, so that we got all the keys. If key set gives me all the keys, if I run a loop on this, if I say for, what's the type of key set? It's a string, right? So I can say string name colon, it is coming from students dot key set. Okay, so what I'm doing is this key set will give me a set, right? And from that set, you are fetching one name at a time. And with that name, I'm printing first of all name as it is. And I will give a space in between, or maybe a colon. And then I can provide I want to get the value. How do you get the value? So you can say students dot, remember we have worked with this, get, and you can pass the key which is name. Of course, right, your key is in this name. Or maybe I can, just to make it simple, instead of same name, I can say key itself. And here as well, I can say key. Here I can say key. Right, simple. And now compile, run. Oh, can you see that we got key and a value there. So that's how you can print all the values from a map. Now, why we are using our put method here is because when we say add, we are adding a new element. When you say put, it says try to add the element. If you already have this key, just replace it. That's put. Okay, apart from this, do we have some more methods to explore? So if I say students dot, we got a put. We can also say get. We can also get values, all the values. The way you have key set, which gives you all the keys. When you say value, it will give you all the values. Apart from this, we can use remove to remove the particular element or the particular entry. We can replace as well. Yeah, those are the methods we have, and please explore those methods to understand this more. So that's how basically you can use map. In fact, apart from this, we also have a hash table. So if you can see, we have hash table here, and both works almost same. If you compile this code and if you run this, you can see we got the same output. So what's the difference between hash table and hash map? If you go here and if you go on top, okay, so if you can see in the hash table code, it says the new collection implementation, which is hash table, is synchronized. Now it depends upon which you want to use. So if you want to use a synchronized version, you can use hash table. If you want normal, we can use hash map. Now what is synchronized? If you remember, we have worked with threads. So if you have multiple threads working, then it's better to use hash table to make it synchronized. Right, so if you go up, let's go to hash map to see what it says. So if you go to hash map, okay, it says if you want to work with multiple threads and if you still want to use hash map, then use synchronized externally. So if you want to use synchronized, use hash table, otherwise hash map works. So yeah, that's how basically you can use map, and that's how you can fetch the values. In this video, let's try to work with sorting. So let's say if you have a collection and you want to sort it, how will you do it? So first of all, I will create a list of values. I will say list of, I will say integers this time, and then let's say nums equal to new, add a list, right? And then we can import this. Okay, now one thing to observe when you talk about this type here, on the left hand side, there is no compulsion to add that on the right hand side, okay? At the start, when generic concept came, it was compulsory for us to assign the values or to set the type on both the side. But after 1.7, they have kept it optional. If you specify on the left hand side, on the right hand side, you can simply keep empty bracket. That completely works. Okay, so in this add, let me add some values. I will say nums.add, I will say 4. And likewise, let me add some elements here. Okay, so let's say we have these values here, and what I want to do is, of course, if I print these values, it will be printed as it is, and it follows the sequence as we have seen. So if I compile this code and run, you can see we got the values. Now what I want is, I want to sort these values. How do I do it? Now we have a very special class called collections. Okay, as I mentioned in the first video, we have a collection class as well. And this collection class has a lot of methods. One of the method is called sort. And in this sort, you can pass the array or array list which you want to sort. Okay. Now collection class belongs to util package. Okay. And then once you say sort, and after that, if you try to print these values, and let's say the output, if I run this code, you can see we got 3, 4, 7, 9. So sorting is actually very easy in terms of collection here, right? Now the thing is, what if you want to sort this based on your own logic? How will you do it? Example, let's say the values are 43, 31, and then 72 and 9, or let's say 29. So we got all these values, right? And then I want to sort them based on their last digit, not the entire number. Because again, if you sort this value, it will be sorted based on the values, right? I want to sort based on the last digit. So I want 31 to be first, then I want 72, then 43, then 29. So this one first, then this 2, then this 3, and then this 9. How do I change a logic here? See, by default, sort will take its own logic, right? In case if you want to have your own logic, in that case, what you can do is, we can use something called a comparator. As you can see, we have a comparator here. Okay, how do I use it? So if you talk about comparator, let's try to use comparator here. So if I use comparator, and if you go there, comparator is basically an interface. Okay, so how do I use comparator? So I can say comparator comp is equal to new comparator. Now this is an interface, right? And we know we have multiple ways of implementing an interface. We can create a class which implements the interface, or we can use something called an anonymous interface, anonymous class here. Okay, this comparator works with integer, and I can specify that here as well, which is integer. In terms of anonymous class, it is compulsory to specify on the right hand side as well. Okay, we can use this comparator here, and in this I will define the method. Which method we have in comparator? So if you look at this comparator, we have a method called compare. Okay, that makes sense. We can use compare here. What's the syntax for compare? It is, okay, not this one. The syntax is int compare and pass the two values. So t is a type here. So integer. Okay, so I will say public int compare. And we have to specify two values basically. One is your, I will say int I, comma int j. See, when you basically sort the values, normally you compare two values. Example, let's say if I give you 4 values here, 2, 3, let's say we got 4, we got 3, we got 1, we got 6. If I want to sort this, at one time I will compare two values. I want it to be ascending order. So smaller value come first and then the bigger value go second. So I will compare these two values. If the first value is greater than second value, I will swap. So after swap, it will be 3, 4, 1, 6. Then I will compare these two values. Then it will be 3, 1, 4, 6. Then I will compare these two values. So this will be 3, 1, 6. Oh, sorry, 3, 4, 6, because the first value is smaller than second value, no swap. In this case, we have swapped it because it was a bigger value. Now, once you got 3, 1, 4, 6, we'll do this iteration multiple times. Again, you will compare this two. This will be 1, 3, 4, 6. Then this two, it will be 1, 3, 4, 6. Now, we don't have to do that. We don't have to compare the last two because in the first iteration, the biggest value comes at the end. So we got that, right? So we have to do that only 3 times. And again, for the next iteration, we can say 1, 3. I know this is sorted, but still we have to continue the iteration. First compare first two, 1, 3, 4, 6, and you're done, right? So this is how basically you sort the elements. The aim here is when you sort elements, this is one of the algorithms for sorting. Basically, we have to compare two values and swap. That's basic rule, right? So here as well, when you say you're sorting, you have to just have to specify when to swap and not to swap. So when you compare I and j, if you say, okay, now we want to compare, and how do you specify that we have to swap? So if you return 1, it will swap. If you return -1, it will not swap. It's that simple. Okay, so what I will do is, I will check, and I want to check the last number, right? So I will check if, how do we get the last number? Oh, mod 10. If I mod 10 is greater then the J mod 10, in that case swap. Else you can say return -1. Okay, so this is how basically you specify the logic. And I can still see an error here. What is the error? The compare method is correct. Okay, there should not be any error here. Okay, let's see what happens. So what I will do is I will pass this com object here itself. So I will say com, and okay, there's still an error. I don't see any reason to get the error. Did I forgot any colon or something? Things are looking good. Let's compile this one. Let's see what happens. Compile, there is an issue. Is not abstract, does not override. Okay, it is giving an issue with the compare method. Is it the right method name when I'm using compare? Okay, that's right. Okay, do we have to use the class names here? Integer and integer. Oh, it was because of the class name. My bad. Yeah, so we have to use a class name here, right? Because collection works with the wrapper classes. And now I will try to compile this code and okay, compile 2 times and run. You can see we got the sorted values. We got 1, 2, 3, 9. So basically what we are doing is we are changing the way it sorts the value. If you want to specify your own logic, we have to pass an object of a comparator. Now in this object creation of comparator, we have to specify the logic based on which you want to sort this. In fact, let me give you a challenge here. What you can do is, instead of creating the list of integers, create a list of string and sort the string array with the help of the length of the string. Okay, that will be awesome, right? Try that. This is how you sort the value based on the comparator. So what is comparator basically? So comparator is a concept or an interface using which you can specify your own logic for sorting. Okay, that makes sense, right? Now I will do something else here. What I will do now is, instead of having a list of integers, let me have a list of students. Okay, so what I will do is, I will create a class here called student, and let's say we have int age for the student and string name, and I also want to have a toString method so that I can print the object as it is. So I will say source action. I want to get a toString method name because I want to print the student values as it is. And let me also have a constructor using which I can assign the values to them. I will say source, I want a constructor which can take both the values. Okay, this makes sense. Let me remove this at override for time being. Okay, so we got a constructor, we got 2 strings. So what I will do now is, instead of creating a list of integers, let me create a list of students. I will say student here. And then, because that type of student, right? And we cannot add numbers now. I will say these are studs. I have to replace this with studs. Or maybe let's have numbers. What's an issue? And then here, instead of adding a number, we have to add a student, right? So I have to say no student. And this will be value 1. Or let's say we have to specifying age, right? Let's say age 21. And name is, let's say, Naveen. Then let me just create some more objects here. So let's say age 12. Name is, let's say, John. And then age we got here is 18. Let's say Padul. And we got age 20. Let's say this is Kiran. Okay, so we got this 4 student here with different age and different names. Now what I do is I want to sort them. Okay, time in, let me just comment this section. I want to print the array list as it is, and let's see what happens. If you compile and run, you can see we got all the values. The only thing is they are getting printed in a weird way. I want to print them one by one. So we can use enhanced for loop here. So I can say student as colons nums. I know we should have used studs there. You know what I can do is I will replace nums with studs. Okay, this should solve the issue. And done. Okay, so we got from studs, and I want to print one student at a time. Let's see if that works. Compile and run. Okay, so we got all these values. Now what I want to do is I want to sort these values based on their age. How will I do that? In that case, I have to say sort. Okay, let me just try natural sorting. The moment you do that, it is not working. Can you see that? The sort method is not working. Okay, let me pass the comparator object. The only thing is now this comparator is not working with integer, it is working with student. So you have to say student now. And both this object, so again, we have to compare 2 students, right? So we need two students at a time. So I will say student and student. Let's say this is I and J. Now, how do we compare them? We are comparing their age, right? So we have to say I dot age is greater than J dot age, then swap. It's so simple, right? Since we have worked with the integers, it should work normally. And if I run this code, okay, so that we got all the students with the ascending order of age. We got 12, 18, 20, and 21. This works, right? So this is how basically we can use comparator and we can sort a student as well. But there's one more thing. Why we have to pass a comp here? Why not, if I just say student, why it's not sorting? It's because the student, we have not specified the logic for the student, right? Because if you go to the integer class, let me just type integer here just to see. If you go to integer class, you can say integer class implements something called a comparable. And that's why by default, the sort works with integers. Our student is not implementing comparable. So if you want to have a natural sorting, you can also implement something called a comparable. The only thing is this comparable interface has a method called compare2. Okay, so we have to define that method. So I can just come back here and say implement this compare2 method. This is the signature. Okay, and we are comparing this with a student itself. And let me say this is that. Okay, the name of the variable is that. I will tell you why I've said that. But now what I'm doing is I'm adding a method called compare2. And I'm implementing something called a comparable now. And then this comparable actually works with a student. We have to mention that as well. Now, if you go back, you can see there's no error now. So sort method does work with student provided you are implementing comparable. If your students are not comparable, how can you sort them? That's what it says. But then if you try to compile this code and run, it will not work the way we want it. You can see it's not sorted. Anyway, I'm not using compare2 now. I'm not using comparator. What I'm using is I'm using compare2 of comparable. So whatever logic we have written here, the same logic I have to write here. Okay. Now the only thing is we have to compare two students, right? One student is that, so we can say this is that. What about the first student? The thing is we are defining this method inside the class itself, right? So what we can do is we can say this. Remember this keyword, current object? So this dot age, the current object, the current student, we are comparing the current student with the other student. It's something like when we don't have a comparable, and if we have two students here, we need a third person to compare two students. But now I'm giving this power to the student itself. They can compare themselves. So if I'm comparing with someone else, I'm this, and that is that. Okay, and let's see if that works now. Compile and run. Oh, it works. You can see that we got 12, 18, 20, 21. So this is how basically we can use comparable and comparator. So you have two choices. Either you can make your class implements comparable. If you don't want to do this, you can also use comparator. In fact, even if you mention comparable, you can still override the logic by comparator. That's your choice. Okay. One more thing before we close this. Let's say I want to use comparator here. If I pass comparator, and I want to reduce this code. Remember Lambda expression? This is a functional interface. We can use Lambda here as well. So what I can do is I can remove this entire part from here to here. I know you have to watch this video multiple times to make it work. I can put an arrow and we can put this curly brackets as well. One more thing, instead of using if else, we can also use a ternary operator here. So the same logic, I can just comment this part. I can say return I.age is greater than j.age, return 1, otherwise return -1. So instead of using if else, I'm using ternary operator. We can remove this part. Now, since we only have one statement and that to return, we don't need return, that is optional. We can remove curly brackets as well, and we can write everything in one line. Again, watch this video multiple times to understand what I'm doing here. And also, in the Lambda expression, you don't have to specify the type. You can simply say I and j, and your job is done. You can see that entire comparator went into one line, and that's why functional interfaces are so important. Let's see if this works. And what I will do is I will just remove this from comparable, just to see if that works without implementing comparable. Implement, run, it works. What is comparator? If you want to specify on which logic you want to sort the elements, you can use comparator. What is comparable? If you want to give a power to the class itself to compare itself or to compare its object to itself, we can use comparable there. In this video, we'll talk about Stream API. Now, before we understand Stream API, first of all, it's a new concept. It came in 1.8, Java 1.8 basically, and it provides some amazing feature. The only thing is, why do we need those features? We'll understand that first. So what I will do is, first of all, I want to create a list of values. Okay, so let's create a list here, and I will say this is of type integer, and I will say nums. And of course, just to keep it simple, I'm going with the default names, so that you don't have to focus much on the naming convention. I want you to focus on the concept. So we have the array list here, and in this array list, I want to have some values. We have nums dot, let's add some values. I would say add 4. In fact, you know what I want to do? Instead of adding values like this, there's another way using which you can add values in the list, which is there's a class called arrays, and arrays dot as list, and you can simply pass the values here instead of manually typing the values. Even this works. So as list is a method which gives you a list, and it belongs to a class called arrays. Okay, this is much simpler, right? Now, once you got this list, what if you want to print these values? Of course, I can say sout and I can say nums, and by doing this, we can simply print all the values, and you can see we got all the values. Now, what if I want to perform some operation on this? Okay, now what kind of operation I'm talking about? So let's say I want to double all these values. And in fact, I want to first apply the filter here. So let's say I don't want odd numbers. I only want to focus on even numbers. Example, we have 4 and then we have 2. Ignore this dot a, basically it represents an array. So we got this 4 and 2. I want to filter them. And whatever value you get after filtering, I want to double those values. So example, 4 and 2 becomes 8 and 4. And at the end, I want to reduce it. So I want to say, okay, 8 plus 4 is 12. So I want the output to be 12. The way you can do that, first of all, I want to apply the filter, right? So we can use a for loop, and we can go from the first value to last value. So I can say int n colon from nums. And once you get this value, I want to apply the filter. Because see, I don't want to add all the values. I want to add only the odd numbers, and that too after doubling it. I want to add even numbers basically. So we can check if my n mod 2 is equal to 0. That means that's an even number. If that's an even number, I will first of all double the value. So I will say n is equal to n into 2. So doubling done. And then once you have doubled it, I want to add it to a sum. Let's say I will create an int sum variable. The initial value is 0. And whatever doubling you get, you simply say sum is equal to sum plus n. Okay. So by doing this, what I'm doing is from all the values which we have here, let's say we have some more values. Let's say 6 as well. And let me add one more value here, which is 3. So you can see we have so many values, but I want to first of all filter only even numbers. Example, I want to fetch this 4, then this 2, then this 6. I want to double each value. So example, 4 becomes 8, 2 becomes 4, and 6 becomes 12. So this is 8 plus 4 is your 12. 12 plus 12 is 24. I want the output to be 24. And let's see, do we really get 24 here? Let me print the value for sum, compile, and run. And you can see we got 24. Now this is one way of performing the operation on your list. Now, sometimes you perform such an easy operation, and sometimes maybe you do something by using which the values, in fact, the original values gets changed. So instead of doing those things, we got this amazing way of doing this calculation, which is called a Stream API. Now, it was introduced in later version. Before this, people used to work with this way. But in Stream, we got a different way of doing this. Okay. Now, basically, we got this new thing, which is called Stream. So if I jump to Stream, which belongs to java.util.stream package. And if I click on Stream, you can say Stream is an interface, and it provides you multiple methods like we got filter. That makes sense, right? If you want to apply the filter on the stream or the collection, we can use filter. If you want to change a value, example, we have doubled the values, right? That can be done with the help of map. And we'll individually see these methods later. So if you go down, you have sorted. In fact, there is also a method called reduce. We are going to use that as well. So there's reduce as well. Okay, we'll see that later. So basically, Stream provides a lot of methods to work with this. Now, how exactly to use Stream, that we'll see in the next video. But before that, I want to show you one thing. So let's say we were able to do this, right? At this point, I will just comment this section because we'll talk about that later. I want to do one more thing before we start with Stream, which is how do I print all these values? A simple printing. So we can use a normal for loop, right? The normal for loop works in this way. We can use int I is equal to 0 and int I less than, we have to get the nums dot length or size. Yeah. The method name is size, and then we have to say I plus plus. So we have to use normal for loop, and then we can print each value. I can say nums dot get, I can pass the index value. And if I clear this, compile and run, and you can see we got all the values here. Okay, this is one way. I can comment this section. The another way of doing this is using a normal for loop. I can say for int n is equal to num, and here I can simply print the value of num. Even this works, right? Now you tell me which is better, using a normal for loop or the enhanced for loop. See, normal for loop, what it does is it basically goes to the loop, or it basically goes to the list by saying, hey, I want to fetch the first element, I want to fetch the second element, right? On the other hand, if we talk about the enhanced for loop, it says the array itself will give you the value, and that value goes into n, right? Now again, this too looks good, but then we have a better way of doing it. So I can just comment this section. The better way is very simple. What you can do is you can say nums dot. Now we got a new method called for each method. Now using this for each, it will give you one value at a time. You can save that in n, and then you can simply come back here and you can say, I want to print this n here. So for each is a part of the list interface. You can simply say for each, and then it will give you one value, and you can do whatever you want to do with that value. So I'm just printing it here and here. And if I compile this and run, you can see we got the same output. So we have three options now. We can use a normal for loop, we can use the enhanced for loop, or we can use a for each method. So let's understand what this for each and what is this statement inside this. This looks weird, right? Yeah, I know we have worked with Lambda expression. It looks like Lambda expression, but what is happening behind the scene? To understand that, what I will do is I will just remove the entire for loop. We don't need that. And let me just push this down. This will be required later once we talk about how do we stream API. But at this point, let's only focus on for each here. So what I will do is, first of all, I will remove this section, or maybe I can just comment it so that we can see this later. Here at this point, let's try to use nums. So when I say nums dot, you can see there is a method called for each. Now for each method, if you see, and if you go to this definition, for each basically got introduced in 1.8, okay? And what it basically does is, it takes an object of consumer. You can see for each method, okay, let me just go to definition itself. So you can see for each method takes an object of a consumer. Okay, that sounds weird, right? Let's see what this consumer is. So if I want to work with for each, I need to create object of consumer. Okay, so the moment you say you have to create object, I can simply say consumer, and you can see consumer is a interface which belongs to a package java.util.function. Okay, that's new. And this is an interface which is a functional interface. So that means Lambda expression will be applicable. And the only method we have to work with this is accept. Okay, that means I have to create object of consumer, which takes the type of integer, because if you see the consumer interface, you have to specify type as well. So I will say consumer integer, and then I will come back here. Let me say con is equal to, how do I create an object of it? It's very simple. You can say new consumer. Now, since this is the interface, we have to define the class, which is anonymous class. Okay, that is also simple. The only thing is we have to define a method also. The method name is public. Void, is it void? Let me just check once. Consumer has a method called accept, which is of type void, okay, which returns void. And the method name is accept, I will say that. And then it takes the integer value. I mean, whatever type you mentioned, I will say integer, let's say n. Okay, now the thing is, once you got this consumer object, you can simply pass an object in this. I can simply say con. So for each needs an object, and we are passing the object of consumer. Our job is done, right? The thing is, when you talk about for each, what it does is it gives you one value at a time, okay? Now, whatever value you are getting here, or for each is giving you, that goes into this consumer object. And the consumer object has only one method, which is accept. Okay. Now, this accept will accept a number. That's right. The for each will give you a number, right? That goes into this n. Now, you can decide what you want to do this with n. Okay, I would say I just want to print it. I mean, that's your choice. You can do whatever you want to do with this n. At this point, I'm just printing it. Okay. And now let's see if this works. I will just go back and clear the screen, compile, run, and you can see it is working. You are able to print all the values. Okay, and you can see the entire code, all the other codes are commented. So they are not running. This code is running and it is printing all the values. Makes sense. Now we also know that the consumer interface is a function interface, which means we can use Lambda expression here. That also means from here to here, we can delete this part. Let's delete that. Let's delete this curly brackets. And I hope till this point you got a mastery in Lambda expression. And I can give an arrow here. That looks good. And since we only have one statement, you don't need to put curly brackets. I will remove that as well. And I can write everything in one line. That looks cool, right? And then we don't even have to mention the integer here. And we don't even have to mention a bracket when you have only one variable. Makes sense, right? Let's see if this works. After doing all those changes, compile and run, there's no problem. Now, what we're doing is we are assigning this expression to con, right? Now, wherever we have con, we can actually use this. So instead of using con here, I can simply use this particular code and replace this con. And that's it. We don't even have to create a reference for the consumer. And this is what we have seen earlier, right? If you compare the earlier example, this looks similar. In fact, exact same. So that's how your for each works. It gives you the value, that is your n, and you can do whatever you want to do with that n. You can print it, you can add it, you can save that in database. That's your choice. Okay, so that's how basically we use a for each. Now, once we understand for each, let's go for the actual Stream API. So basically, we were having this collection or a list, right, where we have values, and then we were able to print that with the help of for each. And now we know what is happening behind the scene, right? What if you want to do this with a Stream API? Now, let me just give you the introduction of Stream API here and how it looks like. So if we talk about Stream, Stream is an interface, right? So if you can see, we have seen that before as well. Stream is basically an interface, right? The thing is, if I go back to nums and if I say dot, you can see now in the list, we got this new method called stream. Again, before 1.8, the method was not there. It was introduced later. But we got this method called stream. Now what this stream does is it gives you or it returns the object of stream. Okay. So that means if I want to accept the values, I can say stream of integers. And let me just name this as S1. So this is our stream, which is called S1 here. And we got all the values. So whatever values you have in this list is available in this S1. Now with this stream, you can perform any operation. And the beauty is it will not going to affect the nums. So whatever changes you make to the stream, if you change the values, if you double the values, it is not going to affect nums. Now, why this is important? See, sometimes when you have a data, and then if you want to perform some operation, it's not like always you want to change the existing values. Remember when we talked about threads, when you have multiple threads and then you are performing some operation, mutation, it's not good, right? So whatever changes you want to do that in this stream and use it. At least you have your original values with you. Okay, now that means I can also print the entire thing with the help of for each. I can say s1.forEach. Mind you, again in the stream of s1, we got all the values which are there in the list. And let me just try if that works. I will say compile and run, and you can see we got the values here. Now, one of the things about stream is once you use the stream, you can't reuse it. And that's why the name is stream. Example, if you talk about the flow of water, the stream, right? Once, example, let's say if you're sitting near the river or the bank of river, basically if the water passes, you can't retouch the same water. In the same way, once you have worked with a stream, you can't reuse it. Example, let's say if I try to print this multiple times, let's say 2 times, it will not give an issue with the list, okay? You can simply say nums.forEach multiple times, there's no issue. But if you try to do that with the stream, once again, you can see you will get an error. Compile time, there's no issue. Runtime, it will work once. The second time it will say, the stream has already been operated upon or closed. That means you can use stream only once. Okay, that makes sense, so we can't reuse it. But then what is the benefit of using stream here? The benefit is, stream provides you a lot of methods to work with. Example, if I say s1 dot, we have methods. Example, we have methods like filter. Remember when we talked about the earlier example where we were removing all the odd values, or we wanted to only get even numbers, we can do that in stream as well. Now how it looks like, I can simply say s1 dot. We can use a method called filter. Okay, now what this filter will do is, filter will say, okay, I want to apply the filter here, but give me a condition. So for any particular value, let's say n, what you want to do with this? So I can say, I can use a lambda expression. I can say n mod 2 equal to 0. So I only want a even number here. So this filter, and if you jump to this filter, you can see filter returns a stream. So what we are doing is, when we say s1.filter, it will give you basically a new stream to work with. Well, let's say s2. Again, as I mentioned before, s1 is used, right? So when I say s1.filter, your s1 has been used now. Now you got a new stream. Now this s2 basically will have only the even numbers. Let me prove that. Let me print s2 and let's see what values you get here. So I will say compile and run. You can see we only got even numbers. Now see what we are doing here. We'll have a separate video on this, how filter works. But the idea is, the filter is filtering the value based on the even or odd. You can specify whatever logic you want to, but at this point I'm just specifying a logic of a condition of even, right? Now once you got this stream, I can create another stream where I'm doubling the value. I can say stream and I can say integer, let's say s3, because it will give you a new stream. I can do the operation on the new stream, which is s2. On s2, basically I'm trying to double the value, right? So you can do that with map. In this map, for whatever value you get, you can perform some operation on that. At this point, I'm just doubling the value, right? As I mentioned, you can use any logic. At this point, I'm just doubling it. And now let's try to see how this stream works. I'm saying s3 now because you can't use s2. s2 is done. And if I compile and run, you can see we got double the values. We got 8, 4, and 12. So yeah, stream provides you this amazing methods on which you can perform the operation on one stream, it will give you a new stream. You can perform the operation on the other stream, it will give you a new stream. In fact, you can also use some methods which will not give you a stream, but a last output. Example, let's say, if I say s3 dot, there's a method called reduce. Now in this reduce, if you say 0, comma, again, I will explain this logic later, what I've did, but let's say if I try to do this, if I say c, comma, e, c plus e, now what this reduce will do it, again, don't focus on the logic now, just focus on my reduce. This reduce will not give me a new stream. This reduce will give me a value of type, whatever type you mentioned with the integer, with the stream, which is integer. So it will give me int values. I can say int result equal to s3.reduce. And instead of using a for each, now why we can't use for each? Because reduce will give you a single value, which is there in the result. I can simply come back and I can print the result. And I can just compile this code and run. And we can see we got 24. Again, let me repeat, just ignore what is happening inside. We'll talk about this in the next video. What is happening inside this? Idea is stream makes your work easy by having these functions. We have a function like filter, map, reduce. Now, I don't know if you know about this concept of big data. Example, in this world, we are getting so much of data, right? Now, if you want to use all this data, first of all, you have to apply the filter on it. There are some wanted data, there are some unwanted data. So you can apply the filter. Once you apply the filter, the data which you got, you can transform it. Something meaningful. You can do that with the help of map. And then you can make a graph out of it, right? With the help of something called reduce. And then we were able to print the result. Let me just see if that works. Compile, no issue, run, and you got 24. And this is the same logic which you have done here. Can you remember? We have used a for loop which was giving 24. The same thing we have done with the help of stream. Now the beauty is you can actually write everything in one line. Let me show you something. I will just comment this entire section, and here what I can do is I can say nums dot, I can say stream, it will give me a stream of values. On the same stream I can say dot and I can apply a filter, and this filter can be any logic. As I mentioned, we are going for even numbers, 0. And on the same stream, because see, nums.stream, nums is the least, right? The stream method will give you the stream. On that stream, we are applying a filter. Again, we will get a new stream. And on the new stream, we are applying a map, which is n into 2. And then this stream will give you a new stream on which you are applying reduce, where we are saying 0, c plus e, or c, e, which will be giving me c plus e. And that's it. This reduce will give you one value, right? And that one value you can store in a result. So this nums.stream, let me just give a tab here. Yeah. So this basically nums.stream will give you a stream. On that stream, you're applying a filter. On that stream, we are applying a map. On that stream, you are applying a reduce. And then you got one value at a time. And this looks much better than the for loop. I know for the newcomers, this will be difficult. But once you get used to it, you will always prefer to use stream. Okay. And one of my favorite trainer or mentor says, Venkat Subramaniam says, it's not difficult. It's just unfamiliar. Okay, so this is how it works, and you can compare with the for loop, and this looks much clearer. In fact, it's much more readable, right? On a stream, you are applying a filter. On that filter applied, you are applying a map, and then you're reducing. Now let's try to understand what is happening here. When you talk about filter, what it does. When you talk about map, what it does. We understood what it does in the for each. It takes the object of consumer, but I'm not sure what it will do here. So what I will do is, just to simplify the code, I will remove everything. And also, let me remove all these things so that it will look cool, simple code. Okay, so let's go step by step. If we talk about this filter, and if I say, okay, let me just go to filter. And you can see filter needs an object. You can see there's a parameter. It needs an object of a predicate. Now, what is predicate? I will just go back here, and if I type predicate here, so if I say predicate, and you can see it belongs to a package java.util.function. And if I click on predicate here, predicate is an interface which has a method called test. It returns you a Boolean value. Okay. Now, based on this Boolean value, it will say, okay, it can be either true or false. If from a stream, when you apply a filter for a particular value, if this is true, it will go ahead. Otherwise, it will stop. It's something like applying a filter on a river. So let's say if you have a river flowing and then you have to apply a filter there. And if you want only the pure water to pass, all the garbage will be stuck somewhere. You can do that with the help of a filter. I hope that makes sense, right? Let's implement predicate here. So of course, predicate needs a type you want to work with. And then let me say this is P is equal to, and I will say new predicate. Now this predicate is an interface, so we have to of course define it, but what method it has. So if I go back and if I say quick fix, add the implementation method. So the method name is test. Okay, remove that. So method name is test, and it takes the integer value, and based on some condition which you can specify is it true or false. So what I can do here is I can check if the value t or whatever value you want to have. Let's say the value is n not. I don't like t later. Let's go with n. So if n is n mod 2 is equal to 0, in that case, return true. I can give a tab and I can say else return false. Our problem solved, right? Okay, so if it is true, if the value of n is even, it is true, then if this is true, I will return true or I will return false. And now what I can do is instead of this condition here, I can put p, right? Even that should work. Let's try, compile and run. And you can see it is working. So basically this filter needs the object of predicate, which specifies the logic of when to pass the value and when to stop the value. Now, if I try to reduce this code, don't you think this condition here itself returns true? Then why to write such a big line? We can actually return n mod 2 equal to 0. Because see, ultimately, we need a Boolean value, right? It can be true or false. So we can do this. Also, the predicate itself is a function interface. That means we can use Lambda expression here. So we can remove from here to here. We can remove the entire part. We don't even need to specify the type. And we don't need this curly bracket. We can put an arrow here. And then, since we only have one statement, you don't even need curly brackets. You don't even need a new return keyword. We can write everything in one line. And since we have only one parameter, we can remove this one. And you can see the p is equal to this expression. And whenever you have the expression, or whenever you have p, you can write this expression. And this is what we have earlier, right? So now we know how filter works. Let's see how map works. If I go to map, map needs object of a function. Okay, what this function is. Now function is this functional interface which takes two types. Okay, makes sense. And there's a method called apply. Okay, so what I can do is I can have the object of map, or not the map, the object of function. Now this function takes two types. One, it is what it accepts and what it returns. And say, let's say fun, because that is fun, and new function. And again, this is a function interface which has only one method. Let me just add that here. So this is a method which we want to override, which is apply. Now what I want to do, whatever value you get, let's say instead of TV, let's say n, whatever you want to do with this n, it will just apply that value. So let's say for this n, what I want to do is I want to return n into 2. So whatever value I'm getting, I just want to double it. Again, as I mentioned, logic can be anything, but I'm doubling it here. Okay, makes sense. And we also know that this is a function interface. Okay, first of all, let me take this fun from here and put it here. So we can say fun, and let's see if that works. I will say compile and run, and you can see we got 24. It works. What we can also do is from here to here, this is a function interface, so we can remove this part and we can use Lambda here. I will just do that quickly. Now we have mastered Lambda and we have only one statement which is returned, so we can remove that. We can remove this curly brackets, we can remove this integer, we can remove this brackets, and this is what we got. And now we know wherever you have fun, you can write this, and this is what we had before. So we don't even need this, right? The same thing can be done for reduce. If I click on reduce, you can see reduce takes two parameters. One is the type and second is the operation. Okay. Now what is this binary operator? So binary operator basically is, it extends by function. By function is a method called apply. Okay, let me just simplify this for you. I know this is a lot of implementation there. Let me simplify this thing. Now, when you talk about reduce, how do you reduce a value? Example, let's say if I ask you to add three numbers, let's say 1, 2, 3, how will you add them? Now, in your mind, you're doing this. So if I say 1, 2, 3, and let's say 4 also, how will you add them? Of course, you cannot add all the values at the same time. You add two values at the same time. So first of all, you will add 1 and 2, which will give you 3. Then you will add 3 and 3, which will give you 6. And then you will add 6 and 4, which will give you 10, right? So you add two values at a time. Or maybe if you want to simplify this, you can start with 0. So you can say 0 plus 1 is 1. Then 1 plus 2 is 3. Okay, so you have to start with the initial value. Remember when we created int sum, we have assigned the value of sum is 0. That is this 0. And every time you will simply add two values. So if I want to add two values, can I say this is C and E? The carry, because see, this 1 is a carry here, right? This 3 is a carry. This 6 is a carry. This 10 is 10 is the output, of course. But this 1, 3, and 6, they are carry, which can be represented with the help of C. And then we have this E, which is the element, right? C and E. And what you're doing is you just have to say C plus E. And that's what we have done here. The 0 is the initial value, what you want to work with, this value. And then the C and E are the two variables which is going to work with this thing. And the C plus E is the operation. It's that simple. Okay. Of course, you can do this with the implementation, but I think you got the point, right? So stream is cool, right? It works with, we can apply multiple functions here. In fact, let me show you one more thing. What if I don't want a int result in between? I want a stream itself, but I want this stream to be sorted. So I will say integer, and I will say sorted values. But I don't want to apply reduce because reduce will give you one value. I only want to filter them based on the condition, and then I want to say sort. That's it. The moment you say sorted, you will get a sorted stream, and maybe you can also print this values directly instead of using a for each. Let's try that. Compile and run. Oh, we have to use for each. Okay. So I will say sorted values dot for each, and you can say whatever value you get, just print it. Okay, let's try compile and run, and you can see we got the value in sorted format. So basically we have multiple methods to work with. In fact, there's one more thing. What if you want to do the filtering but with multiple threads? By default, you have only one thread, right? What if you want to use multiple threads? In that case, there is another function called parallel stream, which will create multiple threads for you to make this faster. The only thing is, When you say sort, parallel stream doesn't make sense because sorting will need all the elements together. So don't use parallel stream when you want to sort. But yes, if you want to filter, parallel stream works. Okay, so yeah, that's how we use stream API, and I hope you got the idea about map, filter, and reduce.